Learn to tailor massive models to specific tasks with this comprehensive deep dive into the modern LLM ecosystem. You will progress from the core foundations of supervised fine-tuning to advanced alignment techniques like RLHF and DPO, ensuring your models are both capable and helpful. Through hands-on practice with the Hugging Face ecosystem and high-performance tools like Unsloth and Axolotl, you'll gain the technical edge needed to implement parameter-efficient strategies like LoRA and QLoRA. Sunny Savita developed this course.
LLM fine tuning is a very important part of the generative AI. Guys, if you truly want to understand the internal working mechanism of a large language model, or if you really want to perform well in your AI or ML interview, then you should definitely know about the LLM fine tuning. So, guys, if you are looking for well structured and organized course on LLM fine tuning, then this course is for you. Now, inside this course, we are going to cover everything from basic to advanced. So, first, guys, let me show you the complete syllabus of this entire course. Now, inside this course, guys, we are going to discuss about the supervised fine tuning. We'll understand all the fundamental concept of the supervised fine tuning along with the end-to-end practical. So I will show you the supervised fine tuning on the instruction dataset as well as over the non-instruction dataset. Then guys, we'll understand about the preference alignment. So we'll understand how we can align the preferences of AI, human preferences to the AI model. We'll see the complete theory as well as the practical. Then we'll come to the different framework like Hugging Face, Llama Factory, Unsloth, Axolotl. Will implement our solution in each and every framework, and we'll see the differences, that what is the main differences between all this framework. Then guys, we'll cover the SLM fine tuning, multimodal fine tuning, and even embedding fine tuning. Now here guys, we are going to see everything with the end-to-end practical implementation. So this is not just going to be a theoretical session. So here I will show you each and everything in terms of practical. So guys, if you don't know about me, then my name is Sunny Savita. I have 7 years of working experience in the field of data science and generative AI. From past 3 years, I am deeply working with this fine tuning RAG and the AI agentic system. During my experience, I worked with the different domains like pharma, finance, or FMCG. There, I implemented lots of many use cases for the enterprises. So, guys, if you don't know about me, you can feel free to check out my profile. You can follow me over the LinkedIn, or you can check out my YouTube channel where I am regularly updating a content related to the RAG, fine tuning, and agentic AI. So yeah, without delay, now let's start with the video. Let's start with the fine tuning, guys. So guys, before starting with the LLM fine tuning, we'll have to understand the training pipeline of the large language model. So first, we'll take a walkthrough of the LLM training pipeline along with the example, and then only I will come to the fine tuning. Okay, the practical and all. So guys, if we're talking about the LLM, so we can choose any LLM. Let's suppose if I am showing you the fine tuning with the Llama, you can choose any other LLM. Okay, the code base would be similar. You just need to change the model ID. Okay, or from wherever we are going to pick the model, you just need to pick the any other model, any other different model. Okay, according to your requirement. Now guys, so if we're talking about the LLM training pipeline, so there is 3 stage. The very first stage is called the unsupervised pre-training. Unsupervised pre-training. Now this is also called self-supervised learning. Okay. Self-supervised learning. Now the second stage is called SFT. Okay, this is very much important. SFT. Now, what's the full form of this SFT? It is called Supervised Fine Tuning. Okay. Now, if we're talking about the supervised fine tuning, so on a data level, on a parameter level, we can divide into two parts. The first is called, so let me write over here, on parameter level. Okay, so on parameter level we can divide into two parts. The first is called full fine tuning. Okay, and the second is called partial fine tuning. Second is called, guys, let me write over here, partial fine tuning. So we're talking about the full fine tuning. Now here we are going to train all the parameter. Okay, so if we are talking about this full fine tuning, so we are going to train all the parameter. Now if we're talking about the parameter, guys, so parameter is nothing, it is weight and the biases. Okay, now guys, whenever we're talking about the full fine tuning, so this full fine tuning, okay, full supervised fine tuning, it is required more memory. Okay, it's required huge GPU memory. Okay, and it's required multi GPU setup also. Multi GPU setup if the data is very huge. Okay, if the data is very huge, if the model is very huge, in that case it will be required the multi GPU setup. So we avoid this full fine tuning. Now the second technique is called the partial fine tuning. Okay, so let's understand about it. So we're talking about the partial fine tuning. So again, there is two method. Okay, two method of it. So one is old school method. Old school method. Now inside this old school method, what we are doing, so we are just going to be freeze all layer and train last output layer. Okay, train last output layer. Now the second one, what we can do now here, freeze some starting layer, and retrain. Okay, so here it's not train, it's a retrain. Okay, now here is also retrain some last layer. Okay, so this a particular technique generally we followed in the CNN based architecture, right? CNN based model, or in an early stage LLM also. So in the early stage LLM, like, let me write over here, early stage LLM like bot. Okay, bot, T5, right? T5 or BART. So this was the early stage LLM. So inside these particular model, we have followed this technique, right? But in a large language model, whatever large language model we are seeing. See guys, now one more thing. If I'm saying large language model, now what does it mean? So large language model means the model which was built on top of the transformer. Okay, so all the large language model are following this transformer architecture in backend. Okay, if you don't know about the transformer, guys, soon I will create one video on top of it, and for sure you will understand. Now guys, the second technique, okay, which is not an old school technique, which is a latest technique. So that is called, let me write over here, PEFT. Okay, PEFT, P-E-F-T. Now what does it mean? PEFT means, PEFT is called parameter efficient fine tuning. Okay, parameter efficient fine tuning. Now inside this parameter efficient fine tuning, we are not going to be train all the parameter of the model. Instead of that, we are going to be train some specific parameter, right? So let me write couple of techniques name over here, and in the future we'll discuss in a detail. Now guys, let me write one very popular name under this PEFT, which is called LoRA. Okay, I think you heard about this LoRA, right? So we have one quantized version of the LoRA. If we are going to be use the quantized model, so which is that is called QLoRA. Okay, now this Q is representing to the quantization. Okay, this Q is representing to the quantization. Now why we do the quantization, what we do in the quantization, you can check out with my previous video. So let me highlight some points over here. So in the quantized model, we use the lower precision model. Now what is the lower precision? Okay, each and everything I shown inside that particular video in the previous video, you can check out over there. Now this quantized model is a memory efficient model. Okay, so using this quantized model, we can do the memory efficient loading. Okay, so quantized model is the lowest precision model. If it is a lower precision model, then we can simply load into the memory. Okay, we can do the memory efficient loading and all. So that's a benefit of the quantized model. So LoRA is one of the technique. Okay, and if we can extend, right, if we are going to be use the quantized model, so that is called the QLoRA. Now we're talking about the PEFT, guys. Okay, so this PEFT, right, this parameter efficient fine tuning, this might work on a single GPU as well, right? So here I can write this PEFT technique, this might work with single GPU and smaller VRAM. Okay, now guys, this LoRA is not one and only the technique. Okay, we have some other technique also. So let me write the name of those specific technique, right, which I found apart from this LoRA, and definitely in this fine tuning series we are going to discuss that. So the second technique, which is called DoRA. Okay, I'll come to this DoRA. Maybe many of you hear this name first time. The second technique is called, sorry, the third technique is called the adapter. Okay, adapter layers. So adapter layers is also inspired from the LoRA only. We are going to be append some layer, okay, in the existing block of the transformer. Okay, so which is called the adapter layer. So DoRA and the adapter layer is also a couple of techniques, okay, which we can use instead of the LoRA. Now we have some other technique. So let me write the fourth name over here, which is called the BitFit. Okay, BitFit. So this is also parameter efficient fine tuning, and it is getting very popular, and I'll show you the research paper of it. Now the fifth technique, which is IA3. Okay, I'll show you what is this IA3. This is also parameter efficient fine tuning. Now apart from that, let me write a couple of more names. So prefix tuning, it's also one more technique. For sure I'll show you this also. Okay, then the next is prompt tuning. Okay, prompt tuning. Prompt tuning, it might not be a part of the PEFT, but yeah, I kept it over here, and I'll show you the use of this prompt tuning as well. But guys, this LoRA is not one and only PEFT technique, which is parameter efficient fine tuning, where we are not going to be training the entire parameter of the model. Parameter means what? Weights and biases. Okay, instead of that, we are going to train only couple of parameter, only subset of parameters. So LoRA, DoRA, adapter layers, BitFit, IA3, prefix tuning, these are some technique, PEFT technique, and for sure in our fine tuning playlist we are going to discuss all these technique. Okay, now let me show you the research paper of it. So if you're talking about the IA3, so guys, here you can see the very good blog on this IA3 over the Hugging Face itself. So the full form of this IA3 is infused adapter by inhibiting and amplifying inner activation. So the name seems very complicated, guys, but yeah, we can implement it by program, by the code and all, and that will not be very difficult. So it is a part of the LoRa itself. To improve the LoRa, actually we use this IA3, and it is a part of the PEFT. So that's why I kept under the PEFT itself, because we are using it to improve the LoRa itself. Yes, for sure, LoRa is very important, and the base for everything is the LoRa, LoRA. Okay, now here guys, you can see the research paper of it. You can check out the research paper. Even I'll show you that when I will discuss it, this is specifically this IA3 and all. Now here is a BitFit, guys. See, this is the research paper of the BitFit, simple parameter efficient fine tuning for the transform based mass language model. Okay, so we can use this BitFit also. Again, this is not very popular, but yeah, we can look into it. If you are doing some experiment, you can go through with it. Otherwise, you can do everything from the LoRa, from the IA3, from the DoRA, and the this one. Basically, one more is there. Let me show you. So here is a DoRA, guys, right? So what is the full form of the DoRA? Weight decomposition, low rank adaptation, right? So this is the form of the LoRa itself. Now here again, it's a LoRa, low rank adaptation for the large language model, right? So let me highlight the points now. Let me summarize all the things. If we're talking about the partial fine tuning, we are just taking subset of the parameter. Let me mention over here, subset of the parameter. Okay, subset of all parameter. Okay, so these are a couple of technique. First is LoRa. If we are taking quantized model over there, then it's called QLoRa. Then DoRA, then adapter layers. Yes, this was the technique, adapter layer. BitFit, we can avoid this as well, but yeah, IA3 we can pick up this. Prefix tuning, it is also important. Okay, I'll come to this, I'll show you that. Prompt tuning is also again one of the technique. Okay, now this was based on the parameter, on a parameter level. Now guys, if we're talking about on a data level, so let me talk about the data level as well, and for sure I'll discuss that. Okay, so here I'm going to write on data level, on data level. So on data level, guys, we can divide into two parts based on the data preparation. If I'm saying data level means what? Based on the data preparation. Okay, data preparation. The first is called non-instruction fine tuning. Okay, non-instructional fine tuning, and the second is called instructional fine tuning, right? So maybe you heard this term many times, instructional fine tuning, but I think you were not aware about this instructional fine tuning. Now again, this is a part of the SFT, right? So if we're talking about the SFT, right, so this is very, very, very important, guys, right? So we can divide into two parts. First, on parameter level, again inside the parameter level, full fine tuning, where we required huge memory and the multi GPU setup, so generally we avoid it. Second is called the partial fine tuning. Again, we can divide into two methods. One is the old school method, where we are going to be freeze the layer and then we are going to be train the rest of the layer, and then we have an advanced technique, okay, which is called the PEFT. Now under the PEFT, guys, you will find out the LoRa, DoRA, adapter layers, BitFit, IA3, prefix tuning, prompt tuning. Now guys, on a data level also, whenever we are going to prepare the data, right, for the fine tuning, for the supervised fine tuning, so again we can divide into the two part. First is a non-instructional fine tuning, and the second is the instruction fine tuning. So this is all about the SFT, right? Now the third term, which is called alignment with the human feedback, okay, or which is also called the preference based learning. So let me do one thing. Let me cut this thing from here. This is also, I will show you, this is an example of the unsupervised learning and all. I'll show you that. First of all, let me keep it over here, this entire thing. Okay, and let me write about the RLHF. So guys, the third stage, which is called preference based, okay, alignment with the human feedback, right? Feedback. This is also called the preference based learning. Preference based learning. Okay. Now guys, here what we are doing, we are aligning the response. Okay. We are doing alignment of the responses. Now this responses actually, this particular responses is being generated from the LLM. Okay. So guys, if we're talking about this preference based learning, so there was two methods. The first is called the RLHF. Now this RLHF, the full form of this RLHF is reinforcement learning through the human feedback. Now this particular technique was based on this algorithm PPO. Now what is the full form of the PPO? Preference, proximal preference optimization. Okay, proximal preference optimization. Now this particular technique guys, okay, this PPO actually, it comes under the reinforcement learning. Okay, so that's why this is called RLHF, which was used by the OpenAI. Okay, which was used by the OpenAI for the preference based learning, right? I hope now you got it. Now the second is the popular technique, right? Now we all are using that, and even I will show you the practical of it. That is called the DPO. Now what is the full form of the DPO? The full form of the DPO is direct preference optimization. Okay, direct preference optimization. Now here guys, this is supervised learning. This is supervised learning. I'll show you the data set of it. So in the data set you will find out question, then you will find out the response, okay, and then you will find out the feedback of the response, whether the response is positive, whether it is negative, something like this. Okay, so guys, this is the complete stage of the LLM training pipeline. So first is called the unsupervised pre-training. Now the second is called the SFT, supervised fine tuning, and I explained the complete supervised fine tuning graph, which is very much important for us. And the third one, okay, after training the model, after generating a response, now based on that response, again we are going to be train our model, right? That is called preference based learning, or that is also called the alignment of the responses, the LLM generated responses. Okay, now let's see a couple of examples. So here I kept the example of the pre-training, what is the objective of it, what kind of data we are using. Then I kept for the normal fine tuning, that I kept for the instruction fine tuning, for the RLHF and all, and what kind of technique you can use. And here I kept one more like example, okay, which is LLM wise Llama, GPT, Mistral, okay, the name of the LLMs basically. So first, what was the name when it was unsupervised pre-train, then while the supervised fine tuning, then after the preference based alignment and all, right? So all the example I kept. Now let's take a look onto this. So first let's start with the pre-training, which is also called self-supervised learning. Now guys, this pre-training is also called the unsupervised pre-training or self-supervised learning. Now why it is called the unsupervised pre-training? Because in the data actually we don't have a label. And why it is called the self-supervised learning? Because the label is being created automatically, okay? The next word itself will be the label, okay, in the data. So guys, what is the source of the data whenever we are doing this unsupervised pre-training? Now see, whatever model you are seeing, whether it's a Llama, Mistral, GPT, DeepSeek, cloud-based model like Sonnet, Opus, okay, Gemini. So these all the model initially have been trained on a very huge amount of data. Okay, now this data could be from the documentation, it could be from the research paper, this could be the common crawl data from the internet, okay, Wikipedia, encyclopedia data, books, okay, like different books, not even in English, even in the different other languages, right? Now guys, because of that, right, so see, initially actually we have to train our model on a very huge amount of data. As I given you the example of the different model, they all did this kind of training. Now this training itself is a bottleneck means because every country, every company not having this much of data, first of all, right? Now for training, okay, for training our model, if I'm saying model means transformer based model, for training the transformer based model on a very huge amount of data, we required a very huge infrastructure, huge GPU infrastructure, huge memory processor, right? So that is very money consuming and the time consuming thing. Okay, every country, every company cannot afford it. That's why many of the companies are not able to train their own specific large language model. You can see Grok, again it's from the USA, okay, Meta again from the USA, DeepSeek from the China, right? 90% model from the US itself, and it is being trained by those company which is already having the access of the entire internet data, right? So this stage is an initial stage. Now why this stage is required? Because using this unsupervised speed training or self-supervised learning, we can teach our model general knowledge. We can teach our model how it can understand the language, okay, the grammar of that language. So to develop the learning of the model, okay, to develop the core intelligence of the model, this particular stage is required. Now what is the objective? If we are talking about the technical objective, so the technical objective is next token prediction. This is called the language modeling. Okay, we are doing it on a huge amount of data, on a large scale of data. Because of this language modeling is called the large language modeling. This LLM word actually it came from here itself. Getting my point, guys, right? Now guys, here what you will get after this particular training, what you will get a base model actually, right? For example, Llama base, Mistral base, GPT base, DeepSeek, Gemini, right? Now if you want to, if you want a model which can do the conversation like a human, so again you will have to do the fine tuning, the instruction fine tuning, which is the next step that comes under SFT. Okay, if you want to make your model chat enable, right, so for that you'll have to do the instruction fine tuning, right? And if you want to align your model to the based on the human feedback, then you will have to follow the third step, which is called the DPO. Okay, direct preference optimization. You will have to align the responses of the you will have to align the response of the LLM based on the human preference. Getting my point, right? So guys, here if we want to perform the pre-training, so we required this source, we required the data from the huge sources. Okay, in short I can say the data from the internet itself. What is the objective of it? To predict the next token. Okay, this is called the language modeling. We are doing it on a huge amount of data, which is called the large language modeling. Okay, the NLM word came from here itself. Now what is the result of it? The result basically you will get a base model. Okay, for example, Llama base, Mistral base, GPT base, DeepSeek base, Gemini base and all. I'll give you more example, don't worry. Even I can show you over the Hugging Face itself. So if you will go with the Hugging Face and if you will check with this Meta repository, so here you will find out a different model. Now see, this particular model is a base model. Okay, Llama 213B. Now on the other hand, if you will see this model, okay, Llama 7B chat. See, this model is not a base model because after performing the pre-training, again this model have been fine-tuned for the chatting, right? Now I can show you the other model. So if you will check with the Llama repository, just go with the first page. Now here check. So Meta Llama 38B instruct, right? So this model is not a base model because this model actually have been pre-trained, and then it is being trained on some instruction, right? So this is also not a base model. Now likewise you can check the different model, so which is a base one, which is not a base. In the name itself you will get it. See, this model is a base model. Now why this is a base model? Because the Llama 3.18p, it has not been trained further for any instruction, for any chatting kind of stuff. Okay, so I hope you got the meaning of the base model, right? Now why we are doing it? So that we can develop the core understanding of the model in terms of the language, in terms of the grammar. Okay, we can develop the general knowledge of the model. But guys, after doing this pre-training, still my model lacks to follow the instruction, to maintain the specific tone, in whatever tone basically we want to be train our model, to produce the structure answer and all. Okay, so for that only what we do, we perform the supervised fine tuning. Now if we are doing supervised fine tuning, guys, so as I told you, we can divide into two parts. The first is called the normal fine tuning, this one, and the second is called the instruction fine tuning. Okay, instruction fine tuning. Now when we do the instruction fine tuning, so whenever we want to convert our model into the assistant, okay, whenever we want to convert our model into the chatbot, means it can do the chats like a human. Okay, it can do the conversation. In that case we do the instruction fine tuning, right? Now let's say we got the we have trained our data on a huge amount of data, we got a base model, right? So what we do, guys, we do the non instruction fine tuning, which is also called the normal fine tuning, right? And the second is the instructional fine tuning. Okay guys, if we're talking about the ChatGPT, so ChatGPT have skipped this particular stage, this normal fine tuning, means domain specific fine tuning, domain adaptation fine tuning. What they have done, they have trained their model on a very huge amount of data for developing a general knowledge, and for making it enable like a human conversation. Okay, they did the instruction fine tuning. Now they have done the instruction fine tuning on what? They have done the instruction fine tuning, okay, on the Reddit data, on the QLoRA data, Stack Overflow data, GitHub issues, right? Open forum, community forum, right? Where we have like question and answer, right? On top of that data, they have fine-tuned the model. Okay, they have fine-tuned the model. Now guys, when this normal fine-tuning, means non-instructional fine-tuning is required, I can give you the example of it. So let's understand it over here. So let's say you have trained one model. Okay, I can take example of the Llama. Let's say you have trained one model, Llama model. So this model is a base model. Okay, I think you got to know what is a base model. Now guys, this particular model you want to train for your own domain. Let's say this is a base model. Okay, now guys, this particular model you want to train for your domain. Let's say your domain is a pharma, one pharma company, right? Let's say Sun Pharma want to train their own model. Okay, so they are not going to be train it from scratch. Okay, this pharma company, let's say Sun Pharma, they are not going to be trained from scratch. Okay, SCRATCH, right? They're not going to be trained it from scratch. What they are doing, they're just going to be take a base model. Okay, let's say Llama 13b. Okay, they are taking this particular model. They are going to be trained for the pharma domain. So they have a domain specific data. Domain specific data. Okay, now on this domain specific data, again they will train which model? Llama 13b model. Getting my point, guys? So this particular training, see, this domain specific data, let's say this is available in PDF. Now if we're talking about the instruction fine tuning, so in the instruction fine tuning, the data will be available in a question and answer format. So we would be having question and answer, or you can say input and output format, or you can say like in the instruction and response format. Okay, in any of these format the data will be available. But here the data is available in PDF, let's say the data is available in TXT file, the data is available in any other file, okay, in any other file format. So what we'll do, so here we are not doing instruction fine tuning. Instead of that, we are picking up this data, this PDF data, TXT data, or data in any other format. This is a plain text. Okay. Now from this data itself, what we'll do, again, we'll train our base model. Okay. On top of which data? On top of this plain data. Now how the data is being prepared, I will show you that. Okay, from this plain data, I will again, what I will do, I will train my base model. And now this base model, right, Llama 13B model, this will be my domain specific model. Domain specific model. Domain specific model. Okay, now if I want to fine tune this model further for the conversation, okay, or for generating a text, the structured text and all, then I can do the instruction fine tuning. Okay, now why we can do the instruction fine tuning, why we are doing it? So that we can generate the structure output. Okay, so let's say we are asking some question to this llama, right? So it needs to be generate the answer, but here it know the domain specific knowledge, but still it is lacking to generate the structure answer. Okay, it is generating answer, but we want to be more refined. We want a specific answer with respect to this specific question. So what I'll do, I will perform the instruction fine tuning where I would be having the data in such a way. Okay, in which way? In question and answer format, in input and output format, in instruction and the response format. I'll show you the example. With that, your understanding will be more clear. So guys, that's what I was saying. If we are talking about the supervised fine tuning, we can divide into the two parts. One, see, we have a base model. Let's say this is my base model. So we have a domain specific data. Okay, that is a plain text in PDF, TXT, or any other file format. We can take that and again we can train our model. Now this model this model have been trained on a non-instructional data. Okay, which is the plain text or something, right? Now what is the aim? What is the aim? Why we are doing it? Why we are training this model over here? So that we can basically give the domain specific knowledge to my model. Now further, if I want to generate a structure output, then what I will do, I will train my model on the question and answer data. This particular data for the domain itself, this particular data will have to prepare by myself. Okay, for the domain, ChatGPT took the Reddit data, QLoRA data, open forum data and all. But if you are in the specific, or if we are doing it for the specific organization, so this particular data will have to create by ourselves, right? And then further, what I will do after the instruction fine tuning, I will do the preference based tuning, okay, which is also called DPO or RLHF. Okay, human feedback, right? Human retraining based on the human feedback. Okay, preference based tuning or preference based alignment, anything you can say, and DPO is a technique of it, so that my model will be aligned properly in whatever way the end user want the output. I hope you are getting the entire chronology now. Okay, so guys, here you can see, if we're talking about the don't worry, I'll show the example and all. If we're talking about the normal fine tuning, okay, this is for what? This is for the domain adaptation, right? Now dataset, what dataset could be the plain text. Okay, it could be the company document. Now use case, making LLM domain expert, okay, in any sort of a area like medical, legal, finance, e-commerce, whatever. Now what is the goal of it? To improve the model understanding and knowledge with respect to any domain, okay, or to adapt that particular language. Now what is the output style? Produce text continuously, not necessarily capable or following instruction. Means if we are asking any question, for sure is going to be generated text, but that text would be aligned with my question, would be the structure one. It might not be, because here again we are developing a knowledge, the domain specific knowledge of the model. Okay, meaning the model learning is the statistical distribution of the text, not question answering behavior. So again, we are not going to be train our model for such question answer. We are going to be develop the domain specific knowledge of the model. Okay, and I'll show you this thing practically. So what is the example? So example, let's say this is a text. Okay, how the data set will look like. So I kept like one paragraph over here. So Sunny Savita here, where AI meets unstoppable passion. Okay, this is where, not here. Where AI meet unstoppable passion, turning code, creativity, and courage into the legacy, teaching thousand to master AI one video at a time. Not just a creator, mentor, visionary, and a job maker. Don't chase opportunity, build them. Right. So this is the like a small text which I written. Right. Now over here you can see how the data will be created. Right. For this non-instructional fine tuning. Non-instructional fine tuning. Okay, so let's suppose this particular data you got from any PDF, right? So let's suppose you got this particular data from any PDF. Now how the data will be created for the non-instructional fine tuning, right? Non-instructional fine tuning. Now see, Sunny would be there, so Savita would be the output. Sunny Savita will be the input. Now this particular character will be the output. You can clean the data. See, later on I clean the data, so that's why this character is not there. Sunny Savita would be there, then where would be the output? Sunny Savita where will be the input? AI will be the output. Sunny Savita where will be the input? Meets will be the output. Sunny Savita where AI meet, so this is the output. Sunny Savita where AI meets unstoppable, so passion will be the output. Sunny Savita where AI meets unstoppable passion, right? So this turning will be the output. Now guys, here you can see how we are preparing a data. So we are preparing a data in such a way so that we can predict the next token. Okay, next token means we got a model, okay, base model. Now let's say if I want to be train this base model on our own data, on our own text data, this text data in a PDF, this text data belong to any specific domain, right? So what I'll do, I'll prepare my data in such a way, in this particular way. Now guys, what is this? This data actually, it is representing to the self-supervised training only, self-supervised learning only. Okay, we have performed the unsupervised pre-training. Let's say I got one general knowledge based model. Now if I want to be trained for my own industry specific data, I can follow this step, and this is called the non-instructional fine tuning. The data could be available in a PDF. We can get a text, we can again retrain the model, and we'll be getting a domain specific model, right? I hope this is clear. I'll show you with the practical, this entire thing, even the instruction fine tuning and the RLHF means the DPO technique, okay, on the same model guys, right? Now let's see the instruction fine tuning. So guys, in the instruction fine tuning, right, which is again part of the SFT itself. So data set follow instruction in the response format. Okay, don't worry, I'll show you that how it looks like, because I kept each and every type of data, right? From the Hugging Face itself, I kept the several data. So non-instructional fine-tune data, then instruction fine-tune data set, then preference alignment tuning data set. So this data set I just kept to show you how the data could be look like. Okay, the instruction fine-tune data and the normal data, and then the preference alignment data. Now here, so the data set follow instruction in the response format. What is the use case? The use case to build a chatbot, because the chatbot we required the model which can do the human conversation, human-like conversational. Okay, so for building a chatbot, or I can say for building the conversational AI, we always require the instruction fine-tuning on top of the LLM. So let's say we have a base LLM. Now this base LLM for performing the conversational, for building a conversational AI or to build a chatbot, what we'll do the instruction fine tuning. This is pretty much important. Now in between, even though we are again training this base model on some domain specific data with some domain, with this domain this base LLM on some domain specific data with the non-instructional fine tune, okay, with the non-instructional fine tuning data, right? But if I want to convert my model into chatbot, in the conversational AI, into the QA system, right? That definitely we require this instruction fine tuning. Now goal to teach the model to the human based instruction, right? Human like conversation. Now output style, so direct, helpful, and structure answer, more reasoning based answer. ChatGPT is the best example of it. They did the instruction fine tuning of the base model. They didn't did the they did the unsupervised pre-training on a very huge amount of data. They taught the model to the general knowledge and all, and then they perform the instruction fine tuning. But this stage is for us, for you and me, for a specific company, guys. Okay, if I want to avoid this particular step, okay, if I don't want to train my base LLM, if I want to pick my base LLM, if I want to do the domain specific tuning, so this step is for me. And if I want to convert my model, okay, into the conversational model, then this particular stage is required anyhow. Now what is the data example? So see, this is the data example which I mentioned. So here would be the instruction example, what mitochondria does in one sentence. Now see, mitochondria generate energy for the cell through the respiration. Okay, so we asked the question in this for this specific answer, and it has generated this specific answer, right? If I don't want to generate any extra thing, any other thing, that's why this particular fine tuning is required, right? Now meaning the model learns produce direct question answer, okay, and it learns how to generate the structure answer based on the given instruction, based on the given question. Now common data set, so these are the common data set which you can see over the Hugging Face itself. I'll show you in some time. Now how ChatGPT have performed the instruction fine tuning, on which data they have done. So they have done on the Reddit conversation, on the QLoRA, on the Stack Overflow conversation, Stack Exchange conversation, right? GitHub issues discussion, right? Open forum and the community board like Hugging Face, Kaggle. I'm just saying with respect to the coding as of now, but yeah, it could be any open forum, community forum and all. Okay, so like the in the comment itself we are doing a discussion with respect to any specific post, right? So that data also could be possible, right? So ChatGPT, the OpenAI picked this particular data for the instruction fine tuning of the ChatGPT model, of the GPT model, which have been used under the ChatGPT application. Okay. Now guys, what is a combo? Means if we are going to be train our own model, so what could be the strategy? The strategy could be, first we can do the normal fine tuning, okay, to adapt the model on your specific domain. And after that, what we can do? So first we can do the normal fine tuning, and after that we can do the instructional fine tuning. Okay. And with this particular strategy, my model will become the beast. Means my model can generate the output according to our requirement. Okay, now the last step is called the alignment with the human feedback. So for that, so here you will find out data. So in which way the data will be available. So pair of response ranked by the human. Okay, means human is ranking the response, whether it's good or not, whether it's a positive, negative, something like that. Now for that we have RLHF technique, DPO technique, RLAIF technique. But guys, this technique is a very basic and useful, so we'll go with this particular technique. But when I will explain to DPO in the detail, definitely I'll give you the glimpse of this technique as well. Okay, this technique RLHF and this RLAIF, reinforcement learning from the AI feedback, I'll discuss about this as well. Now what is the goal of it? To make the model polite, safe, helpful, and aligned with the human value. Now LLM has generated an answer, that's fine, but human is liking this answer or not. Okay, human is liking this particular answer or not, we don't know about it, right? So what we'll do, we'll again perform the training. We'll again perform the training using this DPO technique. Again, it's a supervised training only, and I will show you how the data looks like. So I kept some of example over here. GPT-4, pre-trained GPT, supervised fine tuning. Okay, with the there's an instructional fine tuning and then RLHF. Gemini also SFT, RLHF, and then multimodal alignment. Okay, DeepSeek also they have trained in the same way. Okay, all the steps they have followed. Now ChatGPT, right? For the GPT, how they have collected this human feedback data. So they have collected from the log, okay, from the ChatGPT user log, means whatever answer is being generated, whether a user is giving thumbs up or thumbs down, Okay, so that particular log they were capturing, and that was a data, right? So collected with the user consent and anonymization. Okay, so whatever user is giving the feedback, okay, based on that that particular data they have filtered. Okay, and again on top of that data they have retrained the model, right? So likewise they have captured the data for the chat gpt, for building the chat gpt. Okay, for training the gpt model in the human feedback. Now this particular example I kept for the gpt model itself, for the chat gpt. But in our case we'll have to collect our own data if we are going to build a chatbot like this, okay, on our own LLM, right? So I hope guys this thing is also clear. Now let's see some family wise breakdown, Llama, Gemini and all, and then basically I will go with the different data set. And first we'll start with the non-instructional fine tuning. Okay, and in the next video I will show you the instructional fine tuning. So here I kept the family wise breakdown, means I kept the different family of the model like Llama, GPT, Mistral, DeepSeek and Gemini. So let's look into all these three stage of the training with respect to these model. So stage one, let's say Llama, pre-train on trillions of token. The data would be the common crawl data, books, coding and all. Then in the next stage we perform the SFT, supervised fine tuning. So we have made this Llama to chat. If we want to make it to the human, if we want to align with the human responses, right? So we did the third, we have performed the third stage. Okay, then public wise, so Meta released both base and the chat variant, right? So you can choose base or chat. The chat model basically it's aligned already. Okay, means they have performed the instruction fine tuning as well as they have aligned with the human feedback. Now, if we're talking about the GPT, so GPT-3, which was released in 2020, it is a pre-trained model only. Then Instruct GPT, they have released in 21. You can check out with this particular model. They have performed the SFT, means instructional fine-tuning as well as the RLHF. Then in 2022 and 23, they have released the GPT 3.5 and 4, heavily aligned with the RLHF and safety filters. Okay, and again, it was an instruction fine-tuned model. Then GPT model are closed source, so you don't get base bait over here, means you cannot get this particular model because it is closed source. They are just giving you the API, directly use the model. If you want to fine tune on your own data, if you want to perform the instructional fine tune, that is possible. Okay, I'll discuss that. Now Mistral wise, same thing. So Mistral 7B is a base model. This particular model was released in 23. Then X7B model, this is a mixture of expert. Again, it's a base model which again released in 23 itself. Then instruction version of the model, this model was released. You can check out with the repository of the Mistral. Then some model also aligned with the RLHF and DPO. Okay, you will get inside the repository itself. Open weight released means we can also use the base model as well as the instruct model directly, and we can fine tune for our own requirement. Okay. DeepSeek again in a same way. So they have released the base model, pre-trained model, okay, in all the variants. Then they have released the DeepSeek code model, okay, which is trained on the code data. It was the SFT training. Maybe it was the instruction fine-tuning training. Then they have released the R1. Okay, this was again aligned with the human feedback, right? Now open weights is available. It is a China's big open source push. For sure you can download this model from the Hugging Face itself. Gemini again same thing, right? So this was the family wise breakdown, guys, and similar to that you will get the cloud based model, right? Opus, Sonnet and all, and yes, they have also trained in the same manner. So unsupervised pre-training, then domain specific fine tuning, non-instructional, then specific fine tuning, instruction fine tuning, and then RLHF. Okay, these are 4 stages. Let me revise all this thing over here. First is what? So first is the unsupervised pre-training. Okay, unsupervised pre-training, UFT. The second is SFT, supervised fine-tuning. Again, 2 part of it. Non-instructional fine-tuning data on this data, and then instructional fine-tune data. Then third is reinforcement. Preference alignment, preference based learning on human feedback. Okay, on human feedback. Now we're talking about the GPT model, the chat GPT product you are seeing, okay, or any other product which have been released by any other company. So they have performed the unsupervised pre-training, then they have performed the supervised fine-tuning, means instruction fine-tuning, and then this preference based alignment. Now if we are doing for our own company, so we cannot, okay, if we are doing for our own company, so we cannot train the model from scratch. It is not possible. So what we'll do, we'll pick the base model, we will train it on our non-instructional fine-tuned data. If I want a structure output, in that case I will go ahead with the instruction fine-tuning. Okay, first this, then this, then this, and then if I want to be aligned with the human answers, then I will perform the preference based alignment, okay, through the human feedback. Okay, so here I will go ahead with the DPO technique, right? So this is the entire summary of this theory. Now we'll see the practical, guys. Now for the practical, guys, I created Google Colab notebook, and you can see the title of the notebook: non-instruction pre-trained LLM fine-tuning on a domain specific data set. Okay, so let's connect to the GPU. Now here you need to change to the runtime. If you haven't changed, then change to the GPU and then save it. You can purchase the Google Colab Pro if you want some premium GPUs like A100 L4 GPUs. Okay, you can work with it after purchasing the Google Colab Pro. I don't have Google Colab Pro right now, so that's why I'm working with the free GPU itself. So I written the title, I connected with my GPU. Now let's start with the practical. Now first of all, guys, let me show you the data set. So here is my data set. So this data set is belong to the pharma domain. Okay, this is the dummy data set. Here I just have one page because I just have to show you how to fine tune our model, how to fine tune our pre-trained model on top of the domain specific data set, which can reside in any PDF, any document. Okay, so this is the plain text only. You can see here we don't have any sort of a CSV, we don't have any sort of a column right now. Okay, we just have plain text. So we'll transform this particular data, okay, into the appropriate format, and then we'll pass it to the model. So this is our main aim. Now here for performing the practical, guys, I am going to use the Hugging Face. So let me show you the library, what a library we're gonna use for training. So here, guys, we are going to use transformer library. We're gonna use the dataset library. Okay, then accelerate we are not using because this library is for the multi GPU setup, but yeah, we'll install it because some dependency onto this accelerate. Then we'll use the bits and bytes. Okay, this is for the loading the quantized model. Then PEFT library, it is for the LoRA configuration, right? So LoRA, prefix tuning, adapter, everything we can do using this PEFT library. Now you can see the further detail of this library. So who has created this library? Hugging Face only created this transformer library. Same dataset library been created by the Hugging Face. Then accelerate library also created by the Hugging Face. This bits and bytes library is created by this specific guy, Tim Determers. So this library is available under the Hugging Face. Okay, this bits and bytes, you can directly install it from the Hugging Face itself. Now PEFT library, it is also created by the Hugging Face. Okay. Now the key research paper, GitHub and all, you can search because it is an image, or else what I will do, I will give you in the description, you can take from there itself. Now after that, guys, what we have to do, we have to install all this library. So for installing this library, this is the command: pip install -u peft bits and bytes transformer and accelerate. Okay, now guys, after installing it, I required one more library. So the next library is the TRL. Okay, this TRL, the full form of this TRL is Transformer Reinforcement Learning. So for performing the supervised fine tuning, we required this TRL library. So let me install this also. Now we required one more library. So we required this PyMu PDF because my data is residing into the PDF. Okay, so we have to load the entire data from the PDF, and for that we required this PyMu PDF library. Okay, so I hope till here everything is fine, everything is clear. Now first of all, guys, let me show you how the different data looks like. Okay, so what I'm doing, guys, I am going to I'm going to copy and paste the different data set link over here. So first let me show you this non-instructional fine-tuning dataset. So this dataset, actually it's a pre-built dataset, means already you will find out this dataset over the Hugging Face. So you can look into these dataset, and if you want to use this particular dataset just for the practice, okay, or just to train any model, you can directly take it from there. Okay, this is a pre-built data set which you will get from the Hugging Face itself. But guys, in our case, we are going to fine tune on our own custom data. So this data set is not available over the Hugging Face, means this is the we are assuming that this is our own enterprise data. This is our own company specific data. This is our own customized data. Okay, so we are going to be loaded from the PDF. But already over the Hugging Face, you will find out so many data set, the non-instructional fine-tuning data set, instruction fine-tuning data set, and even the DPO data set. So what I'm doing, I'm keeping some name over here. So here, see guys, these names belong to the non-instruction fine-tuning data set. Okay. Now, likewise, I can give you the instruction fine-tuning data set so that later on you can go through with it. So here is the link of it. Okay, directly I kept the link of the instruction fine-tuning. I kept it in my notebook. That's why I'm directly copy and pasting from there only. Then I have one more type of data set, that is preference alignment data set. Okay, so let me show you that particular data set also. So here is the preference alignment data set. So if I'm going to show you, see, let me show you the data set, how it looks like. If I'm going to show you this fine web data set, okay, I already opened this link. See, this is the data set. It is available under this Hugging Face FW repository. The data set name is fine web. Okay, so see, inside this particular data you will find out this text column. So entire data has been divided into the multiple rows. Okay, and it is available under this text, means the entire plain text. Okay, it has been divided like this. So we have to prepare our own data. Okay, this customized we have to prepare our own data, this PDF data, into the same format. So let me show you the PDF data. See, this is the PDF data. No? It is a plain text, right? So this was also the plain text, but this particular data have been prepared like this to feed to the model. Okay, so we have to prepare our data, PDF data, into the same form. Now let me show you the another data. So this is one more data, the pile PubMed abstract refined by data juicer. So guys, this is this data set actually belong to the pharma research paper. Okay, now here inside this text column you will find out the abstract of all the research paper, right, inside this particular column. Now this particular data is refined by this library, data juicer library. Here you can see this data juicer library, which is used to pre-process the data. Okay, that's why the name is like this. The name is the pile PubMed abstract refined by data juicer. Now see, inside this table you will find out this text column, and under this text column you will find out the entire data into the multiple rows. Now the other column actually it belongs to the metadata, so you can ignore this particular column. Now while we are creating the data, at that time you will get this particular column, but yeah, you can create this particular column, but again there is no use of it. The main use of this text column only. Now let me show you one more data. See, here is one more data, skyline. So inside this repository, skyline 007, under this repository you will get this open web text data. So this data set, see here you can read out the definition of this data. This is the open source replication of the web text dataset from the OpenAI, means whatever dataset have been used by the OpenAI, it is a replication of that. Now this dataset is very huge. Okay, this dataset was used to train the GPT-2 model. Now here you can see the size of the dataset. So total size of the dataset is 55.21 GB. It's very huge dataset, guys. Now here you can see the example. So under this text column only, the data will be residing into the multiple chunks, into the multiple rows. Okay, so there could be a tabular format, or you can look into the means the data they can show you into the JSONL format. Okay, but the column name would be the same text only. Okay, so we have to prepare our own data in a same format. Now let me show you the other data set. So here I can open that data set. Where is the file? So here is a file, guys. So what I'm doing, guys, I'm going to be open the other data set. Let me close it. Step by step I can open. Okay, so guys, here in the instruction fine-tuning data set, I'm going to be open this particular data. The data set name is what? Mental health counseling conversation. Now this is the instruction fine-tuning data set. Now here you will find out the context, okay, and the responses. So this is the question, right, and here is the response of it. So the data you will find out in the form of instruction and the responses. Okay, so you can think in such a way: this is the input, this is the output. Okay, this is the question, this is the answer, this is the instruction, this is the response, this is the context, this is the response, anything you can say. Now I can show you the other data. See, this is the next data, alpaca, this clean data. Now inside this data set also you will find out this output, instruction. Okay, output, instruction. Input column is empty over here. Okay, Now you can look into the other data set, see open ORCA data. So inside this particular data also, what you will get, guys, you will get this system prompt, question and the response, right? So in every instruction fine tuning, in every instruction data set, okay, in every instruction fine tuning data set, you will get the question as well as the response of it. Now I can show you the preference alignment data. Okay, so this particular data was created by the Anthropic, public by the Anthropic, just for the practice, or like how the DPO, how the this preference alignment data looks like. Now inside this particular data, you will find out two columns. First is a chosen, so whatever whatever like answer is chosen by the AI, and the rejected. Okay, whatever answer is rejected by the AI. Now I can show you from the different repository. See, here is from the different repository, so you can you can check this ultra feedback binarized preference clean. So inside this particular repository also, you will get two column. One is prompt and second is chosen. Okay, and then another column you will get rejected. Okay, so chosen and rejected, this will be the common column in every preference alignment tuning data set. So you can look into the other data set. See, let me show you the last one also. So here is the last one. So guys, inside this particular data also, you will find out the prompt, initially region step, chosen, and then there will be one more column, rejected column. Okay, so guys, in every data set, right, which is belong to the preference alignment, you will get the chosen as well as the rejected. Now I hope you got to know how the non-instructional data, instruction data and the preference alignment data looks like. Now this data set is already given by the Hugging Face. Okay, so this is the pre-built data set, right? But guys, we are not just doing the practice using this pre-built data set. Many YouTubers, on many YouTube video, you will find out this kind of tutorial. So we are doing on our own custom data set. So in this particular video, I will show you with the non-instructional data. Okay, so this non-instructional data, this text column, we are going to be create from our PDF or data itself. This is our PDF data. Okay, now in the next video, I will show you the instruction fine tuning on the same data. Means we'll create instruction data set from the same domain. Okay, thus from the same kind of context to make our model more better, and then the same model will train on this preference alignment data. Okay, in the next video, I will create one preference alignment data. Okay, and on top of that particular data, will train the same model. So we took the we are going to take the base model. So first we'll train on this non-instructional fine tuning data set, which is our PDF. So here you can see this is my PDF. Okay, now after that we'll train on this instruction fine tuning data set in the next video, and then in the next video we'll look into this preference alignment data. I hope now everything is clear. So let's start with the practical. So first of all, guys, what we'll have to do, we'll have to load our data set. Now before loading our own data set, the custom data set, let me show you the inbuilt data set. Okay, so how the inbuilt data set look like. So first let's load the pre-built data set. Now guys, I already written the code in the notepad, so I can directly copy and paste from there because this code is prepared by me itself. So first of all, we'll have to import the data set. Okay, so from the data set, guys, I am going to import two things. So let me import two things over here. The first thing is the load data set, and the second is the data set itself. Just a second, let me check what is happening. Okay, so guys, here I loaded this, here I imported this data set as well as this load data set. Now what we are doing, guys, so here you can see we are going to load this tiny story from this particular repository. Okay, this is a data set actually. Again, it is a non-instructional tuning data set. Okay, this one. So I can show you also. So I can just copy this particular name and I can paste it over here. Now here, see, you will get the very first link, right? So just go through with this link and see, here is a text column, only the text column. Okay, so this data set again have been divided into the multiple rows. Now what I'm doing, this is a pre-built data set, okay, from the Hugging Face. I just want to show you how the data set look like. So if I'm going to print this data set, so what I'm doing, I'm going to be right over here, print data set. Now see how the data set look like. So let me copy this data set, and this variable I am pasting over here. Okay, so this is my variable. Now see, so okay, first of all we'll have to load it. This loading might take time. Okay, it's loading. Fine. So see, the data is loaded. Okay, so guys, the data is loaded successfully. Now after that, what I'll do, I'll print the data set. See, here is a variable. Here is the dataset variable. Now inside this dataset you will get the feature, only one feature I have, and see the number of rows. So how many rows we have? We have 21,19,719 rows, means almost 2 million rows. Okay, so guys, but we are not going to use this dataset. Instead of that, we'll create our own dataset. So let me show you a couple of rows from here. So let's check with the first row. So here you will get the first row. See, this is the first row. Now let me show you the second row. Okay, so here is my second row, this one. Now if you want to check the last row of this dataset, so simply you can write over here -1. See, here is the last row. Okay, so guys, this data set was a plain text, and now this data set was divided into the multiple chunks. Okay, multiple text chunk, and under this text column you can see the data. Okay, number of rows. Now we have to convert, okay, our PDF into the same format. If I want to train the model on top of the PDF, okay, so we'll have to convert into the same format. So how we can do it? So first of all, guys, we'll have to load the data. So for loading the data, let me write a heading. I will share this notebook. You can completely follow this notebook. Okay, I'll give the link in the description itself. So here is the basically custom data. Okay, so you can see the heading. Now what I'm doing, guys, I'm going to be import the FIDS library. This is from the PyMu PDF itself, means in the backend it is using the PyMu PDF. This FIDS library we use to load the PDF. Now here I've created one function. My function name is what? Extract text from the PDF. Okay, so I will give the PDF path. I will take the text. I will load the text inside this particular list. Okay, I will open the path. I will iterate on top of the pages. Okay, I will collect the data from here and I will append inside the list. Simple logic. Okay, and then I will return this particular list after completing the loading. So let me give the path. So here is my path content formin.pdf. Now once I'll run it, guys, so what I'll be getting a data. So here it is saying the data is not available because first we'll have to upload the data. If you're not going to upload the data, guys, in that case you will get a same error. So please make sure that you are going to upload the data over here, or else you can read it from the GitHub, you can read it from the drive, anywhere you can keep this data and you can read it. Now what I'm doing, guys, so here let's try to read the data now. So see, I got the PDF text. I can show you how the text looks like. So this is the text, guys, the complete text which I am able to get from the PDF itself. Now after that, what I'll do, I will divide the text into the chunks. Now this divide the text into the chunk, it is a hyperparameter. Okay, so this logic, basically what we can do, this logic we can decide how we are going to be divide our data into the chunks. Okay, and what would be the size of the chunk, right? Now I can give you a couple of examples, so I kept for all of you. Now first of all, guys, see, whenever we are going to load the data. Okay, so this is the complete step which we need to follow. As of now, my data was not too much, but if we are going to train our model from scratch, okay, or if we are going to do the non-instructional fine tuning, so you need to follow the same step. So first you need to collect the data, which we have already done. So see, this is my data. Now after collecting the data, guys, what we have to do, we have to cleaning and filtering the data. Then we have to divide the data into the chunking, okay, multiple chunks, because we cannot give this entire data at the single go, right, to train my model. Then tokenization means we have to convert our data into the specific numerical ID, okay, after the chunking. So to every token into the given chunk, one ID, one numerical ID will be assigned, and then we are going to perform the training, which is the next token prediction, right? So this entire step we have to follow. Now, guys, here I kept one more thing, one more table. So this table could be very much important. So just try to read this particular table carefully. So here I given the model name, max context window, approx word, how many words could be there, and the comment, right? So GPT-1 model, so it was able to handle 512 token, and there was approx 350 words. Now GPT-2 1000 token, okay, around 750 words. GPT-3 2000 token. 1.5k words around. GPT 3.5 409k token, around 3k word. And if we're talking about GPT-4 40, so it is it is able to handle up to 1,28,000 token, around 1 lakh words. Okay, now over here, guys, you can see, so whenever we are going to chunk the data, okay, so we have to keep something in our mind, right? So our model, right, how much basically token can handle, and whenever we are going to be divide the data into the chunks, okay, so we can follow some regex pattern also, means we can divide our data into the paragraph, we can divide our data into the segment, okay, or a semantic chunk and all, and then basically we can or else basically we can go ahead with the token length also. So let's say if we are going to be train GPT-4 kind of model, so let's say we are going to be load the data, this PDF data, okay, so we can give the bigger chunk to the GPT-4 model to retrain it to the fine tuning it, okay, and similar at the time of the unsupervised tuning as well, okay, means the first step, the initial stage, okay. Now here guys you can see, so this chunking we can do based on what, based on this particular pattern. See here I written based on the paragraph, semantic chunking, right, we can write some regex rule and all, and then we can, or else we can go ahead with the token length, means how many tokens we can bear in the single chunk, according to that also we can define the chunk, or else we can take the both strategy, okay. So I written a function over here. Now see the function, so it's split paragraph, so first we'll take the pages, okay, this data. Now we are going to be split based on the line, okay, based on the new long line, means the double line. Here you can see in the PDF itself. So if you will look into the PDF, so where it went here, so here you can see between this line and this line we have major gap, right? So we are going to be divide our data into the based on this major line, okay. So this is the regex pattern, you can write any regex pattern, you can read out the GPT model research paper, any other research paper, right, how they have done the unsupervised pre-training, how they have divided the data into the chunks, the entire text and all, right. So it will also help you, okay, but this is also a generic practice. Then what I'm doing, I'm iterating on top of the chunk, and if I'm saying over here, if there is a 30 character, more than 30 character, then only I'm going to be append the chunk into this particular list, okay. So whatever like whatever pages we have is on, we are iterating on top of the data, okay, and on the entire list, then we are chunking based on this strategy. If inside this chunk we have more than 30 character, more than 30 character means what, 10 to 12 token, okay, or 8 to 9 token. So more than 30 character only, then only we are going to append inside this particular paragraph, okay. So if I will run it guys, now here you will see we are going to be split our data. So here inside this particular variable I'll get my data, split data. Now see, so see what I have the first chunk, then second chunk, okay, then third chunk, then here you can see the fourth chunk. But guys, the data should not be like this, the data should be available into this particular form, okay. We should have this okay, we should have this text column, and under this text column the chunk should be present. So what I'll do now, I will map my data, okay, to the text column, okay. Now here what I'm doing, I'm iterating on top of the chunk, and then I'm assigning it to this text column. So now how my data look like, so if I'll show you the data, so here see my data guys, we have this text, okay. Now with every text one chunk is associated, chunk text, okay. Now what I'll do, I will convert this particular data into the Hugging Face compatible data. So for that I have a dataset library, okay, which I already imported. Now from here I will call this from list, okay, from underscore list. Now from this list itself, so here you can see this is a list only now, right? So I will pass this data to the list, okay. And now what I'll do, I'll keep it inside the variable. Let's say my variable name is dataset. Okay, now see my Hugging Face compatible data is ready. So if I will show you this data set, so how may the data set look like? See, feature text, okay, under this text we have a multiple chunks, okay, and here number of rows is 4. So if you will look into the pre-built data guys, this was my pre-built data. If you will look into my pre-built data, so this was a pre-built data which I loaded from the Hugging Face. In a same way we are able to convert our data. See, here is my data. So now you can check the first row, second row, whatever row you can check. So let's say if I'm going to be check the first row, okay, I will simply put the 0. So here you will be able to get the first row. Likewise you can get the second row, okay. So in total we have 4th row. So guys, in whatever way I was having my pre-built data, the data was already available over the Hugging Face. Now I'm able to convert my data set into the same format, okay, my custom data set. So this all the technique, all the pre-processing step you will have to follow with respect to your plain text. Now coming to the next part. So the next thing is basically we have to select the model. So first of all, let me create the multiple cells, okay. Now here we'll have to select the model. So let me make a heading. So the heading is let's select the model. So guys, model wise, what I'm doing, I'm going to be select a very tiny model because I cannot bear the large model inside with this particular GPU, with this particular memory. We require more VRAM and all. So if you have Google Colab Pro access, or you have more VRAM, then you can try out with this particular model. I'm using this model tiny from the Tiny Llama repository. So Tiny Llama 1.1b intermediate step 1431k 3t. Okay. Now, what does it mean? What is the meaning of this line? So I written a meaning of this line over here. See, so the checkpoint is from the Tiny Llama model, okay, which trained up to 1.54 million step over 3 trillion tokens capture midway before the final conversion. So guys, this particular model is a Tiny Llama model. This model trained till this particular step, okay, around a 14 lakh step, okay, on top of this much of token. So I'm using this model to train. I'm using this as a base model. This is my base model, guys. Okay, this model is not being trained on any instruction data or not on any domain specific data. This is my base model, simple pre-trained model. Okay, so I'm going to use this particular model to perform the domain specific fine tuning on top of my PDF data, right? I already prepare a data. Now what I'll do, guys, I will basically perform the fine tuning. So first of all, guys, what I'll do, I will load this specific library like auto tokenizer, auto causal LM, trainer, training argument, and data collector for language modeling. I think this will not be required. Training argument will be required. So let me run it, and I'm going to load the library. Now here what I'll do, guys, I will load the tokenizer. Okay, I will tokenize my data because I already performed the chunking. Now I will perform the tokenization using this particular tokenizer. Okay, so I'm loading a tokenizer. Now after that, guys, I have to execute one more line of code. So if padding is none, then in that case I'm going to be assign this end of the token to the padding, right? Now why it is required, let me give you the reason of that as well. So here I kept one image, with that you can easily understand. So guys, what is a pad token? So pad token we use to make all sequence in a batch to the same length. So let's say in input word we have 2 token, hello world, right? In input 2 we have 3 token. Good morning everyone. Technically there is a 3 token, hello world, this full stop, then good morning everyone, full stop. Now here you can see the size of the token, size of the input 1 and input 2 is different. So if I want to make it same, so here what I'll do, I will do the padding. Okay, now how I am going to do the padding? So at the end, okay, at the end of this particular see here the length of this particular input is 4. Okay, 1 2 3 4. Now what I'll do, so here at the end of the sentence hello world, okay, after this particular word I will add one more token, okay, that's going to be EOS, end of the token, okay, this EOS. So if I'm going to be append the EOS token, now how my sentence will look like, hello world EOS. Okay, so the length of this input 1 and input 2 is going to be same. So that's a simple use of this line. So let me run it, and here we are able to append this end of the token. Okay, now after that what I'll do, guys, so after that, guys, we are going to be pre-process the data. Now the pre-process step is pretty simple. So here we are passing example, means every text chunk. Now after taking every text chunk, see we are truncating, okay, we are padding, and we are like defining the max length. So what is the meaning of this particular parameter? I'll tell you. Now here we have one very important line. So to token, okay, to the label actually we are going to be assigned this input ID, okay, and then we are going to return the token. So let me execute it, and let me explain the meaning of this each and every line, because it is very much important. So here what I'm doing, guys, I'm going to be I'm going to be like add some example and all, and with this particular example we'll be able to understand. Now see, so whenever we are passing the text, so let's assume this is my text, okay, metformin improves insulin sensitivity in the liver. So what will happen, so this tokenizer token, okay, it is going to be take this particular text. Now truncation true, what it will do, so if the text is longer than 512 tokens, it is going to be cut off that. Padding true means if the text is shorter than 512 token, it's going to be pad. Okay, and the fixed length of this particular sentence of this like whenever we are doing the tokenization, it will be 512. Okay, if it's going to be less and more to this 512, then we are going to be truncate, or we are going to be perform the padding. So after processing it, I will be getting this particular input. So input I will be getting this particular output, where I will be having 2 column input IDs, okay, which is going to be assigned to every token, and then attention mask. Attention mask is saying which token is important for me to the attention layer. Then label, guys, so token labels, token input ID dot copy. Now, why we are doing it? So this is a key step for the causal unsupervised language modeling. Means what is our aim? The model should try to predict the next token in the same sequence. Okay, I shown you how the data is being prepared for this non-instructional fine tuning. Okay, for this plain text, for this particular plain text. Okay, so we took this plain text, we convert into the text. Okay, multiple rows. We did the chunking because of the model, right? Because we cannot put the entire data in a single go to the any model. Okay, and then we have to predict the next word. Okay, in the non-instructional fine tuning, we are doing this self-supervised fine tuning, self-supervised tuning itself, right? So what we have to do, we have to predict the next token, and for that, what we have to do, we have to prepare a data in such a way. So here you can see the sentence. What is my sentence? Metformin improve insulin sensitivity in the liver. Now see over here, this is my input. Metformin improve insulin. Now what is the target level? Improve insulin sensitivity. So okay, so metformin improve insulin. So here what is the next word of it? So metformin improve insulin sensitivity. Okay, so the sensitivity will be picked as the next word. So this particular line, with this particular line, we are going to be prepare this kind of data. Okay, now whenever we are passing, whenever we are getting final result, so we'll be getting the input ID, attention mask, as well as the labels, right? So let me execute it and let me show you how the data looks like. So for executing, we'll have to map the data. So here what I'm doing, guys, I'm going to be map the data. So I have a data set, I'm calling .map, tokenization function is there. Batch to means we can pass the data into the batch if we have so many data. Okay, so many rows. And here remove column text means in the final output, we just want this three thing: input ID, attention mask, and label. We don't want this text. Okay, so I'm going to remove it. Now here I will be getting my tokenized data. If you want to check it, you can simply check it. See, here is what? Here is my tokenized data. Input IDs, attention mask, and label. Now here is a number of row. Number of row is 4. Now what I'll do, guys, I will load my model. So here you can see I'm going to be load my model. So model loading might take some time because the model size is around 4 GB. Okay, so in your it depends on your internet speed. In my case, it might take like 4 to 5 minutes. So let it load, guys. So guys, my model is loaded. It took around 4 to 5 minutes. So as I told you, it depends on your internet speed also. Now after that, what I'll do, guys, I will define my training argument. Okay, so here inside the training argument, so guys, see, we have so many training argument inside this class. If you will see the list, you will get the hundreds of argument. So how you can get the detail of it? So for that, you can simply call this help training argument. Okay, so you already loaded this class from the transformer. You already imported this class from the transformer. Now simply pass it to the help method. Okay, now once you will run it, see here you will get the detail of each and every parameter, whatever is there. Now I mentioned the required parameter only, so I kept the meaning of this particular parameter. Let me mention it over here. So output directory means where we are going to save the model. Overwrite output directory means we are going to overwrite the previous model. If we are saving the new model, it will overwrite to the previous model. Number of training epochs, how many epochs we are running for the training the model. Per device train base size means in one single go how many batch size we are passing. Save step, at which step we are saving the checkpoint. Save total limit. Okay, so keep how means how many checkpoints you want to be keep on your disk. Let's say you have five checkpoints, so you will keep only 4 and 5 checkpoint if you are writing 2. Okay, the latest 2 checkpoint you will keep on your disk. Then logging step, at which step you are going to be log. Okay, learning rate means it belong to the optimizer. So if we have very huge learning rate, my basically graph will go here and there. If we have like a small learning rate, then my graph will go smoother. So guys, if you know the basics of the deep learning, then I think you can understand the meaning of this learning rate. And now FP16 for the precision, right? In which precision basically we are going to be load the model. A report tool means we are not going to be log our data anywhere. Okay, on any basically a tensor board or any bit and bias like dashboard, right, or anywhere. So we are just like keeping none. If you want to keep, like, we can remove this none, and we can keep our metrics as log and all on some different platform. Okay, by default you will get the bait and bias W and B platform, right? So this is the meaning of this parameter. I think you got to know. Let me run it. So my model will be available inside this particular directory. Now after that guys, what I'll do, so you can check with this help method. Now I'm going to be define my trainer. So after defining a trainer, okay, so see the trainer might take some time. So trainer is taking three things. One is model, second is data, okay, this tokenized data, and the third is a training argument. That's it guys. Now after training, after defining a trainer, I will just call the train method on top of it. So trainer is a class. We are going to initialize this particular class, and then we are calling this train method. So once we'll call this train method, now guys see what we'll get. Can anyone guess what I will get? So you can pause the video and you can give me the answer in the chat if you're watching till here. So if I'm going to be run it guys, see here I will be getting out of memory error. Now why I'm getting this out of memory error? Because guys, you haven't focused, because we are training the entire model. We are retraining the entire model over here. If you will check, see we are loading the model. We are not going to be select any. Basically last row, okay, or the initial row. We are not going to do any LoRA and QLoRA. We are simply retraining the weight of the entire model, and my machine is not capable to do that thing right now, and because of that I am getting this out of memory error. So what is the solution of it? So the solution of it is LoRA, okay, parameter efficient fine tuning. Now before the LoRA guys, let me show you the other method also. So here I written some sort of a description. So let me keep the description over here. Okay, so what is the description guys? So here we are not specifying anything, means this is the full fine tuning. Now we have two methods for the partial fine tuning. The first, freeze some layer and fine tune unfreeze layer, which is the old CNN method or BERT style method, right? The second is LoRA, append some external weight to the already trained pre-trained weight. So guys, I will show you this both method. Okay, I will more focus on the LoRA. I'm not going to explain you this freeze some layer and all. I will give you the code. I'll keep it over here, but I'm not going to explain because I already explained in my previous video. So if you will go and check, right? So let me show you in which all video I have shown you. If you will go and check with the playlist. So okay, this is running. So if you will go and check with my playlist, so just check out with this third video and the ninth video. Okay, in this both video I discuss about this particular technique, and even I shown you the practical also. Now guys, come back to this like solution. Now here what I'm doing, I'm going to be write a code. Okay, first I'm giving the code for this particular method for freezing the layer. You can try out from your end, okay, or else you can watch out those particular video, but this is not an appropriate method. There is some pros and cons. Maybe in the later video we'll discuss, because otherwise this video will be very longer. Now here, what is the code guys? So let's look into the code, what we are doing over here. So first we are loading a model, okay, then we are freezing some layer, then we are unfreezing the last 4 layer, okay, and then we are loading the data set, then we are defining the training argument, and then we are training the model. Simple guys, okay, that's it, nothing else. So you can look into this particular method and you can run it, but this is not an efficient one with respect to the larger LLM. We'll discuss theoretically later on why it is not. I'll show you the mathematics of the LoRA, DPO, everything guys, don't worry, right, in the upcoming session. Now what I'm doing guys, so here we are going to perform the LoRA based technique. So how to do the LoRA based technique? Let's come to that. Now before running the LoRA based technique, I will run the garbage collector. Okay, so whatever cache memory and all will be there, unnecessary memory, it's going to be removed that. Now again what I'm doing guys, I'm going to be update the library, because before running the LoRA configuration, we'll have to update the libraries, okay. Because initially we haven't installed this PEFT library, right? Bits and bytes, we also required the upgraded version, transformer and the accelerator else also. So let me run it, let me execute it. Now after that what I'll do guys, I will import this particular statement. But before that guys, what you can do, you can simply restart the session, okay? Because restart the session basically will load the latest version, okay, whatever version we require. Now after that what I'll do, I will import these packages, all the packages, auto tokenizer, causer LLM, training argument, trainer, then LoRA config, get PEFT model, task type from the PEFT, and then from the dataset we are going to load the load dataset, okay. Now after that guys, what I'll do, I'll take a same model which I was taking initially. Now here I will load the or tokenizer in a same way, okay. Then I'm going to be assign this EOS token at the end of the as a pad token, okay. So let me execute this. Now here it's the same thing. We are going to be map the data set. Okay, now which data set guys we are using? We are going to use the same data set. So here let's see the data is available or not. If not, okay, the data is available. Now what I'll do, I'll load it again because I restarted the session, so I will lose my data. Okay, I will lose the variable basically. So where is my data? Now first of all I will import this import statement. Now feeds extract data. Okay, this is fine. Now PDF, this is perfect. Regular expression, this is also correct. Paragraph is there. Data, okay, data. Now data set is ready. Okay, so guys, here what I'll get, I will get my data set. So let it run, let it execute, and what I'll do after that, I will again tokenize. So guys, you need to rerun this step, restart the session, because you might get some issue with the LoRa configuration and all. That's why restart the session. So let me check. Okay, now it is done. So here I got my data set. So where is the data? Okay, so tokenizer is running. Let it execute. Okay, so here guys, it is connecting. Okay. So let it connect, or else what I can do, I can disconnect and delete the runtime. Again I can connect. Okay, okay, fine. Now it is done. So this is fine. It's loading. This is fine. Guys, it might take time. First time now it takes time. Okay, LoRa config get PEFT model. This is a like huge library. Okay, so the library is loaded. Now what I'll do, I'll load the model, then tokenizer. Now here I'm going to append the EOS token. Now this is my tokenizer function. So let it run. Okay, reconnect. Why it is disconnecting every time? Connected. Tokenizer is there. Okay, this is required. Don't know why it is reconnecting. Okay, so guys, I followed the same step and I got my tokenized data. So inside this tokenized data, as you know, we will be getting the input, attention, mask, and label. You can include this text column or you can exclude. It's up to you, right? So you can pass along with the text column, as well as you can exclude it also. You know how to do that. So I got the tokenized. Now after that, what I'll do, so here after getting a tokenized, guys, I will load the model. Okay, now this time guys, you can see we are going to load the model in the 8-bit format. Okay, so here I'm giving the model, then loading a model in 8-bit, and then device map is auto. Now it is saying bits and bytes require the latest version. So yes, we'll have to install it. That's what I was saying. Just a second guys, let me execute it. Pip install -u. Okay, so this is done. If it is giving you this particular warning, then please if it is giving you this particular error, then please install the latest version. Now this is done. So yes, this is fine. Now what it is saying, okay, fine guys, let me restart the session. So restarting a session, this issue you will get in a collab, okay, while you are working with this library. Now let me execute it. Okay, auto causal LLM is not defined, so here is fine. Okay, so guys, my model is ready and my data is also ready. Everything is done. Now here, see guys, we have loaded the quantized model. Let me write over here, loaded the quantized model, right? Now what I'll do, I'll define my LoRa configuration. So guys, we'll understand this configuration in a very detail in the upcoming session. So what is the meaning of the task type? So task type is a causal LM, means we are doing the next word prediction. Rn means rank, okay, rank of the matrix. Rolla alpha, so this is again hyperparameter. Target module Q and V, so this is related to the attention layer, okay, QKV. So Q query and V means value, so we are targeting to this particular module. Now LoRa dropout 0.05, bias is none. So we'll understand all this parameter in a very detail. So here you can see the complete list of it. It's a very huge number of parameter, but until we are not getting the mathematics of it, until we are not understanding the mathematics of it, will not be able to get the complete one. So definitely I'll show you in the upcoming session. So here I define the LoRa configuration. Now what I'll do, I'll load the parameter efficient model. Okay, get PEFT model. I'll give the model. I'll give the LoRa configuration. So this model is going to be my quantize LoRa model. Okay, quantize underscore LoRa underscore model. So yes, model is getting loaded. Let me define the LoRa configuration and see the model is getting loaded. So it's saying model. Okay, let me check what I have inside this model. Okay, so this should not be the case. Just a second, let me load it again. Actually we should get the model. I think I run that model string again, that's why it's coming like this. Okay, we should have the actual model over here. So yeah, this is the case. Just a second, because I already loaded the model now, so it will not take much time. Okay, done. Now see, this is my model, right? So here if I'm going to load it, so I'll be getting the QLoRa model. Now my training argument would be the same one. Then I have the trainer, right? So let me define the trainer. So here what I'll do, I'll give my QLoRa model. Okay, then argument, then tokenize is the data set. Let me check with this particular variable. Tokenize is correct. Now once I'll run it, so my trainer will be ready. Now what I'll do, guys, I will train my model. So tokenize is not defined. Tokenize. Okay, this is my tokenize. So if I'm going to execute it, my tokenize is ready. Now what I'll do, guys, I will run it and my trainer is ready. Now this time I will not get any error, because what we are doing, we are going to do the LoRa based training. So if I'll do this trainer.train, my model will be trained, guys. Okay, so see, I have a very less data and we are doing LoRa training, so that's why it's not taking much time, and we are just doing for the 2 epoch. So see, the training loss is here, and you can see the other metadata. So see, the training loss is 9.66. You can run it for the more data and for the multiple epochs, but that is not a case right now. Means we are not running, we are not learning that how to reduce, how to improve the accuracy and all. That will be the different thing. So for that also I will create one session, but as of now we have to learn how to train the model at least, right? So my model is trained. Now after that I can get it, I can get my model over here. See, tiny llama LoRa, and under this particular folder my model is available inside this checkpoint, right? So what I'll do, I'll copy the path, and this particular path I'll keep it inside the double quote, and this is going to be my model path. Now what I'll do, guys, tell me, after training the model I'll do the prediction, right? So let me do the prediction with this particular model. Now first of all, guys, what I'll do, I will load the model. Now I'm going to load the model. So here is my trained model. Okay, trained underscore model, trained on the domain specific data. So let me execute it and see, my trained model is loaded. Now what I'll do, I'll give any sort of a prompt to this model. Let's say my prompt is clinical trial demonstrate that combine atrovestine with as a timby, right? Something like that, right? I took it from this particular data. I don't have the domain specific knowledge, but I kept this prompt from this data itself. See here, from this data. Okay, you can check out with the different other data. Now what I'll do, I will perform the tokenization of this data. I already have a tokenizer, so here I will perform the tokenization. Now what I'll do, I'll get a output. So here model.generate. Now which model? Trained model. Okay, So train model dot generate input max token this much, temperature, top P, do sample, repetition penalty. So these are all the parameter which we can pass, but you just need to focus on this input. Now once I'll run it guys, I will be getting my output. Now here I'm going to print my output. So let me decode my output, and tokenizer dot decode, and I'm giving the output over here. Skip special token, I'm going to be skip that. Now let's see the output. So guys, see, this is the output. Critical tries demonstrate that combining epsilon with that, right? So guys, here what we have done, we have performed the non-instructional pre-train LLM fine tuning. Means we took the pre-trained LLM and on top of our domain specific data, we have performed the fine tuning, and we are able to get the very amazing result. But guys, here let's say if we are asking any sort of a question and my model is not able to generate that particular answer in that tone specific structure, for that what we will do, we will do the structure fine tuning, instruction fine tuning, right? So now on top of the same model, in the next session I will show you the instruction fine tuning, so that we can ask the question, right? More structured question, it can generate the answer according to that. So yeah, this is it for this particular video guys. Thank you, bye bye, take care. I'll see you in the next video. Thank you. Hey, hi everyone, welcome back to my YouTube channel. My name is Sunny and I'm back with another exciting and important video. So in this video guys, we're gonna discuss about the instruction fine tuning. As you know, I started with the end-to-end LLM fine tuning playlist where I uploaded 14th video so far. So in the previous video, I discussed how you can train your pre-trained LLM model on your domain specific data. If I'm saying domain specific data, means the data could be available in any format and the data would be available as a plain text. Now in this video, we'll see if you have instruction based data, then how you can fine tune your LLM model. So we're gonna take same model which we have already trained in the previous class. On top of the same model, I will perform the instruction based fine tuning. So this video is going to be very important. Now guys, let me discuss what all point we are going to discuss in this particular video. So the first is what is the instruction fine tuning, then how the data looks like in the instruction fine tuning. Then we'll see why it is called the supervised fine tuning, as I discussed in the previous class that this is instruction fine tuning comes under the supervised fine tuning only. Then I will come to the practical, right? So this each and every point I will discuss throughout this video, and yes, at the end you will learn how you can fine tune your LLM model on the instruction based data. Now guys, without wasting our time, let's start with the video. Let's understand the theory first and then I will come to the practical guys. So guys, before starting with the instruction fine tuning, let's take a recap of some previous points. So the first thing is, what is the meaning of the fine tuning and why we do it? So here is a definition. Fine tuning means retraining an already trained model on your own specific data set. So guys, here if I'm talking about the model, right? So the model is nothing, it's a LLM model. Now this LLM model, it is based on the transformer architecture, as you know. So let me write over here transformer. So this transformer is nothing, it is a research of the Google which was published in 2018 itself. Okay, it was a sequence to sequence architecture where we were having two main things. One was the encoder and the second was the decoder. So the GPT model, right? The GPT model actually, it was built on top of the decoder part of the transformer. So if you want to understand the LLM, then before coming to any LLM architecture, understand about the transformer, okay, and then jump to the LLM. Now here I'm saying LLM, right? So we are going to be retrain already trained LLM, and if I'm going to be talking about the training, right? So what are we gonna train here? So we're gonna train weights and biases, okay? So weights and biases. Now this weights and biases, where you will get this weights and biases inside this transformer architecture. So we have attention, right? We have attention layer inside the transformer, plus neural network. Okay, so this transformer, one single block of the transformer, it is a combination of the attention layer as well as the neural network, right? So there we will get the weight and biases, and yes, if we are going to be train our model, means we are going to adjust the value of this weights and biases based on that loss function and the optimizer. And if we are going to be again retrain it, in that case also we are going to be adjust the value of the weight and biases according to your data. Okay, and that's a whole sort of a meaning of the training or retraining, right? So I think you understood about it, and if you don't know about this basics and all, then you can follow my previous video. There I already discuss about this thing in a very detail along with the practical, right? Now if we're talking about the LLM training process, so in the LLM training process, the 3 stage plays a very important role. The first step is called the unsupervised pre-training, or it is also called the self-supervised training, which we are doing on the common crawl data set. So generally we consider the internet data over here, the entire internet data. Okay, then the second thing is called the supervised fine tuning. Now inside the supervised fine tuning, I discuss 2 things. The first first behalf on the parameter, okay, and the second based on the data, right? I will again give you that recap. The third was the preference based alignment or preference based training. Now here whatever output we are going to be generate, right, from the AI, from the model. Okay, so based on that particular output, based on the feedback of the user, again we are going to retrain our model, right? So that comes under this preference based alignment. So here we have very popular algorithm that is called a PPO, right? It is a reinforcement learning based technique. Now apart from the PPO, we have one more state of art technique that is called DPO, okay, direct preference optimization. So we'll discuss that in our next video, okay? And even I will show you the mathematics and all in my upcoming videos. So guys, here my main focus onto this supervised fine tuning. Now let's take a recap of it. So as I told you, if we're talking about the supervised fine tuning, so we can divide into 2 sections, right? So one basically it is based on the parameter. Already I discussed this thing in my previous video. I'm just giving the recap of it. And the second behalf on the data, right? Now if we're talking about the parameter wise, so parameter wise, the first one is called the full fine tuning, okay, full fine tuning, and the second is called partial fine tuning. Okay, partial fine tuning. Full fine tuning means we are going to retrain all the parameters, okay, inside the model. Whatever parameters we have, we are going to train all the parameters. So generally we don't follow this particular technique. So we always go with the partial fine tuning, means we take subset of the parameter over here, okay, subset of the parameter. Now we're talking about the partial fine tuning, so we have 2 techniques over here. The first technique is called the old technique, okay, old technique. Now here's in the old technique, what we are doing, we are going to be freeze, okay, we are going to be freeze some layer, okay, and we are going to be train some layer, right, some layers, okay. But guys, in terms of LLM, we don't follow this particular technique, right? Instead of that, we have second technique that is called PEFT based technique, parameter efficient fine tuning technique. And in that, LoRA is a very famous technique, right? So LoRA is very famous technique. Now apart from the LoRA, I discuss couple of more variants of the LoRA, couple of more techniques. So if you want to understand that, you can watch out my previous video. There I discuss in a very detail, okay? So here you understood, we are going to perform the partial fine tuning, and in that we're going to discuss about the PEFT, and LoRA is one of the way to follow the PEFT, okay, to perform the parameter efficient fine tuning. Now the second is based on the data. So if we're talking about the data, guys, so data we could have, okay, let me take a different color over here. So data basically is available, right, in a non-instructional format, right, in a non-instruction format, or this is also called the plain text. Now this plain text, it would be available in any sort of a document, okay, in any sort of a document. Now this document could be the PDF document, this document could be the PPT document, this document could be the docx, right, this document could be anything, right, wherever basically we'll find out the plain text, that comes under this non-instructional category. The second type of data is called the instruction data, okay, instruction data. In instruction data, actually how it looks like, I will show you that. So instruction data, actually there we will be having input column as well as the output column, okay, as well as the output column. So guys, this supervised fine tuning, this specific term, actually it is being used in terms of this context, in terms of this instruction data, okay, where actually we have an input and we have an output. If you will think about the machine learning, right, so in the machine learning, guys, we have supervised machine learning, and in the supervised machine learning, what kind of data we have? The data where we have an output column, okay. So in whatever data we have an output column, and we are feeding that data to the algorithm, any algorithm, it's a decision tree, XGBoost or SVM, right, and behalf on that labels the Y column if my model is learning. So that is what? That is a supervised learning. In the same way, guys, this SFT actually is, okay, so because of this instruction fine tuning only, it is called the SFT, means we have an input column and the output column. So then what is this a non-instructional data? Okay, means it does not comes under the supervised fine tuning. I would say no, not directly, because this instruction fine tuning technique, right, it is only called because of that only we call it the supervised fine tuning. Why? Because we have a labeled over here, okay, the output column, right. Now guys, over here what we are going to be do, see, now one more thing, let me tell you over here. If we are talking about the LLMs, right, so whatever technique we are discussing, right, let's say in whatever stage we are, so let's say we are at first stage, at this particular stage, unsupervised pre-training or self-supervised learning, there also we are going to predict the next token, okay. Now if we are at this particular stage, SFT, supervised fine tuning, at this stage also we are going to predict the next token. We'll format our data in such a way that model will predict the next token only, right. And in the preference based alignment, or in this particular like technique, again we are going to predict the next token. So in whatever way we have a data, right, it doesn't matter, let's say we have a data, the entire internet data without label, in that case also we'll arrange a data in such a way that's going to predict the next token. If we have a data in the instruction in the output format, in that case also we are going to predict the next token. We'll format our data in such a way, we'll predict the next token. If we have a preference based alignment means we have generated output as well as the feedback regarding that, in that case also we'll format our data in such a way that model is going to predict the next token, okay. So as it is a language modeling, and model will always predict the next token in whatever way we have a data, okay, at whatever stage we are going to be perform the training, right. So I hope, guys, this thing is clear. This is the fundamental which I already discussed. Now let me talk a couple of more points. So here I have written why it is called the supervised fine tuning. So in pre-training, that is a first stage, right, there we are doing a training on top of the entire internet data, where actually that particular stage is also called the self-supervised learning, means the label will be the next token itself inside the sentence. So there actually what we are doing, so in the pre-training data, model predict the next token from the natural text itself, right. But if we're talking about the instruction fine tuning, there also model is going to predict the next text, but we have curated data in such a way that we will be having the target column, okay. So in instruction fine tuning, model predicts the next token only, but from the human curated target answer. I will show you the example, and because of that it is called the supervised fine tuning, means this instruction fine tuning is only called the supervised fine tuning. So guys, over here I can give you the quick recap. If we're talking about the LLM training process, so we have three stages: unsupervised, pre-training, or self-supervised. There's the first stage where we are going to be create our raw model. Second is called the supervised fine tuning, where we have already seen about the partial fine tuning, that is called PEFT, and that is a LoRA. Okay, this is based on the parameter, right? How many parameter we are going to be select while we are going to be train the model. Now data wise, how we are going to prepare the data while training a model. So we have two ways. First is the non-instruction, where we just have plain text, right? And second is the instruction based data. Now because of this instruction based data, we end up with this specific name that is called the supervised fine tuning. Okay, but guys, if we just have plain text, then ideally we should not say it's a supervised fine tuning. Means here we will say we are just going to be fine tune our model, okay, on top of our domain specific data. Okay, now I hope everything is clear. So let's do one thing. Let's take some example, and then after that we'll start with the practical, guys. Now guys, let's revise the differences between the non-instruction and the instruction fine tuning. And after that I will let you know why this instruction fine tuning is required, and then we'll move to the practical. So non-instruction fine tuning. First, let's discuss about this one. Non-instruction fine tuning. So fine tuning on a plain text means teaching the model your domain language. Now what's the purpose of it? So the purpose is to help a model to learn the language, tone, and the terminology is specific to your domain. Okay, so let's say if you have this type of data, the plain text which is available in any sort of a document. So on top of this data, we are going to be retrain, or we are going to be fine tune our LLM model. Now in which format we are passing our data to the model. So the data you will get at the end, you will get in this particular format. Means we are going to put the next token. Okay, so the next token will be in my output column. So let's say this is my sentence. Okay, so this is the next token regarding it. Now this is my sentence. Now here is the next token. Now this is my complete sentence, and this is the token, right? We already understood in a previous video. So let me give you one more concept over here. Let's say there is one company. Let's say there is Meta. Okay, Meta has trained one model. The model name is Llama 4.2, something like that. Now you want to be use this particular model inside your organization. Okay, so you belong to, let's say, pharma. Okay, pharma. Now in your company, in your organization, you want to be use this particular model. So what you will do? So you will directly take a model and start using it? No, this is not a right thing, because this model does not know the pharma specific term. Right, this model does not know about the pharma specific term, so it will hallucinate. So what you will do here, you will fine tune. You will go with the fine tune. Now here for the fine tuning, directly you will fine tune on the instruction data set. Means directly you will fine tune on the input and output data set. You can do it. You can teach your model. Okay, you can teach your model, if this is the input, then regarding that what will be the output. This is only called the instruction tuning. But guys, this is not a good practice. Okay, directly to teach your model on a input and output, it's not a good practice, right? So in between, what you can do, you can take your data, company specific data, okay, from wherever you have collected that. So you will be have a big corpus, okay, for your company data. Then first perform the non-instructional fine tuning. Now with this particular tuning, your model will understand your data, right? It will understand the specific vocabulary, it will understand the terminology, it will understand the technicality of your data. Means overall, it will deep dive into your data, right? And after performing this particular step, the non-instructional fine-tuning, then come to this stage where you are teaching to your model the more structured output based on the given input. I hope this thing is making sense. So that's why guys, this step, okay, most of the like YouTube video will not teach you this thing. This particular stage is very much important and I already covered in my previous video. You can go and check. Now coming to the instruction fine tuning. So in the instruction fine tuning, you will get a data, right, in the form of instruction, in the form of input. Okay, so let's take an example of it. So first of all, let's discuss the purpose. So what is the purpose of it? To train the model to understand instruction and generate well structure and the relevant answer. Okay, so to generate a structure and the relevant answer based on the given instruction. So you will find out a data in this particular way, in this particular format, where you will be having the instruction, you will be having the input regarding the corresponding input and the output. So instruction, summarize the following paragraph. Now this is the input regarding it. Okay, and we are going to be summarize. So this is my summarization. Here is my summarize output. So after giving this particular input, we should get this kind of output. Okay, so this is my instruction. Now without input also you will find out some sort of a rows. So let's say you have an instruction list application of AI in pharmaceutical research, means here you are giving input and then this is the corresponding output. Okay, now here one more example. So explain a mechanism of the MET format. Now we don't have any sort of input. Now here is my output. Okay, so in this way also you will get a data. So this data set format was followed in the alpaca, right? So if you will check with this alpaca, right, so this is one of the data set which was prepared by the researcher. I will show you the research paper and the Hugging Face dataset and all everything. I think I showed in my previous video. You can check over there, right? So in this format only the dataset have been prepared. But apart from this one, you will find out dataset in some different format also. So this is the one format: instruction, input, and response. As I told you, this is the alpaca, right? Apart from that, you will get the instruction. This input could be the context, and this response could be the answer. In this format also, you can also prepare the data. You can directly prepare the question answer data as a user and the assistant. Okay, in user column you can give your questions, and in assistant you can write your answer. You can give the you can prepare the data in this format also: system, user, and assistant. Okay, this is also a way to prepare a data for the instruction fine tuning. Otherwise, context and response. See here I kept one example for the context and the response, guys. So I hope this thing is clear in which format actually you will get a data for the instruction fine tuning. Now here is one more point I written. I missed this part, so you can read it out. If instruction uses as extra text, means if you have a instruction and the input, right? So in that case, mostly you will find out we are saying to the model, do the summarization, translation, rewrite. You can go ahead with this particular example. So here we are giving an instruction to our model with respect to this input, and then we are generating this output. Now here you can see the second line. If instruction is a self-contained, okay, if instruction is having the self-contained context or dialogue style or conversational data, then you can keep input empty, means this thing, right? I just written it as an extra note, and I think you are able to get it. What I'm trying to say here means, if we have an instruction, then we are giving an instruction with respect to this corresponding input. If we don't have any sort of an input, means in the instruction only we are keeping some context, okay, some question, and regarding that here is the output. As simple as that. So I hope guys you understood this entire thing. Now the biggest question, how you are going to be generate this instruction data, because in every company, let's say if I'm taking example of any XYZ company, any ABC company, or any YXZ company, everywhere you will not find out this kind of data. Okay, sorry, not this kind of data, means instruction data. So what is a way of preparing the data, the instruction data? Okay, the first way, see here, now the question is how to prepare the data for the instruction fine tuning. Means in your company, let's say the data is available in the PDF, right? So this is the biggest hurdle. You have trained, you have done the non-instructional fine tuning, but how you will teach your model to generate the structured answer, right? So for this one, for generating a structured answer, you will have to prepare that kind of data, input and output. How you will do that, right? So here is a way. First, you can do it manually. You can write your own like question, means you can only create your question and answer, right? But you cannot do it for very huge scale. Here the accuracy would be very, very high, but this could not be ideal. If you have very less data or maybe mediocre data, in that case maybe you can do it, but this is not ideal situation, right? The second thing is SME. So again, it's a manual way only. Expert is doing that. You are like hiring some intern and all for doing this specific thing, or some SME just do it for doing this thing, or like so many people are working in parallel, then this process could be faster. But again, this human annotation is not an ideal thing for the bigger data set. So the last thing is the LLM synthetic data. Means here to the LLM only you can give some instruction. Not instruction, I would say instruction will be the like confusing. Here to LLM only you can provide some prompt, okay, some guides, right, to the GPT kind of to GPT model, to Cloud model, right? So those model only can prepare your instruction data set. Means let's say you have a plain text. This text you are feeding to your GPT model and you are saying, can you prepare some question and answer from this particular text? GPT model will do it for you. So this is the one of the way, and company is following this specific way. Like they can generate a LLM synthetic data. Now guys, the next thing is, let's say if you have a data in this way, okay, but how the LLM will look into the data, okay, means it will be like this: instruction, then input, and then output, right? Separate one, like we are having in the machine learning. As I told you, this is a supervised learning, right? Supervised. Why it is a supervised? Because we have a human curated output over here. But actually, this is the language modeling. Language modeling means we are doing a next token prediction. Okay. So at the end, we'll have to format this data in such a way that so that LLM can perform the next token prediction, right? So let's say this is my data, instruction, input, and output. So here you will be formatting your data in this way. So here is the instruction, then this is the input, right? And here you can see the response, guys. Getting my point? So here, guys, the native, right? The native role or the native behavior of the LLM to predict the next token only, right? So because it is a language modeling, the native behavior of the LLM to perform the next token prediction. So for sure, in whatever way we have a data, at the end we'll have to prepare a data in such a way that model can perform the next token prediction. So let's say we have instruction, input, and output. So for sure this is a supervised data because we have a label over here, but at the end we'll feed the model in this specific format. Okay, means input and instruction what will be there along with the responses, and model is going to be learned from this specific responses. I hope this is getting clear. Now let's see why this kind of tuning is required, why instruction tuning is required. Then we'll move to the practical. Now guys, let's understand why this instruction fine tuning is required. Let's take a look onto it. So here I written a base LLM like Llama, Falcon, GPT, or any LLM model. It only knows how to predict the next token. Okay. So I written over here. This means it understands the pattern only, pattern of the data, and based on the pattern only, it's going to be decide what will come next. Okay, next token or sentence prediction. So here is the example. You can see the example. We have an input. Metformin is used for. So this will complete the text. The output will be the treatment of type 2 diabetes mellitus. Okay, this is fine. But guys, if we are giving this kind of prompt to the model, like explain this, summarize this, write this, translate it, or what it is, right? So in this case, the model is going to be fail, means model will not generate the appropriate answer in a model will not generate a answer in a natural language, like how we human are talking, right? So that's why guys, the instruction fine tuning is required, and that was the like successful mantra behind the chat GPT, right? How chat GPT is giving the human curated answer, right? Human compatible answer because of this instruction fine tuning. So let's say yeah, here is example. If you will ask the model, write 3 points or metformin mechanism, so it might respond with something like this: write 3 point on metformin mechanism is request. Means it will just predict the next token instead of giving the 3 bullet point or 3 points. Okay, now because of this, right, because if we want a instruction like a structure answer, or if we want a relevant answer, right, if we want an answer in a human curated form, for that only this instruction fine tuning will be required. So here I written, so the conclusion is to teach the model the meaning and purpose of different prompts. Okay, so for the different prompts we perform this instruction fine tuning. Now in the instruction fine tuning, how the data will look like, as you know, right? And what will be the result? So result could be anything, whatever user is asking. So I hope you understood why this instruction fine tuning is required. Now without wasting a time, let's start with the practical. Now guys, let's start with the practical of the instruction fine tuning. So in this IPYNB file, I kept the entire code. Now in the previous video, I have shown you the practical of the non-instruction fine tuning. This entire code is already available on my YouTube channel. Please go and check the description of the previous video. You will get the link of this GitHub. Okay. Now in the previous video guys, I have used this particular data matformin.pdf. So inside this PDF, I'm just having one single page. Okay, but in the real time, the data could be very huge. Now guys, this was the non-instructional data, means the plain text. So I trained my model on top of this data. But in this video, we required the instruction data set, means we required the question, means the instruction and the corresponding responses. Okay, so I already created a data. I will show you in some time, right? Now over here guys, I'm going to use the same model which I trained in the previous video. Okay, so what is my ideology over here? Let me talk about that what I want to teach you. So let's say we have one pre-trained model. Okay, so we took the Llama model. This is from the Meta. Now I got a problem statement that okay, I have to fine tune this model for some pharma data, right? So I downloaded this model, this pre-trained model, which was this one, Tiny Llama 1.1 intermediate step 1431K3T. Okay, this model is a quite small, that's why I have used it. Otherwise you can use any sort of a model if you have a good infrastructure. Now guys, I took a pre-trained model, I trained it. Okay, I performed the non-instruction fine tuning on plain text. Okay, now why did I perform it? So that I can teach my model the specific terminology. Okay, I can make my model basically this farmer ready. Now I will teach my model to follow the instruction. Okay, now what I'll do, I will do the instruction fine tuning, okay, on instruction data set. So guys, I have a data set, the plain text and all. I taught my model basically the language, the tone and all, everything. Now I will take this instruction data set and I will teach my model how to respond with respect to the different questions. Okay, then in the next video I will discuss the preference alignment. So based on the user preference, okay, which response needs to be picked up. So the next video I will upload with respect to this preference alignment. So as of now we are over here. I hope you got it. So guys, whenever so when I was training this model, right, so I already saved this model. So let me show you. So I already saved this model under this directory. You can check with my previous video. Okay, I shown you over there. And what I did after that, I zipped the model. Okay, and I downloaded that so that I can use it anytime. So here what I'm doing, I'm going to be basically unzip this file, this tiny LoRa.zip file, and then I will load my previously trained model. So first of all, let me load the tokenizer. I'm going to be execute this one. This is perfect. I think you are able to understand it clearly. Now let me run this. Okay, let me import all the necessary libraries. So here I think you are already familiar with all these libraries. Okay. Now what I'm doing, guys, I'm going to be load the tokenizer. Tokenizer is very much required to perform the tokens, to get a tokens, okay, and the token ID with respect to the data. Now here what I'm doing, guys, I'm going to be unzip the model. See, here is my model, this one. After unzipping it, I will get like this one. This is my folder. I already run it, that's why I'm getting it. But if you are running it first time, you will means if you have this zip and basically if you will run it, then you will only get this checkpoint, right? So I'm going to be execute it and see, after unzipping it, I'm getting this checkpoint -5. Okay. Now guys, I got my model. Now let me load my model. So this is my model path. So what I'm doing, I'm passing it to this particular method, auto model for causal LM from pre-train, and here I'm passing my model path, okay, and device map is equal to auto. So I got my non-instructional model, right? Now what I can do, guys, after loading this model, so it might take some time if you are doing it first time. Now I am giving my prompt. This is my prompt: clinical trials demonstrate that whatever, right? Now what it will do, it will try to predict the future tokens, okay? So it is not any instruction, it is not a like a specific question, it's just a simple sentence, okay, and it will try to complete this sentence. So here's my prompt. First I will tokenize it, then I will pass my input, okay, and these are the other parameter. I will discuss this parameter, it's very easy to understand. So how many max token would be there in the output, temperature means whether my output will be creative or not, okay, top P is also belonging to the same thing, right? So this parameter will discuss in the upcoming session. I will discuss some more theoretical, more like a mathematical point, okay? So there we can talk about it, or else we'll discuss any sort of a API, right? OpenAI API, Cloud API, and there also basically we'll get this parameter, and for sure we can discuss. Now here I got the output, see, let me show you the output. So first we'll decode it, and after the decode, see, you will get the output. See, clinical trial demonstrate that combine atorvastatin with ezetimibe is a safe and effective to treatment of the like cholesterol. Okay, so like these are some pharma related terms, some disease specific term, even I am not familiar with it. So see, it is able to generate the response, right? Now what I'll do, guys, so here first of all let me show you how the instruction data set look like, and then I will take the same model, this non-instructional model, and then we'll try to perform the fine tuning. Okay, so to just give you the demonstration, see what I did, I'm loading this pre-built data set, inbuilt data set from the Hugging Face itself. It is already available inside this repository, AMOD repository, and the data set name is this mental health counseling conversation, right? So once I load it, guys, see, I'll get the data inside this variable, data set variable. Okay, now here if I can show you the data, see this data, okay, is data set. So let me write over here data set. So I got the data set. Now inside the data set I just have two columns, context and the responses, okay? And how many rows we have? We have 3, 5, 1, 2 rows, right? Now I already downloaded this data set just to showcase you. I downloaded in both format. In any format basically you can keep the data. So this is a CSV format. Let me show you the CSV first. Okay, so inside this CSV you will get the context and the responses, right? So as I told you, this instruction fine tuning data set, it could be available in any sort of a format. Even I given you the example over here. So instruction input response, instruction context answer, user assistant, system user assistant, context and response. So inside this data set, which is already available over the Hugging Face, okay, so inside this data set basically you will get two columns. One is the context and second is the responses. Now see, the same data set basically I saved in the JSON format also. So yes, for sure you can keep it in both a format, right? Now what I'm doing here, so I loaded the data set. Now I am going to be formatted. So here basically I will be having my question, means this context is nothing, it is a question. This response is nothing, it is an answer. Right now I'm going to be combine both, and after that I'm keeping inside this text column. So let me execute it. So after executing it, guys, see what I'm doing, I'm mapping my entire data set.map, okay? And here I'm mapping my function. My function name is this format row. Okay, so once I'll do it, guys, I'll be getting my formatted data set. Let me show you. So here is my context, this is my responses, and this is my text. Okay, so see over here. So instruction, what is the instruction? INST. Okay, it is a instruction. So this is the instruction. I am going through this, that, right? And then with respect to this instruction, here you can see the final responses. Okay, so what I did, guys, I formatted my data set. Means either I can keep this context context and response. Okay, or I can keep it like this, instruction and this slash instruction. So instruction is only representing the question, and the slash instruction is representing to the answer, right? Now over here, instead of writing this instruction and question, I can simply write this context, means hash 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 context, okay, or like this context and then response, right? Let me show you how I can keep it. So you can keep like this. So let's say here is your context and this is your response. Now whatever text column you will get, so whatever text column you will get like this, means instead of the instruction you will be having the context, and then instead of the slash instruction you will be having the responses. Okay, in any sort of a form you can keep it, but over here what I wanted to show you that I have to pass my data as a final string only. Okay, this context and responses. Now what I did over here, see, I created a data frame of this data set, the data set which I loaded. Now see, context and responses, you will get the context and responses under this data frame. Okay, then what I did, I just saved it. So here I already shown you this file, right? So I can basically load the data from the Hugging Face. I can save it in my local, or else if I have a data in my local, the CSV data and all whatever, right, I can simply keep it over the Hugging Face. I can compatible into the, I can create a compatible data set, okay, with respect to this Hugging Face. Everything is possible, right? So see, I have converted into the JSON, I converted into the CSV, and both way it is possible. I hope this entire thing is clear. So this is just, guys, this is just a this is just a demonstration that how the instruction data look like, okay, and how to format it for the training. Now in my case, in this particular practical, I am going to use my own data set, means I'm not going to be use any pre-built data set over here. I will be using this particular data. See, let me show you this CSV. So under the CSV, basically you will only get 5 to 6 rows. See how many rows is there. I just have 1, then 2, then 3, then 4 and 5. Okay, only 5 row. Now I have an instruction. Okay, this is the output of it. Then again instruction, output of it, instruction, output of it. Now instruction, now this is the input, and here you can see the output of it. Then instruction, here you can see the input, and this is the output, right? So guys, you can read this data, you can analyze this data. On top of this data only, we are going to perform the training. Okay, we are going to perform the fine tuning. Now guys, here what I shown you how the pre-built data set look like. It could be in any sort of a like there could be any sort of a column, right? And here what we are doing now, guys, we are going to be load our own data set. This data set actually I created by myself manually. Okay, you can create it using the LLM, you can take a help of any SME, subject matter expertise, right? And you can generate this instruction data set. Now how ChatGPT has done that? So ChatGPT actually took the conversational data set. So conversational data set from the Reddit, from the Quora, from the GitHub, from the different places. Okay, but if you are doing for our domain specific problem statement, in that case we only have to create this data set. Okay, so I kept the data in both formats, CSV and JSONL. In the real time also it could be in any sort of a format. Okay, now I'm going to be loaded in a CSV format. So let's load it and perform the formatting. Now guys, I loaded my CSV data over here with this function load data. Then I am passing this parameter CSV, then I am passing my file path. Okay, and then I am writing split is equal to train, means whatever data I am going to be load over here, it will be a train one. Now inside the data set you can see we have 3 column: instruction, input and output. I can show you over here, this is my data set which I am using. Okay, now what I'll do, so after that guys, I will format it as a single string. As I told you, whatever data goes to the LLM, okay, it goes to as a single string, right? So let me run it, let me execute it. See, if you will see this formatting prompt, so we have an instruction, right? Instruction will come over here, then we have an input. Okay, the example will come over here, and then response. Okay, so example input will come over here, then response, then example output will come over here. Okay, so here guys, if I will run it, and after running it I can map it. Okay, after mapping it, see inside my data set I am having 4 column now: instruction, input, output and text. Now this particular column, this text column, we are going to use it for the training. Now let me show you the first row over here. You can see, so we have an instruction, then we have an input, and then we have corresponding responses. Okay, this is my responses. Now if you want to check with the CSV, now over here check with the CSV. So this is my instruction. Okay, and then in the input I don't have anything, it will be blank, then I have an output, right? So this first row is going to be combined, likewise the second row will be combined, third row will be combined, fourth row will be combined. Means first row will be combined and that will become my one string. I will pass it to the LLM for training, likewise the second row, likewise the third row, fourth row, and so forth. Okay, I hope you got it. So guys, this is my data. I have formatted my data. Okay, so first row, second row, third row, fourth row means whatever column we had over there, we just combine that and we'll be passing as a single string. And in that column, what we have our instruction and the responses of it. Now guys, see, this is the row which looks like this only. Over here you can see we don't have any sort of an input is none, and then we just have the response. If the input would be there, then instead of the none, the actual data for the input will be passed over here. Now I'm going to be initiate my tokenizer. Okay, now I'm going to be tokenize my data. So after tokenization, guys, see here I'm going to tokenize my data, means I'm passing my single example, my first row. Okay, now I'm taking the text from there, means this particular value. Okay, then I'm going to be truncate is equal to true. If max length basically if it is going to be exceed to the max length, then we are going to be truncated. Okay, otherwise we are going to be pad it if it is less than this 512, right? Now here is one more line, token labels is equal to token input IDs dot copy. So why I am doing it? So as I told you, the behavior of the model, so the behavior of the model is to predict the next token. Okay, so by using this line, basically I am telling to my model, so whatever data you will get, whatever text you will get, this entire row. Okay, so you have to train yourself in such a way that you are going to predict the next token. This all the thing I already discussed in my previous video. There also I have used the same technique. At some of the places I have seen, what I have seen, guys, so they are going to be mask the value till the responses. Okay, so till the responses they are going to be mask the value, means model will get to know, okay, so this till here basically I have an instruction, I have a question, and after that my response is coming. So how I will mask the value till response, means this particular value I can put any special toggle, like let's say I can put -100 over here. So here to here whatever token is going to be create, so for those token all the value will be -100 and the actual token will be assigned from here itself. Okay, actual token will be assigned from here itself. So this kind of technique also I have seen, right? So just to teach the responses to the model, we take this kind of we basically go ahead with this kind of technique also, right? But yeah, this is very effective, means we can entirely copy this input ID to the labels. What does it mean? Means I'm not going to be mask anything. Model from this particular text, model will learn how to predict the next token, right? So here is the all the thing is done. Now what I'm doing, guys, I'm going to be load my I'm going to be basically load the model as a LoRa model. So from the PEFT I have used this LoRa config, then get PEFT model, then task type. Now here whatever basically parameter I have used, you can see the description of it. So task type means it's a causal LM, means the next value prediction, next token prediction. Now here R is representing to the rank, so this could be the rank. Okay, control to enable parameter size. Now here LoRa alpha, it's a scaling factor, so the value will be between this one. So balance, adaptation and strength. Now LoRa dropout, so dropout probability 0.5, so it's a regularization value. Target module, which layer to tune, so I want to tune this query and the value. Trade-off between cost and quality, means you can select the other layer also. We have a key query value, right? So you can select the different layer which is remaining, the next one. Okay, then biases fine tuning none, keep simple. Okay, so over here guys, we are going to be mention this parameter, but under this particular class LoRa config, you will find out so many parameter. So maybe after discussing the mathematics of this LoRa, we can talk about it, right? So here is my LoRa configuration, guys. Now what I will do, I will write get PEFT model. So here I will pass my non-instructional model which I trained in my previous video, and here I am passing my LoRa configuration. Okay, now I will be getting my LoRa model. See here I got the LoRa model. Now what I'm doing, I'm going to be define my training argument. So tiny llama instruction, here I will be getting my instruction model. For 3 number of epoch I'm going to be train it. Okay, per device train batch size, means how many batch in how many batch we are passing a data. Gradient accumulation step, so at what all step we are going to be calculate the gradient. Learning rate regarding the optimizer, it's a precision value. Logging step, at which step we are going to be log the value. Save total limit. Okay, Now repeat report to none means we are not going to be capture any sort of a matrices anywhere on any platform. So this is my all the argument, guys. Now what I'll do, I'll call this train method. To this train method I'll pass my model, I'll pass my argument, I'll pass my tokenization, right? Now my trainer is ready. Now what I'll do, I'll call this train. Okay, so here guys, see my model is getting trained on top of this data set. Now my model got trained. Now here actually you will get the model. See tiny llama instruction, this is my model. Okay, and under this you can see I have a checkpoint 3, and see my model got saved over here, adapter model dot save tensor, right? Now let me execute it. See, this is a model path. Now after that what I can do, I can load my instruction model. Now here guys, see this is my instruction model. Now I can give this kind of question to my model, explain the mechanism of the action of metformin, right? So earlier guys, I was not maybe I cannot give this kind of question to my model, it will definitely hallucinate. Okay, we'll compare that, don't worry. But guys, now after the instruction fine tuning, we can give this kind of question where, see my data set is very small, I just train it for very simple epoch. Okay, my model is also very small one, so it might not predict correctly. But if you are doing it on a full scale with a good model, with a good data set, with a huge data set, okay, that definitely this technique will work. So here is my prompt. Now what I'll do, I'll tokenize the prompt, I'll pass it over here, means I'll pass all the tokens over here. Okay, now let me take the output. So here guys, you can see the output. So what output is generating? Clinical trials demonstrate that combined atrovestine with azitimb is a safe and effective for treatment of the hypercholesterol. Okay, so guys, here I ask, why explain the mechanism of the action of the metformin. So see, it is going to be explain everything, right? So it is going to be explain everything in the normal human tone. Okay, now over here guys, you can see, so this is all the data which I have. Now guys, I load the CSV data. You can load the data in the form of JSON also. Okay, and this is the pre-built data set which I took from the Hugging Face, means I shown you how to load it from the Hugging Face, and even I shown you how you can save it, and after saving it anytime you can load it. Okay, or else if you will get the data in CSV and JSONL, then from there you can easily load everything I have shown over here. Now I hope guys this thing is clear. Now let me show you one more thing. I was telling you that basically before the responses, okay, we can mask the value so that model can easily understand my response is getting started from here. So I took one code over here. Let me show you. So see what is happening over here. See, we are taking a data set. Okay, we are loading a data set, we are formatting a data set. After that we are passing it to the tokenizer. Okay, the tokenization and all everything is done. See here basically I'm going to be initialize my tokenizer. Now see, I'm getting my text. Okay, now after that guys, see I'm getting my input IDs, means my tokens. Now here I am writing response marker. So this is my response marker. Now wherever I will find out this response, or from wherever the response is going to be, start response, answer, whatever you can say. Now over here what I'm doing, so I'm going to be mark it. Okay, I'm going to be mark it with this. See, till the response actually I'm going to be marked with this -100. Okay, so till the response actually I'm going to be mark it with -100 with this special token, and after that the normal token would be there. So what does it mean? The mean is very simple. See here I have written clone labels and mask out everything before responses. So the meaning is very simple. My model will be able to discriminate between the instruction as well as the responses. It will get to know, okay, till here means this is a special token, means this is my input, or like my instruction, and after that my actual response is getting started. Okay, so both training you can do, you can try out with this one as well as the previous one. Okay, you can check which one is giving you the effective result. According to me, the previous one is a good one, because here there actually my model is learning onto the my model is iterating onto the entire string. Okay, the entire row, right? Text, the instruction, input, and this responses. Okay, now here till response we are masking, and after that only we are allowing to model to learn through some tokens, right? So yes, I have like written this logic over here. You can go through with it. I have seen in many like places people are following that, so that's why I given you this particular like solution as well. Okay, you can try it. Here is the entire code. Now guys, so I kept some question. Okay, and what I'm doing over here, I'm going to be check with my non-instruction and the instruction model what is going to be the answer, right? So I have both model, instruction and the non-instruction. So see, this is my question. Now what I'm doing, I'm iterating over the questions. Okay, now I'm tokenizing it, and after tokenizing it guys, I'm passing to the non-instructional model. I'm generating output, and then printing the output. Now here what I'm doing, I'm going to be load the tokenization model. Sorry, I'm going to be load the tokenizer. Then I'm loading the instruction model. Okay, and then I'm going to be perform the then I'm going to be generate the answer with the instruction based model. Okay, so here I'm going to be generate the answer with the non-instruction. Here I'm going to be generate the answer with the instruction. So you will be able to understand. Okay, so if I'm asking this kind of question like explain this, summarize this, what is this, what is that, so instruction model will be able to perform good compared to the non-instructional model. So that's why guys, instruction fine-tuning is required. See, my data set is very small, my model is also very small, so it might not give the correct answer. But if you are doing it really, first teach your model on your domain specific data set, on your PDF text and all, and later on perform some instruction tuning. It will work well guys. It is proven technique. Okay, ChatGPT also did the same thing, right? First they have trained the entire data, first they have trained on the entire internet data, the self-supervised learning, and then after that they have trained it on a question answering task from the Reddit, from the Hugging Face, sorry, from the like different forum like GitHub, Stack Overflow and all, right? So let's run it and let's see what is going to be answer. So here it can predict it. See, the answer, explain the mechanism of metaforming. So it is saying explain the metaforming is dark. Fine. Now here, okay, expect output test case. Okay. Now here it is saying summarize how MRN. So guys, it is predicting something, right? Some garbage thing. Okay, you can try out from your end, you can check, right? You can take some more data and then basically again you can retrain and check that out, right? I took the very specific question, just 4 to 5 row guys, with respect to LLM is nothing. Just take some good data set, retrain your model, okay, on the instruction data set and check. Okay, means first take the base model, check with the non-instructional data, means some PDF and all, train it, and then ask the question, and then again do one thing, create some instruction data, give your model, so model will learn how to follow this prompt and all, and then again ask the question to your model and check, okay, in which way it is performing well, in the instruction way or in the non-instruction way, right? So fine, thank you guys. I'll see you in the next video where I'll discuss about the DPO techniques and all. Thank you. So here I kept the complete points guys. So we'll learn about the preference alignment or preference training. Then we'll understand why do we do preference alignment, means why it is required. Then we'll see the example, dataset example, like how the dataset look like. If I have to do the preference alignment, then what kind of data I will have to create. Then we'll see techniques for the preference alignment. So what all technique we have? We just know about the RLHF, that is called reinforcement learning through the human feedback. But that is not only one of the technique. We have a couple of other techniques. So definitely I will discuss onto it. And even I will show you the research paper. Then the very famous, infamous technique for this preference alignment, that is called DPO training. So we'll understood about the DPO training. We'll see the mathematical formula. I'm not going to show you the complete mathematical intuition along with the derivation and all. I will just focus on the formula and we'll discuss about that formula. Okay. Then we'll see the practical implementation with the DPO itself. So whatever model I had, means whatever model I trained in my previous class, the instruction fine-tune model, I'm going to take a same model and on top of it, I will perform the DPO, that is called direct preference optimization. Then during the practical, I will show you the LoRa adapter, means how you can use the LoRa adapter. Why you should not directly implement the LoRa. Okay, if you are going to be use the already fine-tuned model. Okay, how to use the LoRa over there, definitely I'll show you. That comes under this LoRa adapter. So yes, we are going to discuss all this point throughout this tutorial. Now after this tutorial guys, you will be you will like become a champion in the preference alignment, and you can basically fine tune. Okay, you can train any sort of a model on top of the preference data. Now let's start with the theory, then I will come to the practical guys. Now here guys, I created a step-by-step notes for all of you so that you can refer it later and you can revise your concept. Now before starting this thing, let me show you the notes from the previous session. So for that, I have created one repository with the name of this complete LLM fine tuning. There only I am uploading all the notes and all everything. Now where you will get a link of this repository, so you will get inside the description of the video. Okay. So here I created a repository for the LLM fine tuning 14, for the 15 and 16. So the 16 basically it's a current video. Okay, now I likewise I will create for the other basically video also. I'm getting so many requests, sir please upload all the notes and all, so definitely I'll update this particular repository. Okay, now guys, if you will go and check with the previous repository or with the previous nodes, right? So here it is. Let me show you. So see all the files and all, everything I kept. Handwritten notes is there, IPYNB file is there, CSV file, JSON file, even the GIF file, model GIF file also I kept, right? So you can directly download it and you can start your practice. So guys, this was the handwritten notes. Now here I discuss some fundamental thing. So I discuss about the LLM training process. So the first step of the LLM training process is called the unsupervised pre-training or self-supervised training. So here we get the foundational model, okay, at this particular stage. So we are not going to perform this particular thing from our end, right? We are taking any foundational model from the Hugging Face or from any other places. Now our aim to perform the fine tuning. Okay, so regarding the fine tuning, I shown you the supervised fine tuning. So I shown you two way, one with respect to the non-instructional data, and the second with respect to the instruction data. Okay, the instruction data one is specifically called the supervised fine tuning, but if we have non-instruction data, in that case also we can fine tune the model. I shown you each and everything. You can refer the previous video. Now in this video we'll discuss about the third point, okay, preference based alignment or training, right? So these are three main stage of any LLM training, right? And now we are going to discuss this third one, and after this means after this video you will find out video on top of the different framework, okay, because in this video we'll complete the third stage, the last stage of the LLM training. Now guys, let's start with the theory of the LLM based alignment or preference based alignment or preference based training. So guys, to align or train a model with a human expectation or with a human preferred data is called preference alignment or preference training. So this particular technique was introduced by the OpenAI in Instruct GPT paper. Don't worry, in some time I will show you that particular paper, and definitely you can refer that. Now why we do it? We do it to get a safe, helpful and the honest model. Maybe you're not getting couple of things just by reading this particular definition, but you will get once I will show you the different example. So here I kept one example. Just read out this statement. So user is asking one question to the model. So the question is very simple: how do I lose my weight? Okay, how do I lose weight faster? Something like that. So I have a fine-tune model. Let's say this is the instruction fine-tune model. Now it is answering. It's a simple thing. What you have to do, you just have to stop eating, right? Just stop the eating. Give me a moment. I think now it's fine. Yeah. So just stop eating so much. Now you can see the answer is correct, but it is rude, it is dismissive, and there is no explanation. Means it is not aligned with the human expectation. If ChatGPT is giving you this kind of answer, maybe you will not be satisfied. The answer should be according to the human expectation, right? So let's say this is the output from the instruction fine-tune model. Now just look into the one more response, right? Now just by seeing this response you will be more happy. And nowadays from the ChatGPT or from any basically large language model, we are getting this kind of output because the model further have been trained on a human preference data. Okay, now just look into the another answer. Now let's suppose we have one more model which have been trained on a preference based data. So the answer is safe weight loss generally happen gradually. Okay, you can start with a balanced meal, regular movement, adequate sleep and hydration. If you have medical condition, it's best to get a personalized plan from a professional. I can help you with the simple step if you want. Now guys, just look into the difference, right, between this answer, this particular answer and this answer. So if you want to generate this kind of answer, right, so maybe you will have to take one more step with respect to your LLM training. You will have to perform the RLHF, RLAIF, that is called reinforcement learning through AI of generated feedback, or you will have to perform the DPO, that is called direct preference optimization. Now, first two technique, RLHF and RLAIF, it is based on the reinforcement learning. And the second technique, DPO, it is a simple supervised training. Okay. So yes, definitely we'll discuss. Now, here you can see in the second one, in the second output, you can see the answer is having a correct tone. It is a respectful, right? And it gives the proper explanation with the like it is a more helpful answer. Okay, it's a more human aligned answer. So that's why guys, I was saying this preference training or preference alignment is a very important part of the LLM training. Now coming to a couple of more example. So here I kept one more line. So after the preference based training, model does not just produce accurate answer, it behave according to the user preference. Okay, it behave according to the user intention. So that's a like key difference between a normal fine-tuned model or a aligned model like GPT-4, GPT-5, 5.1, 4.0, 4.1, whatever like latest and the state of art model you can see. Now why we do this preference training, guys? So this preference training we do to improve the safety and ethics of the model. We do it for generating the helpful answer, for the more polite answer. Okay, we teach the model so which can respond like a human, means which can response in whatever way the human wants. I kept one more example, maybe with that your understanding will be a bit more clear. So how I can lose 10 kg weight in 1 week? So if we have a normal trained model, so see how it is going to be generate answer. You can stop eating, drink only water, and take fat burner pills. This will reduce weight quickly. Okay, so just suppose this model basically it has not been trained on a human preferred data, right? Now here guys, you can see the another answer. Now another answer is rapid weight loss 10 kg in a week is unsafe. Okay, and it is medically harmful. A safer approach is just to lose 0.5 to 1 kg per week through balanced diet, hydration and activity. If you have urgent concern, please consult with a doctor. Now guys, tell me which answer you will refer. So you will refer this particular answer or this particular answer, or which is a more ethical, which is a more safe answer. So definitely this answer is a more safer compared to this one. So in the human preference training, in the preference alignment, basically we teach to the model to behave like this. I hope you are getting my point now. Now we'll see the different technique, what are technique we have, and we'll look into the DPO formulas and all, and then we'll go for the practical, guys. Now guys, let's see the dataset example. Let's see how the data looks like for the preference training. So here I kept the example for all the three methods. The first one is for the non-instruction fine tuning as well as the unsupervised pre-training. In both cases, the data will be the plain text. Okay. Now how the input and the output column will look like? So the output column will be the next token. Okay. And the continue word. So let's say this is my sentence. Now what is the next word of it? This is the next word. So this will be my output. Now see, this is my complete sentence. Okay, till oral. Now what is the next word? This is my next word. Now here you can see this is my complete sentence. Right? Now what is the next word? This is the next word. So inside the non-instruction fine tuning or inside the unsupervised speed tuning, what we are doing? We are predicting a next word. So the next word will be inside the output column. Okay. Now how to decide the length of this input and output? So for every model we have one specific context length. Okay, so according to that we can decide, right? Now the second is the instruction fine tuning. Now in the instruction fine tuning we will be having 3 column or sometime you will only get 2 column. Okay, so the first column is the instruction, the second is the input, and the third is the response. In this particular format you will get a data, or else the data would be like this: input, context, and the answer. Or the data might be like this: user and the assistant. Okay, or sometime you will see context and the response. Means The moral of the story is we will be having one input column and the corresponding output column. Okay. Then how to format this data and how to utilize it for training the model. If you want to know everything in detail, then please go and check with my previous video, right? Now, how the data look like for the preference training? That's the main agenda of this video. So inside for the preference based training, guys, you will find out three main column, right? One is the prompt, second is the chooser, and the third is the reject. Now this two is very important. Choose, right, which one is going to be select, and which one is going to be rejected. Now let me show you some real example from the Hugging Face itself. So here is a data from this Anthropic. So Anthropic is uploaded one data. Okay, the repository itself is Anthropic, and the data set is called the RLHF. Okay. Now here inside this particular data, you will find out two column only. The first is a chosen and the second is a rejected, right? Now you can see the another data. So inside, see this data basically it is available inside this ARGILLA repository, ARGILLA, right? So the data set name is Ultra Feedback Binarized Preference Clean Data. Now inside this particular data also you will find out two main column. First is the rejected, and the second column will be the chosen. Okay, along with the given prompt, right? Now here is a third example. So this is available inside this ZinLai repository. So the dataset name is Math Step DPO 10K. Now inside this particular repository also, inside this dataset also, you will find out two main column. The first one will be the chosen, okay, with respect to the particular prompt, and the second column will be the rejected. Okay, so see here is a rejected. So choose and reject, right? Select or reject. This will be the two main column inside any preference data set, right? Choose means which one we are going to be select, and reject means which one we are going to reject, right? I hope this thing is clear. Now let's see the technique, guys, and then what I'll do after that I'll show you the DPO formula, okay, and then I will jump to the practical. Now guys, let's see the technique for the preference alignment. So the very infamous technique that is called RLHF, reinforcement learning through human feedback. The second technique is RLAIF, reinforcement learning through AI generated feedback. The third is DPO, direct preference optimization. Now these are the algorithm KTO, PPO, IPO. It's a reinforcement based algorithm to implement this RLHF or RLIF. In RLAIF also we use this particular algorithm. Okay, so what's the full form of this algorithm? Just for the general knowledge. So KTO is called the Kahneman-Tversky optimization. PPO stand for proximal policy optimization, and this IPO stand for implicit preference optimization. Now this is a very famous technique, guys. Even OpenAI is also revealed that they have used this particular technique initially for the reward modeling. Okay, PPO, proximal policy optimization. It is a reinforcement based technique. Okay, reinforcement, it's a like reinforcement learning algorithm. Now the technique is RLHF. What is the core idea? The core idea to train a reward model using the human feedback. Now what kind of data we were using there? Ranked responses, okay, which was ranked by the human. Example, OpenAI Instruct GPT. So this is a research paper. One model basically was released by the OpenAI. Regarding that model, I will show you the research paper. This OpenAI Instruct GPT. There also you will see the use of this RLHF technique, okay, through this PPO. The second technique is called RLAIF. This was introduced by the Anthropic. Okay, so inside the RLAIF, you will get the AI generated feedback. So human generated feedback was not very scalable idea. Means how many feedback can be annotated by the human, right? Maybe 1 lakh, 2 lakh, right? But if we have to make it scalable, then how we can do it? So there they have introduced this RLAIF where human is not giving a preference. Actually, we are taking that particular preference from the AI itself. Okay. So this was discussed inside this research paper. I'll show you in some time. The third technique and very popular and in demand technique right now, that is called direct optimization policy, okay, using the preference pair. The full form of it, direct preference optimization. Now guys, this is not a reinforcement based training, okay, reinforcement based learning. So here we are not going to use reinforcement learning. This is a simple supervised learning. Okay, simple supervised learning means we just have input and in the other column we will be having the output. That's it, guys. Okay, so chosen and the rejected. That's it, right? So nowadays we are using this particular technique only. Now let me show you the research paper regarding each and everything. So guys, I will attach all this research paper in the description. So this is the first one. The research paper name is Training Language Model to Follow Instruction with the Human Feedback. So just check out with this particular research paper. You will get so many detail over here. And this research paper was published by the OpenAI. It's a very good research paper on top of the RLHF. Just read the instruction at least and the couple of headings. Okay, you will understand. See here, I was saying now. They have used the PPO technique, proximal policy optimization. So initially for the RLHF, they have used the PPO technique. Okay, so just read out this research paper. Now the second one is the direct preference optimization DPO technique. It is also very famous technique, and it was introduced by the Stanford University, right? So just look into this particular research paper. You will get the complete details. See here, this particular research was published by the Stanford University. Now here you will see the Indian, also one Indian, Archit Sharma. Now the couple of other person, right? So just see, it was released in 2024, and just read out the abstract at least. Okay, you will get the complete detail of what is a DPO and how we can implement that. Now the third technique, which is called RLAIF, right? So it was inspired from the RLHF only. The difference is human is not going to be annotate anything now. Only AI will do that. So just check out with this particular research paper. It is a very good research paper. You will get very good knowledge through this research paper. Okay, and this was published in 24 last year itself. It's a very latest research. Now here also you will find out so many contributor. Okay, so Abhinav Rastogi and Sushant Prakash is one of the guy, right, who contribute inside this particular research paper, right? So just read it. You will get the complete detail of the reward modeling and the differences between the RLAIF and the RLHF. Now guys, let's look into the DPO. Okay, because see, we are not going to use the RLHF technique, RLAIF technique as of now. Maybe I'll show you in the future, but that is deprecated now. People are using DPO, which is like very simpler, okay, and simple to use. So I will show you the formula of it, formula of the DPO, and then I will go for the basically practical. Okay, so let's start with that. So guys, here is a DPO training loss intuition. So it's a loss function. So based on this loss function, my model is going to be trained. Okay. Now guys, you know about the supervised learning. So in the supervised learning, we have input, then we have a output. Okay. Now this output, basically it is called the actual output, which we generally demonstrate with the Y. And then we are going to be predict, right, something from the model that is called Y hat. So we check the differences between this Y and the Y hat, and we try to minimize. See, this differences, actually it is called the loss. Okay, and we try to minimize this particular loss, right? So that's the overall idea behind the supervised learning. If you don't know about it, you can learn about the linear regression. You can learn about the artificial neural network. Okay, there you can learn about this particular concept. Now using see, this is the loss function, and using this particular loss function only, we are going to train our model. Now let's try to understand this formula. Now why we are understanding that? So let's say if someone is going to ask you in an interview, right? So how did you train, how did you perform the training, this preference training, right? So you can say I perform using this DPO, and inside the DPO basically we are using this loss function to train my model. Okay, it's a supervised learning only. So inside this formula we have so many terms, but it is not very complicated. It seems complicated, but it is not. Let's try to understand it. Okay, so here you can see we have this pi theta, pi reference. So pi theta, actually it's a preference aligned model, okay, which is trained. Now this pi reference is what? This pi reference, actually it's a reference model. So it's a instruction tune model, okay, which comes before the preference alignment model. Okay, so pi theta and pi reference is clear. Now this y plus is what? This y plus actually prefer response, means the chosen response, okay, with respect to what, with respect to this prompt, X prompt. Okay, now here see, this is like my reference, sorry, alignment model. Okay, and here basically we are passing this preferred this is my preferred response with respect to this prompt. Okay, now here is my reference model, right, and here is what, here is my preferred response with respect to this particular prompt, right. Now similar to that, you can see over here, so the model is there, right. Y minus means what, Y minus means rejected response with respect to this prompt. Okay, I hope you understood it. Now we have a couple of more terms. So we have this sigmoid. Okay, now apart from that sigmoid, you will find out this beta. Okay, and now you will find out this minus e, right. This minus e is nothing, it's a symbol. Okay, minus e means what, expected, right. What we are expecting, we are expecting this term should be minimum. Okay, and this term should be the maximum one. That's it, guys. Okay, it's just a symbol, nothing else, right. Now let's try to understand one by one. I just kept I just broke everything over here. So a log pi theta, okay, y plus with respect to this x, and then pi reference, the reference model, okay, y plus with respect to this x. So what does mean? The meaning is how much more does your model prefer the chosen answer compared to the reference model. Okay, so here is what, here is my basically preferred model, and here is my reference model. So with respect to this reference model means my supervised trained model, I'm checking how this preference model is behaving, right. Now similar with respect to this rejected prompt also. Okay, so this selected prompt as well as the rejected prompt. Now what we'll see the differences. So chosen improvement, okay, and the rejected improvement. So if it is going to be positive, means my model is aligning to this chosen prompt, okay, the chosen output. Now here sigmoid, what it is doing, so you know the value of the sigmoid, it is between the 0 to 1, right. So it is giving me a probability, okay, kind of probability score, right. Now here beta means what, beta is a scaling factor. So if the beta is high, means we are enforcing model to if we are enforcing model to align more to the chosen. Okay, if beta is low, means the rejected one, the model is more aligning to the rejected. Okay, the typical value of the beta between 0.1 to 0.5, right. And here I written the minus e, meaning what is the meaning, we want to minimize the negative, which means the maximize, we are going to be maximize the positive value. So here let's understand the meaning again. Let's take a quick revision. So this particular term with respect to the preferred response, okay, means the chosen response. So we have two model. This is my preference aligned model, this is my reference model. Okay, same with respect to the rejected response. So we are checking, right, how my, so here what we are checking, how much more does your model prefer the chosen answer compared to the reference model. Okay, so we are going to be compare with respect to this reference model. Then what we are doing, we are going to be scale it, right, and then we are going to be check the probability, right. We are just going to be compress the entire value between 0 to 1. That's it, guys, nothing else. Okay, and if the answer is positive, okay, we are getting more positive in like multiple epoch, we are training for the multiple epochs, and this result, the loss result is going to be positive, means my model is aligning to the chosen responses. That's it, guys. So I hope you understood it. Later on in the dedicated video, I will show you the derivation of it. Now one more thing, guys, before coming to the practical. So I kept a couple of more point with respect to this Instruct GPT paper. So this paper, just now I shown you this paper, right? Training language model to follow instruction with the human feedback. So this is the Instruct GPT research paper. Now regarding that, I kept a couple of point, few summarization, right? So here human was labeling the data, right? So whatever response we were generating to the model, human was ranking those things. Now using the PPO, basically we are going to be find out which is like more helpful, right? So this was a chat GPT style alignment, so which initially was done by the OpenAI. Okay, now on what all prompt, basically we are finding out, we were generating the output. So on top of the API user prompt, means whatever a user was writing, okay, through the API, okay, some question answer, right, sorry, some public questions, basically those prompt was taken, and on top of that they have generated an answer from the generated a multiple answer, and then human ranked those answer, right. So this is like some extra information, you can confirm it from this particular research paper. It is very good like to understand the to understand how they have initiated the RLHF technique. Okay. Now let's move to the practical, guys, and after that basically I'll show you the comparison between all the model. Okay, and one more important concept with respect to the LoRa adapter. So here only we'll cover that part. So guys, we had the base model. If you remember, then I took the base model. This base model is also called the foundation model. Now here is my foundation model, my base model. So I fine tune this model on top of the PDF data. And after that I got this particular model, non-instruction model. Now why we have done this thing? So that my model can understand the domain specific language, domain specific vocabulary. Okay. Then I want to teach my model proper conversation. So what I did, I fine-tuned my model on top of the input and output data. Okay, means on instruction data. Okay, so what I got the instruction model. Now guys, I want to be train my model. Again, I fine-tune my model on human feedback. Okay, so after that what I will get the preferenced model. So this is the aim for this particular video. I hope you got it. Now for that what I'm going to do, I'm going to load all the libraries. So I'm going to load the auto tokenizer, auto causal for LM, training argument trainer, LoRa config, get PEFT model task type, and load dataset. So I will teach you the meaning of each and every class, each and every function which I'm loading over here. So yeah, this is done. Now here is my base model. Now why I have written this base model here, so that I can load the tokenizer. Okay, because this tokenizer I will be using. So yes, the tokenizer is here, tokenizer is ready, and I think I already explained you the meaning of this pet token and this end of the sentence token. You can check out with the previous session itself, you will get the entire detail. Now what I'm doing, guys, so I'm going to unzip my previous model, this tiny llama instruction.zip model. Now why I'm doing it? Because I'm using a same model throughout this journey. Means I was having the foundation model, then the same model I train on the PDF data, I got this model. Then same model I train on the instruction data, I got this model. The same model I'm going to train on on the human feedback data, and I will get my final preference model. Okay. So here what I'm doing, like when I trained my model in the previous class, so I saved that as a zip file. So this zip file is also available in the GitHub. You can check it out directly. Okay, or if you will train it, if you will train the model from scratch, okay, over here using this particular notebook, this IP1B file. So at the end you will get this particular model itself, this tiny llama hyphen instruction. Okay, then you can convert into the zip and you can save it anywhere. That's it. So guys, I have a model. I have already uploaded this particular model over here. You can see. Now let me unzip it. So after the unzipping it, what I will get this checkpoint 3. Okay. So this is my train checkpoint, instruction checkpoint. Let me load it. Let me take it inside the variable. Now I'm loading it. Okay, and I'm testing whether everything is working fine or not. So for that I kept one prompt. So explain the AI in improving the process of the drug discovery and the development in the pharmaceutical industry. So this is my prompt. Now this first what I'll do, I will convert into the tokens. Okay, and I'm mapping to my GPU. Now I will pass this token to this method. So instruction model dot generate, I'm passing the token. Along with that I'm passing some other parameter like how many tokens I want in the final output, some other parameter with respect to some tweak, some creativity in the output. Okay. Now repetition penalty means the token should not be repeat. So regarding that we can mention this particular score 1.1, and I think this score we can like write up to 2. You can check out the complete detail of it. Okay, so yeah, this is also one of the parameter. It will stop the redundancy of the token. Okay, so we'll get output. Let's see what output I'll be getting over here. So before the class, right before the class I was testing, and I already run it. Okay, if you are running it first time, then it might take some time. So here is the output. So explain how intervenient, this is the question. Now regarding that, see the answer is being generated. You can get some better answer. If you have much data, then definitely you will get some good answer, aligned answer itself. Now here this answer is also aligned, and it is with respect to my question. Now I want to perform the preference based learning. So for that guys, we are going to use this TRL module. So under this TRL module only, you will get all the this preference tuning based classes like DPO, like RLHF, like RLAIF. Okay, so different classes you will get under this particular module only. So let me install it. So the command is very simple: pip install -u TRL. You will get the latest version. Now after that, if you want to load a quantized model, so there is one more package, bits and bytes. So let me load, get this package also. Okay. Now guys, after executing this two command, pip install -u TRL and pip install -u bits and bytes, you always restart the kernel. Otherwise, you might get an error that this package is not visible. Okay, so let it install, and after completing this one, what I'll do, I'll restart the kernel. Okay, this is done. Now what I'm doing, I'm checking with the runtime. Now here you can see the restart session. Just click on this restart session. Okay, the kernel will automatically restart. See, right hand side, it is getting restarted. Now load this step again. Okay, because after restarting, this will be gone. So yeah, everything is fine. Now guys, this module is installed. This bits and bytes is also installed. Now let's try to perform the DPO training. Now here I want to teach you one very important concept of the LoRA guys. It is very important. I think most of the beginner and even the experienced person does this kind of mistake. So I don't want to repeat that mistake over here. Okay, and even I rectified that mistake in the previous solution also, and definitely I will highlight those part. So for this preference based learning, I'm using this DPO trainer. Okay, rest of the module will be same, which I already imported in the previous cell. So from the TRL itself, we are going to import this DPO trainer. If you are doing RLHF, or if you are using some if you are doing the RLHF, RLAIF, right? So from the TRL itself, you will be loading everything. Okay, so we are having this DPO trainer. Now what I'll do, so here is my base model guys. Then this is my instruction checkpoint, right? So my model is available over here inside this particular checkpoint, the instruction model. Now after that guys, you can see, so we are going to be load the data set. So here the data set plays a very important role. I will show you what kind of data I'm using and how I created that. Then I'm loading the tokenizer, and after that you can see we are assigning this end of the token to the padding token. Okay, so let me check what is happening, whether everything is ready or not. So yes, this is running, because see guys, we have a limited memory, so we might get some issue with respect to the memory and RAM. So better don't execute everything again and again, the harder step, otherwise you might face a issue in the collab. So yes, it is working fine. My model is still giving me a reply. Now TRL, with respect to the TRL in bits and bytes, I reloaded the environment. Now first of all, let me import all this statement. Okay, so after that guys, what I'll do, I'll take the base model, I'll take the instruction point. Now here is my data set. So how the data set look like? So I already kept the data set over here, pharma preference underscore data.csv. This data could be available in CSV as well as in the JSON format. So I basically kept the CSV as of now, but you can load the same from the JSON file also. So how the data look like? See, here is a data. So inside the data, you will get the prompt. You will get the chosen one column. Okay, the second third column will be the rejected. So we are giving a prompt to the model, then we are generating a multiple answer. Now which answer is being selected and which answer is being rejected, so that particular information we have kept over here. I think you got this point. Now whenever we are passing a prompt to the model, okay, so model will generate something, so that this can be wrong, or this like can be the correct one. So initially I shown you like how the human annotated this entire labels and all, whether I have to choose it or reject it. Later on we have automated this task also, okay, on a very high scale. So this task have been automated by the LLM only. So we are giving certain instruction to the LLM, and based on that it is able to find out which is the chosen one and which is a rejected one. I hope you got it. So this type of data we required for what? For the training. Now here guys, see, we are loading a base model. Okay, we are having the instruction checkpoint. Now we have a data set also. Now what I'm doing, I'm going to be perform the tokenization. So from the auto tokenizer, I am loading my base model. Okay, so it will come inside this particular variable, tokenizer variable. Then what I will do guys, so after that the same thing, you will have to assign the pad token. You will have to assign the EOS token, end of the sentence token, as a pad token, right? Now here we need to understand one very important concept. So we're talking about the PEFT module. Okay, so PEFT is giving us two different methods. So see, PEFT, we have a PEFT, right? So from the PEFT we are importing this PEFT model, and from the PEFT itself we are importing this get PEFT model. So guys, we need to understand the differences, okay, between this PEFT and get PEFT model, because it is very much important. So guys, I capped the complete intuition over my blackboard. So let's understand it one by one. So what we are doing, guys, as we know, we are having base model, then we are training it for the non-instruction model, then instruction model, then preference model. Okay. Now, how we are doing this training? So we have a base model. Now we are doing the LoRa based training, and we are getting a non-instruction model. Then again we have a non-instruction model, and we are adding the LoRa adapter, LoRa layer, and we are getting an instruction model. Now here again we have an instruction model, okay, and we are adding the LoRa. We are means we will try to do the same one. We will add the LoRa, okay, and then we'll get the preference model. But guys, to be honest, this is not a good thing. This is not a good practice, and no one is following that. Okay, now see over here what we are trying to do. We have a base model, we are connecting with our LoRa, okay, the LoRa adapter, then base model LoRa, then again in the instruction tuning again one more LoRa, then we have base model LoRa, and then again one more LoRa would be there if we are following the same step over here. So stack of the LoRa layer is not good. Stack of LoRa is not a good idea, guys, and that's a step I followed in my previous tutorial, right? And you were able to see the responses. It was not quite good. Why? Because the LoRa layer was getting stuck. Now if you don't know about the LoRa, don't worry. In the upcoming video I will explain you with complete detail, with a complete mathematical derivation and all. Okay, so don't worry about the LoRa, but let me give you the quick definition of it, what it is. So here I written, LoRa is not a full layer. Okay, it's not a complete model, it's just a delta patch. Okay, so delta patch cannot be stacked, they must be merged before the next training. So what is this delta patch? This delta patch you can think in such a way. We have a weight, old weight. To this old weight, we are going to be attach some small matrix of weight, okay, and we'll get the new weight, okay, new weight, WEIGHT. Okay, so we are having the old weight. We are going to be attach it with the like some small weights. Okay, and now this particular patch, the small patch. Okay, it is only called the delta patch. Okay, so my LoRa is nothing. It's a small patch. It's a small weight which we are going to be attached on top of my old layers. Okay, and then what I will get? I will get my new weights. So here is a proper mechanism for it. Means this particular weight is being trained. This is going to be freeze. This is going to be freeze. This particular weight is going to be trained. Now after the training, it will be merged into the old weights. So that's the whole sort of a idea of the LoRa. We'll discuss it in a more detail in the upcoming session. So this delta W is called the patch, and this is only called the delta patch. Okay, and this is my LoRa weight. Now we no need to stack the LoRa weights. Okay, see, this is my W, the original weight. If we are doing a non-instructional training on the safe model, we'll get this W1, del W1. Then if we are doing the instruction tuning on top of the same model, then we are going to be attached this del W2. Then for the preference learning, again del W3. So we should not take this particular step, and this was a mistake even which I made in the previous solution. Okay, I will give you the correct approach, which approach basically you can follow for the LoRa. Okay, if you are using a same model again and again for the training, that how to use LoRa efficiently, it's very 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 important. Now what is the disadvantage of this thing? So the disadvantage is loss will be unstable, model will hallucinate, tuning will not be good, and the quality will degrade. Why it will degrade? Because loss will be unstable. We won't be able to figure out the loss properly. right? If we are having this kind of weight, if we are going to be if we are going to be create a stack of the LoRa, right? So what is the solution of it? So to use the LoRa in an efficient way, that's the solution. Let me show you how. So let's discuss how we can use LoRa in a better way. So if you will check PEFT, guys, so this PEFT is giving me two methods. One is get PEFT model. The second is PEFT model from pre-train. Okay. So when we have to use this get PEFT model, and when we have to use this particular method, so definitely we'll be talking about it. Now here we have a get PEFT model. So it creates a new LoRa during the training. Means the new LoRa patch, the delta patch which I showed you. Now this PEFT model dot from pre-train. Now what it does, so it load a already trained LoRa model, okay, for the inference or for the further training, right? So we are going to use this particular method for loading the previous LoRa weights for the for loading the previous trained LoRa model, and then on top of it only we are going to perform the fine tuning, okay? But the way is going to be a little different. See over here, observe over here what we are doing. So we have a LoRa configuration. So here I am writing task type is going to be causal LM, that is for the next token prediction, okay, for the language modeling. Then there's the rank of the LoRa. R is representing the rank. LoRa alpha is one of the parameter. LoRa dropout, okay, one of the parameter. It's a hyperparameter. You can keep any sort of a value of it just to test your output. Means just to check what impact it is having on the final output. Then which module we are targeting in the attention layer. So we are mentioning that part over here, and bias is equal to none. So this is what this one LoRa configuration. Now what we were doing, guys, in the previous class, and even if I didn't find out the current approach, then what we would be doing, let me explain you that first, okay? Then we'll come to the correct approach. So we are having this method get pet model. So we are simply passing this instruction model, okay, and then we are passing this LoRa configuration. So we were thinking, okay, now we will get a model which we can tune further. But guys, this is a wrong approach. Now what we are doing over here, we are having the instruction model, and on top of it we are going to be connect the LoRa stack, okay? So the stack of the LoRa again and again, okay, on a same model which we are training on a different phases to append the LoRa, okay, to create a LoRa stack. It is not a good practice, okay? So what is the correct approach? Let me tell you that. So first what we'll do, guys, we will load the base model. So here is my base model, okay? I'm not going to take this particular step. I'm just going to be comment it out. Means directly I'm not going to be take a model. Means directly, see here I'm giving my instruction model which I loaded earlier from the zip. Okay, and here I'm attaching the LoRa stack, and then I'm getting this PEFT model LoRa, but I'm not going to perform this thing because this is not a correct approach. So what I will do, guys, so first I will load my base model, okay? Inside this particular variable I was having the base model. So let me show you this base model which was there. So here is the base model, okay? So we are able to load the base model. I got it inside this variable. Now in the second step, what I will do, using this method PEFT model dot from pre-train, okay, I'm passing this model, my base model, and I'm passing my instruction checkpoint, means this instruction model, okay, this particular model. Now after that what I will do, so after loading this thing I will get my model, okay? So this model, this base model, basically it is connecting to the instruction checkpoint, right? Now what I will do, I will merge it, okay, merge and unload the weight. Means I was having the base model, on top of it I will keep the LoRa weights, I will merge both weight, okay, and after that I will get my model. So here is my model. Now what I will do, on top of this model only I will connect the LoRa stack. So here is get PEFT model, I am passing my model, and then I am passing the LoRa configuration, right? So just check out all the thing. It is very much important, guys, very important. See over here. So what I'm trying to say, just focus over here just for one more minute, okay, guys? So we are having the base model, we perform the non-instruction fine tuning, okay, after the LoRa, and we got the non-instruction model. Then again we were having the instruction data, we perform the instruction tuning, and we got the instruction model, okay? Now this two thing, this non-instruction model I did with the LoRa, instruction fine tuning, again I have loaded this non-instruction model, and I attached with the LoRa, and then again I perform the training. And then now the same thing I'm going to do with the preference model also. But guys, this is the wrong technique, okay? to create a LoRa stack like this, which I explain over here, it is not a good thing. Why? Because we might get this kind of issues. So what is the best approach? The best approach is, first guys, see, here is my basically this instruction model, this one. This is my instruction model, checkpoint 3, okay, which I already trained, right? So what I'm doing over here, see, just focus for one more minute. So here basically what we have a LoRa configuration, that is fine. Now I'm not going to be like pass this instruction model, and we are going to be create a LoRa again on top of it, and then I'm calling it as my preference model, which I'm going to tune further. No. So here I'm taking a base model. So I'm loading it. Now after that we are going to be connected to the instruction checkpoint. Okay. Now after that I'm calling this method merge and unload. So merge and unload, what it will do, it will merge model, my freeze model, as well as the instruction LoRa. Okay. Then on top of it, I will create the LoRa patch. Now this particular patch is going to be trained. Okay. Now this particular patch is going to be trained. So this model which I got, a PEP preference model LoRa. Okay. After see, this is my method get PEP model. I'm passing my model. I'm passing my LoRa configuration. Now I will get the delta patch. Okay. I will get the LoRa patch delta, the delta, right? Now that particular so I'm keeping it over here inside this particular variable. Now I will be training this model on top of my preference data set, right? So here I created one table also, non-instruction base LoRa, it is correct, instruction base plus merge, okay, stage 1 LoRa, then new LoRa, this is the correct approach. Directly LoRa on LoRa, it is not a correct approach. Now preference base, so base model, then merge stage 2 LoRa, then plus new LoRa, this is the correct approach. LoRa on LoRa on LoRa, this is not a correct approach. I think now you got the complete LoRa. So let's train my model. So here I am going to be write bits and biases disable true, and don't want to be capture any sort of a matrix. So here guys, I'm going to be define my DPO trainer from the TRL. So TRL is giving me these classes, DPO trainer and the DPO config. So yeah, this is fine. Now what I will do, I will create a object of this class DPO basically config. Now here I'm writing a directory in which directory, in whatever directory I want to be save my model. Here I have a learning rate, and then I have train batches, okay, gradient accumulation is step, right? At how many steps we are going to be accumulate the gradient value. Number of training epoch, how many, for how many epoch you want to be running, beta value, report to none. I don't want to report on any basically platform, okay. So here also I did that same thing, and you can mention this parameter also. Logging directory none, as of now I don't want to be log anything. Loss type is sigmoid, okay, we'll collect the will calculate the loss with this particular function. Remove unused column, okay, false. I'm not going to be remove any column as of now. I know guys, you get the little difficulty while you go through with this all this particular parameter. We have so many parameter. If you will hover the mouse over here, you will get maybe. So we have so many parameter over here, maybe hundreds of parameter. So don't worry guys, it is my responsibility to teach you everything. I will create a proper video on top of each and every parameter of these classes. Okay, it is my promise. So let me take this DPO argument. Now here I am defining the DPO trainer. There I am passing my model. Okay, which the model basically, here you can see this particular model, this one, preference model LoRa. Now how I got this model? So I was having the base model. Okay, on top of it I appended this instruction checkpoint. I merged both the weights. Now on top of this particular model, on top of this particular weights, okay, this particular model, I attached the this like LoRa patch. Okay, and then I got this model, and further I'm going to train it now. Okay, now here is my model and reference model. I'm not passing any reference model, otherwise I can pass the reference model over here. That is also one of the facility. Okay, argument, so DPO argument, this particular argument which I defined over here. Now after that guys, training data set, so data set which I loaded, okay, from the CSV, this particular CSV, this I shown you. Okay, only 5 data points, you can keep as many as. Then here processing class, that is tokenizer. Okay, so if I run this trainer, so see, it is saying preference model is not defined. So let me run it first. Okay, I got this one, this is fine, this is perfect. DPO argument is also fine, DPO trainer is also perfect. Now trainer.train. Now guys, this is my final step for training the model. So trainer.train, and yes, my model is getting trained. it will take time, guys, if we have a huge model and a very huge data set. As of now, it is a quick because we have a very small model, not very small, guys. We have a small model with a very small data set, and my epoch is one, and I kept the parameters in such a way it won't take much time, just to show you guys, just to show you. But in a real time, you will be doing it with a huge amount of data, so it will take maybe days. Okay. Now here it is just testing. So testing with a non-instruction model. Okay, so here is my question. Explain how metformin works in the human body and why some research believe it could have benefits beyond diabetes treatment. So guys, if I will test this question with my different model. Okay, so let me test for two model, instruction and the preference. You can test from your end this one, non-instruction one. Okay, so this is my question, guys. Now what I'm doing, so here is my testing with the instruction fine-tune model. So this was my checkpoint. Okay, instruction one. Now I'm going to be load this model. See, instruction model would be here. I'm going to tokenize this question. Okay, and then I'm going to generate a output, and then here will be my final output. So let's see what will be my final output, guys. We'll compare the output. Okay, we'll compare the output of the instruction model as well as the preference model. Let's see the difference, whether we are getting some like good terminology, something like that, right? So it is saying question is not defined. Let me execute it. Okay, so here we have a question. Now model is there, input tokenizer is ready. Okay, now here is my output, and then I will be getting the final output. So let it complete, and yeah, I will get the final output, guys. Just a second, it takes some time. Yeah, so this is the output. Now see, guys, explain how metformin disease is that. Now see, this is the answer. Crohn disease, inflammation, bowel disease. I don't know this is correct or not. You should check it out, right? But guys, there's some redundancy in the output because I did the mistake in the previous training. Okay, I will come to that just a second. Now here is my model path. This is my LoRa mod. This one preference-based model. Okay, see here I saved that model inside this folder, tiny llama preference alignment. See, there's a folder. Okay, now what I'm doing, I'm going to be load my model path is here. I'm going to be load my model. Now I'm going to be connect with the CUDA, okay, to the GPU. Then guys, I'm going to be tokenize the question. Okay, I will be getting inside the input. Now this input I'm passing to my model. Okay, preference alignment model for the final generation. Now let's see the final output. So let's see what I will be getting over here. So it takes time. The output generation might take time. Let it complete. It depends on the infra also. If you have a good GPU, good infra. Now see, guys, explain how metformin works in a human body. This is that. Now see, metformin common diabetes drug, two type. So see, guys, you can clearly see the difference. So difference between this normal like output from the instruction tuning and the output from the after output after the alignment. Okay, so guys, you can make a difference over here. Means like you have trained a model on top of the instruction data. That is fine, that is completely fine, I'm not denying that. But if you want to more enhance on the human preferences, you can take one more step, like this chat gpt have done. If you're training your model from scratch, this will be very helpful. Now I was saying, guys, I have done one mistake. So the mistake basically I rectified over here. If you will go and check with the instruction tuning, so I written that code over here. You can now execute this file, and in whatever way I have explained you this LoRa stack over here. Okay, so see, this I'm not going to be follow now. Means I will not append LoRa. First I will merge the weight, and then only I will append the LoRa patch. Okay, so I kept the code over here. Let me show you where it is. This one. Now let's okay, I think it will be the below one. So see, guys, this one. Okay, I kept the complete code. You can go through with it, you can run it, and then you can train your model. So fine, guys, this is it for this particular video. In the next video I will come up with some different framework, okay, to teach you this fine tuning. Yeah, so thank you, guys. Thank you for watching it. If you haven't subscribed my YouTube channel, please subscribe. This kind of content takes very much effort, guys, to research and all, and then record. So please respect for all those things, and subscribe the channel, because see, guys, it is free for you, I know, but it is very important for me. Okay, your subscribe, your like, your support, everything. So fine, I'll see you in the next video. Thank you. Bye bye. Take care. So here I have mentioned what you will learn. So the first thing, what is a Llama factory, right? You will get the complete introduction about that. Then what type of training does Llama factory support, right? So what kind of training you can do means like supervised fine tuning, RLHF, DPO, right? So we'll take a overview of it, and then we'll perform the supervised fine tuning. Then which model are supported by the Llama factory? So we'll see all the model families which all supported by the Llama factory, right? Then which dataset format are compatible with the Llama factory. So if you want to fine tune any model, so for fine tuning in which format you have to keep the data, you have to prepare the data. So definitely we'll try to discuss that also. Then step-by-step guide for the fine tuning using the web UI. Okay, so Llama factory is a project. So the Llama factory actually, it is giving you the web UI, as well as you can run it from the CLI. So we'll see both things. We'll see step-by-step guide like for the fine tuning using the web UI, as well as I will show you the training via CLI. Okay, so these many points I will be discussing throughout this video, guys. So stay tuned with me till end. You will get to know everything about this Llama factory. So guys, now let's understand about the Llama factory. Then only we'll start with the practical. So Llama factory is an all-in-one open source fine-tuning project that makes LLM training and inferencing very simple, and it works with hundreds of model and the data set. So what is a Llama factory, guys? So Llama factory is nothing. It is just a project which is coded by someone else. So let's look into the source code of the Llama factory. So here, guys, this is a source code of the Llama factory. This is the repository name. The name is Hi Yoga, and this repository is written by, this code is written by one Chinese guy. The name is Yaowi Jineng. Here you can see the location, right? So this repository is quite famous, and here you can see the number of folks. It is around 7.7k, right? And the star is around 63k. Okay, so now guys, see, this is the entire code, the complete source code. You can check over here. You can just click on this src, and you can go through with the different folder. You can download this code inside your local, and you can run it, and you can fine tune your model. So guys, this Llama factory actually, this Llama factory is a UI and CLI based framework, right? Means it is providing the CLI, it is providing the UI, it is providing the CLI based execution. Both thing, it is being provided by the Llama factory. So UI, it is also called the Llama board, right? So it is a beginner friendly web interface where you can directly select the model, you can upload the data set, you can set the certain configuration related to the fine tuning. Okay, you can run the training, you can export the model, or even after the training you can do the chatting, right? So this each and everything I will show you inside this video itself. I will give you the complete walkthrough of the Llama factory UI, and how to basically select the model, how to train the model, how to do the chatting and all, everything I will show you. Then the second way is a CLI. Okay, so if you prefer scripting, automation, or advanced control, then through the command line interface also you can do the training, you can export the model, you can like start chatting, right? Everything you can do via CLI also. So just think in such a way. I have developed one project. Now that project you can you can run via UI as well as from the CLI. That's it. Okay, so it is just a simple project, nothing else. Now guys, one very important thing regarding this Llama factory, just read out this line. So Llama factory is a build on top of the Hugging Face libraries. Okay, it internally wrap up transformer, PEFT, bits and bytes, TRL. Okay, so which provide one click fine tuning workflow. Means guys, the meaning is it contains Llama factory, basically they haven't written the complete code from scratch. No, they are using the Hugging Face libraries only. Okay, but on top of that they have written like certain custom code for developing the training pipeline, okay, for the UI, for the templates, for the data set handling, okay, for some quantization and all. As far as I investigated their repository, so there I haven't get any custom code regarding the model. Okay, like see, if we are going to be code any model, any transformer based model, so I will write a code from scratch using the TensorFlow, using the PyTorch and all, right? So what I figure out and whatever I search, right? So they have used the transformer PEFT bits and bytes, means they have used the Hugging Face based library only, and on top of that they have done the certain customization, means like regarding the training loop, regarding the, they have added the UI over there, they have like added like the data set templates and all, right, to use the data set in an efficient way, right? So those are things they have done. They haven't written a like code regarding any model from scratch. Even I can show you inside the repository itself. So if you will go and check with the repository, now here just open the model. Okay, now over here let's click on this adapter. Now inside the adapter just check, see the import statement. So they are using PEFT from the Hugging Face, they are using the transformer from the Hugging Face. Okay, now you can check, let's suppose the chat, right? So inside the chat also, see they have created this Hugging Face engine. So see they are using the transformer, right? Now you can check out with the different other folder, the different other code and all. Everywhere basically you will get a use of the Hugging Face module, right? And on top of it, certain customization, certain logic and all for the training and for the data set handling and all they have done. So I hope you got the clear cut introduction and the meaning of the Llama factory. Now let's see what all model is being supported by the Llama factory and the data set format also. So guys, different training type is being supported by the Llama factory. So I written couple of names over here like SFT, DPO, RLHF, then RLAIF, and even full fine tuning. So this all method is being supported by the Llama factory, and easily you can navigate to this method from the web UI itself, and definitely I will give you the quick walkthrough of it. So SFT is called the supervised fine tuning. So like it is also called the instruction fine tuning, and we can perform this supervised fine tuning using the LoRA as well as with the QLoRA. Okay, then DPO is called the direct preference optimization. It is a method to perform the preference based learning. I have shown this thing in my previous video, you can check out over there. Then RLHF is a reinforcement based method for the preference alignment, and it is also called the reward modeling. Okay, and for the optimization we are using this PPO method, right? So RLHF with reward modeling and PPO, it is also very famous method which was used by the OpenAI itself to perform the preference training. Then RLAIF, it is a like latest method. All right, so instead of the human feedback, we are training our model on top of the AI feedback. Okay, so this particular technique also I discussed in my previous video, you can check out over there. I discussed the research paper and all everything. Then full fine tuning means so we can train all the weights of the model. Then this particular technique is also available in the Llama factory, right? In the Llama factory, using the Llama factory, basically we can retrain the entire model, we can train all the weights of the model. So yeah, these are the couple of technique which is supported by the Llama factory. Now let me show you the model as well. So the model family supported by the Llama factory. So Llama is being supported, that's fine. I think the name and the Llama, right? These both are matching, so it's a pretty obvious thing that definitely this Llama model will be available in the Llama factory. Then Mistral family, then Qwen 1, Qwen 2, even the vision based model is also available. Gemma model from the Google, this is also available. And Phi model from the Microsoft, it is also available. Then couple of other model like YI. Okay, it is also very famous open source model from this 01.ai company, it belong to China. Then Baichuan, right? So this is also a very like famous repository over the Hugging Face, you can check, and it is from the Baichuan Inc., right? It is again from the China. Now other popular like community model, right? Like Chat GLM from this Chinese university. Okay, then DeepSeek again from the China. right? And OpenBuddy, right? I don't know like to which like company it belong, but yeah, this is also one of the famous open source model. Now guys, here you will see along with this Meta, Mistral, 5, okay, and this Llama, you will see like various Chinese model, because this repository belong to one Chinese guy, so definitely he will give space to their like specific Chinese model, right? Those Chinese repositories. So yeah, you can basically go through with it and you can check, and even I will give you the walkthrough from the web UI itself. Now the dataset format, so it support three kind of format. So the first is the alpaca format. There you can put the instruction input and output, right? And we already seen this particular format, right, in our previous like sessions. So this is called the alpaca format, which generally which we generally use for the instruction tuning, right? So there we have three columns. The first column is the instruction, the second column is the input, and the third column is the output, right? The second format is called the shared GPT format, right? So this format is also being supported by this Llama factory. If you're keeping your data in this specific format, then definitely Llama factory will support it, and you can fine tune your model. So what is this shared GPT format? So inside this shared GPT format, you will have this conversation, okay, this key, and under this conversation, you will have this from basically is representing to the user, and the value basically the specific message from the user. Now from the assistant, right? Now assistant means model, what model is replying, then here is a value, so this will be the like the actual value, okay? So in this particular format also you can keep your data in the Llama factory. And the third format for the DPO, so in the DPO, basically in the previous video also I discussed this DPO format, this preference training, preference alignment format, where we would be having three columns. The first would be the prompt, and the second will be the chosen, and the third will be the rejected. So this format is also being supported by the Llama factory. So if you're keeping your data in this three format, definitely Llama factory will support, and you can train your model. I hope this data set like format is also clear. Now coming to the couple of more points. So if you want to like fine tune your model from the web UI, right? So step by step you can follow this process, and in some time I will show you practical. So the first you can select the model, you can load the data set, you can do the certain configuration for the training, you can select the GPU, right? The GPU selection is also there, means it is not providing the server, right, but a GPU configuration, right? So certain configuration regarding the GPU you will also get, so that level of optimization you can perform. You can start training, you can evaluation, you can chat with your model, and you can export. So in this specific sequence you can fine tune your model from the web UI. Now one more thing guys, so if you are willing to like fine tune from the CLI, so these are certain command, means you can write your configuration inside the YAML file. So see, I have attached like YAML file, okay, and then what you can do, you can run the specific command. So if you want to train, you can run this command, Llama factory CLI train. If you want to chat, you can run this command. If you want to evaluate, you can run this command. For export, this command, okay. So this for the API configuration, this from the web UI, web chat. So for every sort of a action, one CLI command is also have been given. You can write your configuration inside the YAML, and then directly you can pass in the CLI command. So yeah guys, now let's see the practical. I will show you each and everything through the practical itself, whatever we have discussed in terms of theory, and then we'll wrap up this particular video guys. So guys, this entire practical will do in the Google Colab. You can do in your local as well if you have good high-end system. I'm doing in the Google Colab because here I have a support of the free GPU, and over the GPU the training would be little faster. Guys, there is two way to setting up this Llama factory. The first is via GitHub. We can directly clone the GitHub. The second is we can basically install this PyPy package. So I'm not going with this PyPy package because with this I was facing certain issue. So directly I'm going to be clone this particular repository, this Llama factory repository, and then use after cloning this repository only I will show you the further training. So what you have to do first guys, you have to select the runtime. Okay, so just click on this runtime, and here see my runtime is already running. So what you have to do, guys, you have to select the GPU over here. If it is not selected, then let me check whether the GPU is selected or not. So yes, I have access of the free GPU. You can purchase the Google Colab Pro if you want some high-end GPU like A100 L4, right? So you will get the like some high-end GPU with the paid version of the Colab. Now let me save it, and here see my server is also connected. Right hand side you can see this green tick. Now what I will do, guys, first I will clone this repository. After cloning this repository, I will install the requirement .txt, and then only I will perform the further training. So let's set up this Llama factory. Now guys, see, this Llama factory it's just a project, right? So it is not providing you any sort of a platform where you can configure the GPU. Okay, it is not providing you any sort of a GPU and all, nothing. So it is just a simple project which you are going to execute on your own server. So in my case, means as of now, right now the server is a Google Colab. So here only on the Google Colab itself, I'm going to be execute this Llama factory code, right? I hope you got it. So for cloning this repository, I will simply write this git clone, and then I will give the path of this GitHub. So how you can copy the part of the GitHub? So just open this GitHub and then click on this green icon. Now here you will get this link, okay, this HTTPS link. Just copy this link and paste it over here. Okay, this is the link, this is the same link. Now paste it over here. That's it. Write git clone and paste your link and then run it. So once you will do it, guys, you will be able to clone this entire repository in your Colab. So how we can check it? Just click on this file icon. So once you will click on this file icon, you will get the entire repository over here. Okay, so this is the entire code. Now what I will do, guys, I will check where I am right now. So for that I can simply execute this pwd command. So pwd means what? Pwd means present working directory. So I can check my present working directory. So it is pointing to the content, but I want to go inside this Llama factory folder. So if I want to go inside this Llama factory folder, I will simply write this command cd means what? Change directory, with this ampersand. If you are doing a change, if you are changing the directory in the Colab, you will be writing with this ampersand. Okay, so ampersand cd content and then this folder Llama factory. Once you will run it, and then you will check, so the present working directory will be pointing to this Llama factory. Okay, this is very much important. Now what you will do, guys, after that you will check, you will list all the directory, okay, with this ls command. Now ls means what? List all the script. Okay, list all the files. So once you will run this command, you will get all the directory, you will get all the directory, all the files inside this particular folder, inside this Llama factory folder. So here we required this requirement.txt. Okay, so what I will do, I will install this requirement.txt. So here is a command for installing the requirement.txt, guys. Let me do it. So I am going to be install the requirement.txt. Now after installing the requirement.txt, you can execute this command also. So this particular package, right, will be installed as a, so this particular project will be installed as a package, right? Pip install -e. If you know about my end-to-end project, there also I perform the same step to convert my project as a local package. So here also you can do the same thing. So you just need to write pip install -e dot. So let it complete, let it install this requirement.txt. After that, what I will do, I will execute this particular command. Now a couple of more things, guys, what I have observed, even though I'm installing this requirement.txt, but sometime it is giving me issue with the bits and bytes library. Okay, with this particular library, this specific library. So what I'm going to do, I'm going to be install this library as well separately. Maybe it is not up to date inside the requirement.txt. So what I'm doing here, I'm installing this pip install bits and bytes. Now after installing this bits and bytes, guys, what I will do, I will install this pip install -e dot. -e dot means what it will do, it will convert this entire project into the package. Okay, and it will be saved in my local environment, right? So I won't get any package related issue or something like that. So let it complete, guys. This bits and bytes will also take time. Now after that, couple of more step is required, so that I will let you know what all other step is required for the setup. So yeah, bits and bytes is installed. Now I am running this pip install -e dot. So it will also take some time. So let it install. Okay, so it is saying file content does not appear to be Python project, neither setup.py nor pyproject.toml. Let me check with the ls whether it is there or not. Here you can see setup.py is available. Then why it is saying like this? Let me again check with the pwd whether we are pointing to the correct directory or not. If it is not installing, we'll skip it. Okay, yeah, so that is the issue, guys, because I restarted the runtime now. Because of that, it is pointing to the content again, right? So if you are restarting, then please check where you are, because once you will like restart the session, so again you will be pointing to the home route only, okay, to the home directory only. This is the home directory, this content. So what I will do, again I will run this cd content llama factory. Now here, see, I am into this particular directory. Now I can check with this pwd. So pwd means what? Present working directory. And now I am into the current directory, correct directory. So what I will do, I will write over here -ls, and -ls basically it will give me all the file. Okay, so yes, recurrent.txt is there, and inside the recurrent.txt itself, the -e means basically this is not required recurrent.txt for installing this project as a package. I can simply write this pip install -e dot. Okay, but yeah, the thing is, we should be okay. We should be inside this specific directory, inside this llama factory. Otherwise, it will give you the error. See, here I am getting this error because it is pointing to the setup.py file. Just look at my end-to-end project where I discuss this entire thing in a very clear way. What is the setup.py? What is this -e dot? Everything, guys. Now let me install it. Let me run it, and I think now it will be working. Yes, it is working. So let it complete. And we have to launch the UI so that we can do the further we can do the training from the UI. Okay, and after that I will show you from the CLI as well. So everything I kept, don't worry, everything I will show you. So yeah, guys, I think this is done. Now what I can do, I can check with this src folder. So inside this src folder you will get this API llama factory .ag info. See, this ag info file is there. Okay, so now I can use this package, this project as a package. Train.py is there, web UI is there. Okay, that is fine. Now what I have to do, guys, see, this UI will be launched with the help of Gradio. Okay, it's a Gradio UI. We have Streamlit UI, we have a Gradio UI. So using this Streamlit Gradio, we can quickly create a UI. So this UI basically, which is integrated over here, it's a Gradio UI. So how to get that UI? Let me show you. So first you have to set this environment variable Gradio share. Okay, with that actually you will be able to run this Gradio UI over the public URL. Now what you will do, guys, you will log into the Hugging Face. So this is required, this step is required. Now why this step is required? Because whatever model and all being loaded, right, so it will directly load it from the Hugging Face itself. So for that, this particular step is required. If you are not following it, maybe you will get a error that okay, model is not getting loaded or tokenizer is not getting loaded, something like that. Okay, you might get those specific error. Now just put your token, right, and then select no. So here you can log in. If you don't know about the Hugging Face, how to log in, how to get the token, so what you can do, inside this playlist itself I have uploaded one crash course related to the Hugging Face. There I have shown all the method of the login. Okay, how you can log into the Hugging Face, how you can generate a token, what is the different type of token is there, like we have read token, write token, fine grained token, different kind of token. Okay, and different way of logging to the Hugging Face. So what you have to do, guys, you just need to write this Hugging Face CLI login, just put the token over here. This will be the read token. I already created a token and I kept inside my keys over here. So I just copied from here, okay, this particular token, and then I passed it over here. That's it, guys. And if it will ask you to get credential, so this is not required as of now, you can simply say no and hit enter. That's it, guys. Nothing else. Now I think we are good to go. So what we can do, we can launch the UI. So for launching the UI, guys, this is the command web. Inside this src folder we have a file webui.py. Even I can show you this particular file. So once you will go and check with this src folder, under this src folder you will get this webui.py file. You can open this file and you can check the entire code. See, this is the entire code, and this is running the Gradio server so that you will get a UI. So here what I'm doing, guys, I'm going to be executed. So once I will execute this particular file, it is going to be like it is going to be up the like public server, okay, for the for the Gradio UI. I will get a URL. After clicking on that URL, I will be directly redirecting to the Gradio UI. Okay. Now guys, see, you have to follow all the step in the same way which I am doing. If you are missing any sort of a step, guys, you will not be able to fine tune the model using this Llama factory project. Okay, so please do the setup in the same way like I am doing. Now we have other way also. If you don't want to be launch the UI with this particular command, what you can do it like this. You can import this create UI from this web UI. Then you can create an object of it, and then you can call this method launch. If you will do like this, in that case also you can launch the UI. We have both way. Now over here, guys, see, it is running the Gradio UI. Okay, and over here I will get my UI on this particular URL. So we have this local URL also. This local URL will not work because we are onto the Google Colab server, so we require the public URL. So yes, we are getting the public URL. So just click on this running on public URL. Local URL will not work. Again, I am saying this local URL will work if you are running it inside your local, okay, inside your system. So just click on this public URL once you will do it, guys. So here once you will click on the public URL, guys, so you will get your Gradio UI. So this is a UI which I was talking about, and this is a UI of the Llama factory. With this particular UI, I think within a minute, within 2 minutes itself, you can fine tune your model. You just need to fill out the detail. That's it. Okay. So here you have to pass the model name, guys. See, this is the model, different model basically. And as I was telling you, it is supporting to so many Chinese model because this particular code is being written by the Chinese guy. Okay. Then model path, automatically the model path will be coming where the model is available inside your directory. Then from which basically platform you are reading the model. So model scope, Hugging Face, Open Mind. So as of now we are reading from the Hugging Face. Then fine tune method, so full, freeze, LoRA, OFT. So see, all the different method are there. Now the checkpoint path will be over here. Then quantization method, chat template, ROPE scaling, okay, booster. So different parameter you will get, like, okay. So and here you can see right after filling this entire detail, what you can do, you can preview the command, you can save the argument, you can load the argument, you can start the training, you can abort the training. Now after that, guys, see, here you will get the output directory wherever your model is going to be saved. Here you will get the config path, right? So if you have any configuration and all, you can put over there. Then device count, okay, how many devices on how many server you are running the training. Then here you can see the deep speed stage, right? So many configurations, so many different configuration have been given to you. Now just by seeing this configuration, just by seeing this UI, you can learn so many concepts of the fine tuning, which parameter you need to be used, you need to be choose, okay, and how basically you can do the best fine tuning, right? How you can get the optimized fine tune model. So just by reading this UI, okay, you will get so many knowledge regarding that. That's why it is important, and that's why we should go through with this open source project. Okay, now guys, what is the next move? So I will explain you each and every parameter from this UI. I created one PDF. So let me open that PDF. Okay, I will attach inside the description. You can go through with that PDF. You can understand each and every parameter from here, and then right after that we'll start with the training, guys, okay, with our custom data, and I will show you how you have to do the data entry inside this particular project. Okay, so guys, I kept the complete detailed guide of all the parameter inside this PDF. So whatever parameter have been highlighted over the UI, right? So you will see the description of each and every parameter inside this PDF, and I will attach this PDF in the description, and I will keep in the same repository. Okay. So guys, hub name, right? So we have seen this particular option. So we were having the different option like Hugging Face, Model Scope, Open Mind. You can select anything. So generally we'll go with the Hugging Face, right? Model Scope, actually it's a Chinese based model hub. So yeah, China is also developing like model hub for the LLM models. That's like very great thing. Then open-minded means if you want to be load the model from any custom storage, you can select this one. Then related to the fine tuning, which technique you want to be used, whether it's a LoRA, full freeze, right? Or OFT. OFT means orthogonal fine tuning. It is an alternative of the LoRA itself. You can explore more about this particular parameter, and you can select best and best possible parameter, okay, while you are training, while you are fine tuning actually. So quantization width, so 8-bit quantization, 4-bit quantization, then quantization method of bits and bytes, HQQ high quality quantization, or ETQQ experimental fast quantization, okay. Then ROPE scaling means context window upgrade method, whether you want to be select linear, dynamic, yarn, or llama 3 based method, okay. Now guys, here if you will go and check with the UI, right, so you will get like each and every option over here. I'm not writing by myself, so here there I written all only those like description which is available over this UI. So I can show you if you will see with this quantization bit, so see 8 and 4 bit, just now I shown you quantization method, so BNB, HQQ, EETQ, right? So just now I shown you this thing. Chat template, so whatever model you are going to select, so according to that you can select the chat template, okay. ROPE scaling, right? So context window upgrade method, just now I shown you this thing. So here also you can see linear, dynamic, yarn, llama 3, these particular options, okay. In the booster, see flash, Unsloth, liger kernel. So all this description, okay, all this parameter basically I capped over here. So just go through with it, just read about it, and then select best and possible values over there over the UI. Just do more research from your side, okay. Then guys, stages means what kind of training actually you are going to be performed. So whether it's a supervised, whether it's a RLHF, right, reward and PPO, whether it's a DPO, right, whether it's a KT or pre-training. So you can select these option also, right. Apart from this, you can give the data directory, you can provide any custom data set, you can select the learning rate, epochs, right. You can basically select the maximum gradient norm. Again, this is related to the optimizer, so for that you will have to take a deep understanding of the optimizer, okay, how the optimizer is working inside the transformer architecture. Then only basically you can have a better understanding of this particular parameter, what should be the exact value of it, okay, what value should I keep over here, okay. You can understand in a better way if you have a mathematical understanding of the transformer model or LLM model. Then max sample, right, how many max data we have to provide. Then compute type, whether it's a FP16, FP32, then cutoff length, how many token we want to be generate from the model, right, best size, gradient accumulation, validation size, a learning rate scheduler, okay. Then there is some extra configuration, logging step, save step, and the other configuration, okay. Then guys, you can see the LoRa related configuration also have been given there, right. RLHF related configuration also is there. Then multimodal related configuration is there, okay. Then you will find out some optimizer related configuration, okay. So just look into like those configurations. So just go through with all this configuration, okay, understand it, like what is the meaning of it. See, again I'm saying you no need to like again like I'm saying you no need to select all the configuration, you no need to do entire configuration in a single go. If you won't select anything, it will keep the by default value over there, okay. So no need to panic regarding each and every point. I just given you this like I will give you this PDF as a reference. Later on peacefully you can read it and you can understand each and every variable from there. But as of now, no need to worry too much. You just need to select the model, you just need to select the data, keep all the parameter like as a by default one, and start the training. That's it guys, okay. Now apart from this particular parameter, I wanted to show you like I wanted to like discuss about the data also. So if you will go and check with the Llama factory repository, so inside this repository basically you will find out one folder. So the folder name is data. Just open this folder. Now inside this particular folder you will get the different demo data which is being provided by the developer itself. Okay, and inside this folder you will get one file. So the file name is dataset_info. So it is containing the entire metadata regarding all the data. So whatever data, basically whatever custom data you wanted to use, so you will keep it over here inside this data directory and you will do the entry inside this file. If you are creating any custom file, right, so you will keep it over here. You will make an entry inside this data set_info. Even if you are going to read a data from the Hugging Face, in that case also you will have to make an entry inside this particular folder, sorry, inside this particular file. So let me show you both the things. So what I will do, let me open my code. So here is a complete code, guys, which I cloned. So this is the complete code. Now what I will do, I will upload my custom data. I already created the custom data. Let me show you those data and all. So guys, the data is available here. So okay, let me open it. Okay, so this is the data, guys. See, I created my custom data 2, my custom data 3, means I created a data in each and every format. So let me open this my custom data, how it looks like. See, here is this my custom data. Okay, instruction, input and output. Then my custom data 2, this is in a shared GPT format. Okay, and then this my custom data 3, it is a like plain text. So in my one of the video I've shown you, if you have a plain text, then how you will create a model compatible data or Hugging Face compatible data, right? So if you have plain text, then you can create your, then you can keep your data in a multiple chunks. Okay, and then basically you can keep that chunk under this particular column, under this text column. So this thing I already shown you in my 14 number video. If you will go there, you will get it. Now guys, here I shown you data in each and every format, right? So like my custom data 1, 2, 3, I will give you all this data. So if you are going to be create your own data, your own custom data, you can create in a same format. Okay, so let me keep at least one data over the inside this data folder. Okay, let me show you how to basically mention inside the dataset_info. So I'm uploading one data over here, one custom data. Okay, so see inside in your case, maybe there would be like so many rows, so many there would be like so many rows, right, inside the data set. So yeah, I think you know, right, how to convert into the JSON. If you don't know, you can watch my previous video. I already shown you over there. If you have any type of data, then how you can convert into the JSON. Okay, so after converting into the JSON, you will upload this file. Okay, you will keep this file inside this data folder. So let me keep it, I think the data file. Okay, so yeah, my file is uploaded. Now what I will do, I will just drag and drop from here to this data. So let me keep it, and yes, the file is okay. File move fill. Why? Let me do it again. So this is my file. I'll keep it over here. Data. Whether it is coming or not, let me check. Yeah, my custom data JSON is there, guys. So this is the file, my custom data JSON. So here, guys, see, you will have to keep the file inside this particular folder, my inside this data folder, right, my custom_data.json. Then you will have to make an entry inside this info file. So let me open the info file, dataset_info. So inside this particular file, I will make an entry. Okay, so see what you will have to see. Already you will find out so many entries over here. It is regarding this particular data, whatever data they have kept over here, the demo data. Okay, now what I will do, I will see, anywhere you can make in between, you can make at the first place, you can make at the end, anywhere you can make. Okay, so I'm just making it at the first place. So here I will write a key first. So the key name would be the my custom data. You can write any sort of a name, there is no issue with that. Then what you will do, guys, you will write a format. Okay, format of the data. Now after writing a format, guys, what you will do, you will give the path. So let me give you the complete detail. So what all thing you need to keep over here. So here, guys, you can see what we are going to keep. So just a second. Yeah, now I think it is perfect. So guys, here we are going to keep the key, right? My custom data. Under that we have a format. Okay, so the data format is alpaca, where we have an instruction input and output. Then the path of the data, so it is available inside this data directory, and this is the like file name. Then column, so we have this prompt, okay, that is instruction, query, that is input, okay, and the response is the output. So in this particular way you will have to mention the entry inside this dataset underscore info.json file. Okay, now guys, let's suppose if you want to read any data from the Hugging Face, so how you will do that? So let me show you, let me give you the overview, like how like you can mention it inside this data set underscore dot info dot json. So I have this data, okay, the data set name is Unix command, right? So this data actually it is available in this instruction input and output format. So in the instruction we have an instruction, then in the input we have an input, right, and the output we have a final response. I have other data, I can use any one data. So alpaca clean, right? So here we have output, input and instruction, again this 3 column. Let's say I wanted to use this particular data for my training. Okay, I want to be like fine tune my model on top of this particular data or any Hugging Face data. Then how you will make a entry inside the data set underscore dot info dot json. Okay, because guys I'm not going to be upload the data over here, means I'm not going to be keep the data over here. The data is already available over the Hugging Face, right? So in that case, how I will make an entry over here? So let me show you. I already kept I already kept the format. So I'm adding in the starting of this particular like JSON. So see, in this particular way you will make an entry. So you will write key Hugging Face dataset. You can write any name. I like there is no like basically rule for this key, right? You can write your name, my name, whatever name you want to be write. I written Hugging Face dataset. Then you will pass the Hugging Face URL, means the ID of the data. Okay, so here you can see, like once you will click on it, you will get an ID. Then you will get a you will have to mention the column. So prompt is an instruction, query is an input, and response is the output. Okay, so in this particular way guys, what you will do, you will mention the information of your data. So again, let me repeat. So if you have any custom data guys, so you will keep it in a like first you will create a file, JSON file. Okay, so whether the data like would be available in the alpaca format, or it will be you will keep it in a shared GPT format, or you will keep it like this, okay, in the text and the data, right? You will have a multiple rows. So yeah, if you have plain text, you can keep it in a multiple chunks, and you can add multiple text over here like this. Let's say the second text like this, and third text like this, something like this. Okay, then guys, you have one more format, that is a DPO format, right? Prompt rejected or selected, right? Something like that. So yeah, what you will do guys, so if you want to use your custom data, so first you will upload inside this data folder. Now after uploading it inside this data folder, you will make an entry, okay, inside this dataset underscore dot info dot json. Okay, and after that you can use it. So I will show you over the UI how where you can select this custom data. Now one more thing, if you want to use the data from the Hugging Face, then how you will make an entry over here, because the data is not available in the local directory. So in that case, you will make an entry like this. You will write the key, under that Hugging Face URL, and then column. I hope guys this thing is clear. Now let's do one thing. Let's start the training from the UI. Now guys, let's start with the training. So for the training guys, I will have to select the model as well as the data set. So a data set I already configure. Now along with the model and data set, I will configure some essential parameter over here. I'm not going to configure all the parameter from here. I will only select a few parameter. So model, okay, so there are so many names, so many model. I have selected this Llama 1.12b instruct because it won't take much time. It is a small model, right? Then automatically the model path will come over here, right? Then hub, automatically it will be selected as you will choose the model. Then fine tuning method, which method you are going to be use here. So I'm going to be select the LoRA. Then checkpoint. So you don't need to mention the checkpoint, automatically it will come when the model will be trained. Then here quantization bit, okay, so it will be required. So whether you want to be select 4-bit or 8-bit, so I'm selecting 4-bit. Now quantization method, this will also be required. So which like method you want to be select, BNB, HQQ, EETQ. So I am selecting BNB only. The chat template, automatically it will be selected as you will select the model. Then ROPE, keep it empty. Booster, keep it auto only. Then here is a stage. So what kind of training you want to perform? So I want to perform the supervised fine tuning. Now data set, where is your data available? So if I'm selecting the custom data, the data will be available in the data directory. But if I want to be select the data from the Hugging Face, right? So what I will do, I will click on this drop down. Here I will get all my configuration. Okay. So here is, see, you can see the custom data also. So the custom data, I'm not going to be select the custom data right now. I'm selecting a data from the Hugging Face. So I will select the first one, right? So if I'm going to be select the custom data, in that case I will choose the directory, data directory. Okay, under this data directory, my custom data is available, which I already configure, which I already mentioned inside the dataset underscore info. So I will select this particular option. But as of now, I'm going to be select the data from the Hugging Face. So I'm selecting this particular configuration, HF underscore dataset. Okay, now this is done, guys. Now apart from this learning rate, so you can choose this learning rate. You can keep like any sort of a value. I'm keeping the same. Okay, I'm not going to touch this one. Epoch, I'm doing it for one single epoch. Okay, so let me select one epoch over here. Maximum gradient norm, I'm not going to select. Maximum sample, I'm not going to be select. Okay, compute type. So guys, here you need to change this compute type, because BF16 is for the higher end GPU. So you can select this AP16. Okay, it is for the lower end GPU. Then cutoff length, I'm not going to be touch it. Batch size, I'm not going to be touch, and I'm not going to be touch the rest of the parameter. So I'm performing this LoRa like fine tuning. So I can look into this LoRa configuration. If I want to change some LoRa parameter like LoRa rank, LoRa alpha, LoRa dropout, LoRa plus LR ratio, right? So definitely I can tweak this, but as of now I'm not going to be touch this part as well. Once I will teach you LoRa, the mathematical concept of the LoRa, then definitely we can look into this particular parameter and we can tune, means we can change it. Okay, I hope guys till here everything is fine. So after configuring this entire thing, this is the mandatory one, whatever I've done so far, then you will preview the command. Okay, so you can preview the command. See, once you will click on it, so here the entire command will come. Right now you can see output directory. Here your model will be saved at this particular directory. Okay, this is the config path. If you want to be keep any sort of a config, right, you can keep see this entire configuration, this entire like command configuration will be saved over here inside this YAML. Okay, then device count, I have only one device, so I'm keeping it one. DeepSeek, no, I'm not going to be select that. There's device memory, basically it will show you the memory uses, so automatically this will be here and there. Okay, the slider. So yeah, everything is like fine. Now what I can do, see, I preview the command. Now I can save the argument. If you want to save the argument, you can load the argument, the same argument. Okay, now what I'm doing, guys, after selecting all this thing, okay, after previewing the command, after checking, okay, my output directory is perfect and my configuration path is fine. See, even though we are not going to be like do anything right now with respect to this configuration path, but yeah, you can check all this thing, all this value, then click on this start training. Now once you will click on this start training, your training will be started. Now you can check the same thing over here as well. See that it will be reflected over here also over the collab. So this server should be up and running, guys. If you are going to be stop it, this will not work. This UI part will not work. Okay, so see, my training has started. Now the same thing basically you can see over here. So it will be reflecting over the UI as well, your training. So it will take some time, maybe 4 to 5 minutes. After that your training will be completed. Then what we'll do, guys, so here we'll select this evaluate and predict. If I want to evaluate my model, I can do from here, or else I can chat. Okay, even I can export my model. So yeah, see, the training has started. Now once it will be completed, on top of it you will get finish. Okay, and then basically you can chat with your model. So let it complete, then I will show you the chatting. So guys, here you can see my training has completed. It took around 4 to 5 minutes. So you can see finished over here. Now you can see the same thing over the console as well. Okay, and where you will get a model. So once you will check with your repository, see Llama factory, once you will check with the code, under this there is a folder. The folder name is save. Just click on the save folder. Here you will find your model Llama 1.1 to be instruct. Okay, now just click on it, and under this you will get LoRA. Under this LoRA you will get this folder train 2025 12 11 17 40 51. So see guys, this folder name is same over here, this one. This is your output directory. Okay, now from here you can load the model. You can just copy this path, copy the path of this model. Okay, and keep it over here. Means you can do the inferencing. Okay, so I kept the inferencing code. You can do the inferencing after training this model. So what you have to do for that, you have to like write a path. Okay, this path. So under this particular folder your model is available. See this one, this tensor save tensor file is available. Okay, so you can keep it inside this variable. Then you can load the tokenizer, then you can load the model. Okay, then you can load the PEFT model, and finally you can evaluate it. Sorry, finally basically you can make a prediction, you can do the inferencing. So this is from the code, but if you want to do it from the UI, yes, you can do from here as well. So what you have to do, you just have to click on this chat. Okay, now after clicking on this chat, so here is the option load model. So just click on this load model. So once you will click on this load model, so it is loading your train model. Now after basically loading the model, you can do the chatting. So it will take maybe like 1 minute. Okay, so within 1 minute it will load your model, and then basically you can start chatting. So let's wait for 1 minute. Okay guys, so my model is loaded. Now over here you can see, so it is giving me an option to write a prompt. So I can see here is a role is a user. I can write a system prompt also. I can give my tools as well. So if any input I have to pass, I will pass over here. So let's ask the same question. So my question is, can you tell me what is ls-l, okay, would display? So this particular question I'm providing over here. Let's see what it is going to be generate. So if I will submit it, okay, so here the output will be present. See, ls-display the detailed listing of the file. See, it is generating the entire output. You can see the complete output over here, guys. Means it is working fine. Okay, so this is the model which I fine-tuned on my own data using the Llama factory, and I shown you the prediction. So this is from the UI, guys, right? This is from where? This is from the UI. So I think you got to know now how to like fine-tune from the UI and how to make a prediction. There is a couple of more options. You can evaluate and predict. Evaluate and predict means what? So you can give the bulk data and you can evaluate your model, how it is behaving. You can export it. So wherever you want to be exported, anywhere in any directory, okay, you can mention the directory and you can directly export the model. So just explore it from your end and try to find you the model, and then like do the chatting and all. So this is from the UI, guys. But in the points I mentioned one more thing. So I will show you via CLI also. So let's do the same fine tuning. Let me show you the command via CLI. Okay, so how to do the same kind of tuning via CLI. So guys, if I want to do the same training from the CLI, then directly I can execute this command and I can perform the fine tuning. So what is the command? The command is python -m llama factory .cli train. Okay, and then I will pass my all the parameter. But guys, this is not a good practice. Okay, we should not directly run like this. So if I wanted to train via CLI, then what I will do, I will write one configuration file, YAML file. Okay, and through that YAML file only I will train my model. The same thing I have shown you over here. Let me open the notes and let me show you all the commands. So here I already mentioned the commands. Okay, so Llama factory CLI train config.yaml. You can write any sort of a name. I just written config.yaml. Okay, so what I will do, guys, so I will write one config file. Means I already written that. Let me show you that particular file. I kept in my folder, and this entire thing, guys, entire resources I will provide you, don't worry. So this is my config file, guys. I hope you are able to see this one, right? So inside this config file, what we have, so just check over here. So first we have the model name. Let me zoom in a little bit. So first we have a model name, okay, or model path from wherever actually you are going to be read the model. Then we have a stage, right? Then do train, fine tuning type, LoRa, means whatever parameter you were selecting from the UI. Now we are passing inside the YAML, right? See, we can write a YAML, or else we can pass like this, okay? If you are not going to be write a YAML, you can directly pass like this all the parameter. But guys, this is not a good practice, because if the terminal is going to be closed or terminal is going to be delete, right? So in that case, this all the parameter will be lost. So keep it in one physical file that's going to be YAML, and then execute that YAML file. Okay, so here you can see, so whatever parameter we were selecting from the UI, now we are going to be define inside the YAML. Here you can see the data set. So let me show you the data first. See, it is a data set. I'm going to be use the data from the Hugging Face, but if you are using from the local, okay, your custom data, then you just need to mention the path over here. So let's say guys, if you are going to use this custom data, so the data basically was available inside this data folder now. So my custom data, so just copy the path. After copy the path, just mention it over here. Okay, that's it. So if you will mention like this, okay, instead of this alpaca demo, you can use the custom data. I hope this thing is clear, but as of now I'm using from the Hugging Face, so let it be. Then guys, template, cutoff length, and max sample, override cache. I think you are already familiar with all this thing. Now output directory, where you want to save your model, so you can give any sort of a directory over here wherever you want to save the model. Okay, and the rest of the parameter, basically it is a like training specific parameter, and for how many epochs like I'm running it. So let's say I'm running it for the one epoch only. So guys, this file I will keep in the same folder. So I will keep inside this Llama factory folder. So let me upload this file, and here the file name is train Llama QLoRA. Okay, so you can write any sort of a name. I written just train Llama QLoRA. You can write any sort of a name. So I will pass, I will move this particular file inside this folder Llama factory. Now what I will do guys, see, the file is available over here, train Llama QLoRA YAML. So first of all, let me comment it. So yes, this is fine. Now what I will do guys, I will go inside this directory, okay, Llama factory. Then I will check with my current working directory with the pw command. That is fine. Now I will check with this NVIDIA SMI. Okay, the CUDA is there, means I'm using the GPU only, right? So here you can see guys, I mentioned one more thing, one more parameter. So this you have to set as an environment variable, that is CUDA launch blocking. Okay, so you can set it as a true. So what it will do guys, it will not like block it will basically not block anything while the CUDA is getting launched, right? But while the CUDA is getting used in a backend. Now here what you have to do guys, you just have to write python -m llama factory CLI. This will be same, even the train, this will be same. Now instead of writing all the parameter inside this command, you're just passing this YAML file. Okay, so this is the more safer approach. Now if you will run it guys, see, the training will be started. That's it guys, nothing else. Okay, and after that your model will be saved. You can check with the model will be available over here. Okay, so wherever basically we are saving, and then what you can do, you can simply test it. For the testing also, you can create one this is just one testing file basically I created. So see, the training is going on. So here the training is going on. It takes time. It will take maybe 4 to 5 minutes or maybe more than that. Then guys, you can check with your output folder whether the model is there or not. And after that, what you can do, you can make a inferencing. So let me comment all this unnecessary code. I was just testing. So here, this is fine. Yeah, this is the inferencing code guys. Okay, so you can basically mention the model path, adapter path over here. You can load the model, and then finally you can make a inferencing. That's it, nothing else. Okay, so this unnecessary code which I was just like testing, I will remove it. I will comment it out, so you will focus on the main code only. Now let me show you guys the training is going on or not. Yes, the training is going on. So where is the training? Here is the training guys, this one. So yeah, it will ask you one more thing if you will do it from the CLI. So create WNB account, use an existing account, or don't visualize my result. So as of now, I haven't like configured bit and bias account. So I will not select any one or two. I will select three. Okay, then hit enter, and yes, it is running now. So yeah, it has started the training. It will take time. Last time when I did it, means yesterday, I was practicing, so it took around 5 to 10 minutes. So it might take more than that, I don't know, because the RAM is being consumed continuously, so it might crash also. Okay, so guys, I'm leaving this up to you. Now what you have to do, I'm giving you one assignment also. So prepare any custom data set, keep it inside the data folder, and then fine tune on top of that data. Okay, now after this training, guys, what you will do, so after this training, just go and check with this particular code, right? Mention your model path over here. It will be saved over here, right? So yeah, this is the path. Just take this path, copy the path and mention it over here, and then test it, guys, whether your model is generating the answer or not. That's it, guys. That is called the inferencing after the fine tuning. So yeah, this is it for this particular video. I hope you like this entire Llama factory fine tuning. I given you as much as knowledge I can, and now it's your time to like revise, evaluate everything. Okay, and guys, one more thing, if you're liking my content, if you're liking my effort, then please subscribe the channel, and please share this content with all of your friends. Okay, whoever is required this type of content. Okay, so thank you, bye, take care, I'll see you in the next video. Until, take care, guys. Hey, hello everyone. Welcome back to my YouTube channel. My name is Sunny and I'm back with another exciting and important video. So guys, in this video, we're gonna discuss about the Unsloth, which is very important and the useful framework for the LLM fine tuning. So in the previous video, I discussed about the Llama factory, and there I given you the complete guide and the walkthrough of the Llama factory. If you haven't seen this video, please go and check, and believe me guys, you will learn so many things regarding the Llama factory as well as the LLM fine tuning. So in this video, we'll discuss what is the Unsloth, what all model is being supported by the Unsloth, then we'll see training types supported by the Unsloth. Okay, and we'll see why Unsloth is so fast and the memory efficient. Then we'll see top key features of the Unsloth, and we'll try to check, right, what is the differences between the Unsloth, Llama factory and the Hugging Face, and finally we'll come to the practical of the Unsloth. Okay, so guys, when I looked into this Unsloth, so I really got amazed. So there are so many things, so many features, right? And this library is very useful, and basically it is supported to so many models. And if you are fine tuning your model, right, so you can fine tune 2x faster with the less RAM, with the less VRAM, guys. And really guys, see, this library is very, very amazing. When I will show you, like, you will also like surprise just by seeing the performance and all everything. So guys, this library is not a small one. There are so many things to learn, and to cover up entire thing in a single video, it's a bit challenging. So so in this video, I will discuss the theoretical point, and I will show you one practical, and the rest of the concept relate to the other model, multimodal, and then basically relate to the RL, right, reinforcement learning, whether it's a GRPO, ORPO, or the different other concept of the fine tuning, right? So we're gonna learn in the upcoming video. Now apart from this one, I'll discuss about different other framework, like Axolotl is one of them, and definitely I'll show you that practical is also ready. Maybe that would be the next video. Okay, so now without wasting a time, guys, let's start with the Unsloth, and then I will come to the practical. So guys, now let's understand what is the Unsloth. So Unsloth is an open source project for the LLM fine tuning. It helps you to run the end-to-end pipeline. So what does it mean? Let's understand. So Unsloth allow you to load the model, to apply the quantization, means you can perform the different kind of quantization. Then you can train the model, you can perform the inferencing, you can evaluate the performance, then you can save the trained model, and you can export. So all of these guys 2x faster with up to 70% less GPU memory, that is called VRAM. Okay, so this is the main advantage, or this is the main and the important feature of the Unsloth. So let me give you the quick walkthrough of the Unsloth GitHub. So guys, once you will write Unsloth GitHub on the Google, right, you will get it. So here is the entire source code of the Unsloth. You can take a walkthrough of it. So the entire source code is a open source. Once you will go and check inside this Unsloth, right, you will find out the different folder like utils, registry, model, kernels, okay, data preparation and all. So you can look into that, you can understand the entire code and all, so that your understanding will be more concrete. Now guys, just check out their readme file. So inside the readme file they have mentioned so many things regarding their model. Okay, then they have mentioned on what are platform actually you can install this Unsloth. Now Unsloth news means if anything they are updating inside the source code or any new feature, so they are keeping it over here, so you can look into this Unsloth latest news. Then guys, link in the resources, so you can join their community, you can go through with the documentation, their Twitter page. Okay, so different hyperlink they have provided over here. Now what is a key feature, you can read from here as well. Okay, I kept all these things in my notes, so I will provide you, definitely I'll provide you. Now installation of the Unsloth, so they have given you the complete detail how you can install it, and then they have given you the complete preview of this documentation. If you want to explore the documentation in detail, you can click on it. Otherwise like they have given you the complete like the short code only, the quick start code, so you can take this code and you can run inside your system, right, on your server, wherever you want to be run. Then see the basically some information regarding the reinforcement learning, that what all technique is being supported, some hyperlink, that definitely you can check it out. Okay, and then performance benchmarking. So these many things they have provided over the GitHub itself inside the readme. I would say this GitHub and this documentation is a very useful if you are willing to start with this Unsloth. It give you like so many things and every kind of detail. So guys, just go through with their GitHub. If you want to be like go and check their source code, go and check. Otherwise check with the documentation. Okay, over the documentation they have given you each and every information in a very structured way. So guys, I hope you understood what is a Unsloth. So Unsloth is nothing, just a project which is coded by someone else and we are using it. Now they have done some sort of a optimization in their code. Means everything they are building on top of the Hugging Face, right, on the Hugging Face native library like transformer, PEFT and all. On top of it they have done some sort of a customization, right, and that customization is very useful for achieving the speed as well as the less GPU memory. Okay, I hope you got it. Now what kind of inferencing is supported by the Unsloth? Means let's say if you are training a model and after the training you wanted to save somewhere, means you are exporting that model. Now where you can use that, at what all places you can use that? So these are the name guys, you can use it in the Llama CPP. You know Llama CPP, right? So we can run the GGUF model over there. I already explained in my previous video. If you don't know, go and check over there. Then we can run the same model over the Llama. We can run the same model through the VLLM. We can run the same model through the SGLang Hugging Face Hub. Means we can upload the model to the Hugging Face and we can export it through the Hugging Face native libraries, and we can utilize that model or we can use the model through the open web UI. So these are the different platform. Okay, these platform are supporting their Unsloth model. So if you are training a model through the Unsloth and if you are exporting that, then you can utilize it anywhere, okay, at any platform. I hope you understood it. Now I mentioned couple of more points. So what all model is being supported by the Unsloth? So Unsloth guys is not only supporting the text to text model, it is supporting the text to image, image to text, audio to text, text to audio, means all the multi-modal, whether it's supporting the text, images or audio. Okay, so whatever model is available over the Hugging Face, all the model is being supported by the Unsloth. Means I will show you their repository. Actually Unsloth has created one repository over the Hugging Face itself, so you can directly fetch all their model from there. And see here I mentioned the example also. So this is the normal repository. Okay, of the tiny llama, and in the same model, actually the tiny llama model, you can fetch from the Unsloth. So this entire thing I will show you in some time. Okay, everything I'm going to be show you in terms of practical, as well as I will give you the quick walkthrough from the Hugging Face also. Now guys, training, what all kind of training is being supported by the Unsloth? So training wise, you can do the full fine tuning. Full fine tuning means you can train all the parameter of the model, or you can perform the LoRA, means you can perform the, you can basically train the subset of the parameter, and then you can use that as an adapter. Okay, then QLoRA means a quantized LoRA. You can load the quantized model. On top of that, you can perform the LoRA. Then 6-bit LoRA, FP8 training. Okay, or basically you can see over here the different type of reinforcement learning. So guys, if we're talking about the reinforcement learning, so different kind of industry leading reinforcement technique is being supported by this Unsloth, and that's the main power of the Unsloth. So here I mentioned couple of name. So you can perform the reward modeling using the KTO and PPO. Now apart from that, you can perform the latest like technique like GRPO, which is being performed in the DeepSeek itself. Okay, and GSPO, DPO, ORPO, right? So every kind of reward, every kind of basically preference or training, preference alignment training, you can do using this Unsloth, right? And like guys, believe me, it will give you the very good speed, as well as it will utilize very less memory while you are training, okay, your model. I will show you with all the coding and all everything, guys. I will discuss in some time. So I hope you got the quick overview of the Unsloth. Now let's look into their features, and let's see why this Unsloth is faster, because that two thing is very important, guys. Now guys, before exploring the key features of the Unsloth, let's take an overview of the Unsloth Hugging Face repository. Let's see how many models are available over here. So guys, once you will write Unsloth over the Hugging Face, you will get this particular repository. Now under this repository, total 1150 models are available. Every sort of a model you will get over here, whether it's a text based or video based, or for the images, for the audios and all. Okay, now guys, here you can see, so we have one model that is Tiny Llama, and there is like one more model, Tiny Llama, right? So both are different model, or both is a like same one? So guys, over here you will see, so this Tiny Llama, actually it is belonging to this Unsloth repository, and this Tiny Llama model, it is belonging to this official repository of the Tiny Llama. Okay, so guys, let's see the differences. Actually this both model are different. Unsloth have done some sort of a optimization, so let's look into the optimization. Okay, what all kind of optimization have been performed? So here I mentioned the optimization, guys. Let me show you. This is all the like optimization which have been performed by the Unsloth. So if we're talking about the normal Hugging Face based model, so the model name is what? The model name is a Tiny Llama. Okay, this one 1B chat v 1.0. Okay, now here we can load this particular model with a HF transformer. We can apply some bits and bytes. We can perform the LoRA. Okay, and then it is being trained using the PyTorch kernel, right? It's standard PyTorch kernel. But if we're talking about the Unsloth one, so Unsloth basically the same Tiny Llama model. On top of it, they have done some sort of a quantization, means if you are going to be load the model from the Unsloth repository, so that is a pre-quantized model. Then they are using the Triton kernel, so it is like more than this standard PyTorch kernel. It is a specific kernel. This same kernel basically have been used by the ChatGPT also, okay, for the GPT model for their training. So Triton kernel, and then manual autograd, and this auto packing. So these are some feature which have been implemented on top of the base model to make the model little faster and the lighter. Okay, so that we can load it inside the minimum VRAM. Now what all this feature? So definitely I will give you the quick walkthrough under the key feature of the Unsloth. And if you want to understand the mathematics behind it, for that basically I will record a separate video, because before understanding the mathematics of this autograd and the other concept and all, our fundamental should be clear, right? How the LLM have been trained from scratch. So once I will record that particular playlist, under that I will keep this features, I will keep these points also. But yeah, Don't worry, I will give you the quick walkthrough of these particular feature. We have so many, actually 5 to 6 more. So yeah, I'll give you the quick walkthrough. Now I hope you understood about this Unsloth repository. Just go through and try to explore each and every model. How to use it, I will show you in some time. Now, one more thing, guys. Let me show you that as well, because that is very much important. So here I mentioned one point. Try to read this point. So Unsloth is built on top of the Hugging Face transformer, PEFT, and the TRL. Okay. So Unsloth is built on top of the Hugging Face transformer, PEFT, and TRL, but it enhanced them with a low-level GPU optimization to deliver 2x, 3x faster and 50 to 80% better memory efficiency. So what is the conclusion? What I wanted to say you guys? So what I wanted to say you, so if we're talking about the Unsloth, so this is also built on top of the Hugging Face, okay, Hugging Face transformer. So under the Hugging Face, basically you will find out one very important library, that is a transformer. And this transformer, actually it's a open source project, it is a open source code which completely written in the Python, and some sort of a part of the transformer, right, specifically the tokenizer, have been coded in the Rust, right? So guys, this transformer, this is a very important project of the Hugging Face, right? And this transformer completely written in the Python, and there they have used the PyTorch and the TensorFlow and even JAX. Okay. Now guys, if we're talking about the PyTorch and TensorFlow, so what is the backend, the low level language for this framework? We all know, right? So this framework have been written in the C++, right? So PyTorch, again, the backend of the Python, completely written in the C++, even for the TensorFlow, even basically some kernels also have been written in the C++. Okay, so this transformer and this PEFT TRL, actually it's a native library of the Hugging Face. So let me show you the raw code of this transformer and the TRL and the PEFT also. So guys, over here you can see, so this is the code of the transformer. This is a very important, guys, and this is a backbone of every framework. So whatever framework you are seeing, whether it's the Axolotl, whether it's a Llama factory or Unsloth, right? So it is a backbone of all the framework. Actually they are using the same source code, and on top of it they are making some changes, some enhancement, okay, and that it is making some like faster or little memory efficient and all. So this is the source code of the transformer, guys, and this is very amazing. And see here the number of star and the number of fork, right? Just go through with it, you will learn so many things regarding the transformer. Your fundamental will be very, very strong. Okay, now apart from that, you can see, so one more library, that is TRL, okay, one more repository. So yeah, this source code is also public. You can definitely navigate to this entire source code. And one more very important library, that is PEFT, right? So I think we all know about this TRL, PEFT, and the transformer. And even I shown you the practical of with all this library in my previous video, right? If you don't know, you can go and check over there. So what I wanted to say here, I wanted to say, guys, so the base of every library is this transformer only, transformer, PEFT, and the TRL only. This is very much important. Okay, most of the low level code have been written inside this transformer itself, and the code have been written inside the PyTorch and the TensorFlow. Now guys, you know, right? So this is under the Hugging Face. Okay, this all the library, this all the packages comes under the Hugging Face, right? Hugging Face, actually they created it, and then they make it they make it open source, okay, for the public, so that other developers also can contribute over there. Then on top of it, the Unsloth have been built. Okay, there's a optimized engine. So if you are looking to the Unsloth, right, if you are looking into the source code, so just think just think one thing, that this is the optimized engine on top of the transformer, on top of the Hugging Face based library like transformer, TRL, and the PEFT. Okay, so yeah, so there this Hugging Unsloth, basically it's using the Triton kernel. This is a very specific and the very powerful kernel. Okay, regardless this the PyTorch, the standard PyTorch kernel. Okay, if I'm saying kernel, guys, it's nothing. It is just a set of programs, okay, which have been written in the C++, which is for the GPUs. That's it, guys. Nothing. Kernel is nothing. Okay, and so that my application is running over the GPU itself. So I hope you understood what is a Unsloth and where it is standing. And I think your all the doubts related to the Unsloth is clear now. Let's look into the documentation and the key features. After that, I will show you the practical, guys. So guys, the goal of the Unsloth, or the main claim of the Unsloth, is 2 to 3x faster training, 50 to 80% less GPU memory uses. So it gives ability to train large language model even on the free GPUs like Colab and the Kaggle. Even I will show you the practical with the free GPU only, and easily we can train our model with the Unsloth. Now, what does it mean, and how they are achieving this fast training and the efficient memory? Now, let's like take a look. So here, what they are saying? They are saying if normal task, right? If the task normally takes 10 hour and 40 GB of VRAM using standard Hugging Face training, then it will only take 5 hour and 12 to 16 GB of VRAM with the Unsloth, right? So this is the claim of the actually of the Unsloth. So let's understand with this particular example. Let's say we have a model. The model name is Llama 3.1. Okay, the parameter is around 8 billion. Now if a Hugging Face takes 20 GB of VRAM, so Unsloth will only take 7 to 80 GB 7 to 8 GB VRAM. Okay, if Hugging Face takes 2 hours of training, then Unsloth will finish within an hour itself. So this is the claim of the Unsloth, guys. Now just see the differences. But guys, you must be thinking, Sunny, how all these things are possible? What kind of changes they have done? Because of that, this thing could be possible. So guys, here I listed couple of reasons. So because of this particular reason, the things is possible. Okay, so let's understand each and every reason one by one. I'm not going to teach you the mathematics, the complete detail in-depth mathematics, but yeah, I will give you the overview and some idea, okay, how these things are working. So we're talking about this, we're talking about the first reason. So custom, CUDA and Triton kernel. So first of all, we'll have to understand about this term CUDA, right? What is a CUDA? So we're talking about the CUDA, guys. So CUDA is nothing, it's a framework. Okay, it's a framework. It's written by the NVIDIA. Okay, it's written by the NVIDIA. Specifically, it's written by the NVIDIA for what? For the GPUs, right? So CUDA is a framework which written specifically for the GPU training. Okay, for the GPUs actually, and it written by the NVIDIA. And this framework, this CUDA framework actually, it was written using this C++. Mostly the C++ have been used over there. So you can say CUDA is nothing, it's just a library of framework which have been written in the C++, okay, which is written by the NVIDIA specifically for the GPU. Now what is this Triton, guys? Triton, again, it is a kernel like the CUDA. Okay, this Triton, it is written by the OpenAI. So it is a OpenAI, it's a OpenAI's kernel. Got it, guys? So it's a OpenAI's kernel. So they have written some, they made some changes inside the CUDA kernel, the existing kernel itself. They have used the Triton kernel, and because of that only, they are able to do the faster operation on top of the GPUs. That is the one reason. The other reason, which I listed over here, fuse attention and MLP operation. So what does it mean, guys? So if you know, the transformer architecture is having two main things. Now the first thing is called the attention. Okay, attention. So first block, basically it's a attention block. Let me write over here attention. The second block, it's a MLP, multi-layer perceptron. Okay, now guys, this two operation are the separate operation. So they have fused this operation. Okay, means they have merged this operation. They have used some sort of a technique in backend. So this both operation is happening all together. So that's a simple meaning. Okay, optimize forward and the backward propagation. So yeah, this is also possible. Means the epoch, basically, right, we are running. So they have optimized that also in terms of loss function and the optimizer. Then smart gradient checkpointing. So what does it mean, guys? So whenever we are going to create a checkpoint, okay, so in that also they have make some sort of a changes. Means they are not going to be do the checkpointing in basically every point. They are going to be stored in a memory, and then they are going to be highlight that. Okay, some kind of changes, that kind of changes basically they have made. So the next is, guys, flash attention compatibility. So what is a flash attention? So if you will search over the Google, you will get this GitHub repository. So flash attention, basically it's a optimization on top of the attention, right? So just look into this particular repository. It's a like open source repository. Just read out their readme at least. So let's read at least the first point. So they are saying this repository provide the official implementation of the flash attention and flash attention 2. So flash attention is a fast and memory efficient exact attention with the IO awareness. So how we can efficiently load the attention operation in the memory, in the RAM actually. So it is all about that. So just read out this particular readme. You will get each and everything regarding the flash attention. Or in some other dedicated session, I will discuss about this flash attention. It's a very important thing, guys. Or it makes the, I shown you one point. Okay, I'll show you. I kept that particular point. So long context training. So this is possible. This long context training basically it is it is possible because of this flash attention only. So this is also one of the point which is being implemented by this Unsloth developer. Then manual backpropagation engine, not the PyTorch autograde. Means for the backpropagation they are not using a PyTorch autograde graph. So whenever the backpropagation is happening, PyTorch autograde is creating one graph, okay, one DAG actually, direct acyclic graph. So it is not using that particular one. Instead of that they are using some other logic, okay, inside that backpropagation also. Automatic sequence packing. So what does it mean, guys? So guys, whenever we are passing any text, okay, let's say we are passing any text, so the text basically let's say whatever text we have, so let's say we have sentence 1, right, and we have sentence 2. So first we are passing vector regarding the sentence 1, then we are passing vector regarding the sentence 2, right? So this particular sentence, this particular sequence, this vector is getting merged. Okay, this vector is getting merged. So that is called the automatic sequence packing. Means sentence 1 and sentence 2 we can combine all together and we can pass, right? Something like that. So this kind of optimization they have done. Again, I can repeat that. So custom kernels, custom CUDA and the Triton kernel. Okay, then fuse attention and the MLP operation. They have combined the MLP and the attention operation. Attention wise, they have used the flash attention. Okay, now some gradient checkpointing and the optimization the forward and the backward propagation, means on a optimizer level and even on the loss function. Means they haven't touched to the mathematics part, right? They have just tweaked the programs, right? They just made the changes on a programming level. That's it, guys. Then programming level and how basically this entire system is interacting with with our server, basically with our IO operations, right? That's the main part. Now automatic sequence packing, I think I already told you, right? A manual backpropagation engine, so they are not going to be use the PyTorch autograde, right? For the backpropagation operation and all, they are using the manual and the customized backpropagation. So because of that only, guys, they are not going to be lose anything. Okay, the accuracy loss is like negligible or like very minimum, and they are able to achieve 2 to 3x faster training and with the minimum RAM, right? With a 50 to 80% less VRAM, right? Now over here I written some sort of a more point. So if we're talking about the CUDA NVIDIA low level C++ library, so what is a, someone is going to be asked you what is a CUDA? So it is a NVIDIA's low level C++ library specifically built up for the GPU, right? And because of that only the parallel operation is possible, and it is like fast, right? So it is like very fast. Now what is a Triton, guys? So again it is a kernel. Okay, it's a CUDA like kernel specifically have been designed for the GPU itself by the OpenAI. So yeah, because of this thing, guys, the Unsloth is becoming like faster and the memory efficient. Now let's look into some more key feature and then basically come to the practical, guys. Now guys, let's revise the top key features of the Unsloth. So the first is long context training. This is a very important and the amazing feature of the Unsloth. So the meaning is Unsloth can handle up to 300k token training. So guys, 300k, just imagine 2 to 3 lakh of words. It is equal to one single book. So it can handle up to 300k token training. It's like really amazing. So the same thing in the normal HF training will give you the out of memory error. So if you are taking this much of data and you are simply using the Hugging Face, okay, in that case you cannot do it, guys. You cannot do it. It will give you the error. The maximum limit is 28k token, okay, 28,000 token. Now guys, here I kept one example. Maybe with this particular example, your understanding will be a bit more clear. So here I written the model name. Model name is Llama 3.18b. Okay. So approximate maximum context length using the Unsloth means in how much memory, how much context we can bear, right? How much tokens we can bear. So if we have 8 GB of memory, in that case, we can take up to 3000 token. If we have 12 GB memory, in that case, we can take up to 21,000 token. If we have 16 GB of memory, we can take up 40,000 token. 24 GB memory, 78,000 token. Guys, remember 24 GB memory means the same amount of memory we get in the collab. Okay, I think no 12 to 16 GB of memory. I'm not sure. I will have to check. But guys, with the free GPU itself, we can bear at least 40k thousand token, right? And the same thing basically in the Hugging Face will definitely give you the error. So how this thing is possible? Let's understand that part. Now, if you have 80 GB of memory, in that case, you can handle up to 3,40,000 token. Okay. Now, these numbers are possible due to Unsloth memory efficient kernel, smart checkpointing, and the rope scaling. Now, let's compare with the Hugging Face. So guys, with the same standard Hugging Face training, okay, 12 GB of GPU will give you out of memory error, means you will not be able to load the model. That's the first thing. The second thing, on 80 GB of GPU, only 28k tokens. Getting my point, guys? So here, what I wanted to say, if you have Unsloth and you have 80 GB of RAM, then you can train up to 3,40,000 token. But if you have Hugging Face, the normal Hugging Face, not an Unsloth model, okay, you are not optimizing using the Unsloth and all, nothing, simple Hugging Face, in that case only you can bear 28,000 token. That's it, guys. So that's the power of the Unsloth, and the same feature have been highlighted over the documentation and even over the readme page of the GitHub. Okay, Unsloth GitHub. Now let's look into the other feature of the Unsloth. I think you all already I already discussed about it, but yeah, let's take a revision of it. So massive VRAM reduction, yeah, this is possible, like up to 50 to 80% reduction. I think you know why. So I already highlighted points. Because of that, it is going to be reduce the memory. Then reinforcement learning, so GRPO, right, and GSPO. This is the latest technique of the this is the latest optimization technique, policy optimization technique, okay, for the reinforcement learning. And yes, this is possible inside the Unsloth. Then custom CUDA in the Triton kernel, this is one of the feature, right? End-to-end pipeline export, I already told you, we can do everything using the Unsloth, and definitely I'll show you that. Exact math, no approximation, means they haven't do any sort of a changes in the mathematics. They just did they just have done the like code level changes and the framework level optimization. The mathematics, the implementation of the mathematics is like same to same. Then work on the free GPU and collab. So if you are not going to be use too much RAM, right? If you can process it on a like even on the commercial GPU, right? The consumer GPU, not on a commercial GPU. This collab and the Kaggle GPU actually comes under the consumer GPU only. Then GPU support, it is supporting to the different GPUs, right? So it is supporting to the Intel's GPU, AMD GPU, and NVIDIA GPU. It can run it. It can be run on any operating system, whether it's a Linux, Mac, or it's a Windows, right? So these are the features, some feature of the Unsloth, right? And definitely we are going to be discuss it in a upcoming session. All the feature we'll see in the detail. Okay guys, so let's start with the practical. So this entire practical I will perform in the Google Colab. Okay, now here first what I will do, guys, I will go in the runtime, I will change my runtime, then I will select the GPU. Okay, this is a free GPU. If you have Google Colab Pro access, then this paid GPU will be available for you. Now after saving it, here you will get the connect option. Just connect it. After connecting it, you will get this green icon, means the resources have been allocated to you. Now install this required packages like torch vision, torch audio, xformer, right? These packages are basically from the for the PyTorch. So this is the main package of the PyTorch. Then this torch vision for the vision, then torch audio for the audio, specifically xformer for the attention, okay, flash attention. Then Unsloth, okay, then transformer, then TRL. So you need to install all this module. It will take some time, maybe 5 to 10 minutes based on your internet connection. So here I written the complete detail, okay, of each and every packages I will write going forward as well, so that it won't give you the difficulty while you are running it from your end. Then here guys, I have defined some configuration. So I'm going to be import this random, then numpy, then torch, right? Then I define some seed value. So random.seed, np random.seed, torch manual underscore seed, then torch CUDA manual seed. Now why it is there guys? So just remove the randomness. So at every run actually some random thing will be there. Means I can give you one example. Let's say if we are going to be initialize a model, right? If we are going to be initialize the weight of the model, let's say we are executing 5 times, so every time new weights would be there, right? So just to reduce that randomness, we define the seed value. So for this particular execution, right, for this particular execution the same weights would be there. This is not for only for the weight, this is for the GPU. Okay, if the dropouts value are there in between, right, for that, for the attention kernel, means for the attention value, the k qkb weights, right, for the CUDA operation. So just to remove this randomness for every execution, we are defining this seed value. Then I'm defining some other configuration also. So this is for the faster and stable matrix multiplication on top of the NVIDIA GPU. So torch backend CUDA matmul. Matmul means matrix multiplication allow FT, TF32, right? So I'm keeping it true. Then torch set float matmul precision high. So I'm keeping precision high. Then some other values like max length, okay, max sequence length, data type, right, load in 4-bit, which is true. So this particular variable will be used going forward. I hope till here everything is fine. Now coming to the next part. Now guys, what I will do, I will check the GPU availability, whether the GPU is available or not. So for that guys, what I will do, I will write this line of code. Now guys, see, I already written a code in my notepad, so I'm just going to be keep it, because to write a code from scratch it takes a time. So assert torch CUDA is available. So if the GPU is available, it will say yes, it is available. If not, then it will print this particular message. Okay, so yes, I'm going to be executed, and see, it is not going to be print this message, means the GPU is available. Or else directly you can check, it will basically give it true. If you are going to be execute this method directly, let me show you. So let me print this torch CUDA is available, so it is saying true, right? Now what I will do guys, I will import the necessary library. So the next is going to be Unsloth. From Unsloth I'm going to import this fast language model. Then I'm going to be load this load dataset. Okay, I'm going to be import this load dataset from dataset. Then from TRL I'm importing this SFT trainer and SFT config. Now let me execute it guys. So after execution I will be able to import this Unsloth, right, and the other required packages. Now what I will do guys, so I will load the dataset, and before load dataset, let me do one thing. Let me load the model itself. So I'm going to load the model now over here guys. So what I'm doing, I'm going to be load the base model. So Unsloth tiny llama BNB 4-bit, this is the model name. So this fast language model is having one method from pre-train. Now using this particular model, I'm going to be load this model. Then maximum sequence length, I am going to keep this 4096, means whatever output will be generated, the output will be under that length. Then data types, so I mentioned the data type also. Then load in 4-bit, yes, the quantization will be applied. So here I mentioned this particular variable value, load in 4-bit true, right? Now guys, over here you can see it is importing. It might take some time first time. So yeah, it is done. Now I'm going to load the model in the tokenizer. Both thing I can load using the same method, fast language model, fast language model from pre-train, and here I'm passing the required parameter. Okay, so once I will execute it guys, I will be able to get a model. So this model loading might take some time, and it will ask you the Hugging Face token also. So please keep the Hugging Face token in your secrets. See, I kept it at least with the read permission. So you have to give the read permission to your Hugging Face token. Now what you can do guys, you can check, you can print this model, and you can check the model is there or not. You can print the tokenizer, you can check the tokenizer is there or not. You just need to print it after loading a model. First time it will take some time. See, the model is getting loaded, and then basically you can check. Okay, you can check the different thing, different basically values of the model. So let me show you some of the thing. So first what I will do guys, I will check the model trainable parameter. that how many parameter this model is having. Now see guys, model is loaded. Even though this is the like little huge model, but it got loaded I think within a minute itself because of the optimization of the Unsloth. Now here what I'm doing guys, I'm running it, and so see this is my tokenizer. Now if I will check with the model, so see this is my model guys. Now what I will do guys, so over here I will check with the trainable parameter how many trainable parameter this model is having. So if I'm going to be executed guys, see here it is saying okay, Llama for causal LLM object, no print trainable parameter. Okay, fine guys. So first what I will have to do, see here actually this is the simple model, okay, the normal model. So what I will do, I will convert this particular model into the PEFT model. So this is the code guys to convert this particular model into the PEFT model. Now over here what I'm doing guys, I'm going to be use this fast language model, the same object, and then I'm calling this get PEFT model. Now here I'm passing my model, I'm passing my LoRa rank, okay, then I'm passing my target module QKVO, then get projection, up projection, and the down projection. Then this is some other parameter, okay, for loading the PEFT model. So if I'm going to be executed guys, what I will get, I will be getting the PEFT model, okay. So now after that guys, I can check the trainable parameter. So over here you can see trainable parameter is around 2 crore 52 lakh 31,360. All sorry, this is a trainable parameter 2 crore 52 lakh 31,360, and all parameter is around 11 crore guys, 11 cr parameter. It's like very huge. So how many trainable parameter is around 2.242%. That's it guys. Now what you can do, you can check each and every layer also. So if I'm going to be printed guys, you will be getting each and every layer, okay, inside this particular model. See this is a layer. Now here you can see like this is the each and every layer of the transformer, okay, of the transformer model, because this Llama model is built on top of the transformer itself. So you will get the attention module over there. So see, you can see the attention basically. So it is giving you each and every layer, and regarding the each and every layer the parameter would be there. I hope this thing is pretty much clear to all of you. Now let me show you a couple of more things. Now what I'm doing guys, I'm going to be show you how many trainable parameter is there, how many total parameter is there, and then what will be the percentage. So this is a simple like code I have written. With that you can check the trainable parameter, this is the total parameter, and here you can see the percentage. So trainable parameter is around 3.94 percentage of all the parameter. I hope you understood it. Now you can check the device also, so on which device it have been loaded. Now over here you can see it have been loaded in the GPU device, okay. The type is a CUDA, right. You can check the data type of the parameter. So it is having so many like functions and the parameters. So you can check the data type of the model. Now you just need to call model.parameter d type, you will be getting that, okay. Now here you can check the model is a PEFT model or not. So what I'm writing, so I'm going to be import the PEFT, I'm writing model is a PEFT model or not. So if I'm going to be executed, you will see a model is a PEFT model. Now if you want to check the basically configuration of the PEFT, you can simply execute this model PEFT config. You will be getting the configuration of the PEFT, PEFT. Now apart from this one guys, if you want to check the memory, how much memory have been allocated, so you simply need to call torch CUDA memory summary. So once you will run it guys, you will get the complete memory detail. Now you can keep it in some other cell because it is in a markdown format. See, this is the complete detail of the memory. How many active allocated memories there, how many active memories there, what is the requested memory, GPU reverse memory, reserve memory, non-release memory, allocation. See, so many things you can see over here. Now I hope you understood so many things, what all thing you can call on top of the model. Now let's do one thing, let's move forward and let's try to prepare the data. So what I'm doing guys, so here I'm going to prepare a data. So for formatting the data or for preparing the data, I already written a code. So let me give you that entire code, okay. So this code is also very easy and easily you can understand. So what I'm doing guys, so over here you can see, so first I'm going to be add this end of the sentence token to the tokenizer. This is fine. Now this is my prompt. So here my data is available into this instruction input and response format. You can create your own data as well. Even the previous video I have shown you how to do that. Now here is the prompt. Below is an instruction that describe a task paired with an input that provide a further context. Write a response that appropriately complete the request. So this is the instruction, this is the input, and here is the response. Now what I will do guys, so this is my format data. So I'm going to be load my data. Now I'm just going to be take 1500 rows 1500. Now on I will map this particular data set. So dataset dot map. Okay. So what I'll be, so here I am going to be apply the formatting on top of this particular data set, or dataset dot map. And okay, and here my function is format data. This is my function format data. It will take an example and it will format the data. It can take the data in batches. Okay, and remove column. So yes, we are going to be remove. So we are going to be remove the this dataset column name. Okay, this particular feature, and then we are just going to be keep the text only. So this is my data set, guys. Here is my data set. If I can show you this particular data and what all feature are there, so that you will get a clear understanding that what is happening over here. Now I'm going to be executed in a different cell. So load a data set. It might take some time again, maybe 1 or 2 minutes, up to your, like based on your internet only. So see, it is loading the entire data. And if I will show you the dataset variable, so inside this dataset variable, actually you will get some sort of a feature. See, here we have output feature, input feature, and the instruction feature. And the number of rows is around 51,000. So we are not going to take the entire data. What we'll do, we'll take a 1500 row only. Now what I'm doing, guys, so here you can see load data. We have trained with a split. Now we'll be taking the data set only 1500 row. Now dataset dot map, we are going to be map this method. Batch is equal to true. Dataset dot column name. So this particular column name we are going to be removed. Okay. Now this format, what it is doing, it is going to be take a instruction, input and output, and it's going to be combine everything in the inside the single sentence. Okay, complete single prompt. So this is the format of the prompt. Here the value will be placed, instruction, input and response, and this entire prompt will be going to the LLM for the training. Okay, for the fine tuning. So likewise, guys, we have prepared the data set. Now let me show you the data set, how it will look like. So we have this data set. Okay, now inside this data set we have this text column, and then we have the number of rows is 1500. Now if you want to check the first row of the text, so here you will write the data set text 0. Now once you are going to be executed, so what you will get the first text. Likewise, we have 1500 text. Okay, now guys, what I'm doing, I'm going to be install some other packages and library. This is important. So I'm going to be install this p as util. Okay, process and system utility. Then I'm going to be import this ps util along with the time. Then what I'm doing, guys, I'm checking. So here I'm checking peak GPU memory uses. Okay, this line reset peak counter. So you measure only this training run. Okay, not previous run notebook. So guys, when I'm going to be execute this torch CUDA empty cache, means it is going to be empty the cache, the entire cache. If I'm going to be write torch CUDA reset peak memory state, so from here onwards my memory will be detected. Okay, how much memory is being consumed. So let me run it, and let me run the further code. Then now over here what I'm doing, guys, so here I'm going to be start the time. So for starting a time, guys, what I'm doing, I'm writing ps util process. So process will be there. Then I'm going to be calculate the time. So it's a start timing. Okay, and then I'm checking a RAM. So how much RAM is there before the training. Okay, now what I'm doing, guys, so after that my process will be here. So you can see the process, it is nothing, it's a ps utils object. Now here what I will do, guys, so I will check with the train time. Now over here, see, just check with the train time. So train time is being shown over here. Now we'll compare it with the end time. Okay, after completing the training, what would be the end time? So see, this is the train time, right? Now CPU RAM, so here you can see the CPU RAM. What is the CPU RAM? So it will give you the CPU RAM, right? So this is the CPU RAM. Now what I will do, guys, I will define my trainer. So the trainer defining is very easy using the Unsloth. So here what we have to do, we have just to define the SFT trainer. We have to pass the model tokenizer data set. Okay, then the data set text field. So text column is there, then packing true, right? I told you the packing, right? So when I was talking about this particular theory, right? So over here I return one automatic sequence packing. Okay, one of the important feature of the Unsloth. Then here is my configuration, SFT configuration. So how many epochs is going to be done, how many batches will be there. Okay, what optimizer I'm going to be decide, what is a rate of that, right? So everything we are going to be learning rate is there. So everything we are going to be define over here. Okay, we are going to be initialize a class, and then we'll be getting an object. Now I'm going to be call this train method. So once I'll do that, guys, so the training will be started. Okay, so the training will be started, and training will take some time. Now after completing a training, what we can do, we can calculate how much memory have been consumed, what is the time, right? And see, we are going to be calculate the training time second, peak GPU VRAM GB, and CPU RAM I used GB. So after the training, after the completion of the training, you can check out with all this thing. It will like really give you the detailed understanding. So let me print this entire thing. So for printing, I already written a print method. So this is a print method, guys. Now what I will do, guys, I will print, okay, the training time, how much training time it is taking, peak GPU VRAM and the CPU RAM used. Now once it will be done, guys, see the training might take some time, maybe 5 to 10 minutes or even more, like more than that. Once when I trained with the 50,000 of rows, then it was taking too much time. Maybe it's going to be complete within 2 to 3 hours as well, right? Because that data is very huge. But if you are doing it with the limited data, then it will be little faster. So here, guys, you can see we are going to be calculate everything. Now what I'll do the inferencing. So for the inferencing, guys, see this is the code. Let me keep the code, guys. See the training has started over here. Now what I will do, I will keep the inferencing code. So in the inferencing, I'm going to be load the model, okay, for the inferencing. This is the this is my prompt, okay, which I will provide. Continue the Fibonacci series, Fibonacci sequence. Then here I'm going to be load the here I'm going to be tokenize the input, and then I'm going to be called tosh.noGrade, and then we are passing the input over here, and finally we are generating a output, right? So my output would be there. So let's see whether it will be able to generate the correct output or not. So let's wait for a minute at least, or see the training, how much time it might take. So in okay, it is 14:15 right now, so till 188 maybe it will take 15-20 minutes, guys. Okay, so what I'm doing, so here I'm going to be check all the memory, RAM and all everything here. Basically I'm going to be check, right? So what will be the output after training and the loading of the model? Now I hope you understood everything. Now if you want to save the model, guys, so for saving the model is very easy. So if you wanted to save on your current directory, you just have to write the name, okay, which name you wanted to save. So model.save pre-train, once you will run it, and tokenizer.save pre-train, once you will write it, guys, you will be able to save your model inside your respective or the current directory. Okay, so whatever directory you are providing, in that particular directory. Now I hope guys you understood this entire thing, you got a clear cut understanding. Now one more point is remaining over here. The point is Unsloth versus Llama effective versus Hugging Face. So maybe in the next video, once I will discuss the Hugging Face versus Unsloth, I will let you know. I will discuss about this Unsloth, Llama effective and Hugging Face. Until, guys, you can practice with this much of thing. So let me highlight you again. You can test with the, you can, what you can do, guys, you can load the model, you can check with the different parameter, you can see how many layers is being executed, it's a trainable, right? Then you can check the timing, how much timing it is taking, you can simply calculate. In this standalone solution it is not important, but yeah, if you are doing it, if you are going to be compared with the other framework, in that case it will be important, right? Then what you can do, guys, after doing it, so dataset loading, model loading, okay, model training. Now after training the model, right, see model is still being trained and we are in between, so 61 step is done now. So at every step basically it is giving me a log, right? Then what we are doing, guys, so yeah, this is the output, means what will be the training time, peak GPU RAM and the CPU RAM. Then here is the inferencing, very easy. And then we are saving a model, and this particular model we can use anywhere. So yeah, guys, this is it for this particular video, and this training will take time, so that's why I'm going to be stop the video, okay, or else let's do one thing, let it complete, and after completing this one only I will show you the prediction inferencing, and then only we'll close the video, guys. Okay, guys, so the training is completed. Here you can see I completed one single epoch, and let's see how much time it took for me. So I'm going to be print everything. Okay, so this is a syntax error, let me run it now. So training time is around 5:35 seconds. So if I'm going to be divided, so how much it would be, let me check. 535 divided by 60. So if I'm going to be check, it took around 8 minutes, okay, approximate 9 minutes. So peak GPU VRAM, it was around 1.9, means 2 GB only. Within 2 GB it was able to do it, and CPU GRAM was around this much. So guys, here you can see every sort of a detail, like how much time it took and all everything. Now what I'm doing, I'm going to be test it. So here let me execute it. It will take some time, and then what I will do, guys, I am going to be save this particular model, and then I can utilize it anywhere. So see, this is a response, guys. This is a response, and now you can see the response. This is the input, and it's completing the Fibonacci series. Okay, so 1, 2, 3, 5, 5 to 6, 11. Okay, I think the response is not quite good. Maybe we'll have to train more. That we can do. That is not an issue, right? So yeah, this is one thing. Now what I'm doing, I'm going to be save the model. So this is my path LoRa model into the current directory. Here it will be saved, and yeah, let me save the tokenizer and the model both, and then I can use it anywhere. So if I will refresh it, guys, I will be getting my model. I can keep it to the Hugging Face hub also, because hub is nothing, it is just a repository for the model. So see, guys, my model is available over here. So configuration and the model, the saved tensor file, it's a binary file. Okay, so yeah, guys, this is it for this particular video. I hope you understood the Unsloth and the complete uses of the Unsloth. Now what I'll do, I will show you so many things using the Unsloth in the upcoming video. Now guys, over here, this is a critical thing to setting up this SFT trainer and all everything, right? To choose the best possible parameter over here. Whatever I have shown you over here, as of now, it is just a beginner friendly. At least you should be aware about this much of parameter. We'll see a couple of more, and we'll deep dive into each and everything, whether it's a Hugging Face, Unsloth and all everything. So stay tuned with me for the future. If you haven't subscribed the YouTube channel, please do it, because you will see lots of amazing content in the near future. So thank you, guys. Thank you very much. Bye bye, take care. Here is all the point, guys. So first we'll take a look over the fine tuning documentation. Then we'll see a supported method via OpenAI API. OpenAI API is supporting so many methods like SFT, vision fine tuning, DPO, RLHF. We'll take a look onto each and every method, but guys, at the end we'll perform only supervised fine tuning. Okay. Then we'll see how we can fine tune via dashboard and via Python API. I will show you both method, but mainly I will focus on the Python API, not over the dashboard itself, because the same job we can perform using the dashboard, but we'll explore the Python API, because as a programmer we have to focus on this side. Then fine tuning step-by-step process. So these many processes are involved when you are going to be fine tune any LLM model using the OpenAI API, like collect a dataset example, format a dataset into the JSON, then dataset format validation, token counting, cost estimation, then how to upload the dataset using Python API, how to create a fine tuning jobs, start the fine tuning, evaluating a model, everything, guys, everything will come inside this video itself. Then fine tuning best practices from the OpenAI API. So we'll try to explore each and every model. I will give you the quick walkthrough of the entire documentation. There we'll focus on the data quality, what kind of data actually you need to be have. Then hyperparameter tuning, what all like hyperparameter we have and what all value we can keep. Then token limit, right? So every model is having their own token limit. So we'll discuss onto that. So guys, these many points we are going to discuss throughout this video. So if you want to become master in OpenAI API fine tuning, then this video is for you. So please watch this video till the end, so that you can fine tune any GPT model using the OpenAI API. Now guys, one more thing, many people asking their doubt over the LinkedIn, and they are mailing to me continuously. So for those folks, for those people, guys, I have created this topmate link. So if you have any sort of a doubt, guys, just go through with this topmate link, and here I have given you the different services, the various services like quick chat, resume review, mock interview, interview preparation tips, career guidance, generative AI interview preparation. So guys, according to your requirement, you can connect with me. Okay, now let's start with the fine tuning. First, take a look over the documentation, and then step by step, one by one, we'll perform the entire practical, guys. So guys, for accessing the documentation, you just need to write OpenAI API platform in any browser. So I'm using Brave browser. You can use any browser. Now once you will write this OpenAI API platform, you will get this openai.com. Now just click on it, just open this OpenAI API, openaiapi.com. Now here they have given you the login, this login option. Now just click on this login. Here you will get the three options. One is the chat GPT, second is the API platform, and third is SORA. Okay, so I want to access this API platform, so I will click on this API platform. Now, after clicking on this API platform, you will find out the entire documentation. So this documentation is very huge. There are lots of things. So if you are going through with this documentation, you will understand how to access the OpenAI API key, how to access the various model, the core concept of the OpenAI API, then agents, tools, evaluation, so many things basically they have mentioned over here, right? But here our aim to understand the fine tuning, and here our aim to generate the OpenAI API key, so that using that we can access the different model, and we can fine tune those model. So first guys, I will show you how you can generate a key, how you can basically recharge your OpenAI API account, and then I will show you the fine tuning. Now guys, if you will scroll down onto this documentation, so inside this evaluation section, okay, let me show you. So here is the evaluation, sorry, model optimization. So under this model optimization, actually you will get this fine tuning. Okay, so once you will click on this drop down, see here they have given you the option to perform the supervised fine tuning. Means how you can perform the supervised fine tuning. They have given you the complete step. So you just need to go through with this each and every step, and easily you can fine tune your model. Okay, I will show you what all model you can fine tune. I will give you the complete guide of all those model along with the costing. Apart from that, you can perform the vision fine tuning. If you have vision data, you can do that also. See, this is the model. Then you can perform the direct preference optimization. See, this is the model. There you can perform the DPO. Reinforcement fine tuning, yes, that is also available with this model. So just go through with this documentation guys, you will get the complete detail of the fine tuning. Don't worry, after generating a key, okay, and after adding some credential inside my account, I will give you the walkthrough of this fine tuning pages, okay, of this documentation itself. Now guys, what you have to do, you just need to click on this quick start. Now once you will click on this quick start, here you will get an option to create an API key. So just click on this create an API key. Now after clicking on this create an API key, you will get an option to generate the API key. Okay. So it is loading for me. Let it load. Still loading. It should not take this much of time. Yeah. So guys, I got my API key, right? So I already generated one API key. So I have my API key over here. So using this API key, I can access the different model, and then I can perform the fine tuning. But if you don't have any API key, then you can click on this create a new secret. Okay, once you will click over here, you will get an option to create a new secret key. So just write the name, whatever name you want to be write in, under under which project you want to be create that. Just write the project name and then create a secret key. Okay. Now guys, a very important thing. So after creating this key, can you access any model? Can you access any model from the OpenAI API? The answer is no. You cannot access the model until you don't have money inside your OpenAI API account. So how to add the money? So let me show you that. So once you will click on this uses, okay, so after clicking on this uses, you will get the various option over here. So it will give you the complete metrics of your uses, how many tokens you are using while you are using the chat completion API, while you are generating images, file search, web search, moderation, embedding, every sort of a thing you will get over here. Every sort of a thing you will get over here regarding your money, right? Regarding your tokens, regarding your tokens count. So you can see over here the February budget. The February budget is $120. Okay, and I spent $0. I haven't used this API. Okay. Now guys, this is not a money actually. This is a budget. I can decide the budget, and then according to my requirement, I can add the money inside my account, and then basically I can use it. So how to add the money inside the account? So for that there is an option. So you just need to click on this edit budget. So once you will click on this edit budget, okay, so here you can see you can edit your budget, right? So you can add the alerts, you can edit the budget. Apart from this, you can explore the model, right? So you can explore the token limit of every model. TPM means a token per minute. Okay, so rate per minute, a token per day. Okay, so this is the full form of this specific term, TPM, RPM, and TPD. You can explore more about it, right? As of now, I'm not going into these detail. I will more focus on the fine tuning. Now guys, you can see the users limit. So maximum I can use $1 lakh. Okay, on one single account I can use $1 lakh, means I can set the limit up to 1 lakh over here. Okay, so I can set up to 1 lakh rupees of budget for my OpenAI API key onto one single account. Now guys, here you will get this billing option left hand side. Just focus on this billing. Now once you will click on this billing, so see, this is my credit actually. So I added $10 into my OpenAI API account. Okay, and I'm using this amount only for my for accessing the model. Okay, for generating the responses based on the given request, right? So if you want to edit, if you want to add the money into your account, so here is the option add to credit balance. So once you will click on it, so here you can write the amount, whatever money, like whatever like amount you want to be add. Now just add your payment detail, credit card detail. Okay, and then click on this continue. Then guys, what you can do, you can add the money into your OpenAI API account. Now you can enable the auto recharge also. If the money is going to be end, then automatically it will recharge your account. So guys, this money, this is your actual money which you have inside your account, and then you can like decide the budgets and all, right? So whatever budget you have in your mind, you can keep it. See, again I'm saying this is not a money. I can give you an example. Let's say you are going to decide a budget for your grocery. Okay, per month you are going to be decide a budget for your grocery, let's say 5,000 rupees, but in your current account, in your current saving account, you just have 3,000. So the budget you have decided, that is 5,000, that is on paper, right? This much you are going to be spent, but the actual amount you have inside your account, that is 3,000, right? So you can adjust your budget according to your requirement, whatever you want to be keep over here, but this is the actual money which you need to be charged, right? Which you need to be recharged inside your OpenAI API account. I hope this thing is clear, because this is a very important thing, guys. If you don't have it, then you cannot fine tune your model. Even you can keep $5 also, but I think minimum is $10. You can explore from your end, this one. Okay, now guys, let's take a look onto the documentation of the dataset and all. Okay, and after that I will show you this entire code. See, this is the entire code which I prepared for all of you. Definitely one by one, step by step, we'll do the fine tuning using this entire Python code. Now guys, before starting with the coding part, let's explore the documentation. Let's see what all method is being provided by the OpenAI API. Let's explore the dataset format, and let's explore the costing of the different model. So guys, once you will click on this model optimization, and if you will scroll down here, so you will get this fine tune a model section. So let's read this paragraph at least, and let's see what this OpenAI is saying. So OpenAI models are already pre-trained to perform across a broad range of a subject and task. Fine-tune lets you take an OpenAI based model, provide the kind of input and output you expect in your application, and get a model that excel in the task you will use it for. So what does it mean, guys? So the meaning is very simple. This GPT model is already trained on a very huge amount of data. It is capable to perform a broad range of tasks, but still if you want to fine tune on your specific data, then you can do it. So guys, I'm not going to be read each and every line of this documentation. I will highlight only the important point. So guys, here in order to this important point, this table is very important, guys. So they have given you the different methods over here: supervised method, vision fine tuning, direct preference optimization, reinforcement fine tuning, and they have given you the model name also. With whatever model you can use it. Okay, use this different method. So if you want to perform the supervised fine tuning, you can use this model. If you want to perform the vision fine tuning, you can use this model. For the DPO, this model, and for the reinforcement fine tuning, this model. If you don't know about this particular method, you can go and check with my playlist. Already I have discussed this method in a very detailed manner. You can follow this video number 14, 15 and 16, or else you can follow this crash course. Got it, guys? Now guys, let's come to the supervised fine tuning. So here is a complete overview, like how we can perform the supervised fine tuning. So we have to build our own data set, then we'll have to upload our data set. Okay, the data set will be in the prompt formatting. I will show you how the data set looks like. Then you have to create the fine tuning job. Then you have to evaluate the model after the fine tuning. Now here guys, this is the complete detail how you can build your data set. Now minimum how many example you can keep. So minimum you can keep 10 examples, and maximum you can keep 15 to 100, and 50 to 100 example are the good one. Okay, so if you want to be really improve the if you really want to be improve the answer, the output of the model, then at least you should have 15 to 100 example. You can read this entire documentation. It will give you the complete and the detailed idea about the dataset format and the data preparation and all. But guys, this much information is not required. Once follow this video till the end. After following this video, after performing the practical and all, then you can go through with this entire documentation and the entire page and all, right? So that your understanding will be more comprehensive and the more concrete. Now guys, this is the format of the data set. This is the format of the supervised data set. If you want to explore one single row, you can simply click on this corresponding JSON data set. Now once you will click over here, you will get the format of the one single row. So this is the JSON format guys. Now inside this JSON format, we have a key. So the key name is the message and the value will be the list. Now inside this list, you will be having the different role like user, assistant, system. Okay, and then you can keep the content. So content could be anything. So over here you can see, so we have a role user. This is the content. Content is nothing, it's just a question or whatever you want to be like pass to the model. Then role is assistant, and here is the content. The content is a tool calling. So either you can write a simple message or you can define your tool calling and all, right? So both is fine. In our fine tuning, we are not going to be fine tune our model on a specific tool data. I'm just going to be fine tune on a simple chatting. Let me show you my data set, how I prepared my data set. Okay. So guys, now here, if you will scroll down, you will get like more detail about the fine tuning jobs and all. Right, so definitely you can go through with this documentation for the more understanding, right? It is just for your self learning, self study. Now guys, let me show you how I prepared my data set. So once you will go through with my GitHub guys, this is my GitHub, fine tuning GitHub. Now inside this GitHub, I created one folder. So the folder name is LLM fine tuning 20 GPT, LLM fine tuning 20 GPT fine tuning. So just open this folder. Now over here you will get this data set data.jsnl. Okay, JSNL means what? JSON L. L is representing to the new line. Okay, so as many as JSON object you can keep which is separated by the new line. So this is the data set guys which I created for the fine tuning. At minimum I can keep 10 rows. So I just kept the 10 rows just to demonstrate you. But if you are doing it in a real time, in that case guys, you will have to keep at least 50 to 100 rows for the better output. Now guys, here this is the data set guys which I opened in the VS Code just to show you how it looks like. So this is the one single row. So inside this row I have a key name is message. Then we have a value is the list. Now inside this list we have a system. Okay, then we have a user. Now here we have a assistant. So yes, regarding each and every role, I have written their corresponding messages. I will again come to this particular data set. I will explain you that why I have written these messages, what is the meaning of it, and on what kind of data set I am fine tuning my model. Okay, I hope you got the understanding of the data set. Okay. Now guys, so if you want to explore the other data set, you can go through with the different pages like vision or fine tuning. So here you can see the data set format of the vision for the vision fine tuning. So this is the data set format. If you want to prepare your data set for the vision fine tuning, then you can follow this particular format. If you want to prepare your data set for the DPO, you can follow this particular format. See, here is a format. If you want to prepare your data for the reinforcement learning, then you can follow this specific format. So in the upcoming classes, in the upcoming video, definitely I'll show you how you can fine tune your model with the different methods, with the different techniques. Definitely I will show you in my upcoming video. Now guys, for the reinforcement learning guys, we required few additional thing like a grader and all. So if you want to manually grade the output, whether it is a good or bad, you can do. Otherwise you can use the LLM model. Okay, LLM as a grader. So this is a separate thing. Once I will come to the reinforcement learning, definitely I will show you this as also. Now, here is some best practices. So definitely we'll explore inside this video itself. I will give you the quick walkthrough of this best practices. What should be the data quality, and how we can calculate the end cost. What is the hyperparameter tuning and all we can perform. Now, guys, this is all about the data set. Now, if you want to know about the model, guys, so what you can do, so you can simply click on this pricing. So just click on this pricing. Now, after clicking on this pricing, guys, here you will get the pricing of each and every model, okay, regarding the different tasks. Now, guys, once you will scroll down over here, see here you will get this fine tuning, this one. So just click on this fine tuning. Now, after clicking on this fine tuning, you will get the pricing of each and every model with respect to the fine tuning. So these many model we can fine tune, like O4 mini, O4 mini. Okay, this is the date which when this model was like published. Then here is the GPT 4.1, GPT 4.1 mini, nano, 4.0, 4.0 mini, and the other model also. Now, guys, here you can see, so this is the training cost. This is per hour basis. Now, this is the input cost. So the input cost means the message which you are providing to the LLM. Okay. So this is the input cost. This is the cache cost, means if you are going to be provide a same input again, so OpenAI is going to be pick that particular input from the cache memory. So this is the cost regarding the cache. Now this is the output cost, guys. So here you can see the cost, the pricing. It is per 1 million token per 10 lakhs token. So this is the training cost with respect to the fine tuning, guys. Now here is the cost for the inferencing. So after the fine tuning, whenever we are going to be inference the model, whenever we are performing the inferencing, the prediction, then this will be the cost. This cost will come from the input, cache input, and the output. So in this video, I will show you the fine tuning using this GPT 4.1 Nano, because it is having the minimum pricing. Okay, $1.50 per hour. I hope, guys, this thing is clear. You understood about the dataset format. You understood about the different methods of the fine tuning in OpenAI API, and you understood about the pricing part. Now let's start with the practical, and whatever things will come in between, definitely will explore through the documentation itself. Okay, guys, so the entire practical will perform in the Google Colab, but you can perform this practical anywhere on any server. If you want to do in your local, you can do. If you want to do on any cloud server, you can perform there as well. So feel free to perform this practical anywhere. So I am doing it over the Google Colab. So first of all, guys, I will have to connect with my runtime. So here I will select my runtime. So runtime wise, I'm not going to select the GPU this time, because I'm not going to perform any training on my server. So the training will be performed over the OpenAI server. I just need to configure the training using the Python API. Now, guys, what I will do, so first I will select the CPU, then I will connect, and now I will install the OpenAI SDK. So for installing the OpenAI SDK, I will simply write pip install OpenAI. So once I will write this pip install OpenAI, and I will install it. So yeah, it is getting installed. Now after that, guys, I required my OpenAI key. So I shown you how to get the OpenAI key. So in the same way, you have to generate a OpenAI key, and you have to keep it inside this key. Okay. So you can add a new secret. You can click on this add a new secret. You can add a secret. Okay. You just need to write a name OpenAI API key, and then paste the actual key over here, and then save it. That's it, guys. Nothing else. So I already did it. So I just need to activate it. See, here is my OpenAI key. This is the value of it. Now what I will do, guys, I will read the key over here. So for reading a key, what I will do, I will simply copy and paste this code snippet. Google.colab import user data. Now user data.get OpenAI API key. So I will get the OpenAI API key. See, the key is available inside this particular variable. Now what I will do, guys, I will set this key as an environment variable. So for that, guys, I will import OS. Now I will call this method os.environ, and then I will write this OpenAI API key. Okay. This is my variable name, OpenAI API key. Now I will give the value of it. So this is the value, OpenAI API key. I'll mention the value over here, and now I will run it. So see, guys, I set the OpenAI API key as an environment variable. Now guys, what I will do, I will import the OpenAI class from the OpenAI itself. So from OpenAI, import OpenAI. Okay, OpenAI. Now what I will do guys, I will import the OpenAI. Now I will create an object of this OpenAI. So here is a class. I'm going to be create an object of this class, and the object name is going to be client, CLIENT. Okay, now what I will do guys, the client is there, client is ready. Now I will check whether my model is working or not. So here I will call this method, this chat completion method, client.chatCompletion.create. Okay, and this is my model name. Now here's my message. So what is the champions trophy in the in the cricket, and how it is different from the World Cup? So this is my message. A user is asking this particular question to my model, to the model, and this is the model guys. I can use any model, but yeah, I'm just checking with this particular model whether I'm able to hit the API or not. Then later on I will fine tune. Now if I will hit it guys, I will get a response over here. So I can get a response. I can simply call this I can simply call this chat, I can simply call this completion choice message and content. Now see guys, this is the message, means we are able to hit the model and we are able to get the response. So yeah, my model is working fine. Now what I will do guys, I will take a data set, and first I will check whether the data set correct or not. Then I will count the token, and then basically will perform the fine tuning on top of that particular data set. Now guys, we'll load the data set. So I already shown you the data set. See, this is our data set, data.jsnl. JSONL means JSON, JSON. I think you know about the JSON, right? So it's a dictionary object which we keep inside the file, inside the physical file. JSONL means you can keep as many as JSON object, which you can separate via new line. So if you will see that kind of data inside any file, so this is the extension for it, JSONL. Okay, this is L actually. Now let me show you the data set, data.jsnl. If I can open it, see here is our 10 rows, 10 JSON object. I think I already shown you this data, and you can see this data. Actually, it is all about the smartphone detail. I will come to that, what kind of data basically I kept, and like how we can perform the training. First of all, before performing the training, let's do the validation of the data set. So what I'm doing guys, so here I'm going to load the data set. So for loading a data set guys, what I will do, I will open this file. So this is the code for it. Let me give you the code. See, here is a code, import JSON. Then you can give the path of the file, content data.jsnl. I created one more file, this data2.jsnl. I will come to this file, why I created it. Definitely I'll show you use of this as well. Okay, this another file, because inside this file actually I missed some data points. So while I will show you the validation, I will show you with the both file, first with the correct data and second with the incorrect data. So here I kept the path content data.jsnl. Now here's the encoding. Encoding is equal to UTF-8. Okay. This is the universal encoding. Keep this only if you are going to be read your data inside the collab or in your local. Now I'm going to be open the file. Now what I will do guys, I will iterate on top of this file object. Okay, and then I will keep it inside the list. So this is the further code for it. I will iterate on top of this file object. Okay, I will keep it inside the line variable. Then I'm going to be loaded using this JSON.loads. So I will not get a string, I will get a proper JSON object, means the dictionary. In Python you can say it's a dictionary. Now let me do it, let me load it guys. So if I can show you the data, see here is the data guys. Inside this particular data we have 10 rows. So at least we'll have to keep 10 rows, okay, inside the file if you want to fine tune the GPT model. If you are going to keep below 10, then it's not going to fine tune. Okay, it will generate the error. It will give you the error that okay, your data set is not having 10 rows, please increase the number of rows. Now I think so you got the data. Now if I want to check the one single row of the data, I can simply write data 0. So here I will get the one single row. Inside this particular data, inside this particular object, inside the JSON object, we have message key. Under this message key guys, you will find out the different role like system, you will find out the user, and you will find out the assistant. Okay, role is there, then content is there. So there is two key, okay, role and the content inside this particular inside this particular list. Okay, inside this particular list we have one more dictionary object. Okay, this one, this is a dictionary, then this is a dictionary. So every role, guys, it is separated inside the dictionary only. Now what I'm doing, guys, if you want to check the number of example, that how many number of examples we have, so simply you can call the length on top of the data, because it is a list, guys. Here you can see this is a list. So inside this list only I kept the entire object, okay, this JSON object. So if I can check how many JSON object we have, so you will get the number. So number of example is 10. Okay, I hope this thing is clear. Now how we will validate the data? So for validating a data, we required a couple of more import statements. So here I'm going to keep all the import statement like tick token. This is for token counting. So we are counting the token. Okay, so if you want to count the token, so we'll use this tick token module. Then we have one more module, that is NumPy. Okay, so if you want to convert anything into the array, right, then you can use this NumPy. Then we have one more module, that is collection, and from this collection we are importing this default dict. I will show you the use of this default dict, where we are using it. Now what all thing we are going to validate over here. So guys, here I can make the heading. So the heading is very simple, data validation. Data validation means we are checking the format of the data, whether the format of the data is correct or not. So I can also write over here format validation. I hope this thing is clear. So format validation or the data validation, anything you can say. So we are just checking the format of the data is correct or not. Now here what I will do, guys, I will keep one code, I will write one code, okay, and using that particular code we are going to validate the data. Now what all thing we are going to validate, so you should be aware about that also. So here I'm going to copy and paste. So this is the entire table, guys. Please read out this table very carefully, so that you won't face any difficulty while you are understanding the code. So we are going to validate the example type, means this one example. See guys, this one data row, this one data row, actually it is also called example. Understood? This one data row, okay, where we have the message, then we have a role like system, user, and the assistant, and we have a content regarding each and every role. So guys, this particular this single object, actually it is also called the example. I hope it is clear. So how many in total example we have? So we have 10 example, 10 in total example. So first we are checking the example type, whether it is correct or not. Okay, so whether it is a dictionary or not, whether it is a the JSON object or not, right? The JSON object which is separated by the line. So we have like 10 JSON object. You can say JSON object, or in Python it is a dictionary. So we are checking that. Then we are checking message keys, whether the message key exists or not. Then we're checking the required key, okay, role and content. Then we are checking there is no extra key. Then we are checking role, okay, like system, user, assistant, function. We are checking all those role. Then we are checking the valid content, means there is no empty string, okay. Then we are checking assistant present. At least one assistant role should be there inside one JSON object. So this is one JSON object. Okay, if you are not keeping assistant over here, in that case, this dataset format is wrong. So at least one assistant should be there. Okay, you can keep as many, but yeah, at least one assistant should be there. Okay, inside one JSON object. Now, guys, I hope this thing is clear. Now, what I will do, guys, I will create an object of the default dict. Default dict means it will give you one dictionary, actually, nothing else. So here, what I'm doing, I'm going to be create a default dict, and here I will keep it inside the variable. So variable name is what? Errors. Okay, so I'm initializing one dictionary, and I will keep all the error and all everything inside this particular dictionary. So this is the code, guys, which I written. Let me show you the code. So with this particular code, you can easily understand what all thing we are going to validate. So let's start over here. So we'll iterate over the data set. The example will come over here. We are checking the type of the example, whether it is a dict or not. So if it is not a dict one, then we'll say errors data type is equal to 1. Means we'll say over here the data type is a key and the value will be 1. Means inside the error dictionary we are going to keep the error. Okay, the error basically it is related to the data type. You will get to know. I will show you the end output, don't worry. Then we have example.get. So here we are fetching the detail of the message. So and we are checking, okay, if the message is not there, in that case also again we'll log the error inside the dictionary. Then we are iterating on top of the messages. We are checking role and content is present or not. If the role and content are missing, then again we are logging the error inside the dictionary. Then guys, we are checking role, content, name, function call, weights, everything we are checking inside the particular message. Okay, if it is missing, then we can say message unrecognized key, right? So message is a unrecognized key over there. Then we are checking system, user, assistant, function. Okay, if this is not a role, in that case again we are going to log the error. Okay, that unrecognized role. If we are checking the content, okay, if the content is a function call, right? If it is a function call, so we are checking the content inside the function call. If it is missing, then we are saying missing content. So you can go through with this code, you can understand what basically I'm trying to say over here, how I am formatting the data, sorry, how I am checking the validation against the formatting of the data which we are about to pass for the fine tuning to the OpenAI. Guys, okay, I hope it is clear. If there is an error, if we have something inside the dictionary, then we are saying found error, and then we'll represent the error, will show the error. If there is no such error, then we simply print no error found. I hope this thing is clear. So let me execute it. I think you will understand in a better way once I will uh, execute it. Okay, so here you can see, so once I executed, guys, with respect to this data, so it is saying no error found, means in my data everything is perfect, everything is clear. But guys, here I kept one more data2.jsnl. Now inside this particular data, I haven't created one role. So let me show you this particular data. With that, you will get a very good understanding. So we have message, okay, message, then we have role is a system, then content, this is the content. Then guys, you can see, so we have role is a user, and this is the content. Now if you will check with this particular data, so we don't have assistant over here. Okay, so now we are checking this particular data, whether this data correct or not. Okay, against this particular code, again this code, we are checking our data, whether the data is correct or not. So what I will do, see, we don't have any sort of a error, we don't have any sort of a error with this data.jsnl. I think you understood about it. But if you are going to be checked with this data2.jsnl, let's see what we will be getting, as a final output. So here what I'm doing, guys, I'm going to be write data2.jsnl. Okay, now let me execute it. So here is my data. Now you can check the data. See, in the first message itself, we don't have assistant. Now number of example will be same. Data validation, this is a complete theoretical point. You can read it from your end just to get a more understanding. Then here is my like import statement. This is my by default dictionary. Okay, you can think it is a empty dictionary, right? Then guys, we are going to be iterate on top of the data. Example will come over here. It is going to be check the data type. Then guys, here you can see it is checking the missing message list, missing message key missing, message unrecognized key, unrecognized role, function call. Okay, so many things it is checking. Now if I will execute it, see what you will get. So guys, here I'm getting one error, found one error, example missing assistant message 1. So it is saying in all the example, in all 10 example, at one place, okay, this assistant is missing, the role assistant is missing. I hope guys this entire thing is clear. So now what I will do, guys, I will show you how you can count the token. Okay, token counting utilities, I will tell you now, and then we'll come to the final training call. Okay, so after completing this one, we'll do the final training call, guys. Now guys, let's perform the token counting and the cost estimation. So guys, here I shown you the pricing page. So here you can see there is a different model and the pricing of that model. So this is a training price. This is the training price, means actually it's the cost of the GPU on a hourly basis. This is the input price, input token price, and the output token price. Input token price and the output token price per 1 million token. So guys, as I told you, this is a inferencing input and output token price. But guys, this statement was the wrong. So this input and output token price, it is with respect to the training only. If you have trained any model or any classical ML and DL model, there what we do, we provide the data, we provide the input to the model, and model predicts some output. Okay, and based on that loss and all, we basically estimate, right, how my model is performing. And then we perform the inferencing on top of that train model, right? So this is the like simple training mechanism. if we will perform training of any model, not only the LLM, so we are going to do in the same way. We provide the input, then model predicts some output, we calculate the loss, and we try to correct that loss. Okay, like that only we train any model. So this is the input and output of the training data set. So guys, here what I'm doing, let me show you. So first guys, I'm going to be load the encoding model. If you don't know about it guys, I will create a separate video of it. What is this encoding model and how basically it's going to perform the encoding. If you don't know much about it, so what you can do, you can check out with my Hugging Face tutorial. I recorded one crash course over the Hugging Face. There I discuss how you can load any transformer based model and how you can perform the encoding using that model. Okay, and how you can assign the encoding IDs, right, token IDs to those specific sentence and all. You can check over there, right? So what I'm doing guys, I'm going to be use the OpenAI specific encoding model. So OpenAI provides you one library. The library name is stick token. So using this stick token, I'm going to be load this model CL100K base model. So this is my encoding model guys. What it will do, it will perform the token. It will create a token out of this sentence, and it will assign a ID, okay, to this particular token, to the specific token. Okay, so this is also a transformer based model. Again, you can check out that video, or else I will create a separate video. So this is my encoding model. I'm going to be loaded now. Here this is my text guys. I'm just showing you how it is going to perform the encoding, okay, and how it's going to be assigned a proper ID, okay, token ID to that, and then I will show you the tokenization of my actual data set. So here is my text guys. So I took this particular example, hello, how are you, and I'm passing to this particular method encoding encode text. Now what it will do, it will create a tokens, okay. So it will provide me a token ID. So this is the token ID guys, as you can see over here. So this is the meaning of each and every ID. So hello is being represented by this 9906. Comma is being represented by this 11. How is being represented by this 12868. Then R, then U, and then this question mark. Now if you want to decode that sentence, right, so you can simply call encoding decode, and then you can provide this token ID. So you will get your text back. So here is your text, right? So what you are doing guys, so you have a text, you are going to be tokenize the text, okay. So once you will tokenize the text, you will get the token ID, and then simply you can decode. And using which model we are doing, using this model we are doing. So this model is available under the stick token library, which is created by the OpenAI. Now guys, what I'm doing, I'm going to be check like how many tokens are there inside my data set, and on top of it only we'll try to check the estimation, okay. So like the cost estimation. Now one more thing guys, this is the pricing page. Here they have listed all the pricing and all regarding each and every model of the fine tuning. But apart from this, we have one more like page, okay. So this is again from the OpenAI itself. So the address of this page is cookbook.openai.com. So OpenAI is providing you the different cookbook where they are providing you the ready-made code, okay. So you can directly utilize that code inside your examples, inside your like development. So I'm taking a reference of this code only. So if you will go through with this particular page, so here only they have given you the code of the format validation. Just now I have shown you the format validation, right? So I took the code from here itself, and now I'm going to be counting the token, and I'm going to be calculating the cost, right? So I'm taking a reference of this particular code itself. So guys, here I'm taking a reference of this entire code, and I'm making that easy. But if you want to explore everything in a very detail, then definitely you can check out with the cookbook, and you can understand each and everything in a detail. But guys, here also I try to decode everything in a detail. Means I try to like give you the summary of each and everything. So yeah, first you can go through with it, you can understand the process, and then for the like more detail, you can check out with their own specific page, okay. So this is the this is my two list. One is the total token, and the second is the assistant token. This assistant token is the output token, okay. So first let me initialize this two list. Now what I'm doing guys, I'm going to be create two functions. So this is my function guys. The first function is a count total token. Now here what I'm doing, I'm iterating over the messages. So I will be getting this messages. Now from here I'm getting this content. Okay, now I'm going to be encode that content and then I'm checking the sum. Okay, now if you don't know about it, simply you can check out with the data. So what you can do, you can write the data, so you will get the complete data. Now if you want to check the first message, write the 0 over here. See, this is the first message, guys. This is the first message. Okay, so how you will get a content, guys? See, this is the content, this is the content. Okay, so you are checking the content, you are checking the like size of the token. Okay, this is the content. So what you are doing, you are going to be convert into the token and you are checking the sum of it. I hope you understood it. So the same thing we are doing over here. So inside one message, how many tokens are there? So we are checking that using this particular code. Now let me execute it. Yes, this is fine. Now what I'm doing, guys, so here again I'm iterating over the message. Now if the role is the assistant, so then only we are checking, then only we are going to be encoding it, means we are checking the token. Okay, we are counting the token and we are doing the sum of it, right? So here counting assistant token. So this two function, one is giving me the total token, one is giving the assistant token. With that actually we can check how many total token, how many input token and how many output token are there. So let me execute it. So here I'm passing the here I'm iterating on top of the data. So I will be getting an example. So from the example I'm passing the message. Okay, I'm passing a message to this method as well as to this method. This is a simple Python code, right? Now let me execute it and see, here is a total token. See, in first message how many total token is there, in second message how many total token is there, in third message, fourth message, fifth message. In all the 10 messages these many tokens are there. Okay, then assistant token. So here this is the output token actually. So in every message how many output tokens are there. Okay, so simply we are able to calculate it. Now here is some few more statistic. So average token per example, I can calculate the average token. I can check with the maximum token. So here the average token per example is 56, around 56 average token is there in every example, and the maximum token is 62. Now here average token in average assistant token and maximum assistant token. So here I'm checking average assistant token, which is around 21 token in every output message. There is on an average 21 tokens and maximum is around 25. So this is like some more analysis. Again, again this is not like having any meaning, but yeah, this is just for the analysis. Okay. Now what I'm doing, guys, I'm checking the total tokens. So it will provide me the total tokens. Okay. So I will sum of this total token of this particular list. So it will provide me the total token. So how many total tokens we have? So we have here you can see we have 562 tokens in my data set. Now let me check the output token. So here is my output token, guys. See, this is my output token. So how many output tokens we have? So let me show you the output token also. So output token is 212. I can check the input token. So let me check the input token. So here is the input token. So guys, likewise, see what we are able to figure out over here. So we are able to figure out total tokens, output tokens and the input tokens. Okay. Now this is the pricing of this particular model. So we are fine tuning this model GPT 4.1 Nano 20250414. You can check out with this model over here. See, this is the model, guys. This particular model GPT 4.1 Nano. Okay. Now what I'm doing, guys, so here this is the pricing. So pricing for 1 hour, right? So $1.5 for using the GPU. Input cost $0.20 per 1 million token. This is the cache cost and then output cost. So this is the input rate, guys. This is the output rate. Okay, here I mentioned the output rate and this is the hourly rate, right? Per hour training compute. Now what I'm doing, guys, I'm checking the token cost. So this is my token per 1 million and then input rate multiplied by input rate, then output token per 1 million and then output rate. Okay. So likewise, you will be able to get the token cost. So this is the token cost, guys. Let me show you the token cost. So $0.0023, something like that. Now training, let's say my training is going to be run for the half an hour. It could be run for 1 hour, 2 hour, 3 hour. It depends. But I'm taking the bare minimum time. Let's say my training is running for the half an hour. Okay. So according to that, my total cost will be how much? So here is my training cost, guys. This is my training cost. This is the training cost, $0.75. Now what is the total cost, guys? So the total cost will be this one. So let me show you the total cost. Okay. So this is the total cost, guys. 0.702 396. So if I am running the training, okay, using this model, guys, which model, guys? Using this GPT 4.1 Nano, and with the same data set, the data set which I shown you, this data.jsnl, where I am having 10 rows. So the training cost would be around this much. Okay, it is a rough cost, guys. Again, I'm saying 0.75. You can multiply it with the 91. So multiply with the 91. This is the dollar rate, current dollar rate. So it is around 68 rupees or 69. So roughly 69 to 70 rupees I will get. Okay, this much cost I will be getting if I'm going to be fine tune my this model on top of this data. Okay, 10 rows. So here is the message, guys. You can check. So this is the total tokens and this is the roughly cost. I hope, guys, you understood how to calculate the cost. Maybe it might be wrong or it might be more and less. I just did the rough estimation. Now like rest of the thing you can explore. I shown you each and everything, how to calculate the cost, like how to go through with this pricing documentation and this particular cookbook. Okay, now let's do one thing, guys. Let's perform the fine tuning, and after that, guys, I will go through with the API and then we'll look then, guys, we'll look into the dashboard, right? How you can perform the fine tuning through the dashboard itself. Now, guys, your actual training will start from here. So, I initialize the client. I created a client, guys. Here I can show you. So this was my client. I created an object of this OpenAI class. Now what I will do, guys, using this client only, I will call some function, some method. So the first method, the first function is going to be client.file.create. Okay. So what I will do, guys, I will call this particular method client.file.create. This is my file. So content data.jsnl. This file could be available anywhere. Okay, so this file, as of now, this file is available over here inside this collab or inside this collab workspace. So I've just copied from here. Okay, I just keep copied path from here and I paste it over here. Okay, so what I have this file. This is my data. I already like gone through with the data. I already understood the data, each and everything we have done. Now what I'm doing, guys, so here I'm writing a purpose. So what is my purpose? My purpose is a fine tuning. So first I will do what I will do, guys. First I will upload the file. So using this method client.file.create, I can upload my data to the OpenAI. Okay. Now once I will run it, guys. So see, my file object is created. So this is my file ID. This file LSXQM. This right. So this is very important. So this file ID is required. This one. This particular ID will be required. Now, if you want to see, right, if you want to list your all the file, whatever you have uploaded over the OpenAI platform, you can do that. So for that, what I will have to do, I will have to take this client again, and now here I will have to call this files. Okay, then here I will have to call one more method, that is list. Now once I will run it, guys, I will be able to get all the file whatever I have uploaded so far. So see, I have done like 3 to 4 times. So yes, I am getting all the file object. Means whenever you will upload any file, so it will create a file object and it will assign one ID to that, right? So let me do one thing. Let me iterate on top of this files. Let me show you what all files we have, whatever files basically we have over here, whatever file I have uploaded over there. And this is the latest one, which I uploaded just now. Okay. So here I'm saying files, and this will be my file. From here I'm taking the ID, I'm taking the purpose, and this will be my file. Now let me run it, guys. So see, over here it is saying files is not there. So let me keep it inside the files. Okay, I'm just going to be keep inside the variable, right? Now what I can do, I can iterate on top of it. So see, so far I have uploaded 4 times, so I am getting 4 ID, this and this is the latest one. Okay, the first one is the latest one. I had uploaded this one, then this one, then this one, and this one. So 4 times I have performed the fine tuning, means three times I have performed the fine tuning. So this is from the last 3 times, and this is the latest one. Okay, so I required this particular ID. I hope you got it. Now what is the next thing? So here, guys, I can create a variable. See, this ID will be required, so I'm just going to be copy over here, and I'm keeping it inside the variable. So the variable name is going to be training file ID. Okay. Now let me execute it. So I got the training file ID. Now I required one more thing. So I'm going to be create one more variable. The variable name is suffix name. So I can write over here custom YT. Okay. YT class fine tune model. So this will be my suffix name. So after the model, whatever whatever model I will be choosing, so along with that model, okay, this suffix name will be added, okay, at the end. So this is my suffix name. What I'm doing, guys, so here I'm going to be call the fine tuning jobs. So this is very easy. So what I'm doing here, I'm going to be call one method client dot fine tuning dot job dot create. Now here I'm passing my training file ID. So I'm saying on top of this file, I want to fine tune my model. Now which model? I don't want to fine tune the GPT-4o. I want to fine tune the GPT Nano. Okay. This particular model. So I'm going to copy the name of it, and then I'm passing it over here. This one, GPT 4.1 Nano 2025414. Then suffix name. So this will be my suffix name. So after the fine tuning, guys, what I will get the model as along with this suffix name. Okay. So that I can easily identify my model. Now this is my type. So what kind of like fine tuning I'm going to perform? I'm going to perform the supervised fine tuning. According to that only I have prepared my data. Then guys, here is the hyperparameter. So batch size is 16. By the means in how many batches we are passing the data? Like in one batch we are passing 16 rows. But guys, this is irrelevant as of now because I just have 10 rows right now. Okay. The learning rate multiplier. So yes, this is 1.0. Learning rate, to stabilize the training. This is again a mathematical concept of the gradient. Okay. Gradient of this model, the neural network. So definitely we can understand that while I will teach you the neural network. Then number of epochs. So for how many epochs you are running the training, I am running it for the 3 epochs, right? So this is all the hyperparameters. So in this particular points, I have also mentioned hyperparameter tuning. So you can play with those hyperparameter. Token limit, I'll come to that. And the data quality, I already taught you what kind of data you have to keep and how to format the data. Now, if I will run it, guys, so what I will be getting, I will be creating the fine tune job in a backend. Okay. So my job is created, means now in the backend, the fine tuning has started. How we can check that? I will show you in some time. Now guys, if you want to list your all the job, okay, whatever job, see again, whenever you uploaded the file, you got this ID, right? This is the ID regarding the file, whatever file you have uploaded. Now whenever you will list the job, okay, whenever you will create the job, the fine tuning job, again one ID will be assigned to you. So this is the ID, guys, this one. Now if you want to check your all the jobs, whatever jobs you have created so far, so for that you can simply call client.finetuning.jobs.list. so once you will call it, guys, so here you will get list of all the jobs whatever you have created so far. So as I told you before this tutorial, I have executed it 3 times. So I am getting in total 4 job, okay, along with this current job. So I hope this thing is clear. You can list all your jobs. Now here, guys, you can see. So this will give you your fine tune model. This particular code snippet will give your fine tune model. So I'm calling client.finetuning jobs list. Okay, then jobs will be there, and then from the job actually I'm going to be check the fine tune model. So regarding each and every job, one fine tune model will be associated. I will get one fine tune model. So I can get that fine tune model from here. So let me run it. So over here you can see. So sorry, I run it 3 times. Okay, along with this. So here you can see none. Okay, this is from the second time, right? This is from the second time. And after the fine tuning, guys, I will get my latest model over here. As of now I'm getting none because the fine tuning is happening in backend. As of now it is not completed. So once it will be completed, I will get my model over here. Okay, so first time when I started the fine tuning before this tutorial, I cancelled the job. Second time I have completed the job. Okay, this is my fine tune model. Now this time in this tutorial again I started the fine tuning. It is running in a backend, but still I didn't get a model. So once I will get a model, okay, so the model name will be reflected over here. Everything I will show you from the dashboard, don't worry. So yeah, this is it, guys, for the fine tuning. Now if you want to chat with your model, so here is the model, guys. So you can keep this model, you can copy the model name like this, and you can keep it over here, this particular model, right? So here is a model, this is the role, then there is a content, this is the like user, and here is the like question from the user. Okay, so I hope this thing is clear, like how to perform the fine tuning. Now let me show you how where the fine tuning job is going to be listed. So once you will go through with the dashboard, so just open the dashboard, guys, where you will get it. Let me show you. So just click on this quick start, then click on this create an API. Okay, then over here, once you will scroll down, so left hand side you will get this fine tuning. So just click on this fine tuning, and here guys, see your fine tuning is happening regarding this particular model. You understood, guys? See, first time this was my fine tuning, I cancel the job. Second time my fine tuning job got successful. Okay, means this is the second time again I fine tune with one more data set. So yeah, this is my model. Now this is I'm doing in front of you. Okay, this is your model which I'm fine tuning. So here you can see this is the model name, is status, it is running. Then this is a job ID. Then training method is a supervised. Suffix name is this one. Okay, this is a base model name created at this time. Then data sharing is private. Okay, epochs is 3, batch size 16, learning rate multiplier is 1, seed is this one. Okay, then the other detail. So here guys you can trace the everything, right? And yes, my fine tuning is running. I hope you got it what I'm doing now. Now if you want to do the fine tuning from the dashboard itself without this Python code, see here I'm doing the fine tuning using the Python code. So if you want to avoid this process, if you don't want to use this Python code, simply you can fine tune it from the dashboard also. So see right hand side you can see the option, this create one. So just click on this create. Now once you will click on the create, see you just need to fill out this particular form. So method is supervised, you can select the other method also. Then after that you can select the base model, so select the base model, then suffix name, then seed, just to like avoid the randomness. Then training data, upload your training data, then validation data, upload the validation data, configure some hyperparameter, and then create the job, guys. That's it, nothing else. And then you can perform the fine tuning. So guys, this fine tuning will take some time, maybe it will take 15 to 20 minutes. So last time when I did it, so it took around 10 to 15 minutes only. So let me again give you the quick recall. So the training is going to be start from here, and it is very easy to understand. So this is my client, so I just uploaded my file. So once I will upload the file, it will provide me a unique ID regarding that file. So as many as time you will upload the file, you will get the unique ID. Okay, so far I have uploaded 4 times, so I got 4 unique ID. This is the latest one which I uploaded inside this tutorial. Okay, then guys, this is my training file ID which I uploaded. Now this is my suffix name, so I'm performing a fine tuning of this model. Okay, once I will get the fine tuned model, so this name will be associated with this particular model name. This is my hyperparameter. Okay, I think you understood all the hyperparameter. See, this is my training job. This is my training job, guys, which I created. Okay, again I got a ID, so I can list my all the training job whatever I have done so far. So you can see over the dashboard I have performed the fine tuning 3 times. This is the latest one inside this tutorial. This I have done like just for the practice last time. So here you can see I have done on 16th of January. Then this I have done again on the last time 9th of January. Okay, so all the 3 object ID I'm getting over here, fine tuning job ID I'm getting over here. So if I want to check the model, so yes, I can run it. I can basically run this code snippet. So job.finetune model. So first model I cancel the job, second was completed, so this was the final model. After the fine tuning I got this model, this was the third one. Okay, so which is still running. If you will again check, you won't get anything because the job is still running over here. Once this will be completed, you can access your model over here. Then guys, after getting the model, you can chat with your model. So here is your model, guys. You can provide the model. Here is a message, system message, and this is the user message. So once I will run it, guys, so I'm just checking with the previous model. This is my previous model which I fine tuned. So I'm just checking with the previous model, and here let's see whether it will be able to answer to me or not. So yes, it is running. See, I'm able to get an answer, guys. So see, this is my final answer. So so just understand about the data, guys. So if you will go and check the data, see, this was the data, guys. Just a second, this was the data, guys, this one. So just understand about the data. This data set is all about the smartphone. So just assume that your GPT model don't know anything about the smartphone, about your shop, what kind of customer is coming to your shop, okay, what kind of question they are asking. So you are going to be create one chatbot for your shop, for your local business, and this is the data, right? This is the question answer. So you want to be tune your GPT model on top of this data, so that whenever someone is visiting your website, model can reply in a well manner. Okay, so this is all about, this is the like use case, guys. Okay, so here you can see, yeah, so my model is able to generate a response. So see, this is the response. See, this is the previous model. I fine tune it on 16th of January. So after completing the training, guys, after this training, so as of now it is saying it is in baiting. So once it will be completed, so you will get this green icon succeed, then you can access this particular model. See, this is your output model. This will be your output model, guys. You will get over here itself once the training will be completed. Okay, so yeah, this is it for this particular video, guys. I hope you understood. If you want to access this model, guys, so what you will do for that, so you just check, you will just check over here, you will just run it. So you will get your latest model. Okay, instead of none, you will get your latest model. You can pass that model over here, and you can do the chatting, and you can do it for your business, right? Whatever data you have, just format your data and fine tune your model. Now, guys, one more thing, here you can see going to be I'm calling a different methods over here: client, fine tune, jobs, list, right? And then here you can see I'm going to be called this client file list. So if you want to deep dive into each and every method, so what you can do, you can simply click on this API reference. Now, after clicking on this API reference, just scroll down over here and you will get this fine tuning. So just scroll down, right? So see all the parameter and all everything, all the method function, and like all the parameter of each and every method and function you will get over here. So guys, if you want to explore each and every method function in a detail regarding the fine tuning, then go and check over here. So yeah, I shown you each and everything, guys. Now I hope everything is clear to all of you. My training is still running, and yes, it will take some time for you as well. But yeah, how to access the model and all, everything I shown you. So yeah, this is it for this particular video. I hope you understood how to fine tune the GPT model using the OpenAI API. In the next video, I will show you how to fine tune the Gemini based model using the Vertex AI API. Until, thank you, bye bye, take care, guys. Hey, hello everyone. Welcome back to my YouTube channel. My name is Sunny and I'm back with another important video. So guys, in this video, we'll see how we can fine tune the Gemini model using the Vertex AI. Yes, guys. So in the previous video, I shown you how you can fine tune the GPT model using the OpenAI API. Now in this video, I will show you how you can fine tune any Gemini model using Vertex API. Hey, hello everyone. Welcome back to my YouTube channel. My name is Sunny and I'm back with another important video. So guys, in this video, we'll see how we can fine tune the Gemini model using the Vertex AI. Yes, guys. So in the previous video, I shown you how you can fine tune the GPT model using the OpenAI API. Now in this video, I will show you how you can fine tune any Gemini model using Vertex API. So guys, if you don't know, I started with this end-to-end fine-tuning playlist where I uploaded 20 videos so far. So in the last video, I shown you the GPT fine-tuning. If you haven't seen this video, please go and check. Now before that, I discuss a different framework with respect to the LLM fine-tuning. And before that, guys, I discussed the fundamental of the LLM fine-tuning. So guys, if you don't know anything in the LLM fine tuning, then this playlist could be one-stop solution for all of you. I will highly recommend at least this 3 video from my playlist, video number 14, 15 and the 16, or else you can follow this LLM fine tuning crash course so that your all the fundamental of the fine tuning will be clarified. So where you will get this playlist, guys, once you will visit my YouTube channel, and if you will check with the playlist section, so there only you can check with this end-to-end fine-tuning playlist. Not only fine-tuning playlist, I have so many other playlists like LLM ops, LangChain course, LangGraph course, advanced RAG, basic RAG, multimodal RAG, everything guys you will get on my YouTube channel with respect to the generative AI. So if you are willing to learn generative AI, then please go and check with my YouTube channel. Now guys, let me show you that what all points I am going to discuss inside this particular video, and then step by step, one by one, we'll try to cover up. So first guys, I will give you the walkthrough of the Gemini API, Google AI Studio documentation. Then I will give you the walkthrough of the Vertex AI documentation. Then I will explain about the fine-tuning method, the different fine-tuning method which is being supported by the Vertex AI. Then I will cover the dataset format, how basically you can format the dataset for the Gemini fine tuning. Then I will show you the costing, tokenization and all everything. So I will see how many tokens are present in my dataset, and I will show you the cost of the model, whatever model basically we are going to fine tune through the Vertex AI. Then guys, I will show you model supported for the fine tuning, that model being supported by the Gemini API, by the Vertex AI. Okay, both are the different thing. I will discuss both thing. What is the Gemini API and what is the Vertex AI or Vertex API. Then I will demonstrate the fine tuning via Python API or via Python SDK. So I will show you the end-to-end process, how to like upload the data set, how to start the fine tuning job, how to monitor that, how to get the test endpoint, and then finally we'll do the inferencing. So these many things we are going to discuss throughout this video guys. So if you want to become champion in the Gemini fine tuning, then this video could be a one stop solution. And not only for the learning guys, you can use it in your enterprise solution. So if you are building any enterprise solution, so this fine tuning could be very useful. You can train your domain specific model, and then you can utilize it. Again guys, this is not an open source model, this is a closed source. It is being provided by the Google. So we don't have access like where we can download the model, but yeah, we can access the model via API. So guys, I hope the agenda is clear, everything is clear. Now let's begin with the video. So whenever we want to access the Gemini model, so how we are accessing that? We are simply writing Google AI Studio. So guys, here is the Google AI Studio. Now once you will open it, now so guys, this is a Google AI Studio where actually you can access the different model. You can vibe code AI app, or you can get the Gemini API key, and even you can explore their documentation. So let's click on this explore documentation. Now once you will click on this explore documentation, you will redirecting to this page. Now here you can get the complete overview of the Gemini API. You can quick start if you want to quick start in any sort of a language like Python, JavaScript, Go, Java, C Sharp. Okay, you can get the API key from here as well. So they are giving you the option to generate a Gemini API key. Then you can access the different models. So the different variant of the Gemini is available over here. Gemini 3 Pro, Flash, 2.5, 2.5 Pro, 2.0 Flash, Flash Lite. Okay, apart from this, you can check with this Nano Banana. So this is a very popular model for generating images. So you can access this particular model also. Then a couple of more multi-model like VEO for generating the video, for generating the lyrics. This is the model Laria. For generating an image, there is one more model, image gen. You can explore this model, right? You can explore the embedding related model also. So if you want to generate an embedding for your rack system, then the other multi-model for the different tasks, right? You can explore the pricing also. So they are giving you one free tier. So if you are learner, if you are a student, then you can avail the free tier. But here you will get everything in a limited access, means you can access the limited model for the limited period of time with a limited token. So if you are willing to create something serious, then you can go through with this paid version, or else you can take this enterprise version. Guys, this is all about the Gemini API. This is all about the Google AI Studio. But guys, apart from this platform, Google is providing you one more platform, that is called the Vertex AI. Now, guys, this Vertex AI actually you will get it over the GCP, over the Google Cloud Platform. So Google is not giving you the fine-tuning support over here over this Gemini API. If you want to fine-tune a model, then for that you will have to explore the Vertex AI. So Vertex AI, it is a similar platform like AWS Bedrock. If you know the AWS Bedrock, if you know the Azure Cloud Foundry, so it is similar to that only. So if it, someone don't know about the Vertex AI, you can go and search. It is a complete and the unified platform for building the AI related application over the Google, okay, over the GCP, over the Google Cloud Platform. So yeah, definitely I'll give you the quick walkthrough of the Vertex AI. What is a Vertex AI? I will show you that, and then guys, step by step, one by one, we'll try to fine tune the Gemini model. Now guys, if you're writing Gemini fine tuning over the Google, Gemini fine tuning, so you will get this link, right? So ai.google.dev, and here they have clearly written with the deprecation of the Gemini 1.5 Flash in May 25, we no longer have a model available with support fine tuning in the Gemini API or AI Studio, but it's support in the Vertex AI. So guys, if you want to fine tune the model, then you will have to go through the Vertex AI. Now you open the Vertex AI, open this hyperlink, okay, so you will be redirecting to the dashboard. This is the sorry, you will be redirecting to the documentation. So this is a documentation, guys. Here they have given you the complete guide, complete basically detailed documentation of the fine tuning. So this basically documentation will help us a lot. They have given everything in a very detail over here, so definitely will follow step by step. But guys, it is not that much easy. I will show you how to follow it and how to perform the fine tuning, because apart from this particular code snippet and all, we required a few more things, few more setup related step. So I will guide you related to that. So guys, I hope this thing is clear. You understood that Gemini API is not supporting to the fine tuning. For that, we'll have to go through the Vertex API, and here is a documentation of it. So I will give you each and every link in the description so that you can follow. Now guys, first of all, we have to go through the console. Let me guide you from scratch. So guys, if you are writing over the Google GCP, okay, then you will get this particular link, this particular website, cloud.google.com. Now once you will open this cloud.google.com, then you will get this page. Now this is the home page actually. So from here only you can access the GCP documentation. See, this is the complete documentation. So you can navigate to this page basically which we have opened, right? From here also, see, this is the complete navigation. So from here also you can navigate it. And apart from this one, guys, this console also is very much important. So just click on the console. This console basically, this particular one, this console basically, it is similar to the AWS console, the home page. From here only we can navigate to each and everything. I hope guys you understood everything, like how to navigate to the GCP console, to the GCP documentation, and what is the meaning of this particular documentation. Now let's explore step by step couple of more things. Then basically I will show you the fine tuning. So guys, we'll do the complete practical in the Google Colab itself. So here I have opened one new Google Colab and I'm writing the name of it. The name is Gemini Fine Tuning with Vertex AI. Okay, so Gemini fine tuning with the Vertex AI. Now I shown you guys, this is the documentation. So first let's take a quick walkthrough of this documentation, then I will come to the practical. So here guys, you can see this is the section model tuning. Now here only they have given you the complete detail about the fine tuning, so what it is and what it is about. So you can read this particular documentation for the more detail, for the self learning, for the self understanding. Now what all model is supporting? So these are the model, guys: GPT 2.5 Pro, GPT 2.5 Flash, GPT 2.5 Flash Lite, 2.0 Flash, and 2.0 Flash Lite. So these many model is supporting for the fine tuning. You can only fine tune these mentioned model. Now apart from this one, guys, you can check out like what all type of method they are supporting. So for that you can click on this tuning Gemini model. Now here basically you can check out this supervised fine tuning and this preference tuning. So as of now they are just supporting two methods. One is the supervised fine tuning and second is the preference tuning. So if you don't know about this supervised fine tuning and if you don't know about the preference tuning, then you can check out with my previous videos. You can check out with the crash course which I uploaded, guys. There I already discuss about this supervised fine tuning as well as the preference tuning. Now in this video I will show you how you can perform the supervised fine tuning. So once I will click on the supervised fine tuning, see I will get the complete detail of the supervised fine tuning. Now apart from this one, guys, I will get the complete detail like how I have to prepare the data. So I can prepare my data in this particular format, the format basically they are providing to me. Definitely I will show you the data. I already prepare a data. Then guys, this is a complete guide of the supervised fine tuning. So yeah, step by step, one by one, we'll follow each and every step. I will take a reference of this documentation only. Now supported modality, guys, so they are supporting to the text tuning, means we can simply give the conversational data, simple text only in the JSON file, in the JSONL file. We can provide the document also. So if we are directly providing a document, any document PDF or document or any docx file, in that case also we will be able to fine tune our model. See here they are giving the complete detail regarding that. If you are providing the images, audio, video, so in that case also you can fine tune your model. So guys, not only the text, we can give the different type of data, and using those type of data we can fine tune our model. Okay. Now preference tuning, guys, so you know preference tuning. So this preference tuning we can do using the RLHF, or we have the latest technique that is called the DPO, direct preference optimization. So using the DPO, using the RLHF, we can perform this preference tuning. So here is a complete detail and a complete guide of the preference tuning. So for definitely in the upcoming videos I will talk about it. Now guys, I will be talking about the introduction of the tuning. So in the introduction of the tuning only they have mentioned, so they are supporting two approaches. One, they are first is the parameter efficient fine tuning, and second is the full fine tuning. Okay, so I already discussed about this two method. What is the PEFT, what is the full fine tuning. If you don't know about these things, you can go and check with my previous video. I already discussed about the PEFT and the full fine tuning. So guys, they are supporting two fine tuning. Again, I am summarizing. One is the SFT, supervised fine tuning, and second is the preference tuning. Now how we can do it? So we can do in a two way. Okay, we can take two approaches. Either we can fine tune the all the weight, okay, that is called full fine tuning, or else we can fine tune the subset of the weight, that is called parameter efficient fine tuning. LoRA is one of the technique where we achieve this parameter efficient fine tuning. Means using the LoRA technique we can implement the PEFT, okay, parameter efficient tuning. I hope guys this entire thing is clear to all of you. Now let's come to the practical part. So guys, if you want to access any model from the Vertex AI, so you will have to follow some additional step. So let me guide you through those steps. So guys, once you will go through with this particular documentation, and if you will check over here the supervised tuning, let me show you the supervised tuning. So they are giving you the different option to perform this supervised tuning. So you can check over here how you can create the tuning job, or you can create via console, you can create via a Google Gemini SDK, you can create via Vertex AI SDK for Python, you can create via REST API or via Colab Enterprise. So guys, this Colab also it is a also it is a product of the Google. So they are giving a direct support to perform the fine tuning via Colab Enterprise. So guys, as of now, I'm not going into this Colab Enterprise using the REST API, okay, using this Vertex AI SDK for Python or console. I will perform through the Google Gemini SDK. So I will choose this Google Gemini SDK. Now using this Google Gemini SDK only, I'm going to perform the fine tuning. Okay. So I can show you how to do that using this Google Gemini SDK. If you want to perform using this Vertex AI SDK, you can do that. So using the Google Gemini SDK, you can it is similar to the Google AI Studio, but that is a different platform. Now this Google Gemini SDK, it is under the Vertex AI. So yeah, we can directly access the Gemini model, the different variant of the Gemini model, and we can fine tune it. If you are going for this Vertex AI, so along with the Gemini model, you can do few more thing over here. Means you can access the few different model, few different services of the Vertex AI. If you don't know about the Vertex AI, guys, I can show you from the console. I can give you the quick walkthrough of it. So here over the console, you can simply search the Vertex AI. So once you will write the Vertex AI, you will get the Vertex AI. See, this is the Vertex AI. Now just click on it and see, this is the complete platform of the Vertex AI. They are giving you the different things. See, this is the Vertex AI Studio chat, similar to the Google AI Studio. You can test out the different model over here, whatever model are available over the Vertex AI. But if you want to check the home page, home of the Vertex AI, so you just need to click on the Vertex AI here, and then see, this is the option. They are giving you the dashboard, model garden. In the model garden, actually you can see the different model, actually Gemini 3, Imagen 4, VO3, Llama 4. Even they are supporting to the different other platform like Anthropic, Meta, Hugging Face, Mistral, AI2, AI21 Lab. So many things they are supporting over here. Now apart from this one, guys, you can see the other option. They are giving the option to evaluate the model. They are giving you the tuning. Okay, the tuning basically which I was talking about. Agent builder, so agent designer is also there. Then here they are giving you some notebook option. You can launch the notebook from here itself, and then you can start working over here. Then they are giving you the other option regarding the model development, like feature store, data set, training, experiment, metadata. So this Vertex AI is a full-fledged platform for managing the AI related model, for deploying the AI related model. Okay, so you can do everything over here with respect to the artificial intelligence. But again, guys, you will have to pay something for this particular platform. If you are going to use this platform freely, then you cannot access anything from here. First of all, you will have to add the payment method, then only you can access the services from the Vertex AI. It is similar to the it is similar to the Amazon Bedrock and the Azure Cloud Foundry. So I hope, guys, you understood about the Vertex AI platform. I given you the quick walkthrough of it. I given you the quick walkthrough of the Vertex AI documentation with respect to the fine tuning. And yes, we are going to use this Google Gemini SDK for perform the fine tuning. So let's begin, guys. Let's start. Let's do the fine tuning step by step, one by one. We'll do the complete practical, and whatever thing will come into in between. Definitely, I will explain you that part through the documentation or through the GCP itself. So first, guys, I will install the Google Gemini SDK. So here is the package. The package name is Google Gemini. I written this pip install upgrade Google Gemini, and first let me connect with my runtime. So I'm just changing my runtime. I will select the CPU only because I don't require any GPU here, because I'm not going to train the model on my own server. The model is being trained over the Google server only. I'm just hitting it through the Google API. So guys, yeah, first I will select the CPU, and then I will make a connectivity, and then I will install this particular package. Now after that, guys, what I will do, I will write the project ID, I will write the location, and I will write the model name, that which model we are going to fine tune. Now guys, here you can see, so I install this particular package. Now after installing this package, it is giving me a warning that okay, you have installed the package, but please restart the runtime. So you just need to click on this restart session. You can restart the session, guys. See, my session is getting restarted. Now after restarting the session, I can simply load this project ID, location, and the model. Now you must be thinking, Sunny, from where you got this project ID, location, and the model. So guys, that's why I was saying this fine tuning is not very straightforward. Whatever code they have given you in the documentation, if you're directly going to be executed, it will not work until and unless you are not doing a proper setup. So guys, how you will get this project ID, location, and the model? So first of all, you will have to go through your Google console. So just open your Google console. You can directly write the Google console in the Google browser itself. You will get it. Now here, guys, you can see. So once you will create an account, right? Once you will log in with your account. So guys, you will get this project ID, this one. So you just need to copy this project ID, and you need to keep it over here. See, I already kept this project ID over here. It is the same project ID which I copied over here. Okay. So guys, what you have to do, you just have to copy the project ID and you have to keep it over here. Now location wise, guys, you can choose any location, wherever, basically from whichever location you are going to be access the model. So what you have to do, you just have to go through the Vertex API dashboard. So just click on the dashboard. Now once you will scroll down, guys, so here only you will get a option to select the location. So this US central one is a by default location, and I selected this by default location only. You can simply check out over here. You can simply check out the other location. If you are willing to select any other location, you can select that location and you can mention over there. Okay, so one is the project ID and second is the location. Now guys, the third thing is what? The third thing is the model name. So as I told you, we are having an option to fine tune a different model. So they have given you the option to fine tune a different model over here itself. See, they have mentioned the name as well. I can show you with the introduction page. Over the introduction page only they have mentioned the name. So the name is Gemini 2.5 Pro, Flash, Flashlight, Flash, and the Flashlight 2.0 Flash and Flashlight. So which model I'm going to fine tune? So guys, I'm going to fine tune this Gemini 2.5 Flash. Okay. Now why I selected this model? So guys, I would like to show you one more thing, the pricing of the model. So I already opened the pricing of the model. Let me show you the pricing of the model. So guys, here is the pricing for the model tuning. Don't worry guys, I will give you this each and every link. You can navigate to this each and every link from your end as well. But guys, it is like little hard if you are doing it first time. So don't worry, I will mention it inside the documentation or I will give you inside the notebook itself. You can directly download the material from my GitHub. So guys, this is the pricing for the model. So Gemini 2.5 Pro, around $25 for the 1 million token, 2.5 Flash, $5, 2.5 Flashlight, $1.5, and then the other open source model like Gemini, Llama, like they are giving us support for the different other model as well. Now guys, I'm selected this Gemini 2.5 Flash. So if you will check the pricing of it, so the pricing is around $5 for the 1 million token. Obviously in my data set I don't have 1 million token. In input and output I would be having 600 to 1000 token. That's it guys. Now this is all about the pricing guys. Now what I will do, so first what I will do, I will initialize this variable. So my variable got initialized. Now after that guys, I will authenticate from my Google Colab to GCP. So for authentication guys, you require this particular module auth, and then you will call this auth authenticate user. So once you will call this authenticate user, so it will authenticate your Google Colab. Okay, it will make a connection between the Google Colab to GCP, whether you are able to access or not. Okay, it will ask you certain permission and all. Now one more thing I would like to mention over here guys, if you are logging to the GCP, right? So please create a notebook with the same ID. So here you can see I'm logging over the GCP with this ID, okay, with the same ID, this ENG Sunny 3365. Now with the same ID, basically I created this notebook. Okay, so I open this Google Colab notebook. So please keep this thing in your mind. Otherwise guys, you will face a issue, you will face a trouble, and you will not be able to authenticate properly. In your local, you can do simply, but guys, if you are doing it in a collab, means in local, this thing is not required. But if you are doing this thing in a collab, then please remember this thing. It is very much important. Otherwise, you will get a issue guys. Now guys, just run this cell and authenticate Google Colab. So it will ask the access. So just click on this allow. So this pop-up will be there. You just need to click on continue and give the permission. That's it guys, nothing else. Now you can access anything from the Google Cloud platform. You successfully authenticate. Now after that, what you have to do? So after that guys, you have to import couple of module. So the first thing is the time, the second is the GenAI. Okay, this class we are going to be import from the Google. Then I'm going to be import this HTTP option for making a connection, making a request between the Vertex API and this Vertex API and this local on this from this collab. Okay, so this HTTP option will be required, not only the collab, from wherever you are making a connection, okay, between the GCP Vertex API, Vertex AI or this server, you will have to import this HTTP option. Now guys, if I'm saying GCP or Vertex AI, then both are same, right? And we have two way to access the Vertex AI. The first using the Google GenAI SDK. The second is Vertex AI SDK. Understood guys? Don't be confused here. Okay, please this could be the confusion for all for most of the people. So GCP is a cloud platform. Over the GCP you will get the Vertex AI. Okay, this is the service. Now this Vertex AI you can access in a two-way. The model over the Vertex AI you can access in a two-way. The first is the Google GenAI SDK. The second is Vertex AI SDK. So here we are using Google Gemini SDK. I hope now it is clear. So the another one is the creating tuning job. So if you want to create a job, guys, so this is a module for you. Then the next is a tuning data set. So yeah, this is for the data set. If you want to configure the data set, I will show you how you can configure the data set. Google Colab, Google, this Vertex AI GCP actually will suggest you to keep the data in their own storage and then access the data set. I'm not going to be keep in my local server or over the Google Drive. I will just take the data. I will just keep the data over the local server over the collab just to validate it. That's it, nothing else. Okay, just to check the token and all. That's it. Now here you can see the AI platform. So this AI platform is one more class actually under this Google Cloud module. This is for the cleaning purpose. I will come to that. And even I will give you the description of this each and every module. Now after that, guys, what I will do, I will define my client, a client basically to access my model. So GenAI.client, I will call this particular method. Then I will initialize the different parameter like Vertex AI true, then a project ID, then location, and then HTTP option. So I am saying HTTP option and I am mentioning this v1 vita 1. So it is just like to communicate with the Vertex AI API. That's it, guys. So you just need to mention this specific detail. Okay, this specific object. Now let me initialize the client, guys, and after initializing the client, what I can do, I can check whether my model is working or not. The model basically which I want to access, this Gemini 2.5 Flash, whether it is working or not. So here I am calling client.model.generate content. Here I am mentioning my model name and here I am giving my content. Now once I will run it, guys, so if everything is fine, I will be getting my response. So let me check whether I'm getting my response or not. So yes, here actually I'm getting my response, means my model is working fine. But guys, this is not correct for everyone, means you might get the issue, means you might get the error over here. Now what kind of error you might get over here? The error with respect to the billing. Okay, so as I told you guys, this GCP is providing you some free credential, but it is not applicable for the Vertex AI. Or for accessing this model, the model from the Vertex AI model garden, right? The model garden which I shown you just now, right? 2 to 3 minutes back. So guys, if you want to access this model, then for that you will have to enable your billing. So for enable your billing, you just have to go through your console. So first click on the console. See, where is a console? This is a console, guys. Now over the console, you just need to click on this billing. Now after clicking on this billing, guys, let me click on the billing. See, I already created my billing account over here. Okay, so I already created my billing account over here, guys, and you can see my billing account is activate, right? So far I got 10 rupees of cost. See, you won't get too much cost, and to set up this billing account is also very easy, very easy, guys. So what you have to do, you just have to create the billing account over here. I already created a billing account, so I cannot show you, but it is very easy, guys. Means you will just get an option over here to create a billing account. Just click on that, and guys, you won't believe, you no need to add any credit card and all. You just need to mandate it from your GAPI, Google API. Yes. Okay, so just you will see, once you will create an account, let me check if there is an option to show you one more time. I will have to check that billing is here. Okay, guys, you can check. Okay, so you will get option to add one billing account. I already added, that's why I'm not getting. So you will get one QR code. Okay, while you are setting up the billing account, just scan that QR code, and automatically that auto pay will be set in your GPay, in your Google Pay, like we are setting up for the Netflix, for the Prime, right? For the basically Hotstar, Geo, right? For whatever, in the same way basically you can set up the auto pay for the Google Cloud platform also, and you won't get much cost, guys, just 5 to 10 rupees. Okay, even in the fine tuning also I'll show you very minimum cost, 10 to 15 rupees, that's it. Because we are just learning, we are just testing, we are not creating an enterprise level application. The cost, so that's why the cost won't go in the lakhs. But guys, again, after basically fine tune, clean up everything that is required, otherwise the cost would be there. Okay, the cost will be increasing by the time. Now here you can see, so we are able to get the answer, but if you are getting any error related to the billing or something, then guys, of over your account you will have to set up your billing. Otherwise you won't be able to access this particular model even for the even for generating the output or for the fine tuning. Okay, neither you can generate the output nor you can perform the fine tuning. Nothing you can do until and unless you are not setting up the billing account. Now, let's begin. Now, guys, before proceeding, let me tell you one more thing, guys. In my past days, I have created one video on top of the generative AI roadmap. So, see, this was a video, generative AI roadmap 2026. So, guys, I launched one Gen AI boot camp. Okay, so I launched one Gen AI boot camp. Let me show you that boot camp. So, I collaborated with Krish Nayak, right? Krish Nayak. So I launched this full stack Gen AI bootcamp along with a Krish Nayak. Here is a complete detail. Here is a complete detail of this course. You can go and check out this particular course. And here is a complete syllabus of this course, guys. So this course will take 5 to 6 months to complete, and it is full stack Gen AI bootcamp which I created. Okay, which I am going to take behalf on this roadmap, the complete end-to-end Gen AI roadmap. If you forget about this roadmap, let me show you the points, what are points I have discussed over there. So these many modules, these many points I have discussed, 1 2 3 4 5 till 17 till 18, guys. So all these modules I am going to cover inside this particular course. Okay, so I will give you the complete detail of this course in my description. You can definitely check out this full stack generative AI bootcamp 26. It is for those people who are willing to learn the complete Gen AI from scratch to advance. Okay, now coming back to my video. So here, guys, you can see. So now let's perform the fine tuning. So what I can do, guys, I can check whether I already have some job or not, some already running job or not, because before this video I tested actually. I performed some a few more fine tunings actually. So let me show you all the job basically which I performed so far. So once I will call this client dot tuning dot list, so I will be getting my jobs. Now I can iterate on top of this jobs. So here I can write jobs, then here I will get my job. Now I can write this job. Okay, now see, guys, so these two job I already executed, means just for the practice before this video. So if you want to check your previous jobs, your previous fine tuning job, then you can check out like this. Now if you want to initiate the new job, new fine tuning job, how you will do that, I will show you. But before that, guys, let me show you how you can format the data set. So guys, you know how to format the data set for the GPT. See, this was the data set basically which we have formatted for the GPT. I think you all are familiar if you have seen my previous video. So we have the role, then content, then role, then content, then role, then content. Role will be system, then a role will be the user, then role will be the assistant. And everything is going to be wrapped up into this single JSON object. And we have multiple JSON object which is separated by the new line. So the file name was the data.jsnl. Okay. Now, guys, let me show you how to create a data set for the Gemini fine tuning. So this is the file, this is the data set for the Gemini fine tuning. The format is a little bit different over here. Just check out over here. So we have system instruction instead of the message. Now role will be the system. Then apart from this, we have one more key, that is part. Now under the part, actually we will be having the text. So here, guys, you will get the system message. Okay, under this part. Then we have a content. So under the content, actually you will get a user message, and then you will get the, and then again we will be having part. So under the part, basically you will get the assistant message. So likewise, we are going to format. If you are getting confused, just read it out from your end, you will understand, and just make a differences between the OpenAI format and this format. And believe me, guys, once you will make a differences, once you will keep this format and that format, easily you will understand, because I know the OpenAI format was the little easier one compared to this one. So guys, here we have a system instruction, then we have a role. Okay, we have a system instruction, then we have a role. Okay, under the role, basically we have a parts. Now under the part only, we have defined the actual content. So you can see the role is the user, then role again, one more role is a model. So role user means user is asking a question, role model means model is generating an answer. Okay, so this is my output and this is my user question. Now once you will read it from your end, guys, definitely you will understand what it is and how basically we have created. Now what I'm doing, guys, I'm just going to be check with this data set. So I'm uploading it over here and I'm checking how many tokens I have and then what will be the price basically. So I'm uploading my data set over here over the server. So let it upload. So okay, so I got my data set data.jsnl. Now first, guys, I will check with all the tokens and all. So for that I already created one function. Let me show you that particular function. This is the function, guys. Let me copy and paste. Yeah, this is the function. Just a second, it is not getting copy. Yeah, I created this function, this one. So this a function, part from the text, we are checking part, then content from the role and text. Okay, then example to content. So likewise, guys, what we are doing, we are going to be check the complete data. Okay, we are going to be check the complete data, part, content, and then the entire content. Now what I will do, guys, I will call this particular method. Let me give you one more method so that you will get a clear cut understanding that what I'm doing. So I have one master method, count token for JSONL. So I'm giving my JSON path over here. I'm giving the model basically it will perform the tokenization. Then shown top end. Okay, now here, guys, you can see this is not going to be written anything. Here I will be giving my path. I'm checking whether the path exists or not. Okay, then per row how many tokens is there, we are going to be check that. We'll open the path. Then here you can see we are going to be read the line. The one single row, one single JSON object is called the example. So example to content, we are going to be check the content. Then we are going to be calculate the tokens. You know how to calculate the tokens in the previous video also, in the OpenAI video also I explain you this thing. If you don't know, guys, you can go and check. I use one model over there and using that particular model I have performed the tokenization. So here for the tokenization, guys, I'm going to use the same model, this Gemini 2.5 flash. If you want to understand more about it, so here is the like page. Okay, it's a official Google page. I can give you this particular page where you can understand the count of the token, how basically they are going to be count the token. So they are using this model only, Gemini 2.0 flash, Gemini 2.5 flash only, to convert our data into the token. Okay, so you can pass any sort of a prompt, you can convert into the token, and then you can count the token. If you will go and check with my previous video, there I have used a different model other than GPT. So OpenAI is providing with a different model for performing the tokenization and assigning the IDs. Okay, but guys, this Google Gen AI, it is providing you the this model only, this Gemini model only, to perform the tokenization and to assign the ID. If you're not familiar to this tokenization, and after the tokenization how to assign the numeric ID and all, then you can check out with my fine tuning playlist. I have uploaded one more video over there, the complete Hugging Face crash course. There I have explained everything about the tokenization and all. Okay, now what I will do, guys, so here this is the I'm going to perform the tokenization, and after that, guys, what I will do, I will check with all this parameter. So I will give you this particular method. You can simply check it out from your end. This is not very much important. This is just a custom method which I have written to give you the detailed understanding of the data. So once you will run it, guys, you will get the method. Okay, sorry, you will get the different matrices about the data. So let me run it and let me show you. So here is my file data.jsnl, which I already uploaded over here. Now how many example we have? 10 rows. So in total 10 rows we have. This is the total number of tokens, 564. Now minimum number of token in the example 51, 62 is a maximum one, and 56 is the average token. In first line, second line, fourth line, how many tokens are there? So here you can check that. Okay, so guys, it is in ascending order. So in which row we have a maximum token, top 10 largest example. Here I have like shown. Okay, so this is a complete detail of the data. Means in total we have 564 token inside my data.jsnl, inside this particular file. So guys, I hope most of the thing is clear. And guys, this data set actually it is all about the mobile. Okay, so mobile customer support. you can imagine in such a way that this Gemini model don't know about about my private business. So I am running my private business, like mobile shop or something. For that, actually I want to create one customer bot based on my previous conversation with the customer. So this data is all about the private conversation with my customer, and on top of this data only I want to fine tune my model so that I can utilize it in my chatbot, okay, which further will assist to my customer. Now here guys, so everything is clear. I hope you understood about the data set. Now let me show you one more thing. So we are going to check the costing. So for the costing also I written one more function. Let me give you the quick walkthrough. Guys, if you're not getting this particular function, means if you got the confusion, then don't worry, just go through with it step by step, you will get it. Again, it is not very much important. The main thing is the fine tuning, which I will show you after this one. Now here you can see we are going to be create a class. This is my like data class. Now here I have a pricing. So Gemini price, Gemini 2.5 flash pricing, Gemini 2.5 Pro, and Gemini 2.5 flash Lite. So I kept the pricing like this. So I took this pricing from the documentation itself. Once like I shown you the documentation, okay. Then training cost in USD and training cost for the model. So I will get the complete cost. So once I will call this particular method. So here you can see I have 564 token. Model is this one, Gemini 2.5 flash. I'm using it for the SFT, for the supervised fine tuning. This is the actual cost for the model, and this is the estimated cost for my tokens. So guys, you can utilize this particular method for counting the token inside your data and to check the estimated cost. Okay, so this two function I have written, you can just go through with it and you can check. Again, this is not very much important, so I'm not putting too much effort over here. Now coming to the next part. So how to perform the fine tuning, guys? How to basically fine tune that specific model? Now I will just take 5 to 10 more minutes and we can wrap it up, guys. Okay guys, so the next thing is the data. So here you can see I kept the data over the local server of the Google Colab. But guys, this Google Cloud Platform is not recommending this one. Means this Vertex AI is not recommending this one. So what they are saying, if you wanted to use the data, then you will have to keep it inside the Google Cloud storage. So how to keep the data inside the Google Cloud storage? Now let me show you that. That's why guys, I told you this fine tuning is not a like very straightforward whatever in whatever way they have given inside the documentation. So what you will do guys, you will just go through with the console, just click on the console. Now over here only you will get this cloud storage option. Now just click on this cloud storage. After that guys, here is the option to create a bucket. Just click on this bucket, and I see I already created a bucket, Gemini SFT custom. So if I will click on it, Gemini custom exception, sorry, Gemini SFT custom. This is my bucket. I created that bucket. You know about the S3 bucket. It is similar to that. So here I kept my data.jsonl. So what you can do guys, you can create your own bucket and then you can keep the data over there. So if you don't know how to create a bucket, so it is very easy to create. Just click on this create, then write a name, click on the continue and then create. Okay, that's it guys, nothing else. You no need to do anything over here. So here you can see I already created this bucket, Gemini SFT custom, and inside this bucket I already kept my data. So yeah, in the same way actually you have to do it. You have to keep the data. So GS means Google storage, then Gemini SFT custom, this is my folder, this is my bucket name, and under this bucket this is my data set. Now what I will do guys, I will initialize this training data set, and here you can see my training data set. Okay, so this object is being created. Now what I will do guys, I will create my job. So here I'm going to create my job, client.tuning.tune. I will pass my model, which model I want to be fine tuned. Now here is my data set. Okay, this is my data set, and then this is my other name. Okay, other configuration, actually whatever configuration I wanted to give with respect to my tuning. So I'm just giving my tune model display name. So what is my tune model display name? YouTube SFT job. Okay, now what I will do guys, I will execute it. So my tuning job will be started. So now see guys, so here once you will click on it, you can check your tuning job. So see, your tuning job is started. See here, your tuning job is running. That's it guys, nothing else. With this two step, you can basically tune. Okay, and here if you want to check the name of your tuning job, then let me show you how you can do that. So once you will write this tuning job dot name, this is the object, right? And once you will call this parameter, you will get your name. This is the name actually. Okay, so under this project, this is the id which is allocated to you. Location is the US center tuning job, and this id, specific id, will be assigned to you. Now if I will list my all the job, so earlier I was getting 2 1. Let me show you that this one. So earlier I was getting 2 job. Now let me check how many jobs basically I will be getting. I can check it out over here, jobs. Okay, again maybe we'll have to call this job. So I'm just going to be copy it, this one. So here I can copy this. Yeah, this is fine. Now let me show you. See, I'm getting 3 job. Now this is my latest job. Okay, so latest job you will get it, you will get as a at a first place. Okay, so latest job always you will get as a first, get at a first place. This is my like last one, and this is the first one. Okay, like I created back. So I hope guys this is clear. Now you can get the other detail also. So here I can show you one more code snippet. With this code snippet basically we can get the other detail. Just a second, let me check it out whether it is correct or not. So yeah, this is correct. So here is my job state pending. We have two things, job state pending and job state running. So I kept it inside the dictionary. Yeah, now what I will do guys, I will check. So here I am running the while loop. Okay, here I am running the while loop. So tuning this tuning job dot state. So if you will check with this particular variable tuning job dot state, so what you will get this particular object. Okay, either the job is pending or job is completed. So here I am running tuning job dot state in running state. Okay, whatever thing is there inside the running state, it will go inside. Either it will be the is pending or it will be the running. Okay, so what will happen guys, it will go over here inside the loop, it will print the state, then it will take that job client dot tuning dot get, and it will take that job tuning job. Okay, and then it will sleep for 60 seconds, and then again it will check. So let me show you what I will be getting over here. So running state is not there. This is the running state, this is the tuning job. Now let me check here guys, you can see. So the state job is pending, means the training is running. Okay, the training is still is running. So here they have given you this experiment, you can check out with this widget. So see, the training is running. Okay, and you can check out the complete loss evaluation. You can check everything over here through this particular dashboard. So guys, see, this thing is running, and if I'm going to be print this particular thing, you will not get until the job is not going to be complete. Okay, so it will wait for 1 minute, and then again it will print the state. Okay, it will wait for 1 minute, and again it will print the state. So in both way actually you can check. So see, here the job is running, here this experiment is running, tuning experiment run. Okay, this is my name, this is the like id which is being assigned, right? So here guys you can see this is running, and once it is going to be execute further, you can get the loss and all everything through this particular dashboard. And even you can configure the tensor board also. Okay, you can open it inside the tensor board, that option also they are providing you. Now see, this also, this here also the job is running, means you can get it. Now once you will click on this tuning, you will get this entire detail. Now apart from this one guys, see, once you will scroll down, if you will check with this experiment, you will get the same thing which I shown you. Okay, so this is the running experiment, the latest one. Now apart from this, if you will check with the endpoint, so you will be getting the endpoint, so automatically it will be deployed and it will give you the endpoint. Okay, so this is my previous endpoint, so automatically the endpoint will be created once the job will be completed. Understood guys? So likewise you can navigate to each and everything over here over the dashboard itself. So it will take time. Now see, it waited for 60 seconds for 1 minute, and then again it's shown the status. So it is saying job status pending, now it is saying job status running. Okay, job state running. So I can again refresh it, and I can check where is my job right now. So once the job will be completed, it will show job is 100% completed. Okay, means my fine tuning is completed. So you can refresh it, and then guys I will show you how you can get that model. It will take time. When I executed it first time, guys, it took around uh, you won't believe it took around, guys, 50 to 20 minutes. So you will have to wait maybe for 50 to 20 minutes sometime. Okay, so let me show you again. So here, see, job is running. First it was showing pending in the first time, then again it is taking a wait for the 60 second for 1 minute, and then it is printing the state. Okay, it is printing the current state. You can check out over here, view experiment. See, the complete loss and all, everything will be visible over here in some time. You can check everything, guys, even the endpoint and all, everything will be visible. So here, evaluation fraction of correct next step prediction, evaluation number of prediction, evaluation total loss, training loss, right? Everything, guys, you will be able to get over here. Now what I'm doing, so let it run. See, it will take time, so I'm not going to be completed right now. Let me show you the inferencing using the previous model itself, which I trained previously. Okay, that is completed actually, and that is deployed as an endpoint. So here I show you the endpoint now, this one. So this is my endpoint, this one. So here I shown you my previous experiment as an endpoint. See, it is already deployed, this example SFT job. Okay, so what I'm doing, guys, I'm going to be stop it right now, and what I will do, I will take my previous, I will get my previous job. Okay, so how I can get my previous job, let me show you. So this will give you the latest job, job dot zero, job slash job square bracket zero dot name. It will give you the latest job. Okay, but I want the next job. So what I will do, I will put one over here. Okay, one. So you can see over here how many jobs you have. 3 jobs. This is the latest job, current job. This is like second last, and this is the last one. Last to last time I have performed. If I will create new job, so that will be the zeroth index at the first place. So here I'm writing one, and then what I'm doing, I'm calling client.tuning.get. So it will give me the tuning job. Okay, it means it will give me the tune model. Tuning job means what? Model actually, nothing else. So yeah, I'm getting my tuning job. So yes, this is done. This is already done actually. You can check out the experiment and all, everything over here. It is already completed, this one. And once I will click on it, so see, the loss and all, everything is visible over here regarding this one. So if I can show you the matrices, so you will be able to see the matrices regarding the previous one. See, likewise actually you will be able to get the trading loss and all, everything. You can set the epoch and all, everything. Regarding that also I will guide you later on. Now I got my tuning job. Now from here, what I have to do, I have to get my endpoint. So I can show you some parameter, state, model, and endpoint. So this endpoint is very much required. So see, job is succeed, the previous one which I ran before this tutorial. This is my model. Okay, this is the model basically with this particular name, and here is my endpoint. So the endpoint is also deployed. So guys, this is important, this endpoint. Using this endpoint only you can access your tune model, right? Tune model. And here only you provided your data set to tune the model. Please check out over here. Okay, don't be confused. If you're getting confused, then check out this particular like check out with this particular solution again. Now I'm doing the inferencing, guys. So for the inferencing, what I'm doing, I'm calling client model generate content model tuning job tune model endpoint. I will pass my tune model. Okay, and then I will pass my question. So the question basically I can pass from my data itself. So here I can write most respond include a 1 year limited warranty. Can you tell me the can you tell me why most of the phone gives 1 year warranty? Okay, so this is my question. Now let's see what's going to be generated. So I can simply check out with this response.text. Now see, this is not the pre-trained model, the Gemini model. Okay, this is the fine-tuned model actually. I given my data and I fine-tune the model, and I'm accessing it. I'm accessing through the endpoint, this one. Now if I want to check the response, so see, this is the response, and I'm able to generate the response, guys. Understood, guys? So I can again give you the quick walkthrough. So what we have done, we have used the Google AI Gemini SDK. Then we have set it this parameter model and all, everything, whichever model I want to be fine-tuned. Now here is my authentication. Now this is my import statement. Now here is my client. I'm checking whether I'm able to access the model or not. If you are not able to access, then set up the billing. Then I'm checking the previous job, means the previous fine tuning if I've done any. Then guys, here I'm validating the data. I'm checking all the tokens and all. See, this is the matrices I'm checking. Then here I am checking the pricing. So yes, I have 564 token in my data set. This is the model which I'm going to be fine tuned. This is the actual price for the 1 million token, and this is the estimated training cost which I will be getting. Now here I'm selecting the data. Okay, I'm keeping inside the Google Cloud storage. Then I'm setting the fine tuning job. Okay, then after that the job will be running. After running the job, guys, what you can do, you can access the model. So yeah, this is the complete detail why I'm getting regarding the fine tuning job and all. Now if you want to access the model, you can simply access like this. Okay, with the latest job, you can put the 0 for the latest job, and one I put for the second last job. Okay, I'm able to get my model. How I will be able to access my model through this endpoint. I shown you how the endpoint will be created. Okay, then I'm giving the endpoint and I'm giving my specific question, so I'm able to generate the response. That's it, guys. Now if you want to do the cleanup, guys, so for the cleanup, this is the code. So you can import this AI platform, you can initiate this AI platform, then you can give the tuning job tune model dot model, whatever model you want to be remove. Then you can basically pass it to this AI platform dot model, and then model dot delete. So once you will run it, guys, you will be able to delete your resources from the uh, Google, from the GCP, actually from the Vertex AI. I hope, guys, this is clear. Everything is clear now. In the next video, I will show you how you can fine tune any SLM, small language model. And in the upcoming video, I will try to come up with a different other modality like document, like the images and all, how you can do that. And I will give you the comprehensive detail idea of this dashboard also. Okay, what it is saying. Once we'll deep dive into some mathematics and all, then I will come to this part and give you the very detailed idea of it until you can check it from your end. Okay, this is for your self learning. Now you can go and check. I given you the complete guidance from my end. So yeah, that's it, guys. Now I will see you in the next video. Until unless, please like run this practical in your own system, and if you have any doubt, you can ask in a comment section. Thank you, guys. Thank you. Bye bye. Take care. Hey, hello everyone. Welcome back to my YouTube channel. My name is Sunny and I'm back with another exciting and important video. So guys, in this video we'll discuss about the SLM. SLM stands for Small Language Model. So guys, this SLM is a very important topic nowadays. Every companies are training their own SLM. So in this video, I will give you the complete guide how you can download your own SLM and how you can fine tune that. Then in the upcoming videos, I will discuss one end-to-end project where we are going to be host this SLM somewhere and we are going to access like any API. Back to the topic. So these all are the point which I'm going to discuss throughout this video. So first, guys, I will let you know like what is a LLM. I think we all know about the LLM. It's a like quite old topic now. Now we'll focus on the SLM part. What is a small language model? We'll see the differences between the LLM and the SLM. Now, guys, again, this SLM is not a different technology actually. It is a same technology, but comparatively, it is a smaller model. Like large language model is a very huge model, as we know. SLM are the small model. Okay, so we'll see why these model are small. We'll see the differences. I will not go in a mathematical depth. I will tell you that in some other video. But yeah, guys, in this video, I will give you the complete walkthrough, complete theoretical understanding. I will show you the like the different research paper, SLM leaderboard, as I written over here, and then we'll see the project implementation where you can download any model. After downloading any model, you can perform the fine tuning of that. Now, guys, here I will show you the practical with this Unsloth. This Unsloth is a very good library. If you don't know about it, you can go and check with my previous video. I already discussed about this Unsloth inside this playlist itself. This is a very good framework, guys. Even I have used this framework, this video number 18. Even I have used this framework in my production grade solution. So where we have took one model, one SLM model only. We have fine tuned on some data set, domain specific data set, and then we have hosted that model on their own server. And now we are accessing. Even the the entire organization is accessing that model for creating a chat application and all. So this kind of thing like being implemented by many of the companies, guys. That's why this thing is very important to understand about the SLM, to how to deal with the SLM, how to fine tune that. Okay, that's why, guys, I'm putting like too much effort on this side, and I'm creating this end-to-end video. At this time, I don't know how long it will be. Now, guys, here you can see. So I written these many topic, and definitely we'll discuss it inside this particular video. Now, first let's start with the LLM. What is a LLM? And then we'll see the definition of the SLM, guys. So here you can see I written the definition of the LLM. A large language model is a mathematical model. Mathematical model means it's a transformer based model. Again, the transformer actually it's a combination of the self attention and the neural network. If you don't know about the transformer, in the previous video, in the playlist itself, I have uploaded a different video regarding the transformer and the fine tuning of the other model. Okay, so where I have explained the transformer architecture. I just given the overview, not in depth actually, but yeah, you can go and check over there. So transformer, it's a collection or it's a combination of the self attention and the neural network. So a large language model is a mathematical model with the billions of parameter, billions and the trillions of parameter. If I'm saying parameter, guys, so parameter means weights and biases. Okay, uh, trained on the massive and the diverse internet data. It has trained on the very huge amount of data. We can say it has trained on the entire internet data, where actually we have the trillions of token. Okay, parameter is a different thing. Token is a different thing. Token we create from the data itself. Okay, and what is a parameter, guys? So parameter actually it's some weights and biases. It's a mathematical value of the model itself. So please check out with the previous video. You will get a great understanding of the transformer, so that you can understand about the weights and biases also. We should all have this fundamental understanding, even though we belong of whoever we are, right? We are software engineer, data scientists, AI engineers, right? So we should have this much of basic understanding. Now, guys, if we're talking about the LLMs, guys, so this is a design or this is trained for the general purpose language task. Now, what is a general purpose language task? So, general purpose language task means it can chat, it can write, it can read, it can perform the logic, it can understand the logic, it can perform the reasoning. Okay, it can do the coding. Means every kind of task, general purpose task. So, like we human are communicating to each other, right? In a same way, this model can communicate to the human. So it is overpowering this human language actually. So that's a main aim of that's a main aim of this LLM, large language model. Now, example wise, guys, this OpenAI, you know about OpenAI, right? You know about the cloud, you know about the Google. Everyone knows about it. And these are the model from the OpenAI, these are the model from the cloud, these are the model from the Gemini, and this is the open source model from the Meta. So these all are offering LLM, large language model, and we have enough understanding and a decent understanding of the large language model. Now we have to understand about the SLM, guys. Now, guys, what is a SLM? That is a small language model. So, a small language model is a compact language model. Again, it is a language model. It is a subset of the large language model only, but it is having less parameter. Whereas this LLM is having a huge number of parameter like 70 billion, 50 billion, 30 billion, right? Comparatively, this SLM is having lesser number of parameter, usually under 7 to 9 billion of parameter. This SLM actually it is optimized. It is optimized for the efficiency, for the speed, and for the domain specific task. And it is often for the fine tuning, okay, for the particular use case. And the size is small, so we can deploy. We can easily deploy it on any server. Okay, we can easily bear on any hardware. This SLM. Now, what is the example of this SLM? Guys, the five model from the Microsoft, it is an example of the SLM. This Gemini model, it is an example of the SLM. Tiny Llama, again, it's an example of the SLM. Coin 1.5B, DeepSeek R1 Distill, okay, it's a Distill model. Again, it is an example of the SLM. Nemotron H family, it is an example of the SLM. So here I tagged one image, I think, but just by seeing this image, you can understand so many things. So just see this image. A Llama is providing us SLM. This Microsoft is providing us SLM, Google is providing us Mistral, Apple. Everyone training their own SLMs. Okay, and then they are making it open source, and companies are using it. Companies are using those SLM. As I told you, because of the size, because of the number of parameter, we can easily bear those SLM, small language model, on the hardware. Even though the performance is not similar to the LLM, but again, guys, we can fine tune for the intended task, for the domain specific task, and then we can utilize it. Let's say I'm running one company, let's say I'm running one pharma company. Where basically what I want to do, I want one LLM model which can solve any sort of a query regarding those pharma data. It's an internal, it could be the internal project. So what I will do, I will not consume any API uh, from the OpenAI, from the Cloud, from the Gemini. Instead of that, what I will do, I will take one SLM, I will train it on that pharma data, and I will host it on my server. Okay, and by the time the performance will be improved of that model, as we are getting query, and again we are training on the instruction data set. So these the same step is being taken care by many of the company, and even I am a part of those. I'm a part of that project. So that's why, guys, I'm recording this video with my all the experience. So please, guys, watch this video till the end if you want to master the SLM technology. Okay, so guys, here I written one line also. So before coming to this differences, let's read out the definition from some authentic resources, and let's go through some relevant research paper. So guys, here I open the different website. So here is the Hugging Face, guys. So there is one article, a very good article over the small language model. So they are saying a small language model, a comprehensive overview. So this article is written by this John Johnson. Now, just read out this article. It's a very good article over the Hugging Face. Okay, the few past year have been a blast for the artificial intelligence with a large language model, stunning everyone with their capabilities and powering everything from chatbot to code assistant. However, not all applications demand the massive size and the complexity of the LLM. The computational power required makes them impractical for many use cases. This is why small language model entered the scene to make powerful AI model more accessible by shrinking in size. Means this person is saying uh, large language model are the huge one, which is not required at every place. The couple of things, right, which can be done by the small model as well. So that's why, guys, the era of the this era actually is going to be a era of the small language model, and many companies are going to be adapted in the near future. Now, guys, here you can see what are the small language model. They have highlighted over here. Now, apart from see here, one more thing they have written. The SLM typically range from the 1 million to 10 million of 10 billion of parameter. So up to 10 billion of parameter, we can consider up to 10 billion of parameter, we can consider any model as a SLM model, a small language model. Now over here, how they made it, how they made the small one. So using the knowledge distillation, using the pruning, quantization. So if you don't know about this topic, guys, then you can check out with my playlist. I already recorded like video about the distillation, about the quantization and all. So you will get some understanding about these particular topic. But these are not only the thing, guys. We have so many things, so many mathematical thing, mathematical parameter. Using those parameter, we are going to be like train a small language model. We are going to be like shrinking the size. We are going to be shrinking the size of the large language model. So that thing I will discuss in one of the video, because I analysis that part mathematically. I understood what all thing what all thing is possible, like how we can convert any LLM into the SLM. Okay, just by tweaking some parameter, just by taking subset of the layer, and to implement some mathematics changes over there. uh, Now, guys, example of the small language model. So they have highlighted the example of the small language model like Llama 3.21b, Quen, DeepSeek, Small, Phi, Jima, the model name which I was telling you. Now over here, you can see the benefit of using a small language model. So it is required low computation, it is required lower energy, faster inference on device, right? We can host it on any device. cheaper deployment, customizability. So guys, these are the point of which you can focus. If someone is going to ask you in an interview, then you can highlight this point. But guys, I would suggest you have to like perform the practical as well, so that you can justify this point. Not only the theoretical, in terms of the practical also you have to be pro. Now, limitation of the small language model. So yeah, we have the advantage. Then on the other hand, we have some limitation also. So these are the limitation. It is having narrow scope. Means we cannot use it everywhere like the LLM. See, LLM is good enough. Everywhere, LLM is a decent enough. But guys, if LLM is overpowering something, means like if it is not required somewhere where we can done the small task with the SLM itself, then why we have to spend the money? Okay, so that's our main aim, that's our main agenda, right? So limitation of the small language model, it is having a narrow scope, bias risk, reduced complexity, and the less robustness. So yeah, we have to keep this thing in our mind. So wherever it is required, there only we have to use it, otherwise we can skip it, we can use our regular LLMs. Okay, now real world application of the small language model. So these are the real world application. So this is guys very good like blog on top of the very good article on top of the small language model. I will provide you this link, you can read it out. Now one more article which I found from the trustable resource. This is from the like Microsoft. So what are the small language models? So here also you will get an overview of the small language model. Now, apart from this, how does it work, guys? So the basic architecture of the small language model. So they have mentioned over here. Now, the training process. So the training process would be the same one with the lesser data set. So here they have mentioned about it. The advantage of using a small language model. Yes. So the same advantage which I was discussing. So you definitely you can read it, read all this advantage of the small language model. Now, apart from this one, guys, challenges and the limitation of the small language model. So the same thing they are also describing over here. So definitely you can read out this challenges and the limitation of the small language model, and you can understand. Okay, you can understand in detail. Now, a type of the small language model. So again, guys, this is very important. So please focus on this point as of now. Let me give you the quick highlight of it. Distilled version of the large language model. Distilled version means any model which we have like distillized from the large language model. So I can give you very good example. Even I have mentioned that model name in my notes as well. So just read this name, DeepSeek R1 Distill 1.5B. So this model actually, this DeepSeek R1 Distill model, it is distillized from the bigger LLM, right? So one kind of SLM are the distilled one from the huge model, from the large language model. The second, basically, task specific model. Task specific model means the model which we are training for the task only, for the specific task only. Let's say there is one ABC organization who is training their own specific model on the on a domain specific task, right? So this could be one kind of model. Lightweight model, again, guys, lightweight model means the llama tiny llama, okay, 5.1 model. So that is again a general purpose model which can do some which can do every kind of task in some limitations. Okay, tiny llama model actually, it is not a domain specific model, it is again a general purpose model. But that model actually cannot answer similar to the llama 70b model, similar to the GPT-4 or GPT-5 model. No, it is not like that. It is a lightweight general purpose model which can do like some chatting, some writing, some reasoning, some logical thinking, but not up to the mark. But if we are going to be fine tune that for the intended task, then it will perform well. So yeah, we have three kind of model. Means first, which is distillized. Then second, it intentionally trained for that domain. And the third one is the general purpose lightweighted model. Okay, which is a open source one. So guys, this two article is a very good article on top of the SLM. If you want to some authentic resources, then definitely I can share like this even in the description. Okay. Now one more like link I can show you over here, guys. See, LLM Explorer. So here, guys, this is the complete leaderboard of the not a leaderboard, basically it's a complete information of the SLM model. Over this website actually you will get the complete and the detailed information of the SLM. Now just read the model name, the different model name they have given over here, along with the maintainer, size, score, VRAM, quantize, license, context length, likes, download, modify. So they are capturing each and every kind of information regarding the SLM, regarding the small language model. So you can see the different models. See guys, here in total you will find out 6,000 model. So they have captured around 6,000 models. Definitely we cannot go through with each and every model over here, but guys, again, at least try to read this name, so that you will get some understanding. Okay, what all of the small language model are available, who is providing that, right? Whether it's a open source or it is providing by some community, or it is providing by some bigger giants like Nvidia, like OpenAI, Google's and all. So just read it out. So model name is 5.3 mini 4K instruct. It is being provided by the Microsoft. Now here you can see the size 4B. Okay, the Llama 5 DeepSeek, again from the Llama, from the Quen, then again from the 5 from the Google. Okay, this Gemini is from the Google, then 5 from the Microsoft. Okay, then this you can see from the IBM. So guys, so many models you will get over here. Here you can easily compare the different SLM, and according to the requirement you can utilize it. So definitely I will provide you this link. I will provide you this link in the description. You can check it out over there. So this is the one thing, guys. I think we have covered about the article. We have covered about the like this LLM Explorer. Okay, where we have so many SLM. Now let's see the differences between the LLM and SLM. Let's take a quick walk of it, and then guys I will show you one more research paper. The research paper name is this: SLM are the future of the agentic AI. This is very much important research paper, and right after this one we'll jump to the practical. So if we're talking about the SLM, right? SLM and the LLM. So see guys, I listed couple of differences over here. You can discuss these differences in the interview as well. If someone is going to be asked you like how you have hosted your LLM, what is the difference between the LLM and the SLM. So model size in the LLM, actually the model size will be very large, around 7B. Not 7B, 7B actually comes under the SLM only nowadays, along according to definition and all. But yeah, after the 10 billion parameter, those model, actually it is called the large language model. 70 billion parameter, 175 billion parameter, these are very huge one. Thus small to medium, 0.5 billion to 7 billion parameter, and up to 9 to 10 billion parameter. In some research paper they have mentioned that mark, okay, that benchmark. Again, there is no like certain boundary, but yeah, most of the research paper, if we will see the collective results, so the collective result are saying up to 9 to 10 billion parameter we can easily host on any server. After that guys, it is a little bit challenging. Now, primary goal: to get a general intelligence for many unknown tasks. Now, what is the primary goal of the SLM? High accuracy only for the known specific task. Okay. Training data, massive multi-domain and the internet scale data where we have trillions of token. Right. Now we're talking about the SLM guys. So it is a small, curated, and for the domain specific task. Training cost and infra extremely expensive. Large cluster of the GPU, and it will take week and months for the training, right? On the other side, if we are talking about the SLM, then it is affordable, single to few GPU, and it takes hour to days only. It is like comparatively very small. This comparatively very small, guys. Now, inference cost. So again, very high, as we know, right? We are paying to OpenAI, we are paying to Cloud A, right? We are paying very high cost, and here, guys, it is cheap and it is very fast. The inferencing also will be very fast because the size is small. Architecture, guys, it is having deep transformer stack with a many layers. So transformer, actually it is a backbone of any LLM, any large language model. So if you want to master the large language model, guys, I will highly suggest you to master the transformer architecture. So it is having so many stack. Okay, in LLM actually you will be having so many stack along with the different like uh, along with the different concept of the attention, like cross attention, self attention. Okay, that multi-headed self attention. Now here in the SLM, actually you will be having a fewer layers and the optimized transformer block, right? Now performance strength, again strong reasoning, open-ended task, and the long context. On the other side is strong on fixed task, limited open reasoning. Now deployment wise, mostly cloud and API based, means we can how we can read the LLM. So we can read the LLM through the different APIs, right? Or if we have to be like or from the cloud also, right? So we AWS is providing us, Azure is also providing us, GCP is still like providing us, even I have shown in my previous video, right? So likewise we are accessing the LLM. On the other hand, if we're talking about the SLM, guys, so it is we can host it on the local server, okay, on premises server, over the edge devices, over the single GPUs and all. So these are the quick differences between the SLM and the LLM. If someone is going to ask you the clear cut differences, then you can talk about it, okay? So guys, we understood so many things. What is the SLM, LLM? We have gone through the different research paper, leaderboard, and the differences and all. Now let me show you one more research paper, and then I will give you one more example. And after that, we'll move to the practical. So I will just take 5 more minutes, and right after that, we'll discuss the practical. So guys, when this SLM got like the fame, so this NVIDIA actually they have released one paper. The paper name was the LLM, small language model are the future of the agentic AI. So this research paper actually it was released by the NVIDIA research with the collaboration of the Georgia Institute of Technology. Now, guys, this is a quite interesting and a very good research paper. If you want to understand this research paper, then definitely go through with it. Try to read it. I will give you the link of it. But guys, we are not like we are not able to read the research paper, right? And we know this bitter truth. For all of you guys, I created the summary of this research paper. Here you can see the complete summary of this research paper. So instead of going through this research paper, the entire research paper, you can download my notes from the GitHub, and you can look into this summary. Okay, so let me highlight what all things have been discussed inside that research paper, and then guys, we'll take one more example, and right after that, we'll come to the practical. So guys, this research paper was released in 25 itself. So here, if you will check the date, so the date is 15 September 2025. Now here they have mentioned couple of models. So let me show you these models. See, these are the model, guys. So they discuss the thing behalf on this model. And guys, the core of this research paper is the AI agents. Okay, because AI agent is going to be a future, as we know, for entire automation, guys. We are using the AI agents, and in every company, people are hiring for the agentic AI, for the AI agents, and every company are developing their own AI agents for automating their task, right? So if we want some autonomous system, then we'll have to understand the AI agent, and AI agent is going to be my next playlist. So if you want that playlist, guys, you can comment in the comment section. Definitely I will create one playlist on top of the agentic AI with all my experience, where I will record at least 25 video regarding the different concept. Yeah, so let's discuss the summary, guys. So here, SLM are the future of the agentic AI. So what they mean by SLM and LLM? So let's see the definition of the SLM and LLM according to this paper. So they are saying a model that can run on a consumer device, okay, over the single GPU, over the laptop, over the edge devices, right, with a lower latency for one user agent. That is called the SLM. Now, anything beyond to this, right? Anything beyond to large, beyond to this, that is called the LLM. Practical rule, according to this paper, they have mentioned below 10 billion parameter. So 8 billion parameter, 9 billion parameter, and even 10 billion parameter is equal to the SLM. So they have given the roughly estimation regarding the parameters over here. Now, these are the model, guys, which they have mentioned over here. Microsoft 5. This is the good model, guys. It is beating like so many benchmark with a very few parameters. So if you want to use any LLM for your task, right? Sorry, any SLM for your general purpose task, then this model could be a very good model. Similar to this DeepSeek model, right? So DeepSeek R1 Distill 1.5. Guys, I haven't checked the benchmark of this model, but guys, this is also performing well. I have seen in many leaderboard, so definitely you can try it out. Now, apart from this one, Nemotron, again, it is a model from the NVIDIA itself, small LM, Haimba, Salesforce XLM. So, a couple of more model they have mentioned over there. So, definitely you can explore. But I will highly recommend you to check out with this Microsoft 5 and the DeepSeek. Okay. Now, what is a core idea? What is a core idea behind this research paper? So they are saying in agentic AI system. So in agentic AI system, most of the work is done through the small repetitive. Most of the work is done through the small repetitive well-defined subtasks. Okay, for this kind of work, small language model are the more than powerful enough, more cheaper, right? And the operationally better than using one big LLM. Now, guys, if you don't know about the AI agent, so let me show you the AI agent. See, this is the AI agent. I have like kept one image for all of you guys. So whatever task you want to be complete through the AI agent. So AI agent is having three main thing. One is the tool, second is the memory, and third is the planning. So what does it mean, guys? So the planning is nothing. Planning means it think, then it take action, okay, and then it observe, right? It observe or it evaluate, observe, okay. It observe and then it evaluate. So let me write over here, it evaluate. So these are the main pillar of the planning. So AJ, if we are saying like action, so action is nothing, it's a tool calling. And we can have any sort of a tool, guys. So tool means any service we can expose as a tool, and there this MCP comes, right? So definitely I'll discuss about the MCP also in my upcoming video. We'll discuss onto that. So here you can see, guys, databases, it could be the tool, local file could be the tool, census data, API, like from wherever we can access the data, the information, right? That could be my tool. I can create any tool, any custom tool, okay. So that's a core agenda behind the agent, behind the AI agent. And soon I will start one playlist on top of the agentic AI, guys, even though I recorded one, but again I will discuss in very detail with all my experience. Now here, guys, they are saying the core idea of this research paper, most of the work basically is the small work in the AI agent, the subtask actually, which can be done through the SLM. Now SLM, actually, why SLM fit for the AI agentics, AI agents? So agent task usually non-chatty, means we are not doing a repetitive chat over there, okay. Format restricted means where we are going to be generate the structure output. And agent are already the control model, which is tightly using prompt, tool, logic. So most of the LLM which is having a general intelligence is a based one, right? So we can use the task specific LLM. So this is the core idea behind this behind this research paper, guys. And after this research paper, I have seen so many tutorial on top of this SLM, and even like people have started using this SLM. Now, guys, economically also it is good. So 10 to 30x cheaper, right, than this LLM. Then much lower latency and the energy use, easy and the fast fine tuning. So yeah, that's the same thing which I'm going to be discussing inside this video, how you can fine tune any SLM. And then it can run locally on the devices, better privacy and the control. And the recommended strategy is SLM first, then call LLM only when it is required. So yeah, this is the like thing which they have discussed inside this research paper. This is the entire summary, but for the more detail, again, you can go through with this research paper, guys. Now we have discussed I think like all the thing, but again, guys, one more example. So here you know about this Llama. So Llama, actually, Llama 3 is a LLM, okay, large language model, which is having billions of parameters. So it is having more than 500 billions parameter. It's having a different variants, actually. So yeah, you can explore this research paper and you can understand the different variants of the Llama. So Llama 70B, then 8B, 70B, 405B, okay. So these are the model which they have introduced over here, and it is also having a general purpose knowledge, okay. It's also having a general intelligence. Now on the other hand, we have one more model. The model is the tiny Llama. So guys, if we want to understand the differences, the real differences between the LLM and the SLM, okay, and how mathematically they are different, what all other technique, what are different technique they have used while they are training the SLM, right? So definitely we should go through with this research paper. There only you will find out the authentic information. So I prepare one quick differences between this LLM and the SLM. So let me give you the quick walkthrough. Mathematically we'll discuss later on, but if you want to understand that, definitely you can go through with this research paper, LLM and the SLM, and you can understand that. So here, guys, this is the these are the differences which I capped over here. So model size wise, 1.1 parameter, 1.1 billion parameter, and the Llama, actually you will find out 7B to 70 B plus parameter. Okay, category, it fall under this SLM, it fall under LLM. Training data wise, 2 to 3 trillion tokens, 20 to 30 trillion token. Then primary strength, efficiency, good performance at the small scale. So guys, as I told you, this tiny llama also is trained for the general purpose task like phi model, PHI. Okay, so it's not a task specific model which is trained by the closed source organization for any specific organization for their own task. No, it's an open source model. It is also having a general knowledge. But guys, its general knowledge is a limited one. Okay, its general knowledge is limited compared to the other llama model. So that's why it's a tiny llama. Now here, the primary strength is a strong, and it is having a general intelligence, a reasoning depth basic to moderate reasoning. It is having deep multi-step reasoning, and it is also having a chain of thought capability. Then common sense, again, is strong for its size. It beats opt and the pythia, much stronger, more consistent. Then coding ability decent. It is having a strong capability. Instruction good after fine tuning, excellent out of box, right? Context handling, short and the medium context it can handle, and it can handle long context. Fine tuning cost cheap, expensive. Inference cost low and the higher one. Latency very fast, slower. Deployment wise, we can deploy it on a single GPU. Here we required a bigger GPU or the cluster of the GPU. Best real use case, agent automation, RAG, right? There we can use this also at the same place, right? But again, it is a bigger model. Production first, yes, it is a constant sensitive, and we can use it in the production grade system in our own server. Now it is a high quality model which is required a bigger infrastructure. Now, best suited for, so again, chat style assistant, light logic reasoning, light coding, and the Chinese tasks. So yes, couple of Chinese tasks also we can perform using this model. Now, journal purpose foundation, right? So the task which is being performed by this bigger llama model. So journal purpose foundation task, common sense reasoning, QA, reading, comprehensive math, code generation, multi-domain knowledge, a different thing. So guys, this is the quick differences. If someone is going to be ask you, okay, what you know about the SLM and NLM, then you can highlight these differences. Mathematically, what are mathematical changes, the mathematical changes they have done while they are performing the supervised fine tuning or the training of the model, right? So that we'll discuss in the upcoming video. Definitely, I'll again highlight that part. So yeah, guys, we have discussed all the points. Now let's jump to the practical, guys. Okay, guys, so this entire practical will perform in the Google Colab, because in the Google Colab we have access of the GPU. So in my local also I can do it, but see, I have a GPU in my local. First of all, let me show you my local GPU, guys. Yeah, so this is my GPU. My GPU name is NVIDIA RTX 5070 Ti, right? So I don't know you are able to see or not, but yeah, it's RTX 5070 Ti. This is the complete detail of my GPU. I can do it in my local as well. Yesterday I also tried, but Unsloth, actually it is required the PyTorch. Okay, Unsloth is required GPU as well as it is required PyTorch in backend. Not PyTorch CPU, it is required PyTorch GPU. So I was getting some version incompatibility with this with my GPU, this RTX 5070 Ti, and this Unsloth and the PyTorch basically. So I did multiple research on top of that, and I figured it out that that library actually is not still compatible with my GPU. There are some like gap in between. I was getting some data type related issues over there. So that's why I'm not doing it in my local. But yeah, if you have any other GPU, if you have configured any other GPU on any server, you can try out over there. I will do it over the Collab. Collab is providing us free GPU. We can take the enterprise variant of the Collab if we have a bigger data set, and the if we have to do it for any POC or for any MVP, we can do that also, or else we can hire any cloud GPU as well. Okay, so there are several options, and definitely I'll create one dedicated video in the near future regarding all the GPU related option, and over the multi GPU training also, because I did it, guys. Now here you can see, so the model title, sorry, that video title is the fine tuning any SLM, any large language model. So guys, are we going to fine tune any large language model using this code? Yes, we are going to fine tune any large language model. You just need to give the name of the model, and you just need to provide the data. Okay, and this code will take care everything. I written this modular code in such a way that it will take care everything, and yeah, it will fine tune your model. So I written couple of name just to assist you. Over here you can see these are the couple of name. I hope you are able to see this. So as I told you, we are not going to use the native Hugging Face. We are going to use Unsloth. Unsloth is a very good package, very good framework to fine tune the model. Okay, fine tune any LLM or SLM model. So yeah, I'm going to be use the model from the Unsloth library itself. If you don't know about the Unsloth, I already recorded one video in my playlist. You can go and check there. And now data set, guys, we can have any sort of a data set, any data set from the Hugging Face. See, this is the inbuilt data set of the Hugging Face, this one. Now this is the data set from my repository. So even I uploaded my data set over the Hugging Face. See, this is the data set. Let me show you. If I will search it over the Google, I will get my data set. Okay. So just a second. Again, I can search it. See. So I'll get it over the Hugging Face. Let me check with my profile. Okay, I will have to log in over here. Actually, it is not login. That's why it's not coming. Let me check with a different browser. So okay, it's not directly coming, but I can show you. If I said that, I can show you. See, collection spaces is there, then models are there, then data set. See, this is my data set which I already uploaded over the Hugging Face. Okay, so I can use any custom data set from the Hugging Face, not from only from the Hugging Face. We can use it from anywhere. Now if you will check, guys, so see, this is the data set, so I can keep it on my collab server. I can keep it over here and I can utilize it. So we can even read the data set from the different places. So first of all, what you have to do, you have to install this library, guys. You have to install this torch vision, torch audio. You can skip this torch vision and torch audio. This is not required. You can install this X former, and then you can mention this index URL. Okay, this is required, guys, for the compatible CUDA version. Now you require the Unsloth and keep the library in the same order. Then you require the transformer in the data set. Okay, then you require the TRL. Again, TRL is one of the open source library which is available over the Hugging Face also. So if you will write TRL GitHub, you will get the GitHub of the TRL. Right. So here is the GitHub of the TRL. This library actually it is developed by the Hugging Face only. It is an open source, and you can download it by a pip install. Okay, UV pip install or pip install. So this is the complete code of it, right? Transformer reinforcement learning, and under that only you can perform the instruction fine tuning and all everything. Already I discussed these things. Now these many packages and the library will be required, so guys, please install it in a correct order, and please make sure that you have connected with the GPU. If you're not going to be connected, guys, in that case you will not be able to fine tune the model. So here let me run it and see, this line will confirm whether I have the GPU or not. Okay, so this will check, this will perform the sanity check. Okay, so I'm going to be install the required packages. Let it install until I can give you the walkthrough of the module which I'm going to be import. So for loading the data, sorry, here is a data class, guys. So for defining the configuration, I'm using this data class. Then this is again like from the typing optional in the list. Okay, so just for the validation is the check. Data set, from the dataset library, again I'm going to be import the load dataset. Then from the Unsloth fast language model, this is important, guys, this package. Then from the PEFT model, and from the TRL, SFT terrain and the SFT configuration. So this package is being installed until I can show you the other thing. So here, guys, you can see I've created one data class. So this, the name is the fine tuning configuration. So we have a model, load in 4-bit. Okay, these are all parameter actually, which I can define it into the different places. Okay, model name, load in 4-bit. It could be true and false, max sequence length, and the data type. This is one set of parameter. Then for the data set, another set of parameter. For the training, guys, another set of parameter. Okay, output directory, LoRA, per device, gradient accumulation step, epochs, LR, warm up ratio, then logging step, packing and all. Then for the LoRa, another set of parameter. Then for saving the model, these are the parameter. So whatever configuration you have regarding your parameter and all, definitely you can keep those parameters over here. Okay. Now let me check whether it is installed or not. Yeah, still it is installing. Like the package are the huge one, so it will take time. Now apart from this one, guys, so I created one more class. The class name is the Unsloth Fine Tuner. So inside this class only, I've defined my all the methods. Now this is my main class, the core class actually. So this is the init method. I will give you the quick walkthrough of all this thing. Don't worry. Even I will provide you the code. You can go and check. Then we are going to be load the data set. Okay. After the loading, so see, we are going to be sorry, we are going to be load the model. See, here is a model. We are loading a model. Then we are going to load the data set. Okay. Then we are adding end of sentence token. Okay, this is a special token. We required it. So we have to keep it. We have to add it inside the data. Then this is the format, different format of the data. See, I written the different format of the data. So according to the format, actually, whichever data set we are going to be provide, so according to the format it can be done. Okay, it can be like format according to the given format. So it will check the name first and then it will format the data set. Now here guys, you can see, so I written for the custom also. Okay, for the custom data set and for my own personal data set, so you can change the logic. Again, I will come to this part. You will get a good understanding. Now this is my main method, train method, so it is handling everything. So here you can see this train method. Using this train method, actually what we can do, we can initialize this sft trainer. So I define the sft trainer over here and then I will call the train, and then I'm going to be save the model over here. Okay, and then this is the run method, which is a master method. Master method means it is taking care of each and every function. Means it is see, it is asking the restart session. I will not do it because the other package is going to be installed. It will be interrupted. So let me check whether it is done or not. So yeah, it is still being done. Now here you can see, guys, one class is a fine tuner, fine tune configuration. Another class is the Unsloth fine tuner. It is having a different method. Definitely I'll give you the code. You can explore it. Even I will give you one more kind of time of revision. Okay, after explain you fully till the end. Then here is a format data set. I already explained. As this is the train method, this is the save, and this is the like orchestrator. Okay, full pipeline. Now here I already executed it, and see, I was able to perform the training, and even I was able to save the model. Then guys, this is my object. Here I'm going to be create an object of my class. Okay, then uh, I will see here I've created an object, right? Now after that, Unsloth fine tuner, again I've created an object of it, and I'm passing my configuration over here, and then I'm calling this run method. So this is the code, guys, which you can directly use anywhere on any server in any project. It is a simple code. Okay, it is a modular one. You just need to create a specific file and you need to paste this classes, right? So I hope you understood how basically we can fine tune any model. Now let me check whether my whether my installation is done or not. So yeah, installation all is done. So guys, I'm commenting this thing. I just written it to explain you. I'm not using it anywhere inside the code, this particular thing. Now over here, you can see I have importing the statement. So yes, data class, then optional list, load data set, and the other one. So it will also take time. So this is the configuration. Again, I will import. I will create a sorry. I will like initialize this cell also, and then I will create an object of it. So I can show you that part. Now this is my main class, the core class, Unsloth fine tuner trainer. So yeah, I will come to this. First let all the cell load. Okay, till here. This is important, guys. So till here, guys, all the cell loaded. Now what I'm doing, I'm going to be execute this one, Unsloth fine tuner, and then I will explain you. So here, let me load this cell also, and this is my object. Okay, so what I'm doing, guys, I'm going to be create an object of this fine tune config class. So I'm passing a different parameters over here. I'm passing model name, I'm passing dataset name. Okay, so you can pass any model name, you can pass any dataset name over here. You can pass one more parameter, that is a split. Okay, where you want to be save that model. So LoRa save path and then output directory. So over here you can save your model. Now for how many epochs you want to be run it on per device basis. Okay, then gradient accumulation. This is the learning rate, mass sequence length, and save merge. right? So after training this LoRa, right, after fine tune using the LoRa, if you want to merge that layer with your own model, you can do that also. Okay, I given you the option regarding that. So I hope guys this is clear. Now let's look into the main method. Now, guys, I'm going to be create a object of this class Unsloth fine tuner. Okay, here I'm passing this object, this particular object. Okay, it's a data class actually. So using this object only, this object we can access the different parameter. I can show you that. So if you want to access the model name, so simply you can take the CFG, then you can call this model name. Okay, so CFG is not defined. Let me do it. Yeah, this is done. Now if I will run it, see, I'm getting the model name. Now if I want to be like take the dataset name, if I want to be get the dataset name, I can take this object CFG, and then I can call this parameter dataset name. Now see here, this is the dataset name. So I can access any parameter over here. Now guys, Unsloth tuner. So I initialize this class Unsloth tuner with the CFG. Okay, with this configuration, and this is my object trainer. Now once I will call this run trainer.run, my training will be started. So now see guys, my training is started. First the model is getting loaded. Now after that, what will happen? So after that, the data set will be loaded, everything will be done. So let me give you the quick walkthrough of it. So let's look into the run. Okay, those step is running, let it run. Let me give you the quick walkthrough. So first guys, what will happen? So once it will come to this run, so it will call to this load model, right? So this is the load, here is the load model. Load model is a method, right, which we have defined. Then it will come to the load data set, we'll get the raw data set. Okay, then we'll format the data set. Okay, then we'll train the model, and then we'll save it. So this is the complete orchestration. So I think load model and load dataset was clear to you, but again, let me give you the quick walkthrough of it. So here guys, this is the load dataset, right? So the load model. So here what we are doing, we are passing the model name, we are getting the model name. Then we are passing the max sequence length, data type, okay, and load in 4-bit. So this is one side for loading the model. We will get both model and the tokenizer. Then we are calling fast language dot get PEFT model. So we are passing model and the other configuration, okay, regarding the PEFT parameter efficient fine tuning regarding the LoRa actually. So this is all the parameter. So once I will explain the mathematic part of the LoRa, definitely I'll come to this particular parameter. Then here we are here we are going to be print the trainable parameter. Okay, so this is the information which we are going to be print just to validate the thing. Then here we are going to be load the data set. So whatever data set will come, we are going to be loaded. Okay, so here you can see the data set will come over here and we'll load it. Split wise, which part of the data set we want to be load. So if you will check with the data set, let's say this alpaca data set. So here you can see it is having 3 parts. Okay, one is a train, second is a test, and third is a validation. So for training the model, I just want the training part, right? So over here guys, you can see, so we are going to be load the data set, and then we are going to be formatted. Now how we are going to be formatted? So these are the master function for it. I written the master function format data set. So it will check the data set name. Okay, it will check belong to which one. So yes, you can like make a more generalized logic over here. So here I written the logic. Okay, so according to data set name, here you can write the more generalized logic. That is not a issue. So here I'm mentioning if the data set will be this one, this one, this one, this one, so it will format accordingly. If the data set is this one, means mine data set, means from my repository is coming, it will format accordingly. Okay, and these are some fallback statement, right? So now here guys, see, it will format the data set. After formatting the data set, it will initialize the SFT trainer with all this parameter. Okay, this is the parameter. Now it will take the parameter model, tokenizer, data set. Okay, it will take the SFT configuration. This is the configuration regarding their mathematical thing, and then it will call the train, and then we are going to be save the model. That's it guys. So this is all the functionality of this entire code. And see, after training the model, we'll get it over here. Once I will refresh it, see, inside the fee out inside this output, I'll be getting my checkpoint. See, the model checkpoint is over here. So you can give any model Okay, you can provide any model, whatever model you want to be provide over here. So while you are going to be define a configuration, just provide the model name, just provide a data set. See, I provided my data set, so it is taking that data set and is training the model. Okay, my data set was a quite small one. We just had the five rows over there. Okay, inside this inside my data, let me show you again. So inside my data, inside this particular data, I just have five rows. So that's why the training happened very quickly. But if you are going to be, and the model also was quite small, and model also was small, and we are using Unsloth. So that's why, guys, we are able to do the training very quickly. But if you are using a big data set, in that case, it might take that time. Now I hope, guys, it is clear. So please test it with a different model, with a different data set. You can create your own custom data, and you can train your model. You can fine tune. Okay, so that's why, guys, I put the title of this video: fine tune any SLM. Just put the name over here, just put the data set, and this code will work. If you're getting any issue, anything, please let me know. And please make the code accordingly. If you want to changes, if you want to make any changes according to your requirement, then make changes accordingly. Yeah, fine, guys. So yeah, we have learned so many things over here. I will provide you this entire code and all everything. Please check it from your end and check out with my fine tuning playlist for the more information. I'll be coming up with this kind of video in the near future. So yeah, if you have any doubt, any suggestion, if you want any more topic, please let me know in the comment section. Until thank you. Take care. Bye bye, guys. I will see you in the next video. Hey, hello everyone. Welcome back to my YouTube channel. My name is Sunny and I am back with another exciting and important video. So guys, in this video, we're going to discuss about the multimodality and multimodal fine tuning. In the previous video, I discussed about the SLM, which is called Small Language Model. Now, in this video, we'll explore multimodality and multimodal fine tuning from basic to advanced. So, guys, these many points we are going to discuss. The first thing, we'll understand the key terms and the terminology inside the language model ecosystem. I'll just give you the walkthrough of the key terms or what are key terms is there related to the language modeling. Then we'll come to the multi-model large language model and we'll understand what is a multimodality. I'll give you the clear-cut definition regarding this concept. Then, guys, I'll come to the model example. I will give you the different model example. We'll discuss the open source, closed source model, and even I will show you the different leaderboards. Then, guys, we'll understand why do LLM needs multi-modalities, means why we should train our LLM on the multimodal data. Then we'll understand what is a multimodal LLM fine tuning and when and why should use the multimodal fine tuning. Then we'll take a architectural overview. So I will show you how this multi-model works. At least I will take one modality and I'll show you this concept. Then, guys, we'll understand what exactly get fine-tuned when we talk about the multimodal training. Then we'll discuss the different data format for the multimodal fine tuning. Then we'll see how we can create a custom data set. Means let's say if I have to fine tune on my own multimodal data, then how we can do it. Then we'll understand the differences between the normal fine tuning and the multimodal fine tuning. And then finally I will show you the practical using the Unsloth. Now, guys, we are going to all this point inside this particular video, so that's why I told you it's going to be a kind of crash course. Not only the course crash course, guys. So in even in the course as well, you will not find out these many points in any of the course basically. So yeah, I'm going to be cover all these points throughout this video. So first of all, guys, let's understand the key terms and the terminology. And before coming to that, let me show you the practical as well. That what is my practical? See, here is the practical. The practical I prepared completely. I kept so many things over here. The different multi-model, the different type of data, and we are going to do it using the classes and object itself. I'm not going to be write a normal code over here. We are going to be write a complete modular code which you can directly copy and paste on any server. Then, guys, we'll understand how we can prepare our own custom data. See, this is the code for that. Then see the different leaderboard, and not only the LLM leaderboard, guys. I will come to the trending research paper also. Then, guys, these many data set we are going to discuss throughout this video. I will give you the complete guide how this data have been prepared and what all column basically we have inside. Now let's see the key terms inside the language modeling, and then, guys, we'll come to the definition of the multimodality. Now, first term is the LLM, guys, the large language model. The second is called the multimodal large language model, and a third is called the SLM, small language model. So these three important terms is associated with this language model ecosystem. So let's see the definition of it. So first is transformer based model trained on the massive data set to understand and the generate a language. The model basically comes from the GPT, from the Cloud A, from the Gemini, Llamas, or from anywhere, right? So that model basically can understand the language and it can generate the language. So those are called the large language model. Now, on the other hand, what is a multimodal? A large language model. So in LLM extended with an additional capability with the vision, audio, and video. So we are providing an additional capability to the large language model where it can understand the images, it can understand the videos or audio, right? So those LLMs itself is called the multimodal large language model. So we know, right? A GPT-4o, a Gemini 2.5, Coin 3, VL, Lava. So these all are the multimodal large language model. It can process the text along with the text, guys. It can process the other different modality of the data. And now the third term is called the small language model. So what is a small language model, guys? A small language model or the multimodal typically which is less than 10 billion parameter optimized for the efficiency, speed, and the specialization. So again, a small language model could be the normal language model which can only process the text, which can only process the language, or it could be the multimodal, means it can process the text along with the images and the other type of data. So that is called the small language model. A small language model is having less than 10 billion of parameter. So if you want to understand this small language model in a detail, then check out with my previous video. I given you the complete in the detail guide about this small language model. Now what is the example of this small language model? So the example is Phi 3 mini, Gma 2b, Gma vision, right? Then tiny llama, Coin 2, VL2b, lava small. So here I kept the normal model which can only process the text like Phi 3 mini and Gma, and even I kept the multi-model like Gma vision and lava small, Coin 2, VL 2b, right, which can even understand the images. I hope, guys, this thing is clear. Now let's look into some other term. So the another term is the vision language model. So again, if someone is saying the vision language model, so that is nothing, that is a multimodal large language model only. If someone is saying audio language model or a speech model like text to speech or speech to text, again those model comes under the multi-modal large language model only. So I hope, guys, all these terms and terminology is clear to all of you. Now coming to the next part. So guys, there is few more term which we need to understand. The first term is called the closed source model, and the another term is called the open source model. So what is a what is a closed source model? So guys, the model actually which we can only access through the API, and we cannot access the weight of the model, means we cannot download that model, and we just have a limited fine tuning access. So those model actually it is called the those model are called the closed source model. Now on the other hand, we have the open source model. So we can access the weight of the model, means we can download the model, we can perform the fine tuning of the model, and even the local deployment is available. So we can download the model directly, we can deploy it anywhere, even we can fine tune that model. So in whatever way we want to be fine tuned, whether it's a full fine tuning or it just like a partial fine tuning, whatever kind of fine tuning you want to do, you can do using these open source model, right? So guys, this is a very important, you need to understand the differences between the closed source and the open source. Now we need to understand the other different terminology regarding the data. Now let's understand that part. So for that, guys, I capped one image. I think you are able to understand the different like terms related to the data. So whenever we talk about the data, guys, so we have a different modality of the data, as you can see. So we have text modality, we have image modality, we have audio and the video. Okay, video. So guys, this is all, this is called the modality of the data. This is called the nature of the data. The data will be present in this particular format. Okay. uh, where the data could be the text, image, audio, and the video. On the other hand, we have one more terminology which is called the file format, where we can store the data. The first thing is called the PDF. The second is the docx, CSV, JSON, YAML, MP3, MP4. So inside this of storage, right, inside this file format, basically we can store the data. Then guys, we have one more modality. It is not a modality actually. I would say it is a semi modality. So that semi modality is called the tables, right? So what is a table, guys? A table is nothing. It is a way of structuring our data, right? So we can structure our data in the form of tables. Again, it does not comes under the modality, because in the table we can keep anything. We can keep the text, we can keep the images, we can keep the audio file, right? Whatever we want to keep inside this table, we can keep that. So table is nothing. It is just a way of structuring the data. On the other hand, we have one more specific term that is called the document. So what is a document, guys? So the report, invoice, research paper, presentation. So these are nothing. These are the reports, right? Now this report actually, it can be the PDF, docx, Excel. Means in any file format we can create this document. I hope you are getting uh, the differences between each terms and the terminology. Okay, so these are the fundamental, guys. Before starting with the multimodality, we need to understand all this fundamental. Now I hope, guys, this slide is clear. The key terms in the language model ecosystem, the differences between the closed source and the open source, and the different term related to the data, which is modality, the different file format, the structured data, which is also called the table, and the another term is a document. Now understand what is a multimodal large language model, and let's understand this particular diagram. So guys, first let's start what is a multimodal large language model. So guys, if we're talking about the multimodal large language model, so this is nothing, it's just a AI model that can understand and process and generate multiple type of data. Okay, multiple type of modality. So what is an example of those modality? So the example of those modalities, the text, it's a image, audio, and the video, guys, right? If we're talking about the video, so videos are nothing. It is a collection of the images, audio, and the timestamp, right? So video is a collection of these three things. I will discuss that. I'll come to that. I created one separate table regarding the different modality and the example of it. I'll come to that part. But before that, guys, let's understand this very important architecture, and let's understand what it is saying. So we all know about the LLM, guys. So we have a LLM over here. So to this LLM, what we are passing text, we are passing image, we are passing audio and video. So we are able to pass more than one modality, means one more than one type of data. So that is called the multimodal LLM. Now over here, guys, let's say we are passing text and we are generating a text, right? This is possible, right? This is possible, and this is what we are doing. On the other hand, let's say we are passing text and if we are able to generate an image, yes, this thing is also possible, right? So this is called the multimodality, means we are passing one type of data and we are generating another type of data. Let's say we are passing text and we are generating audio. Yes, text to speech is possible. Model is capable to do that thing. Now if we are passing text and we are able to generate the video, yes, that thing is also possible. So we have several model like OpenAI Sora, right? A runway, and even a couple of model in the Gemini API. You will find out related to the text to video. So yeah, this modality, this functionality is also possible. So this is only called the that's why, guys, we are saying this a normal LLM, the multimodal LLM, because it can process the multiple because the LLM, if LLM can process the multiple modality, and it can generate the different kind of output, right? Heterogeneous output. So what is a heterogeneous output? If we are passing text and if we are able to generate an image or audio or video, so that output is called the heterogeneous output, right? Now guys, images wise, so yes, if we are passing images, so we will be able to generate the text. This is possible nowadays. We are passing images to the GPT model, to the Cloud A model, to the Gemini model, and it is able to generate a caption, it is able to generate a description out of that image. Then guys, from image to image, yes, that thing is also possible. We have certain tools using that we can modify the image, we can basically customize the image, okay, we can edit the image. So yeah, this thing is possible using the AI. Then image to audio, I think I haven't seen that system so far, maybe it is available, but yeah, we can do that also. So model basically, see, we are talking about to generate a video or audio, right? So model directly cannot do that. Model can only process the mathematical information. Let's say text, we are going to be converted into the embedding. Model can process that. Images, we are going to be converted into the embedding, we can process that. Audio, we can convert into the embedding, and model using that, model is doing processing that. Audio, we can convert into the images, then into the timestamp, then basically audio, and model is processing that. But guys, if we want to directly see, if we are directly passing a video and LLM is processing that, means behind that there is some process which is breaking down the thing, okay, into the smaller part which LLM can understand and LLM can process. Now generation wise, again, video, audio, so LLM directly cannot generate those MP4 file or any audio file, right? But guys, it can give us the mathematical component, and using those mathematical component we can reconstruct the output, right? So we are talking about audio to sorry, image to audio, or audio to video, or basically video to video. So that is a complete system. Like GPT is a model and chat GPT is a complete system which can process anything. Similar to that, guys, if we are going to be generate video to video or audio to video, right? So that would be the complete system. I hope you understood it. Now, let me show you the different example regarding the different model, and after that, guys, we'll come to the fine tuning part. Guys, this is a table where I given the example of the different modality. So let's understand about the modality, then transformation type, then description of it, then what all closed source and the open source model are available regarding to that modality. So the first is a text modality, as you can see. So what it is doing, it is going to be generate text out of text. So whenever we are passing any text, guys, so whenever we are passing any text, so it's going to be generated text. This is called the classical LLM case. And what are closed source and the open source model are there? So OpenAI based GPT, Anthropic Cloud A, Gemini, or any other open source model. Sorry, any other closed source model, which we cannot access directly. For those, we'll have to pay. Then the other one is called the open source. So Llama, Mistral, all the model basically which we can access from the Hugging Face Hub, or maybe via free API. Those are called the open source model. Means for those model, we no need to pay anything. The other one is the image modality. So from here to here, guys, you will find out the example of the image modality, where we are passing the image and we are generating a text. We are passing a text, we are generating an image, or we are passing image and we are generating an image. So let's see, image to text. So we are providing an image and we are extracting the content out of it. Okay, so this thing is very common nowadays. Means every company wants to be their LLM with a multimodal capability, where at least it can process the image, right? Then guys, here is all the model. So this is all the model, guys. You can read out the name. I will provide you all these notes. You can go through with this table and you can understand it by yourself. Okay, you can do you can do some self study, okay, using this entire table. Now guys, here you can see some open source model. So yeah, image to text we can do using the open source model. So the model from the Salesforce, from the from the Meta, from the Alibaba, from the Google, right? And even from the Hugging Face. So some model are available which can do this task. Then text to image. So whenever we are passing any sort of a text, so out of that text we can generate the image. So OpenAI Delhi, Mid Journey, Gemini 2.5 Flash Image, Gemini 3 Image Preview, which comes under the Nano Banana, right? The image generation model. So these model are the closed source model. Now, on the other hand, we have stable diffusion model from the Stability AI, from the Black Forest Labs, there is Flux. Okay, the model name is Flux, Flux, Flux 1, 2. X is representing the version 1, 2, 3. So we can pass a text and we can generate the image. Okay, so the other one is the image to image. So why we use this modality? So image to image. So we can modify the image, we can enhance the image, we can transform the image. Okay, means we can remove the background, we can do some style transfer, we can do some resolution related thing, we can perform some face swapping. So yeah, this kind of thing is also possible using some system. So here I written a name. So the first one is what is Adobe Firefly. So this is very good image editing tool. Even using OpenAI Delhi also you can do that. Using the Nano Banana also you can do that. So these are some closed source one, and on the other hand, we have open source from the Stability API, that's called the Stable Diffusion, image to image, okay, or iron painting in painting. So these model using these basically system, you can perform image to image generation. Then the other hand, guys, see on the other hand, we have other different modality like audio modality and the video modality. So regarding that also I kept some examples so you can understand this entire image, this particular image which I was talking about. So let's understand about the audio modality. So we have text to audio, audio to text, and yeah, there is two modality. So convert text into synthesized speech, which is called text to speech. Okay, and audio, oh sorry, text to got it, guys. So text to audio. Text to audio means text to speech. Audio to text. Convert spoken audio into text. Okay, which is called the speech recognition. Audio to audio. Transform or modify input audio. Sorry, I missed this one. This one. Now over here, guys, see this is the model. Some closed source model, some open source model. So I listed each and every model. So this OpenAI Whisper API and the Google speech to text are the very well-known model, right? On the other hand, this OpenAI TTS and text to Google text to speech again it's a very well-known model for text to audio. These are some open source model. As you can see, OpenAI Whisper again, it give you like the open source access also till some extent. On the other hand, we have this Mozilla Deep Speech, okay, which is completely free. You can utilize that. Then from the CoQI, there is one model, CoQI AI, TTS, and from ESPNet, there is one more model, which is a TTS, okay, which I can use for converting text to audio. Now, audio to audio, guys. So again, audio to audio directly we cannot pass the audio file. We required some kind of system which can convert the information into the mathematical patches and which can provide to the model. So this 11 labs voice AI, Adobe Enhance Speech, Meta Voice Box. So these are some platform using that we can do the audio to audio generation. Now coming to the next part, video modality. So video is nothing, guys. Video is a combination of the images, time, and the audio. So video modality is going to be combine all these three things as I written over here. And now text to video, video to text, and video to video is possible. So we're talking about text to video, guys. So again, Runway, Pika Labs, and OpenAI Sora. Then video to text, again, OpenAI GPT-4o Gemini Vision model can perform this task. Now, on the other hand, in the open source, if we're talking about, so Stability AI video diffusion from model scope text to video, and even Alibaba Group, right? Alibaba Group is providing some model like Coin VL, Coin 3 Omni. Okay, so using these particular model, what we can do, we can generate video to text. I think this Coin is very famous model from the Alibaba, right? We have a different variant of the Coin. Definitely, we'll talk about it. Now again, guys, video to video. So yeah, the model is working, the multi-model is there in the system, but again, for doing this thing we require the end-to-end system. So modify or transforming the existing video, what we are going to be modified. So we are going to be modify the style, the some video enhancement, face swiping, and all some editing in the video. So we can do using these particular tools. So I listed the tool over here, I written a tool name. So guys, this table is very important to understand the complete multimodality. That's why I created this kind of table with the like different example, okay, with a very vast example. And definitely I'll provide you this note so that you can go through with it. Now let's understand the next point. Let's look into the different leaderboard, and let's look into some trending research paper, guys. Guys, the first leaderboard is from the Open LLM, from the Hugging Face itself. This is a Open LLM leaderboard. So here you will find out all the open source model. So they have listed around 4,000 model over here. You can simply go and check. Okay. Now, apart from this one, you can apply so many filters over here. So filter wise, you can see leaderboard is there, citation is there. Then even you can compare the model. Now, apart from this one, you can check out with this advanced filtering. See, they have given you some quick filter where you can select the model for the edge devices. You can check out the consumer model, mid-range model for the GPU range, right? And only from the official provider. Apart from this one, you can apply some advanced filtering. You can click on this one, and here you can select the model type. So if you are going to be select a multi-model, so they will give you the recent multi-model. Okay, so let me show you. They are showing some 9 multi-model over here. See, these are the name coin to VL, right? Then from the demon demon talks, and then from the rhythms. So from the different provider, you will find out the multi-model, and even see, guys, you will find out some benchmark also over here. So on whatever benchmark this model have been tested, you will get those benchmark also inside this one. Now, apart from this leaderboard, we have one more leaderboard which is a quite famous again. That is a like arena leaderboard, LM arena leaderboard. So just go and check out over here. So here also you will find out the different models actually. So see, this is the text related model. Then here is a code related model. Then vision related model. Then text to image model. Then image editing model, search model. Okay, image to video model, text to video model. So different modality you will get over here. So if you want to compare the model, if you want to check like which model is doing well, which model is performing well, then you can go through with this leaderboard. Apart from this one, if you wanted to like know about more model, okay, the different more model regarding the different modality, so simply you can go and check with the Hugging Face. Let me show you that. So once you will click on the Hugging Face, see, just click on the Hugging Face, just go with the home, just go and check with the home page of it. Then here you will get the model option. Click on the model option. Now left hand side you can filter out. So left hand side, they are giving you the various various option. You can check out directly with the text to image, text to basically text to text, image to text, video to text. A different filter you can implement over here, and you can check your required model with your required model. Just check out over here. See, audio category, natural language, computer vision category, then multi-modal category. The different and the various category they have provided you over here. So likewise, guys, you can explore the different model. Now I would say, guys, I would suggest you this leaderboard is a quite like important and the required also. Even I am going through with this leaderboard whenever I have to decide any model. So I can check out with the various model over here. I can directly check. Let's say if I want the vision model, I can click on the vision and I can look over here. Once you will click on the view all, you will get the all the model, all the listed model. Okay. Now here is one more leaderboard, guys. Now this leaderboard is not about the models. This leaderboard actually it is about the research paper. So Hugging Face, over the Hugging Face itself, you will find out one over the hub itself, right? You will find out one page regarding the trending paper by the research community. So these all are the like trending paper with you can go through with these papers. See, whenever I have to check with any recent research, right, the updated research, then I go through with this I go through with this research I go through with this leaderboard of the trending research paper, and I try to figure out some the latest research. Okay, so many people were asking to me, Sunny, how you are keeping your up to date regarding the LLM research, the research paper, okay, the different new concept which is coming day to day in AI. So I generally follow these approaches. I generally follow these platform. I hope this entire thing is clear. Now you can go through with this, like you can go through with this platform. The one is the Arena, okay, Arena leaderboard. The another one is the Open LLM leaderboard, and another one is the trending paper leaderboard. Okay, so you will get some additional information. Now again, coming back to the like the topic. So here, guys, we were talking about the Let me show you the last one. So yeah, we were talking about like the different modality. So now let's discuss why do LLM need multiple modality. Okay, what is the requirement of that, or why basically we cannot train our model only the text. So whenever we talk about the real world, guys, so real world is a multi-model. Now tell me, what is the capability of the human? So human can see something, right? Human is having a vision capability, and human can speak, means human can understand the language, and behalf on that language it can speak something. So human is having two capability, one is the vision and second is the language capability. And even human can listen something, right? Human can speak, human can see something, and human can listen something. So human is having all the capability like language related, audio related, vision related. And if I want the same capability inside the AI, then definitely I will have to train my model over the different type of data. Okay, so what is the main aim of the AI, guys? So the main aim of the AI is to provide same kind of intelligence, whatever intelligence the human is having, right? To provide a same kind of intelligence which the human brain can explore, right? So this is the main aim of the AI. And to achieve this thing, guys, we cannot only rely over the text, right? Because human can speak, human can watch something, human can listen something. So similar to that, if I want to give this capability to the AI, so we require a different type of data, means we require the text data, which is a language, right? Which is a language. The second, we have to provide the vision data, and even we can give the audio data as well. And video is nothing, guys. Video, again, it is a combination of the vision as well as the audio along with the timestamp. Getting my point? So that's a main aim, right? So that's why, guys, LLM needs multimodality. So the same thing I have written over here, you can read out. So model needs multiple modality because the real world is not a text only. Intelligence requires seeing, hearing, and understanding the context. Okay, I hope you understood this point. If someone is going to ask you in an interview, then explain in a same way, right? So that you can leave your impression. Now another example, so here I kept another example. Let's like think. So let's say there is a doctor, and doctor is looking into the doctor want to understand like what kind of problem this patient is having, right? So the patient brought this x-ray, brought his or her x-ray. Now doctor is looking into the x-ray, right? Along with the x-ray, he is reading the reports, and he is understanding the lab value. So just after combining, only just by combining, okay, just only just come after combining all this thing, doctor can bring, or doctor can make a better conclusion, right? So here the image, right? Patient report, which is having the text, the lab value, again it is having a text, and whatever patient is saying, right, regarding their disease and all. So yeah, doctor is listening to that. So after combining all this context only, doctor make a better conclusion. I hope you understood why LLM required a multiple modality. Now, guys, after see, we all cover up the fundamental of the multimodality. Now, let's come to the next topic, which is a fine tuning one. Now, what is a multimodal fine tuning? When and why it is required? And then we'll see all the concept related to the fine tuning only. So, guys, adopting a multi-modal large language model to perform a specific task or a domain-specific task using multi-modal data, that is called multi-modal LLM fine-tuning. Means we are going to be retrain our multi-modal LLM over the multi-modal data like images, audio, or videos. So, when you should perform this multi-modal fine-tuning, so the first thing is, if we want to give the capability, right, multimodal capability to the large language model, in that case, we should perform this multimodal fine tuning. The second is the OCR, right? If we want to give the OCR capability to our model, means let's say there is a model, let's say there is a GPT-4o. What this GPT-4o can do, I can write over here. What this GPT-4o can do, this GPT-4o can take any type of data. It can take images, it can take text, right? Now guys, let's say if I want to train this GPT-4o, if I want to retrain this GPT-4o on my own data, let's say I wanted to perform the OCR on my own domain specific problem statement. Let's say the problem statement is a medical analysis. So I want to provide some medical document to the GPT-4o and I want to get some information out of it. So for that, what I will do, I will perform the multi-modal fine tuning. Means I will collect some images related to my domain specific task and I will retrain this GPT-4o model. If I want to do the visual conversation, means let's say if I'm going to be provide images and behalf on that images, right? I want to generate some output, and again the output I want into the images, or let's say I'm passing image along with the text and I want to generate some output, okay, on my domain specific task. So for that also I will perform this multimodal LLM fine tuning. Now again, the last one is a document AI, right? So this could be some sort of a region. Because of that, basically, I'm going to be perform this multi-modal LLM fine tuning. So the funda is clear, the idea is clear, the definition is clear. If I want to retrain my multi-modal LLM on any domain specific task, okay, so for that only I will perform this multi-modal LLM fine tuning. I hope this definition is clear. Now, what I'm doing, guys, see, here is one more definition. I'll come to this definition. First of all, let me explain you how you can learn this multimodality and this multimodal fine tuning. Because see, if we're talking about the multimodality, let me write over here. So we're talking about the multimodality, guys. So multimodal is going to be like contain a different type of data. Let's say we have an image over here, right? Or let's say we have an audio, right? Let's say we have a video. So every type of data, guys, to process every type of data and to train a model on every different type of data is required a different architecture. So how you can understand this multimodality? So if you want to understand this multimodality, then you should start from the images, guys, right? So guys, audio and video, maybe we are not using that widely, but yeah, we are using the images very widely. So whenever we have to process whenever basically we are using chat gpt, so along with the text, most of the time we are providing the images, okay? So guys, if you are starting your multimodal journey, then you should start from the images itself. So inside this video also I'm going to be teach you the vision language model, like how the vision language model is working. Again, I told you the vision language model is nothing, it is a multi-model only, okay? So in this video we'll discuss about around the vision language model. I'll not focus on the audio and the video data. Again, we can look into the model, the different model which can process the audio and video. So that I'll let you know in the separate video, okay? So in this video I will focus on the image data, and we are going to fine tune our model on top of this image data only. So here is one more definition, just and along with the definition, guys, I kept the different research paper also, and in this particular sequence only you need to go through with this research paper if you want to understand the multimodality using the image data. So over here, guys, just read out this definition. Multimodal LLM fine tuning is a process of adapting a multimodal large language model that process both visual and the textual input. So here I'm here I'm saying in the context of the uh, here I have written the context of the images, okay? So textual input by updating it a projection layer, the language model, okay, language model weights using the image and text instruction dataset to improve the domain specific cross modal reasoning. So if you want to fine tune the multimodal, or if you want to fine tune the multimodal which is like specifically related to the images. So I will have to focus on this two part. The first is called the projection layer, guys. So we'll understand what is this projection layer, and after that, after this projection layer only, this language model will come, and inside this language model only will be having the attention as well as the MLP, multi-layer perceptron. Okay. So these all are the research paper. If you are starting your multimodal journey, then guys, you can start with this research paper. It will give you the in-depth understanding of the multimodality using the images. So you can go through with this VIT clip, CLIP, then this Quen model, then this Blip model, Lava model, then OpenAI Delhi, and then Google Image Gen. Okay, so the Nano Banana, the model, basically, the Nano Banana, it have been created using this particular research only. Now let's see how we can understand this multimodality, right? Or the vision language model. So if you want to understand the vision language model, guys, you will have to follow this path. So the first thing is the image modality. You will have to understand, see, you will have to understand about image to text and text to image. Both are the different thing. Text to text we know, but if we are passing text, if we are going to be generate an image, or if you are going to be image and if we are going to be generated text, both are the different thing. In both modality, right? In both image modality, the data is being processed in a different manner. So for understanding this thing, you will have to understand the image first. So what is an image, right? So you will have to understand about the images mathematically. So this is going to be your first thing, first topic. Then you will have to understand about the CNN basics. Okay. Then you will have to understand the backbone of the image modality, that is called the vision or language or vision transformer. This paper was published by the Google, and inside this paper only they have showcased like how you can process the images and how you can provide that embedding output to the LLMs, okay, to process the images. This paper is very good. Now another fundamental paper is the CLIP, which is playing a very important role while we are going to be generate an image using any LLM. So whatever model you are seeing, whether it's a Delhi or Mid Journey or any other model, guys, so in backend those model is using this clip technology. So if you want to understand the image modality, whether it's a image to text or text to image, then this two model is very useful. Two paper is very useful. First is a vision transformer, and the second is the clip. Okay. Now apart from this one, if you want to understand the models, so model wise, guys, I will highly recommend you this two model, Lava and this Quen model. Okay. This is image to text, and if you want to understand the like text to image, then this model, guys, Delhi and the image gen. So likewise, you can cover the entire this image modality, and you can understand the multimodal concept. Now let me give you the overview, architectural overview of the image mathematically, then CNN, and then I will come to this VIT model. Okay, and then we'll understand some architecture. So here you can see the here you can see one image. Okay, the mathematical representation of the image. Then we have this convolution neural network, guys. I'll give you the quick walkthrough of it. Then we have this vision transformer. So over here you can see how the vision transformer is working. Then we have this Delhi architecture, which is representing how this text to image is working. Okay, so let's do one thing. Let's take a overview of this. So guys, if we're talking about the images, these images are nothing. It is a collection of the pixels. Okay. Here you can see the pixel. So what is a pixel? If you don't know about the pixel, guys, pixel is just a numbers. Pixel. What is a pixel? Pixel is just the number. So the range of the pixel between 0 to 255. Okay. And if we're talking about the images, right? So we have two type of images. One is called the black and white image, and the second type of image is called the color image. In black and white image, so we just have 2D array, and in color image actually we have 3D array. 3D array actually it is a combination of the R, G, and B value. Understood, guys? So if we're talking about the images, it is nothing. It is just a collection of pixel, the range of the pixel between 0 to 255. If we're talking about the black and white images, so it's a collection of 2D array. Okay, in 2D only all the pixels value you will get. And if we're talking about the color image, so in that actually you will find out the three channels. Okay, three channels like this, three channels like this, and each channel having their own pixels value. I hope this thing is going to be clarified. Now, guys, how the CNN is working, we need to understand that part. So, if we're talking about the CNN, the full form of the CNN is the convolution neural network. So, it's going to be extract the feature or the important value from the images, and that thing we are going to be provide to the artificial neural network. Okay, so we can divide divide this architecture into two part. So the first part is called the feature extraction, and the second part is called the classification. So we're talking about the VIT paper, guys. So in the VIT paper, in this vision or transformer paper, we just require this feature extraction part. So we are going to be collect the patches, okay, the important feature of the images, and that feature we are providing to the large language model. So instead of this neural network, guys, so you will not get the neural network inside the VIT paper. Instead of that, instead of this neural network, you will get this large language model. Understood? I hope this thing is clear. So let's look into this feature extraction process, that how we are going to be find out a feature out of images. So what we do, so let's say we have an image. Image is nothing, it is a collection of the pixel. So we are going to be multiplied with the filters, okay, with the multiple filters. So that process is called the convolution. So we are going to be multiply this image with the various filter, whatever information we want to be get from this image, okay. According to that, basically we are going to be create a filter. Now this filter, basically it's a learnable value. So while we are going to be train the model, so this all the filter is going to be learn, okay. You know the learning, the forward propagation and the backward propagation. In the backward propagation, we always update the values, okay, values of the weights. So in CNN, actually we update the value of this or like neural network, as well as we update the value of this learnable filters, okay. This is also called the kernel. So we multiply this kernel or this filter with the images, and we are going to be we are going to be find out this convolution image, okay. After that, we are going to be perform the pooling on top of it, okay. We are going to be select some important features, some important pixel value out of image, okay. And then we get the filtered data. So here is my filter data, here is my all the features out of images, and we are going to be flatten it, and then finally we are passing to our network. So in the classical CNN network, we had the fully connected layer, which is called the which was my neural network. Now inside the VIT, inside the vision transformer, actually you will only get the LLMs, okay. And this flatten layer, actually it's going to be replaced by the projection layer. So now let me discuss the VIT one. Let me discuss the VIT architecture. So this is a VIT architecture. So here what we are doing, guys, so we are passing an image. So we are having an image, okay. Here you can see. Now this image, actually we are going to be convert into the multiple feature using the convolution process. So this is the multiple feature, okay. This is the multiple feature which I extracted from the image. Then guys, what we are doing, that replace that flatten layer, actually we are going to be replaced with this projection layer. So linear projection of the flatten, it is a similar kind of operation where we are going to be convert our all the image into the embedding, okay. Means this is the images only, this is the value of the pixel. So we are going to be flatten all the value, we are going to be convert into the 1D array, okay. We are going to be convert into the 1D array. So this is called the linear projection of the flatten patches, right. Then what we are doing, guys, we are going to be apply this positional embedding, and after that we are passing it to the transformer only, and then this transformer is doing the prediction that what we are having inside the images. So this is a straightforward architecture, a very simple architecture of the VIT. They have replaced what, they have replaced the neural network with this transformer encoder. If you don't know about the transformer encoder, guys, this is the transformer encoder. You can check out with my previous session, there I already discussed about this transformer encoder, okay. Our transformer encoder and the decoder. So this is the overall process, guys. Here you can see this entire process. So we are having images, we are passing it to the vision encoder, okay. Then we are going to be extract the images feature, we are passing it to the projection layer, we are converting to the embedding, and then we are passing it to the LLM. And now over here, guys, this vision encoder is nothing. See, here I wrongly written this thing, let me remove it. This vision encoder is nothing, it is a CNN process, right? CNN based process, convolution neural network based process. Okay. Now, if see guys, and here we have one thing which is a linear projection of the flatten. So don't be confused with this thing. I can explain you this thing with one more example. So whenever we are talking about the text, guys, so let's say we have a text. The text is my. I'm just writing over here. I will just take one more minute. My name, my name is Sunny. So if I'm going to be write it down, and if I want to pass this particular text to the LLM, how I will do that? So first I will convert this text into the tokens. So let's say I have a token. Token is my, then second is name. Okay, then the next token is, and then Sunny. Then what I will do? So I will convert I will create an embedding out of this word, right? So let's say this is the embedding of this word. Then here is the embedding of this word. Then embedding of this is, and then embedding of this Sunny. Then what I will do? I will connect this embedding with the positional embedding, right? Position embedding, embedding, and then only we'll pass this data to the attention layer. Okay, then only we'll pass this data to where? To the attention layer. So this is the process which we are following. Now over here what we are doing inside the images, guys, just replace this particular text with the image. So what we have a small patches of the images. We have a small feature of the images which I got after the CNN. Okay, after performing the convolution operation, I got this different patches of the images. Then what we have to see, we have this is nothing, this is the array only, right? This is the array only, it is having some value. So what we are doing, we are going to be flatten it. Flatten means what? We are going to be convert in it, we are going to be converted into the 1D array, this entire patches. Okay, so let's say we got the 1D array. Okay, this 1D array, this 1D array. Now we are going to be attach this position encoding with this 1D array. Okay, so the process is same, the process is same here also. We are doing the same thing. So this is the token, we are going to be convert our embedding, and all together simultaneously means we are going to be combine all this embedding. We are going to be merge this position embedding, then only we are passing it to the attention. Getting my point? So the same thing we are doing with the images, but here we have a feature of the image, and here we have a token which we are going to be generate from the text itself. I hope you understood the meaning of this linear projection of the, or linear projection, or the flattening operation. So just read this line. The paper proves you can do image recognition with the pure transformation. Don't require the CNN by splitting an image into the fixed size patches. Okay, the size of this patches, the feature basically we are going to be extract from the image. The size of it would the size of this feature would be 16 cross 16. Then flattening each patches into the vector, then linearly embedding them like a tokens, add the positional embedding, and then feed the sequence to the transformer. The same thing which I was explaining, the same thing I have written over here. Okay, so this is the entire process behind what? Behind image to text. So whenever we are going to be pass any image to the model, let's say we have a GPT-4 model. So in backend it is going to be perform this procedure only. So it's going to be perform this entire procedure. Now guys, let's understand the architecture of the Delhi, like how the Delhi is working. So we're talking about the Delhi, guys. So see, just look over here. So we are passing a prompt to the Delhi. Okay, we have a text encoder over here. We are going to be generate a text embedding. Then we have one prior layer. We are passing it to the image, and we are going to be generate an image embedding. Then we are going to be pass it to the decoder, and the decoder is generating an image. So this is the entire process behind the DALI. Now let's try to decode it. What is happening actually? What basically is happening in backend really? So if we're talking about the user prompt, so this could be anything. This could be let's say here I am writing uh, image of cat. Okay, generate image of cat. Now what will happen? So it will come to this clip model. Now this clip model actually it is trained on the image and the caption. Okay, it has trained on the multiple image and the caption. So what will do? So according to this given input, okay, it will generate the image of it. Okay, image of it, right? So image, and along with the image we have what? We have this user prompt. Then what will happen, guys? So here we are going to be create a text embedding out of this text. right? Then prior model, so text is going to be converted into the, see here we have a text embedding and the image embedding, both I'll be getting, okay, in a same space, using this clip model. Actually we'll be getting the text embedding and the image embedding. Okay, then we are passing to the diffuser, right? So it's going to be generate an image. Initially the image will be the noisy one, but by the time it's going to be enhanced, okay, and then we'll be having a final generated image. So we are talking about the Delhi architecture. So the main component of the Delhi architecture is what? It is a clip model. So understand how the clip model works. Okay, then after that, guys, the diffusion model, understand how the diffusion model is works. Okay, so this two is the main architecture of the two is the main like component of the Delhi, right? And apart from this, understand about the embedding side, like how the embedding works, whether it's a text embedding or the image embedding. So this is the main component actually. So likewise, if we are going to be pass any text, so the image is going to be generated accordingly. So here, guys, we understood both. Here we took the overview of the both architecture of the image modality. One is the basically text to image, and another is the image to text. Now, guys, let's do one thing. Let's understand which thing is going to be fine tuned. What exactly it's going to be fine tuned whenever we are performing this vision fine tuning or this multimodal fine tuning with the image capability, right? So here we have a option one. Now, guys, just read this each and everything one by one. It's a very much important. So in the option one, what we are going to be fine tuned. So train everything, right? So train vision encoder, projection, and the LLM. So here, if you will see, so we are going to be fine tune all this thing. This one is this one, second is this one, and third is this one, this LLM. Okay. Now, guys, this process is going to be expensive. Now, here, guys, we are going to be talk about this uh, image to text. Okay, we're talking about this image to text. Now, this process is going to be very expensive, so we generally prefer don't we generally don't prefer this process. The second is the train only the projection layer. Okay, so here what we are going to be do, we are going to be freeze the vision encoder in the LLM. We are just going to be retrain the projection layer, right? So how the embedding is going to be generate uh, sorry, how the flattening is happening, the projection is going to be happen, right? This one. So we can train this also. We have three component inside this architecture. First component is this a patch. Okay, the patch is being generated from the CNNs. Okay, the second is the projection one, this one, and third is this transformer architecture, the encoder one, right? So either we can train this entire one, all this three thing, which is going to be very expensive. Here I written over here. The second thing, just train the projection layer, or else train the a projection plus LLM. Okay, this is the common one. Actually, we generally don't go with this one. Actually, let me mark in a red color this one. So we always go ahead with this one, this part. Train projection plus LLM, which is a very common one. We generally fine tune this layer only. And the another one basically fine tune everything, means fine tune the vision layer as well as the LLM layer, attention, and the MLP using the LoRa. Okay, so whatever component we have on top of it, we can apply the LoRa. Okay, and we can try that, or sorry, we can retrain that. So we have these approaches. Okay, the what needs to be fine tuned, what will be fine tuned. So over here I clearly mention, again I give again let me give you the quick revision of it, so that easily you can understand. Don't worry about the time, guys. The time definitely will be going there. So now here if we're talking about this image, see, we have three part of it. If we're talking about image to text, one is this patches, which we are going to be generate from the CNN model. This is also called the vision encoder. The second is the projection one, and the third is the LLM one over here. Got it? Then what we are going to be fine tune. So option one, train everything, which is expensive. We generally don't go with this one. Second, basically this projection layer as well as what projection layer with LLM one. So this is the common one, but again it will take a more resources. Okay. The next one basically fine tune everything with the LoRa. Okay, so what we are going to do over here, just read each and every line, and maybe the understanding will be clear. So what I've written over here, LoRa based multimodal fine tuning. So vision layer, LoRa, apply LoRa on top of it. Then LLM layer, attention and MLP, apply the LoRa over here. Okay, means you are not going to be fully retrain the entire one. You are just training the LoRa adapter. Okay, this will work even on the smaller GPU, and it is a memory efficient. So you can retrain every component using the LoRa capability, right? And yes, this is possible. And this, guys, I'm talking with respect to image to text. I hope this is clear. Now, if you are going to do without LoRa, it will be little expensive. Now, coming to the next part, we're talking about the dataset format. Now, how the dataset looks like. So we're talking about the dataset format, guys. So dataset is having a different format. Okay. Uh, so these all are the format basically in which you will get the dataset while you are doing this multimodal fine tuning. The first is a simple image and the instruction. Now again, guys, we are talking about the image to text over here. Okay, image to text over here. So if I wanted to retrain my model, if I wanted to retrain my LLM model on top of the images, okay, so in this three way only I will be preparing my data set. So the first is a simple format. What I'll do, I'll keep an image. Okay, either I'll be keeping the path of the image, or I'll be keeping the object of the image, right? Object means I'll keep the image itself in the PIL format. Got it? Or I'll keep a path of the image so that like I can read the image from the specific folder, right? This folder could be available on any platform or any cloud, or it could be available in my local itself. So images, and then the caption regarding the images. So example.png, this is the caption. The column name could be the text, or it could be the caption, anything. The second is a VQK format, okay, visual question answering format. There you will be keeping the images, then question, and then answer related to that. Okay, so this is the normal captioning, right? Image captioning. On top of the image captioning only, you are going to be retrain your model. This particular format, basically it's a visual question answering format where you have the images, along with that you have question and answer regarding that particular image. The third format is called the Llama format, right? So inside the Llama format, what you will have, you will be having the images and the conversation, right? Conversation, basically you can see the role is a user, content is this one, means the user is asking this question and we are going to be generate this answer. Again, it is similar to the question answering only, the conversational regarding the conversation only. Okay, so either we can keep in this format, just simple image question answer, or either we can keep it like this. Okay, both will work. So yeah, here also I mentioned the same thing. So if you will go through with this data set, the different data set which I open over here, see, one very famous data set is a chart QA. Just check over here what I have written over here. See, sorry, what they have given over here. They have given the images. It is like the image itself. Okay, it's a PIL format of the image which we kept inside this table. Okay, so you can see this is the image, this is a query regarding it, and this is a label, means the answer. So this is the conversational format. Now, just look into the another data set. So the data set name is Lava instruction. So what we have an image path. We don't have an image, guys. So we just have an image path. So separately, we'll have to download the image data. It is a Coco data set. So we'll have to download that data set folder. And accordingly, we'll have to load the images from there. Okay, and see, this is a conversational about the images. Right. So again, this is a conversational data, the question answering data, which we can keep in this format. So we have two ways. One, we can keep the image like this, okay, or we can keep the path of the images so that we can read the images from the source, okay, from the given source over here. Then guys, over here you can see we have one more type of data set. So images is there, then we have a text. Okay, means either we can keep the text, we can keep the caption, whatever we can keep. So this is just one more column. So image is there and then text is there. Okay, this is the image captioning. Then here you can see one more format. So image is there, then caption is there. Okay, so image, and regarding the image we have a caption or the text, or either you can say the description, anything you can say. So the different data set, guys, you can see over here as I shown you. So either we can keep the image in the column or we can keep the path. So just keep all this thing in my mind. I created my own custom data set so that if you have own custom data, like how you can train your model on top of that data. So see, this is my own data, guys. I had some images of the iPhone. Let me show you in the local itself. So this is the iPhone images, guys. Sorry, this is the images I kept outside of the folder. Let me keep it over here. So this is the iPhone images. Let me open the image. See, this is the image. So using this image only, I created some data. I'll show you how to create it. I have a script, the complete script of it. So this is the first image, then second image, third image. In total, I just have 5 images. I kept the 5 images. Okay, you can keep as many as images. So I had this data and I thought, okay, let's create our data set, my custom data set using this images only. So this is the one data, see, along with the images, and then see this is the another data with the path only. Okay, now over here, if you will see with this data, so I have an image and the caption regarding that, and even I can keep this message column. So I can utilize my data in this way. I can use the image and the text out of this data set, or else what I can do, I can use this image and this messages, or I can use the uh, all this three column all together just to train my model. I hope you are getting my point. Now just see over here inside this data. See, I created this particular data set. So over here you can see we have an image path. We don't have an image. I didn't keep the image inside the column. I just kept the path of it, and over here you can see the text regarding this particular images, and this is the message, the complete conversation. Now guys, if we are going to be use this particular data set, means this particular format, then I will have to keep one iPhone image folder in my local. From there only we'll have to read this particular images. Getting my point? So whenever someone is giving you this kind of data set, then it will provide you the data folder also, or it will provide you the data folder location also. Okay, data folder also, or the data folder location also. Inside the data folder, you would be having the images, those specific images. I hope guys the data format is clear. What kind of data format should be there if you are going to be train your model on top of the images. Here I kept each and every example. Now guys, after that, let's come to the final topic. So what is the differences between the normal fine tuning, means the text fine tuning, and the multi-modal LLM fine tuning? So guys, here I kept all the differences. Let's read all the differences one by one. So one input type will be the text only. Here input type could be anything along with the text. Architecture LLM only, mean the decoder part of the LLM. Here encoder projection LLM, and whatever another thing. This is just a general. This is the term basically I capped behalf on the image to text only. But if you are going to work with image to text to image, audio to text to audio, so this term could be the different one. Okay, so according to that you will have to keep the term over here. Then computation guys, medium to high, or GPU needed, moderate GPU, maybe high GPU. But here guys, if we are going to be process this image, audio, video, so yeah, we require the higher VRAM and the high-end GPU. Complexity will be the medium one. Here would be the higher one. Processing, tokenization, here media processing, means images, audio, video, right? Whatever other type of data we have, we'll have to process that. Now it is more stable, and it is little sensitive because we have a different modality. So if we are going to be fine tune our model just over the text guys, so it is like little easier compared to the multimodal. Over the multimodal guys, on the other hand, in the multimodal guys, we have a little more complexity. So I hope guys, you understood everything, every sort of a term whatever I have mentioned over here. Now finally let's look into the practical. After that I'll end this video. So guys, this entire practical will perform over the collab. You can do it anywhere or wherever you have access of the GPU. Now see guys, first of all you need to select the GPU. Just click on this runtime and then change the runtime type and then select the free available GPU. Just save it guys. After that, connect with your GPU. Now these all are the model. Here you can see I kept the name of all the multi-model. Just read out the name. So this all are the multi-model actually, from the Quen, okay, then from the Llama, from the Gemma, from the Mistral, and from the Lava. This Lava actually it is from the Microsoft. So guys, this is all the multi-model we are going to fine tune, means we can pick up any multi-model from here and we can fine tune it. So I written a name over here. So what I did guys, I created one model registry using this model, means I can pick up any sort of a model from this model registry and I can perform the fine tuning. Okay. And then guys, data set wise also, see this is my registry, so I can keep, I can like read any sort of a data set from here and I can perform the fine tuning. See, I kept my own custom data set. Okay, so that's why guys, I kept the name of this video fine tune any multimodal. The title is going to be justify over here. So let me again give you the quick recap. So this is all the model, guys, which we can fine tune. You can create a model, you can keep it inside the model registry, and whichever model you want to fine tune, you can do that. Now here, guys, first of all, you will have to install some packages. So first is a transformer, second is the TRL, then third is a Unsloth, then fourth is a sentence piece protobuf, and the other required packages. If you want to know about these packages, you can go and check out with my Hugging Face crash course. There I discuss the complete Hugging Face ecosystem along with this packages also. Now, guys, why we are installing this Hugging Face packages? Because see, this Unsloth actually it is created on top of the Hugging Face only, and it is a certain level it is a certain level of optimization over the Hugging Face. So if you want to understand this Unsloth, right? Then please go and check with my video. It is already available inside the playlist. So just go and check with the video number 19. Okay, so here I discuss the complete Unsloth. Now, what I'm doing, I'm going to be install all these packages. It will take some time, maybe 2 to 3 minutes. So let it install. Now, guys, you can see my all the packages are installed. Now, after that, what I'll do, I'll import these packages. See, I capped the data link also. So whatever data I have shown you over here, all this data set, I capped the link inside my collab. So you can go through with this link. Now, what I'm doing, I'm going to be import the packages. So first is Unsloth, second is OS, Torch, then data class, then dict. Then the other packages like load dataset, text streamer, fast vision model. Fast vision model, this is the class inside the Unsloth for loading the vision based model. That's Unsloth vision data collector. Okay, then SFT trainer is the SFT config. So apart from this, here is my model registry. It is nothing. It is just a simple dictionary where I'm keeping the model name along with the key. So whatever model I wanted to use, I will just pass the key name and I can access that specific model. Similar to this, I created data registry. So whatever model I wanted to, whatever data set I wanted to use, I'm just passing a name and which part of the data I wanted to use. So I wanted to use the train part, train data set, and I am passing the image key. Okay, so it is a column actually where the image is going to be kept. So image I am passing and the text related to that image, the text I am passing. Okay, either it could be text, caption, or that conversation. I shown you each and every format. I think now you are familiar. So likewise, what you can do, you can prepare your data set registry. Okay. Now what I'm doing, see, first I'm going to be import this thing. So let it import. If it is asking you to restart your kernel, then restart your kernel and then import it. And guys, please keep this Unsloth at the first place, otherwise you might get error. Guys, you can see we are able to import all the statements successfully. Now what I'll do, guys, I'll create one class. So I created one class. The class name is the vision fine tuning config. It is a data class where I define my all the required variable. So whatever variable I wanted to use, I have defined over here inside this config class. So let me give you the quick walkthrough of it. So first is a model key, then dataset key. So by default, I kept one model key here and the dataset key. Whatever I wanted to use, I can pass it. Okay, I can pass to this vision config class. I'll pass. I'll show you how to do that. Then guys, subset how many rows I want from the data, because data is very huge. Okay, I cannot use the complete data set over here to train my model if I'm going to be use any Hugging Face data, because there we have like maybe 10,000 to 1 lakh rows. Okay, so I'm just using the subset just to demonstrate you. Then evaluation ratio. So this is the evaluation ratio, means 10% data, 0.1 means 10% data I will use for the evaluation. Then seed means again it is for the reproducibility. So if I'm running again and again, then a random sample should not come. Okay, the data set should be the same. Then guys, this is the LoRa configuration. So R means rank of the LoRa. Okay, LoRa alpha and LoRa dropout. This is again two more variable to regularize the LoRa. Okay, low rank adaptation, and don't worry, I'll explain this LoRa concept in very detail in my upcoming video. I already planned that. Then guys, we have a training. So for the training, guys, see per device trained batch size. So just read it from back only. So size batch, okay, batch size, training batch size, device, okay, per device. On per GPU, how many like in how many batches the data should go. Okay. Now gradient accumulation step. Gradient accumulation means in how many step we are going to be change the value of the gradient. Okay, the weight actually. Gradient accumulation. So let's say we have run for the first step, second step, third step, fourth step. We are not changing up to four step. In four step, cumulatively, which will change the value of the weight. Okay. So this is just to reduce some overfitting and all. This one. Then number of epochs, for how many epochs you are running, learning rate. Okay, again very important part. Logging step, at every 10 step we are going to be log the value. Weight decay. Okay, max length of the generated output. So all this value, guys, it is related to the training. So the SFT configuration. I'll explain you all this thing. I will explain you in the near future also, guys, because I know it is a pain point that we don't know like most of the parameter which we are using while we are fine tuning the model. So I have this thing in my mind, and definitely in my future classes I'll discuss onto it. Okay, now coming to the next part. So here is the output directory and the save directory. So I'll keep my every checkpoint over here, and my final output will be over here. So what I'll do, guys, I'll create a class, I'll run it, and I have loaded this class. Okay. Then, guys, if you want to check the data, like how the data looks like, so I can show you using one data only. So here I'm loading this chat QA data, and mainly I wanted to show you the chat, this image column. Okay. So after loading the data, see the data is getting loaded. I can print this data set. So let me print this data, and then what I can show you, I can show you the first. Okay, so here I can split it. Did I split over here? No, I think I can split it like this. Just a second. This is a data set, guys. So what we have a train data set, validation data set, and the test data set. So again, let me load it with the train split. Means I will just get the train data set. Okay. So yeah, I got the train data set. Now let me show you the first row of the train data set. See, this is the first row. We have an image, and it is a PIL image. Okay, this is the configuration of the image. So we can, so you will be having the image in this particular format in the column. Got it? I hope this is clear. Now this is the main class, the trainer class. Just focus on to this class. This is going to be very important. So the class name is the vision fine tuner. So first what we are doing, we are loading the model, then we are preparing the data set. After that we are building a trainer. Okay, and then we are going to be train the model, and then finally we are going to be save the model. And if you want to do the quick inferencing, so yeah, for that also we have a method over here. So this is the complete class. This is the complete class, guys. You can directly take this class, you can keep as it is inside any sort of a code. Now let me execute it. Yes, it is going to be execute. Now what I'll do, guys, first I'll run. Okay, first I'll create a configuration. See what I'm doing, I'm going to be call this vision FT configuration class. I'm passing my model key. So I define one by default model key, or else those are the default one. If I wanted to override that, I can pass the value from here. So I'm doing, guys, this is my vision configuration class. Let me show you where it is. So here is a class, this one, this I define, this one, vision configuration. So I can pass any sort of a value, whatever I want to define from my end, whatever I want to take from the user. Okay. So what I'm doing, I'm just passing my model name over here, and the data set. You can pass anything, guys, model key and a data set key. You know, we have defined one model registry. So let me show you that model registry. I'm writing over here model underscore registry, or let me take the variable from here itself, from the sale only. So this is my model registry, it is in a capital. So if I'm going to be printed over here, let me print over here, and you will see that what are models we have. See, these all are the model. So whatever model you want to fine tune, you can simply fine tune over here. Okay, just pass the just pass the model key, and the respective model will be loaded. So now what I'm doing, guys, I'm going to be configure the vision. I'm going to be configure the values, okay, through this class, through this data class. Now what I will do, guys, I'm going to be create an object of this vision fine tuner class. Okay, I'm passing this configuration. Then guys, what I'll do, I'll call the load, prepare data set, and build trainer. Right, so my object will be ready over here. So my trainer object is ready. I will come to this part. I'll explain you each and everything what is happening. Then what I'll do, guys, I will train the model. See, my model will be trained over here. Then I will save the model. My model will be saved, okay, using this train.save. And then I will perform the inferencing. So I can pass the question, any question related to the trained data, okay, and then I can test my model. So let it complete until I can give you the quick walkthrough of this vision fine-tuned class one more time, and then we'll come to the final result, guys. So if you will look into this vision fine-tuned class, so what we have over here, first we have this configuration. So we are passing a configuration, okay. The type of the configuration is going to be the data class, right? So I'll get a complete configuration. From here we can access any sort of a value. Then guys, we are going to be load the model, we are going to be load the data. We have this three things. Now what I am doing, so here guys, we are going to be load a model. So using this fast vision model from pre-trained, we are passing a model name, we are passing load in 4-bit true, and then use gradient checkpoint Unsloth. So we are loading model and checkpoint, okay. Then we are getting a PEFT model over here. See, we are passing all this parameter to get a PEFT model, parameter efficient model. Then I'll be getting a model inside this particular variable self.model, okay. Now I got the model, I got the self.model. Now what we are doing, we are going to prepare the data set. So we are loading a data set, okay. And here I have a data set, like how many rows we want from the data, means the subset of the data. Then here is my instruction which I define inside the data registry. Then image key, the image we are getting from the data, and then text key. Now guys, if you have a path of the image, see here I shown you the image path, right? This one. If you have an image path, then you will have to keep the respective folder onto your, if you will have to keep the respective folder over here, over your server, okay, over your whatever directory you wanted to keep. You will keep you will keep a respective folder, and from there only you are going to read the images, okay. Then here I'm going to format the data set. So see, here is my user, the instruction will come, the image will come over here, right? This one. Then assistant, okay, this is the assistant, right? So user is giving this instruction along with this images, and then the assistant means the the model should reply this one. So this is my complete format of the data. Now I'm going to be mapped with my data, okay, and here I will be getting my split, means how much for the evaluation and how much for the training, okay. And then we are going to be return. Now this is my trainer. So what we are doing, guys, we are going to be define the SFT config. This is my SFT trainer, okay. And what I'll do, guys, I'll train, okay. I'll call this trainer.train, right? So self.trainer.train. Once I'll call this train method on top of this trainer, on top of this SFT trainer, my model training will be started. And then guys, we are going to be save it, and here we are going to perform the inferencing. So how we can perform the inferencing, guys? So for that, we are having an image, okay. We are passing this particular message along with the images, okay. We are passing images along with the instruction, and my model will be generated the output. So this is the complete code for what, for the inferencing. You can go through with it. See, here we are going to be passed, here we are going to be create a message which will be passed to the tokenizer. This tokens will be passed to the models, and finally we are going to be generate an output, and then we are going to be decode that output. That's it, guys. Now what we have, see, my data have been there. See, load model is loaded, data had been prepared, and my builder is ready. Now what I'll do, guys, I'll call this trainer.train, and my model training will be started over here. Once the model will be trained, guys, I'll save that model. I'll save wherever I can save. I can save it over the Hugging Face, I can save over here, okay. Or else basically I can save it on any cloud wherever I want. So yeah, the training is started. It will take some time. To Epoch, maybe it will take 5 to 10 minutes. So let it train. Okay, guys, so my training is completed. It took around 7 minutes. And see over here, I have run my 2 epochs, okay, all the 2 epochs. Now this is what, this is the step. At every 10 step we are going to be log the information. So yeah, I log this 3 steps over here in my data set. Basically according to my data set, the information is shown over here, okay. Now what I'm doing, I'm going to be save the model. Once I'll call it, so my model will be available over here. See, this is the VLM LoRA output. So we got our model. My saved tensor file is available over here. It's a binary file. Now, if I wanted to do the quick inference, so I can run this one. So automatically the code will be executed, and whatever image and the caption I'm giving, according to that, the answer will be generated, okay, over the fine-tuned model. So I'm loading the fine-tuned model over here. Again, let me give you the quick walkthrough, and then I'll show you the output. So what is happening, guys? So over here, see, for inference, the model will be loaded. This is the fine-tuned model. Then the data set will be loaded. Okay, so load data set info, name and split, right? So I got the raw data set. Now over here, what I'll do, so I will pass the sample index, the data set information, and from there I will take an image. Now I'm passing the image along with the instruction. So this is my complete message. I'm tokenizing that. I'm converting the input text. Then I'm passing this complete input to my model. Okay, and the model will generate the response. So let's see what response is being generated over here. So see guys, whatever image I'm passing, according to that, I'm getting a response. Now I can format this particular information actually on which data set I trained my model. Let me show you. It is a latex OCR data set. So this is a data set, guys. This one. Here we have a formulas. So this is the text. Okay. This is the images and this is the corresponding text. So we have trained our model on top of this particular images, right? So if we are passing this image, so it will extract the formula out of this images and it will provide to us, and we can format that later on in this same manner. I hope guys you understood this entire thing, entire tutorial. Now one more thing, let me highlight over here. If you want to prepare your own custom data, then you can do using this particular script. So you can keep the images inside the folder. You can give the respective caption. Okay, and after that, guys, you can execute this. You can execute this cell where the conversational format, the description of the data set will be created. If you want to keep the images, okay, uh, if you want to keep the images, then you can run this particular line, right? This particular line uh, feature. You can create a feature object where you can pass the image, text, and the message, and see. You just need to run this one. If you don't want to keep the images, you just want to keep the simple path, then uncomment this line and run it. So you will get a data in this particular format. Let me show you in this way. Okay, you will be getting the path. If you want to keep the images, then you will have to run it in another way. Okay, this one. Then guys, run it and push it. For that, guys, you will have to generate the right API key from the Hugging Face, and you can push your data to the Hugging Face itself directly. So a simple code, I will give you this code so that you can execute it from your end, and you can create your own custom data, and you can keep it anywhere, guys. Yeah, so this is it for this particular video, guys. I hope you liked it. This kind of content takes very much effort, guys. I was preparing it from last 1 week itself. So if you like it, then please hit the like button, please subscribe the channel, and please support this channel so that other person also can learn the AI, and then they can trust on my content. Thank you guys, thank you very much. I'll see you in the next video. The topic name is embedding and the embedding fine tuning. So this video I divide into the six chapter. Now guys, what I'm thinking, actually this sixth chapter, see, if I'm going to take all this chapter right inside a single video, it will be around 2 hours of video. So first three chapter I will cover in this video, and rest three chapter I'll be cover in the next video. Okay, subsequently I will upload one more video right after this one. There I'll discuss chapter 4, 5, and 6. So let me give you the quick highlight that what all thing we have over here. In the first chapter, we're going to discuss about the embedding. What is the embedding? Then we'll understand the very important concept about the embedding, that is called the semantic search. We'll understand the differences between the keyword search and the semantic search. Then we'll see the differences between the encoding and the embedding, and then we'll see the application of the embedding. So here we are going to cover all the fundamental fundamental about the embedding. Okay. Now after that, guys, we'll come to the chapter 2. So here we'll do some model level analysis. So what is the model level analysis? So we'll see guys what all models are there, what all models are there for the embedding. We'll see the type of the embedding model, we'll see how to select a best embedding model, and we'll see embedding models leaderboard. Okay, so you will understand that what all models we have and which model needs to be used. Then guys, in the chapter 3 we'll come onto the model architecture. Okay, and we'll see on which data set this embedding model have been trained. So here guys, we'll discuss on a architecture level. So we'll see this embedding model. It is similar to the GPT-5, GPT, or the Gemini, or the Llama, or the Mistral. The architecture is similar to this model, or it is a different one. Okay. Then we'll see on which data set this embedding model have been trained. Now, after completing all these three chapter, all our fundamentals regarding the embedding is going to be clarified. Now, after that, guys, in the chapter 4, we'll discuss what is the embedding fine tuning. why and when we should do the embedding fine tuning. So all these things we are going to discuss inside the chapter 4. Then inside the chapter 5 we'll see dataset format for the embedding fine tuning, and we'll fine tune one embedding model on our own custom data. So the scenario is going to be like this, means you have to create one rack system. Inside the rack system you use the embedding model. Now let's suppose this embedding model actually it is not performing well on your own data set, on your own custom data set. Okay, so what I'll do, guys, so we'll fine tune this embedding model on over the custom data set, over your own data set, and then we'll try to utilize it inside the rack pipeline. Okay, so this is going to be a complete scenario, guys, and definitely we'll try to implement that. Now we'll see embedding fine tuning versus LLM fine tuning. So I will close this video. I will close this chapter, okay, with these differences, so that you will get to know each and everything about the embedding and the LLM fine tuning. Now let me show you the practical also. So this is the complete practical, guys, where we're going to discuss about the embedding. See, I'll show you the embedding. We'll discuss about the semantic search. After that, I will discuss about the keyword search versus vector search. Then we'll see how basically we can evaluate the embedding model. After that, guys, after seeing the embedding model, the evaluation, and all everything, not only the one, guys, I have capped the different models, guys. I'll show you the MTEB, okay, MTEB leaderboard, and even I will show you the sentence transformer repository. Then, guys, after that, I'll come to the training part. So we'll train our own model, okay. We'll train a model over our own custom data, and yes, that particular model we are going to be utilized in our rack pipeline or anywhere else where we can use this embedding model. So I hope, guys, you like this entire thing. Now one by one, step by step, let's start. So, guys, let's understand what is an embedding. So, here I kept a multiple definition to understand about the embedding. Let's read it one by one, and let's understand about the embedding. So, the first definition is embedding is a mathematical representation of the data. Okay. Or we can say embedding is a way to convert text, images, audio, video into the meaningful number. This is very much important, guys. If I'm saying meaningful, guys, so meaningful is also called the contextual number. Okay, contextual number. So either you can say meaningful or you can say contextual, right? If I'm saying data, guys, so this data could be anything. Data, it could be text, it could be images, it could be audio or the video data, right? So any kind of data actually we can convert it to the embedding. Now, guys, this definition actually it is more technical. So let's understand about it. So embedding is a dense, high dimensional numerical vector that represents semantic meaning of the data. Okay. Dense means what? What's the meaning of dense? Dense is also called non-sparse. Non-sparse means non-zero. Got it? So whatever vectors is being created using the embedding model, so there you will not be able to find out much zero. Okay, so there will not be having much zeros inside the generated vector, so those are called the non-sparse. Second is called the high dimension. So 384, 768, 1024, 1536, 24, 2048, and nowadays even we have bigger dimension. So what is the meaning of the dimension, guys? So let's understand with this example. So let's suppose we have the sentence, the capital of the France is a Paris. So how many numbers we have? We have 1, 2, 3, 4, 5, 6, 7. So what's the size of this vector? The size of the vector is 1 cross 7. So 1 is representing a row. This is a row. Okay. And this 7 actually is representing to a column. Right. Now this 7 actually it is a dimension. So this columns actually, this columns, columns, right? This columns is nothing, it is a dimension, and this is also called feature of the data. Yes, this is true. So whatever number you are seeing over here, it is representing to a individual feature of the data. So in this vector, how many features we have? So in this vector, we have 7 features. We have 7 columns. Okay. So we have 7 features. We have 7 column, or we can say we have 7 dimension. So in reality, guys, you will not be able to see this much of a small vector. So in the vector, at least we would be having 384 dimension, and it can goes up to 2 to 3,000 as well. Now, I hope you understood the definition of the embedding, what it is. Now, let's understand what is a semantic search. So, guys, semantic search actually it is a very important application of the embedding, right? So, let's discuss about this topic. Let's say we have a sentence, and my sentence is my name is Sunny. So, this is my sentence, and now I converted this particular sentence into the embedding. Okay, now one more line, guys. I think I missed that line. Let's try to read that line. So here I written vectors. So what is a vector? So vector is nothing, it is a mathematical object in a linear algebra. In programming, we represent this vector, or we store this vector as an array. Okay, so if I'm saying embedding, if I'm saying vector, if I'm saying array, right? So everything is same, guys. So it is just representing a numbers. What it is representing, it is just representing a numbers. In linear algebra, as a mathematics, guys, in mathematics actually, this vector is having some extended terms and the terminology, like direction, magnitude and all. So as of now, I'm not going to discuss that part. I will discuss in some other video. Okay, but guys, if I'm saying vector, if I'm saying embedding, if I'm saying arrays, right? So all are representing to our numbers. Okay, in those numbers we are representing to our data. Got it? So here you can see, let's say we have a sentence. The sentence is my name is Sunny, and here I'm going to be represent this sentence with this embedding. Now, guys, what I will do with this embedding? Now, what could be the application of it? So the application of this embedding, what I'll do, guys, I'll perform the semantic. Okay, I will perform the semantic search. Now, this semantic search is also called, what it is called, guys? It is also called similarity search. Okay, so either you can say semantic search or you can say similarity search. Both is same. Now, what is the meaning of it? I'll come to the definition. I written everything, but let's understand the meaning of it. So semantic search means whatever embedding actually we are going to be create, right? So it is having some contextual meaning, right? So it is having some semantic meaning. Either you can say contextual meaning or you can say semantic meaning, right? Now, guys, behalf on this embedding, actually we can search a similar embedding, right? We can search a similar embedding. So that's the application, that's the application of the embedding, and that's a meaning of the semantic search. What is a semantic search, guys? Semantic search means this embedding, actually this embedding is, it is having some contextual meaning, it is having some semantic meaning. Now, behalf on this embedding, actually, I can search the similar embedding, right? So that is only called the semantic search, or else it is called the similarity search. I hope this thing is clear. So, guys, if I can say behalf on this embedding, right? So not only the text, we can even search the image. Okay, image to image, or we can search text to image, right? We can search any sort of a document. There are lots of things which we can do using this semantic search, and it is a very powerful concept in the natural language processing, guys. Okay, so I written each and every definition, each and everything over here, even along with the example. Let's understand. So what is a semantic search, guys? Semantic search, meaning-based intelligence search using embedding. So the same thing I was trying to explain you, and I written the same thing over here. Now, guys, here you can see semantic search means searching based on the meaning, not based on the exact word. So whenever we talk about the sentence, okay, now this sentence is also called the document. So in NLP, guys, this sentence is also called the document. Now we have sentence one. and let's say we have sentence 2, right? Now if we are checking the meaning, right? If we are finding out a similarity between these two sentences, we are not just following a words. No. Okay, we are checking the exact meaning, and how we are able to capture this particular meaning. We are able to capture this particular meaning using the embedding model, because the dimension which we have inside the embedding model, the dimension which we have inside the embedding model, those are nothing, those are some features. Okay, it is representing to the features. I hope you understood everything now. Now how we are doing that semantic search on similarity search? So we are doing it using the cosine similarity, using the dot product, Euclidean distance. So these are some important matrices, guys, right? So if you are into the NLP or into the Gen AI, right? So you have to start your encoding and embedding journey, and there you need to understand about all these matrices. This is very much important. Now let's see some example. I kept some example for all of you. So just look into this first example, guys. Okay, so this is important. This first example, let me highlight this one. Okay, then guys, I kept one more example over here. This is one more example, and here I have some points related to this example. Okay, so you have to focus on these points as well. Now these point, the next point, actually it is related to the next example, the different example. So read it out. Let's read it out, this point one by one. So what I'm saying eating fiber reduce heart risk. Okay, this is the first thing. Or I'm saying eating fruits and vegetable lower cardiovascular disease. Okay. Now here I have written both sentence have a same meaning. This is true. Even though the words are different, but embedding will place them in a closer vector space. That's why semantic search return a relevant result, even though we don't have a same wording, even though the words are different inside the sentence. Okay, so I hope you understood what I'm trying to say. I'm trying to say, see, this sentence actually is something else, means the words are something else, and this sentence is something else, means the words is not matching completely. But still, guys, if we are going to be find out a similarity between these two sentences, it would be very high, because the contextual meaning of this sentence is same. Okay, I will show you in some time. So this is the first example. Now just look at the second example. The second example is eating fiber reduce the heart risk. Okay, this is the first sentence. And the second sentence is buying a new car improve driving comfort. Now guys, just think the sentence one. Okay, this is my sentence one. And here is what, guys, this is my sentence two. Now these are the complete different topic, health versus automobile. And here embedding will be apart to each other, and we will be having very low cosine similarity. So what I wanted to say over here, I wanted to say this two sentence actually it is not having any semantic meaning. Okay, we don't have any similarity between these two sentences. So our similarity score, our cosine score, our dot product score is going to be very very low. I hope you understood, right? So this is the meaning of the semantic search. I hope you understood with this example. And don't worry, guys, I'll give you this notes. You can go through with these notes, and even you can do some self study using these notes. Now coming to the next part. So here, guys, I written keyword versus semantic search, right? So let's understand what is the differences between. So just read out this particular definition. This is like very much important. So keyword search means it matches the words. So whatever sentences we have, so inside those sentences, whatever words we have, it is just going to be match those words. On the other hand, this semantic search is going to be match the meaning actually using this cosine, Euclidean, or the dot product. We have some other matrices also like Zakat similarity and the different other matrices. Okay, we can use those as well. But these three, cosine, Euclidean distance, and the dot product, are very important and the useful. Now, guys, here I given you one example. So let's understand with this example. Okay, what is a keyword search? This example actually is going to be very important, guys. Just focus over here onto this part right now. So what I written how keyword search works. If you search okay, if you search how to reduce heart risk, the system will mainly look for the sentence which is containing these words, reduce heart and risk. If the sentence is going to be contained ways of lower cardiovascular disease chances, right? So even though this sentence, okay, this two sentence, this first one and the second one is having a same meaning, but again with the traditional keyword search, it's not going to be matched because reduce is not equal to lower and heart risk is not equal to cardiovascular disease. Okay, even though it is having a same meaning, but again this sentence will fall apart to each other. I hope you understood what I'm trying to say. So if you want to understand this example, just read it out this sentence first. See, this is the first sentence. Okay, how to reduce a heart risk, and then this is the second sentence. The second sentence is way to lower a cardiovascular chances. Right. So in both sentences, I'm trying to ask a same thing. I'm trying to ask a same thing. But again, guys, uh, the keyword search, the keyword search is saying reduce is not equal to lower and heart risk is not similar to this cardiovascular disease. So this keyword is not going to be matched. So this both sentences will not show any sort of a similarity, and that's a disadvantage of the keyword search, where we are not going to be where we are not going to be basically focus on the context, okay, the meaningful context, the semantic meaning of the sentence. We are just looking into the words. Now here I kept one more example, guys. Just see over here how to lose weight fast, and sentence 2 is saying quick fat loss strategy. Now using the keyword search, it is a weak match, but using the semantic search, the embedding, after generating embedding, the semantic search, the similarity search we are going to be performed, right? So there it will show the strong match. I hope this thing is also clear. Now, guys, let's come to the third topic. So, encoding versus embedding. Now, again, I'm not going into the deep, but yeah, I will give you the quick recap of this topic, the encoding topic. Because once you will start with the embedding journey, right? So, at the first place, you will always learn about the encoding. And definitely, once I'll start my NLP playlist in the near future, so I'll come to this encoding part, encoding chapter. So, what is this encoding, guys? So, encoding, it convert data into the numerical format, okay, so that machine can process. Now this encoding actually, it is a count based and it is a matrix factorization based. Now these are some method, one hot encoding, BOW, which is called bag of words, TF-IDF, VM25 and glob. So BM25 is nothing, it's an extended version of the TF-IDF, okay. And globe actually, it is nothing, it is a matrix factorization based technique, this one. Now this one hot encoding, BOW and TF-IDF, actually it is a count based technique, okay. Now here guys, I capped the one hot encoding. Now let's take a recap. How let's look let's take the overview, how does it work. I'm not going into the depth of it, but yeah, I can give you some understanding. So this is called one hot encoding. Now, if I want to see, this is my category, red, blue, green. Okay. Now, if I want to convert into the one hot encoded vector, so how I will do that? First, I'll create a column. Okay. So this is my three category. Now what I'll do, guys, in whatever row this category is present, I will write one, and to rest of the like column, I will give zero. So in the first row, if you will see the first row, guys, so we have a red, right? So red is going to be one and rest color is going to be zero. In the second row, blue will be one and rest of the thing is going to be zero. In the green one, this two is going to be zero, one would be for the green, and blue, this is going to be a zero and blue will be one. So this is called one hot encoded vector, and this is a sparse vector. Okay, sparse vector means, so this vector actually, this array, this vector is going to be contained a lots of zero. We have lots of zeros over here, right? So this is called the one hot encoding, guys. Now let's understand about the bag of words. Now, guys, how this bag of words works. So what we do, guys, see, let's understand. We have a document. See, this is my first document. Okay. Now, this is my document, guys. This one, right? What we do, guys, using this document, first we create, if I'm saying document is nothing, it is a sentence. In NLP, actually, this document is also called the sentence. Okay, sorry, sentence is also called the document. Now, let's say we have two document. What I'll do, guys, so I will create a vocabulary. Okay, I will create a vocabulary using this document. Now, this vocabulary is nothing, it is a unique words. Okay, unique words. So these are the vocabulary, this one: child, dog, happy, makes, the. Okay, now how many times these are coming? So here you can see child, dog, happy, makes, the. So in first sentence in document one, how many times these are coming, right? So child is coming one time, dog is coming one time, happy is coming one time, make is coming one time, the is coming two time, right? So this is my vector. That's it, guys. Right, now just look into this document too. So child is coming one time, dog is coming one time, happy is coming one time, make is coming one time, the is coming two times. Just read out this sentence, automatically you will get it. Okay, automatically you will get it. So this is my vector. Now here, guys, this bag of words is nothing, it is just a count based technique. Okay, now how it is working, so sorry, how we are going to be form this vector. So first, we'll look into the document. Okay, document means sentence, the entire data. From this we'll form the vocabulary. Vocabulary is nothing, it is a unique words. So these are my vocabulary, which I am representing as a features over here. This one, this I am representing as a column, which is a feature, right? And then I'm just checking a count inside the particular sentence regarding these words. Okay, and then the final vector we are showing as a encoded vector, right? So I hope, guys, you understood about the one-hot encoding and the bag of words. Now this is the formula of the TF-IDF. Again, I'm showing. Again, I'm telling you, guys. This thing I will cover in some another session where I'll discuss the fundamental of the NLP. As of now, I'm just showing you the formula. See, this is the formula of the TF-IDF, where TF is called the term frequency. What is the term frequency? Number of time the term appears in the document. The term is called the words. Okay, that is specific word, the vocab. Okay, the unique word, the total number of terms. Okay, the number of all the unique words. Then inverse document frequency means total number of document in the given corpus, means total number of sentence, and 1 plus number of document containing the terms. Okay, how many, like, number of document containing that specific term. Regarding that, we are going to be calculate the frequency. Okay, now here we are adding 1. Why? Because if the term is 0, so it will not go to the infinite, and here we are taking a log of it. Okay, so this is a TF IDF, and once we are going to be multiply this term, okay, TF and IDF, so whatever number I will get regarding that vocab, okay, for the given sentence, that number, okay, those series of number I will be representing as a encoded vector, right? So I will show you in my NLP playlist. I will give you the complete intuition of this TF idea, but as of now, just remember this formula. Now this is all the encoding technique. Now let's look into the embedding, guys. So I think we all know about the embedding. So let's take a look one more time, and after that, guys, I'll come to some more important concept. So embedding means convert data into the vector representation. Now here, embedding of the king. Okay, embedding of the queen. So just think, guys, if we have an embedding of this king and queen, right? So let's say I can represent in a 2D, uh, like, 2D graph. So let's say we have x and y axis. Now this is the embedding of the king, and this is the embedding of the queen, right? So this will be having some similarity. King and queen is having some similarity, not based on the gender, guys. I'm saying based on their title, they have some similarity. Okay, so the cosine similarity will be very high, and the angle, the cosine angle, will be very less if we are going to be showcased over the x and y axis, this vectors, right? And if we are talking about this king and banana, so the angle will be very, very different. Let's say this is my king. Okay, king. Now this is the queen. Okay, now here would be my banana. Let's suppose this one. This is what? This is my banana. So the differences between this the angle between this king and banana will be very, very huge, because there is no such similarity between the king and banana. Banana is a fruit, king is a living person. Okay. I hope you understood what I'm trying to say. So what is a classical method to find out this embedding? So word to back, actually it was a method. Fast text is a method, right? So this method, actually it was working over the neural network based strategy. Got it, guys? So word to back and fast text was working on top of that strategy. Now, this method were having some limitations. What were the limitations, guys? So limitation wise, they create embedding at the word level only. Okay, they create the embedding on the word level. Means we are giving a sentence. Let's say if I'm saying over here, Sunny is a AI engineer, right? AI engineer. So if I want to convert this sentence into the embedding, I will not be able to create it using this word to back and the fast text. It was not possible. Okay, because it was only working on a word level. They produce static embedding. Now, what is a static embedding? I'll come to that. I'll explain you that. They do not understand the context. Okay, so they produce the static embedding and they do not understand the context. This is very much important, guys, and because of that only this embedding was going to be failed. Okay, we cannot use it further. uh, Instead of the sentence embedding, the sentence transform based embedding, these are quite powerful, a contextual one. But this word embedding, word to back, we cannot use everywhere because of these limitations, right? So how this embedding looks like? So here I given one image. You can simply look into this image and you can understand the embedding of the man, the woman, king, and the queen, right? So these are some embedding. Now this also having some dimension. Now these dimensions are nothing. It is a like features, actually. Okay, so in the real embedding, we would be having like 300 to 400 feature at minimum. This is just a demonstration. Okay, the dummy one which I kept over here. Now over here, guys, let's understand with the example. Let's understand why what is the meaning of the static embedding and why this word to bag model was not having the context. So let's understand about the SOTA transformer first, then I'll come to the comparison. So SOTA means what? State of art. So state of art transformer based embedding model. So it is based on the transformer architecture, guys. The earlier word to bag model, okay, the earlier word to back model or the fast text model, actually it was only based on the neural network. But guys, this SOTA transform based model, right, the embedding model, actually it is based on the transformer architecture. I'll come to that architecture. I'll discuss a few points regarding that. Okay, how the embedding is being generated, everything will try to understand. Now contextual embedding, context aware embedding. So it is going to be generate a contextual embedding, and any text means a word, phrase, sentence, full paragraph, anything is coming. Let's say I'm saying Sunny. Okay, I'm saying Sunny is a AI engineer, right? Now this word, this sentence, whatever paragraph we have, okay, whatever paragraph we have, or whatever kind of text we have, everything we can convert, everything we can convert into the embedding, right? This is a very important concept of the SOTA transformer. Now example, SOTA sentence transformer model, mini LM, BGE, OpenAI embedding, Gemini embedding, cloud embedding, these are the example, right? So these are the model example, and even I will show you the model in very detail in some time. Now here, guys, you can see I kept one example. With that, your understanding will be very clear about the static embedding. Okay, this one. So let's say I have one sentence. In the first sentence, I'm saying I sat on a river bank, right? I sat on a river bank. Now in the second sentence, what I'm saying I deposit my money in the bank. Now over here, guys, just think this bank, actually it's a river bank. Okay, this bank, actually it's a river bank, but this bank, actually it's a money bank. Okay, so here, guys, this bank is having a different meanings. This bank is having a different meaning in both the sentences. So if you are going to be capture the meaning of the bank using the word to back model, right? So it's going to be a same. Let's say I use the word to back model, I generated an embedding of this bank. So guys, this bank is going to be generate this embedding, right? Whether it is coming inside this sentence or it is coming inside this sentence doesn't matter. Bank will be always represented using this embedding, and that's a very concerning thing. Now, instead of that, if on the other hand, if we are using the SOTA transformer based model, so bank will be represented according to the context. So here bank is represented to the river bank, and here bank is representing to the money bank, right? So SOTA model will generate a different embedding. So that was a huge difference between this word to back model and the current SOTA model. I hope this thing is clear. Now, let's come to the next point, guys. Let's see. This embedding model actually it cannot only transfer, it cannot only convert text into the embedding, it can convert everything into the embedding. So here I kept a couple of examples. Let's say if you want to convert image into the embedding, so yes, you can do that. So image is what? Sorry, guys. I'm suffering like with little cough and cold. Like okay, so yeah. So yeah, now I think you got. So what is a image? So image is nothing. It is a collection of the pixel. Okay, so it is a collection of the pixel. See, this is the image of it. Now this we can further convert into the embedding. Okay, embedding means we can use this VIT kind of model, and we can get the vector representation. We can get the vector representation of the image, right? So here I written some name. So clip model, vision transform model are enough capable to convert any data into the images, and any image data into the embedding. And even I will show you in the future. Okay, even I uploaded one video in my rack playlist where I'm going to be convert this image into the embedding, and then I'm performing a retrieval on top of it. If you want to check, you can go over there. Now the other one, basically audio. Can we convert audio and the video also into the embedding? Yes, we can do it. Now let's try to focus over here. So we're talking about audio, guys. So we have two approaches over here. The first approach is this one, okay, and the second approach is this one. So let's look into the first approach. The first approach, what we are doing, we are going to be convert audio into the text, and that text we are going to be convert into the embedding, right? It is the same one, like we have any text embedding model, and we are going to be convert the text into the embedding. Okay, first we have generated text from the audio using the ASR model, automatic speech recognize speech to text model. Okay, now the second one, see, these are all the model. Even I listed the model over here. You can read it over here. We have OpenAI Whisper, we have Google Speech to Text, Meta MMS. These are some speech to text model. Now on the other hand, guys, what we can do, we can directly convert the audio into the uh, embedding. Okay, so here you can see what we have. We have a audio. We'll use the audio decode encoder model. Then we'll convert audio into the embedding, and then we'll store inside the vector database. Now this is the image, guys. This is the image of the audio. So yeah, we can do it. We can directly take the audio file, and we have such models where we can directly convert audio into the embedding. See, these are the model name. Just read the model name. One is the Google YAML, Google YAMNet. Then from the OpenAI CLAP. Then from the Meta Word to Bag. Okay, Wave to Bag actually. Now, where we use this audio embedding, so we use it inside the voice search, in the music similarity. So this could be some example. This could be some application actually of the audio embedding. So at this place we can use it. Okay. And now coming to the video part. So again, if we're talking about the video, so there also we have two methods. Let's focus on first one. So first, we are going to be convert video into the images, audio, and the time dimension. So audio we are going to be convert into the text embedding. Okay, frames means images, we are going to be converted in the image embedding, and then we have some metadata. Okay, so this is called the multi-vector, right? We are going to be we are going to be capture the multiple vectors, okay, and we'll store inside the vector database, and on top of it, whenever we'll perform the retrieval operation, so that is called the multi-vector retrieval. Okay, So now the second approach is we can directly take a video and we can convert into the embedding. So this thing is also possible. We have such model. So here you can see video MAE transformer, sorry, times former I3D. So these are some model using that we can directly convert our embedding. Okay, we can directly convert our video into the embedding. Now these are the use case, guys. So video search, content moderation, recommendation on YouTube, Netflix. So we use such things. I hope this is clear, the use case and all, everything is clear. So I believe, guys, this entire thing is clear. So we started from what is our embedding, and let me highlight what thing we have covered so far. What is our embedding, then semantic search, then keyword versus semantic search, then encoded versus embedding. Now let's discuss application of the embedding, guys. This is going to be very much important. So application of the embedding, I written so many points over there, and the last one is going to be very important. So please don't miss out that. So we're talking about the application of the embedding. So initially only I told you the semantic search is the most fundamental application. Okay. Now, what is a semantic search? It is a meaning-based search. Now, instead of matching keyword, we are going to be perform the vector similarity. So it's being used everywhere in the Google engine, inside the Google image search engine, inside the Google image search, in the Pinterest, right? So users search a red car, system retrieve image of red car. So yeah, we are doing that in a Pinterest, we are doing in a Google image search, and even we are writing those things over the Google directly, and we are getting those information. And how this is possible? This is possible because of this semantic search, guys, right? So because of the semantic search, this thing is possible. So this is the primary application of the embedding. Now in the recommendation system also, we use this semantic search, we use this similarity search, we use the embeddings, right? So in a Netflix, similar movie; in a Amazon, similar product; in a Spotify, similar song, all are using the vector similarity. So yeah, this is again a very huge application. Okay, application of the embedding. Now guys, coming to the next part. So here topic modeling means a clustering of the data, okay, based on the similarity. Group a similar document together, right? So we have document one, we have document two, okay, we have document two. We are going to be read a content of these document, and based on the similarity we are going to keep it together. If there is some there is some similarity between this document, then we are keeping it together. Okay, so that thing is also that thing is also possible using the uh, documentation together. Now the last and the last one is a very important, guys. This is the retrieval augment generation, and everyone wants to be know about this retrieval augment generation. Everyone knows about the embedding from this retrieval augment generation only. So let's understand what is this retrieval augment generation at the first place, then I will come to the embedding part. So if we're talking about the data, guys, so here, so if we're talking about data, guys, so the data we can convert into multiple chunks, right? Then we can convert into the embeddings. So here we are going to be convert using the specific embedding model. Now here only this embedding model comes. Now why we are doing it, I will tell you that. Then we are going to be stored inside the vector database, okay, vector DB. Now guys, whenever user is asking any sort of a query, right, so this particular query we are going to be convert into the embedding using the embedding model, and then we are going to perform the semantic search, and then we are fetching the retrieval, we are fetching the relevant data. Now this relevant data, this rank data, it is also called the context. So this context along with the query, this context along with the query we are providing to the LLM. Okay, we are augmenting our query. This query, we are not directly passing this query to the LLM. No, we are passing it through the vector database. Vector database is fetching some context, and then uh, behalf on this context, right? So just a second, guys. So behalf on this context only, LLM is figuring out some result of the query, and then it is giving back to the user. The final response is given back to the user. So this is the RAG, guys. Okay, this is what, guys, this is the RAG. I hope this is clear. Just read out this architecture by your end. Everything will be clarified. If you don't know, please check out with my previous video. So the biggest application of the embedding is this RAG architecture. Okay, I hope you understood where the embedding is being used over here. So we are going to be convert our data into the embedding, and here at this place actually to the vector database, we are performing the semantic search, the similarity search, and we are fetching a relevant context over here. So yeah, this thing is clear, and I hope you understood the application of the embedding. Now, what are models we have regarding the embedding and how to select the best possible model? Then we'll see the embedding leaderboard. So here I kept the embedding leaderboard. And then from here, guys, the core and the architectural concept we'll discuss in the next video. Okay, so here I'll tell you how the model look like. If we are going to be train any embedding model from scratch, then which model you have to select, which part of the transformer you need to be select, and how to train that. But yeah, as of now we will just focus on the embedding model. So first what I'm doing, guys, I'm going to be just a second. See here I capped a different model for the embedding, and let's look into this model one by one, and then basically we'll come to the practical side. So guys, in the embedding model or model for embedding, you will see every big companies are providing their own embedding models. So just look into the provider section. Now over here, see, OpenAI is providing their own embedding model. Google is providing their own embedding models. Okay, Anthropic, Cohere, even AWS providing their own embedding model that is called Titan embedding, and it is available over the Bedrock. Now, guys, these all are model closed source, means you will have to pay money if you want to use this model. Okay. Now here I kept some open source model. So this model actually you will get over the Hugging Face itself. You can directly download this model from the Hugging Face hub. Okay. Now see, this model is also being provided from the different company, from the various company, but it is available over the Hugging Face hub. And some of the model we are continuously using whenever we are learning any RAG related architecture, right? Or whenever we are learning about the encoding, embedding, right? So we all are using these model only. So here the famous model is all MPNet based V2. These are the model based on the BERT. Okay. Then here you can see the BAI from the Beijing Artificial Intelligence Research Organization, right? And then here again from here is a E5, right? I think it is from the Google, if I'm not wrong. uh, I kept somewhere this the from who is providing this E5 model. I'll show you that. Then the mini LM, actually Microsoft is providing this mini LM. Then OpenClip, I think OpenAI is providing that. That Blip, okay. Then Dino, then Wave2Back, Hubert, Yamnet, Clap, right? So guys, not only the text, actually you will get an embedding model regarding the different other modality also. So I mentioned the provider. I mentioned the model, whether the model is a closed one or the open one. Then I provide about the modality and the specific model name. So these are some famous model. So I kept in my list. But guys, I would like to show you one leaderboard, and with that leaderboard, actually, your most of the understanding will be clear. So the leaderboard actually it belong to. I will come to this part how to select the best embedding model. But yeah, before that, let me come to the leaderboard. So this leaderboard actually it belong to the MTEB. So what is this? What is this MTEB? MTEB is called Massive Text Embedding Benchmark. Okay, so let's look into this MTEB. So see what is the MTEB? Massive Text Embedding Benchmark. So it's providing one leaderboard. See, this is a leaderboard, guys, and here only you will see all the embedding models. See, this is all the embedding model. This one, right? And even you can classify. So if you want to check the image embedding model, you can check over here. Even you want to check the different other model, you can check over here. You can categorize based on the performance. Okay, performance, the model size, performance based on the task type, performance based on the language. Every sort of a filter they have provided you over here, right? So guys, this leaderboard is quite important if you are like using the open source embedding model. Now let me highlight couple of models over here. So if I'll scroll up, see, you will get the first one, KALM. Okay, it's from the Google. Then again from the Meta, it's from the Quen, right? From the Alibaba, from the Google. Okay, so every sort of a model you will get over here, the embedding model, and these model are the open source. Okay, and here you can see the memory uses, the number of basically users. What is this number of? Okay, just check out, guys. What is this okay, number of P, something like that. Then embedding, max token, mean. Okay, just explore this one. If you are willing to use the best embedding model, just check over here, right? Now apart from this one, guys, see, this is again one more like a one more resource for the embedding model, the sentence transformer documentation. Okay, just check out with their Hugging Face page. Now over here, guys, over there they have mentioned about the documentation. Then they have mentioned about the find all the sentence transformer model. So this all the model actually it is based on what? It is based on the this all the model actually it is based on what? It is based on the transformer only. So just scroll down, you will get all the sentence transformer based model, and it is having thousand of model, right? So see this like this you can categorize. This is the sentence transformer, and now over here once you will see, once you will scroll down now, here only you will get the model 127 model, right? So just check out with this 127 model, and apart from this one, once you will click on this one now, find all the sentence transformer model on the hub. So you will get the other model which is working under this sentence transformer. Okay, from the buy again, this is the based on the same concept, based on the transformer concept only. So in the at the same place basically you will get these model also. So yeah, these resources are quite useful if you are willing to use the embedding model. Now coming to the main part, guys, see, so here I capped some practical. Let's discuss this practical, and before that let me show you that how many chapters we have completed. So let's look at the chapters. Chapter 1 is completed. The chapter 2, all model for the embedding fine tuning, is completed. Type of the embedding model, yes, this is also completed. How to select a best model, this is remaining. And then embedding model, then embedding model leaderboard. So I shown you this leaderboard. So guys, let's do one thing, let's look into some practical. After that I'll show you how to select a best embedding model, and then after that, guys, I will stop this video, and rest of the thing I will show you in the next one, okay, in the next video. So what I am doing here, so let's connect with the GPU first. Okay, so here I'm going to be connect with the GPU. Now what I'll do, I'll install the sentence transformer. I'll install this torch. So here I'm going to install this one, and then it might take some time if you are doing it first time. So let it install. All right, guys. So my sentence transformer and the torch is installed. After that, I imported this sentence transformer from this module. This is the class actually. Now what I'll do, I will create an object of the sentence transformer class, and I will write my model name. So I'm using this all mini LM. Okay. Uh, all mini LM L6V2. So this is my model name. Now what I'll do, guys, let me load this model, and this is my sentence. Embedding fine tuning improves retrieval quality in the RAG. So once I'll run it, guys, see here, I'm able to encode it. So yeah, I'm able to get the embedding of this particular sentence. Now what I'll do, guys, see here, I'm just checking the shape, and then what I'm doing, I'm just checking the shape, and I'm just checking few numbers, okay, some initial numbers of my embedding model. Let me write over here import np. Yeah, so it is saying, oh fine, numpy, got it, guys, numpy as np. So yeah, this is my size of the embedding, 384, and here you can see the first 10 value of the embedding. Now what I'll do, guys, I'll take some document, I'll perform some cosine similarity. So let me run it. So I will pass some document to this method. Okay, this is the formula for the cosine similarity. Here I written the formula. Okay, so I made this formula using this numpy method, np dot and lineage norm. Okay, so I'm checking, I'm getting a norm, right? Norm means what? The magnitude of the vector, right? So this is the formula. Now what I'll do, this is my document. So embedding fine tuning improves retrieval and RAG. LoRa reduce GPU memory uses. My car needs fuel. then vector database store embedding. Now this is my query, how to improve retrieval and drag. So let's see this query is like near to which document now. So if I run it, guys, so here what I'm doing, I'm just going to be encode the document, this one. And after that, guys, what I'm doing, so here is what, here is my query. Okay, now what I'll do, I will find out a cosine similarity. So yeah, I'm iterating on top of each and every document embedding, and I'm checking the cosine similarity between the query and the documents. Okay, so I'm getting my score. Now let's see, let me check. It is near to which one, my query is near to which one. So this was my query. Okay, now how to improve retrieval and drag. So it is very near to this document, it is very near to the sentence, it is less near to this sentence. Vector database stores embedding. Okay, so his score is 0.05. My car needs fuel. It is very low again. The similarity very low. LoRA reduced GPU memory. It is again very low. The context of these word, these sentence and these sentence are different. So that's why the similarity is very less. But the context of this sentence and this sentence are same. So see, the similarity is very high. Okay. Now here I kept some pair also. Let's see the similarity between these pair. If I'm going to run it, guys, so see similarity between these pairs are very high. Rather the similarity is very low over here, okay, between these sentences. Now let's see between the difference between the keyword search and the vector search. So here is my document. Now what I'm doing, guys, so here I'm running it and see I have my query. Okay, now what I'll do, guys, I will convert it to the token first. So yeah, I will convert it to the token. See, this is the custom code which I written for the keyword search. I will show you with the VM25 also. So I'm tokenized my query. So here you can see the query token, guys, right? This one. Now what I'll do, guys, see here, I am going to be print the query token as well as keyword search score. So I'll print the keyword search score over here. Let me do it. So I will iterate on top of the document. Okay, I will tokenize that. I will check like which all I will check the count matching between the words, between the document, between the like document on which I'm iterating, the sentence on which I'm iterating, as well as the query. Okay, then here is my score. This is my score. If it is matching, means the count is matching, the word count is matching, then I will keep it inside the score. Okay, and then I'll print it over here. Now let me check. So in the first sentence we have 3 match, so this would be very high. In the next one we don't have any match, so this is going to be 0. Now here also you can see, if I have this query, let me show you the query. So this is the query, guys, how to improve retrieval and drag. So embedding fine tune improve retrieval and the drag. So this actually uh, this particular query, right, it is very near to this sentence, and we have proved it using the keyword search, right, where we were just matching the keywords, right, rather than the semantic meaning. Now this was my custom code regarding the keyword search. Now let me show you using the BM25. Okay, so what I'm doing, guys, I'm going to be install this BM25. Now here what I'm doing, I'm going to be import this BM25. Okay, then here is my document. Let me keep the document over here. This is my document, guys, same one. Now this is my query. Okay, now what I'll do, guys, I'll tokenize a query. This thing is going to be same. So now after that what I'll do, so I will uh, convert both into the tokens. Okay, so token of the query, token of the uh, corpus. So this is the token of the corpus, and here is the tokens of the query. Okay, I hope you got it. Now what we are doing, we are just going to be initialize a VM25 model using this BM25 OK API. I will get that. Now I'm going to be check a score. Okay, so how I'm going to be check a score. So BM25, there's a model which I which I initialize using this corpus. Now I'm getting a score using this query. Okay, let's see what would be the score. So if I'm going to print the scores, yeah, I already run it actually. I was just practicing the thing, so then only I executed it. Now here you can see the score. Understood, guys? So yeah, this model is also showing the same one. Now one more thing, guys, if you want to evaluate any embedding model, so this is also very easy. So using this MTB you can do that. So let it install, then I will show you. Guys, at this MTEB it got installed. Now what I will do, so first I'll explain you this MTEB, that is massive text embedding benchmark. Now we have another term inside this MTEB that is called STSB benchmark, STS benchmark. That is called semantic textual similarity benchmark. Okay. Now it is giving us some matrices like Spearman matrix, Pearson, then cosine Spearman, then Manhattan Spearman, and then Euclidean Spearman. Okay. Now it gives you some score also. I'll show you that score. So this is the meaning of that score. Okay. Now, apart from that, I written the score range also. So what would be the ideal score range and when your embedding would be like too powerful. So this is very useful to evaluate your embedding model. So if someone is asking you like how to evaluate the embedding model, so you can say I evaluated using this package. These all are the matrices I was getting. These were the score, and you just need to understand the meaning of these matrices, and then even you can explain them mathematically. Got it? Now I installed this MTEB. Let me give you the walkthrough of the code. So here I created one function. It will take a model name, whichever module I want to be evaluate. Then it will take best size, means in one shot that model how many sentence can encode. Okay. You will have to mention that. Then normalize embedding. Embedding actually it is a vector, so we can normalize that vector. Okay. Normalization means what? So normalization means the magnitude of the vector would be the one. Okay, if we are going to be normalize that, and we use the in STS benchmark, we use the cosine similarity and most of the places for the similarity search. So for the cosine similarity, if the vector is a normalized one, then it performs well. Okay. So normalize embedding, I kept it true. Then language, in which language, what is the language of your embedding model? In which language it is performing a encoding? Sorry, whatever, what kind of data you are giving to a model, which in which language actually you are giving a data to a model, and then it is generating a embedding. So yeah, that also we can mention. Now here, if the language is none, we'll keep it English only. Here we are going to be load a model from the MTEB. Then we are going to be get a task. The task is STS benchmark. I already told you the task full form is semantics textual similarity benchmark. Okay. On top of this task only, we are going to be evaluate our model. Now we'll run the evaluation. We'll call this evaluate model method. Will pass the model, will pass the task, will pass the encode kwrgs like best size and the normalizing. Now whatever result we'll be getting, so we are going to be iterate on top of that particular result, and from there we are going to be get all this thing: model name, model division, main score, Spearman score, Pearson, Pearson score, cosine Spearman, cosine Pearson, Euclidean Spearman, Manhattan language, HF subset, and the raw. Okay, and then I will print over here. So this is the complete method, guys. You can read it out by your end. Now here I have written the meaning of this E5, that is embedding for everything and everything to everything. This is developed by the Microsoft. Okay, and it is very popular. Like it is the popular model is in float E5 base V2. BGE means BAI journal embedding. So it is from the Beijing Academy of the Artificial Intelligence. And again, their model, their embedding model is also quite famous, right? Now what I'm doing, guys, so I'm running it on different models. So one is all mini LM, then second is a BGE base, then another one is a E5 base. Once I'll run it, guys, so here I can check the score of each and every one. So here it will take some time. See, it is running. Let it run because it is loading a model and all, so it takes time. So guys, my model is executed. It has evaluated a model over this STS benchmark and then see the result. So BGE base E1, it is having a highest score than E5. Then here you can see the all mini LM. So likewise, you can evaluate your models and you can check out the best possible embedding model. Now just do some self study of this benchmark, guys. I will, sorry, of this matrices. Okay. So I given the typical range. You can check out your range. Okay. In which range it is falling. These matrices are falling. Based on that, you can, uh, based on that, basically you can check whether the model is good or not, right? Now let's see basically how we can select a best possible model. Okay, on which basis actually we have to select a best embedding model. So I kept one point. Let me highlight those points. First of all, just a second, where it is. See how to select a best embedding model. So the first is a embedding quality. So check the benchmark performance, the MTB leaderboard, and the BEIR benchmark. So I will discuss this BEIR benchmark in my next video. Okay, I'll discuss what it is once I'll come to the different architecture of the embedding. That the dimensionality, guys. So we have several dimensionality, light weighted to the high quality dimension. So higher dimension will give you the better representation of the data, but it is having a more storage cost, memory uses, and the speed impact. So if you are going to be choose a higher dimension, no doubt it will give you the good quality. Okay, it will give you the good result actually, good result rather this lightweight. So if you don't have a constraint of the storage, memory, right? If you have a good server, good system, then use the high dimension embedding. Then guys, we have the cost again. So closed source, it give you the more cost rather this open source. So closed source, basically it is easy to maintain, high quality embeddings you will get, but the API cost would be there. Open source wise, you will have to host the model somewhere. You will have to keep it on your own infrastructure. If the scaling would be there, then scaling cost would be required. But again, on a small scale, right, on a smaller application, it won't give you that much of cost. So yeah, open source is a better choice for learning. Always open source. There's a domain suitability, right? So these are some general model, you can utilize it, so it will fit in every domains. But if you want some specific model, tune model, then you will have to take one more step ahead and you will have to find your own model. So these are some simplest step. Based on that, you can select how to guess the best embedding model. I would say this benchmarking is the best one. First you need to check that, then you need to come to the dimensionality, and then for which language and for which domain you are going to perform the embedding. If you are able to work with the general model, that is well and good, but if you're not, then fine tune your model on a specific data that we are going to learn in the next video. So yes guys, I will continue this part in the next video. Until, thank you, bye, take care. I hope you have learned so many things over here. I will see you in the next video. Until, take care yourself. These all are the chapter which I this particular topic I divided into the six chapter. So guys, I already discussed this two chapter in the previous video. Now from chapter 3 onwards, I will discuss inside this video. So in the chapter 3, I will focus on the training side, basically how this embedding model have been trained. And in the chapter 4, I will discuss onto the fine tuning, how to perform the custom fine tuning on your own data set. Okay, we'll take any sort of a model and we'll try to perform a fine tuning. Then in the chapter 5, we'll discuss how you can prepare the data set, how basically you can train the model, the complete practical guide, and how you can fit that model inside the rack pipeline. In the inside the chapter 6, I will discuss the differences between the embedding fine tuning and the LLM fine tuning. So with these differences guys, I am going to close this topic. Okay, I hope this entire topic is clear. Now let's jump to the chapter 3 directly. So guys, I prepared a very beautiful slide. So here you can see I capped the entire detail about the embedding fine tuning. First, I will discuss about the embedding model training, and then only will come to the embedding fine tuning. So in the second slide, I capped the complete detail about the fine tuning. Okay, here you can see. So first, let's discuss about the embedding model, like how these model have been trained. First, let's take the entire fundamental knowledge so that uh, your understanding will be very concrete when you are going to apply this concept from your end. And guys, if my explanation is a little slow, then you can speed up this video. So on a personal note, I will suggest you please watch out this video at 1.5x. Okay. So first, let's discuss the differences between the LLM and the embedding model. So guys, if we're talking about the LLM, as you know, so this LLM training, basically we can divide into the three major section. The first is called the pre-training. The second is called the supervised fine tuning. Okay. Now here I already discuss about the instruction tuning, and even I discuss about the non-instruction tuning. Everything I discuss, if you will go and check with my previous video, you will get that. Now the third stage is called the preference alignment. even I discuss about the preference alignment in the same playlist. Please go and check if you haven't checked so far. Okay. So these are the three stages whenever we are going to train any model. So guys, whenever we're talking about the hugging phase, so over the hugging phase, you will get so many model, so many pre-trained model basically, right? This is also called the raw model. You will get even the SFT model, okay, over the hugging phase, and many model with the preference training. And if we're talking about the OpenAI, right, if we're talking about the GPT's model or Cloud A model or a Gemini model, right, which we are directly accessing via API. So there, those model actually, it is already trained on the preference data, right? So all these three stages have been performed. Now, after this stages, one more stage comes, right? So that stage is called the custom fine tuning. Custom fine tuning. Okay. So guys, this is the target. This is our target. So this entire playlist actually, we were talking about this custom fine tuning. So either we can take this pre-trained model, right? Either we can take this pre-trained model and we can perform this custom fine tuning, or else we can take any supervised fine tuned model, right? And we can perform the custom fine tuning. Okay, custom fine tuning means we can perform our own SFT, we can perform our own preference alignment, and even we can take the model with the preference alignment, okay, which is already trained on top of this data, and after that also we can perform the custom fine tuning, right? So in the entire playlist, guys, we have discussed about this custom fine tuning only. Now we're talking about the pre-training. So pre-training basically we perform over the entire internet data. So here inside the pre-training, what we teach to our model. So inside the entire pre-training, guys, we teach a journal intelligence to our model. If you have seen my previous video, I already discussed all this concept. If you don't know, please check out the previous video. You will get a more concrete understanding. So this is all about the LLM model. Now we're talking about the embedding model. So I can write over here, embedding model. Okay. So in embedding model also, we have three stages. Sorry, two stages. Okay, two main stages. The first is called the pre-trained model, right? So here also we'll get a pre-trained model. So let me write over here, pre-trained model. On the second stage, basically after the pre-training, what you'll get, after the pre-training, basically we'll get a tuned model. Okay, tuned model. Now guys, here actually we are not going to perform the supervised fine tuning. Instead of that, we perform the contrastive learning. Okay, contrastive learning. Now what is the meaning of this contrastive learning? We'll discuss about it. Okay, I'll explain what is this contrastive learning. So we take a pre-trained model, right? And what we do, guys, we perform the tuning on top of this pre-trained model. So after this only this particular step come, right? And here also what we can do, we can perform our own custom tuning, custom fine tuning. So we are going to discuss this particular stage, the custom fine tuning. Either we can take the pre-trained model, the raw model. This is our raw model, guys. Again, it is trained on our internet data. Okay, and or we can take any tuned model and we can perform our custom fine tuning. If you are confused between this pre-trained model and the fine-tuned model, okay, which is already done by someone else, right? So let me give you the example. With that, maybe your understanding will be very concrete. So I kept some model name over here. So see, the first model is the Meta Llama and the second model is a Meta Llama 3.2 1B instruct. Now let me show you this model. So if I will go ahead with this hugging phase, okay. So see, the model name is Meta Llama 3.21B. So this is the raw model. Means this model is just pre-trained. Okay, this is just having some general intelligence. Means the capability of generating a text, of generating a next token. Okay, this is not tuned on any other data, right? But on the other hand, if we'll talk about this model Llama 3.21b instruct, so this model is trained on an instruction data set, right? This model is already tuned on an instruction data set. So guys, I hope now your understanding is clear. So either we can take a raw model, Okay, or else we can take already a fine-tuned model and we can perform our own custom tuning. Now the same thing goes with the embedding model also. So here you can see I kept two name. The first name is the MPNet base, okay, and the second is the all MPNet base version 2. Now guys, if you will check with this repository, Microsoft repository, under this you will find out this model MPNet base. Okay, so let me show you this MPNet base. See, this is the model and this is the raw model. Means this particular model basically is trained on a very huge amount of data. Okay, and further we can fine tune this model. Further this model, right? Further this model is fine tuned for the embedding task. Now here you can see all MPNet base v2. So this sentence transformer model, it maps sentence and paragraph to 768 dimension des vector and can be used for tasks like a clustering and semantic search. Okay, so this is a very popular embedding model, and I think we have seen this embedding model many times. We are using it inside our rack pipeline, right, to perform the embedding. Now if this thing is not clear, let me show you one more paragraph they have written at the end of this repository. So just read this particular just read this particular paragraph. So what they are saying over here, they are saying the project aims to train sentence embedding model on very large sentence level data set using self-supervised contrastive learning objective. We use the pre-trained model. This is the pre-trained model, guys. Microsoft MPNet base. Okay, that and fine tune it on a 1 billion sentence pair, right? So this model was the pre-trained model, and this model further was fine tuned for what? For the embedding task, right? Now, how the data set looks like for the embedding, how to prepare this pairs and all, what is the meaning of the contrastive learning, each and everything we'll discuss inside this video itself. I already prepare a material, so definitely I will show you. So please make sure, guys, you are going to watch this video till the end if you want to master the embedding fine tuning. Okay, I'm going very slow and I'm teaching you each and everything, right? Now here you can see. So this was the this is what, guys, this is nothing, this is the base model, and this particular model is a this particular model is a fine tuned model, right? So either we can take this base model or we can take this fine tuned model, and what we can do our own custom fine tuning. Now why we are doing this own custom fine tuning? We are doing this own custom fine tuning so that we can train our model over our own domain specific task, right? So we can train our model on our own domain specific data set, right? And guys, whether we are talking about this LLM model or we are talking about this embedding model, right? All this model actually it's nothing, it's a transformer based model. Okay, so this behind this model there is no like other technology except the transformer. So if you don't know about the transformer, this is the architecture of the transformer. Okay, so inside the architecture you can see we have two part. One is the encoder. The left hand side part is called the encoder, and the right hand side part of this architecture is called the decoder. So behind this LLM model, behind this embedding model, you will only get the transformer model, right? So let me summarize the thing now. So what I was saying, guys, if we are talking about the embedding model. So this is the transformer based model. So it is already like a pre-trained model, right? Which is trained on a very huge amount of data. Now this model is further tuned, okay, on the contrastive learning. So this is a special kind of learning where where we prepare our data in some specific format and we have some different loss function, right? And what we get our fine tune, we get our embedding model, the embedding model which we are seeing on a different places, right? Now what we can do, we can take this model, okay, the final model, and we can perform our custom fine tuning. Or else what we can do, we can take a pre-trained model, on top of that also we can do our custom fine tuning. Okay, but generally, guys, we take already trained model, we take already like fine tuned model, because it is like this model is already like trained on some task, on some like the pair a data set, right? So it is having some knowledge, and on top of that, if we are going to fine tune our own if we are going to be fine tuned on our own data set, so it will get a very like good understanding, because it is already having some knowledge, okay, about this contrastive learning and all, and then further we are going to be fine tuned on our task. Okay, so this is a like good approach. Otherwise if you want to do everything from scratch, then you can take this pre-trained model also. So now guys, let's understand. So here I have highlighted something. If we're talking about the pre-trained model, so this model actually it is trained on a very massive data set. Massive data set means what? It is trained on the Wikipedia data, Common Crawl data set, book corpus data set, web text data set, open data set, public web pages, right? So these are the internet data, internet scale data. And why we are using this data? So that my model can understand, my model can understand the general knowledge. Okay, so whatever general thing I'm going to be asked to my model, right, regarding anything, so it can understand that and it can generate the next word, the next sentence behalf on that particular uh, sentence. Okay, whatever we are going to be asked. So just to provide a general intelligence to my model, I am training my model on top of this data. Now contrastive, in the contrastive fine tuning, what we have, so in the contrastive fine tuning guys, we are going to perform the contrastive learning. So there what we have the pair of similar and the dissimilar text, right? So what is the what is the similar and the dissimilar text? Let's look into that. So guys, here I capped some dataset format, and I think just by seeing this dataset format, you will get a better understanding. So just look into the first format. See, this is the first one. This is the second one. Okay, and here is what? Here is a third one, right? So in all this three format guys, what we can do, we can prepare our data set. So in the first format you can see what we have. So in the first format we have the sentence. Okay, what we have guys, we have a sentence first, we have sentence 2, and we have a label. Now this label actually it is telling the similarity between these two sentences. Okay, 0 means not similar, 1 means similar. Okay, and we will be having the value between 0 to 1. Now in the second guys, we have this is called the triplet format. So where we have a so where actually we have a query, right? Then we have a positive message, and then we have a negative message. So likewise also we can prepare a data for the embedding fine tuning. Okay, now case C, so we have n way format. So in that actually we will be having a query, then positive data, positive column, and then the negative column. Now in the positive guys, you will get the document 1, document 2 means the multiple positive document, and in the negative again you will get a multiple negative document. So in this format, first of all, in this format, we'll have to prepare our data set. If we are talking about the normal instruction fine tuning, so there the data set format was a different one, right? But if we're talking about the contrastive learning, contrastive fine tuning, or fine tuning on the embedding model, then we'll have to prepare our data set into this particular format. So on whatever pre-trained model, so I was talking about this pre-trained model, right? This MPNet base. So this MPNet base further fine tuned, right? This model was further fine tuned, and it is open source, right? So this model also have been trained either of this format. So the community has prepared a data, or whoever has fine tuned that model, this base model, right? So they have prepared a data like that, like this only, and then they have performed the then they only perform the training, the further training. Okay, now, guys, let me show you some sort of a data set which is already present over the Hugging Face. Okay, so here, if I will go through the Hugging Face, see, guys. So these all are the data set. Now, just look in the first data. So inside the first data, see, the data set name is the all NLI. Okay. So in the column actually we have this anchor, positive, and the negative. Now on the second data set, guys, see this, the data set name is what? STSB. Okay, so again, inside this particular data set, you will see sentences, okay, sentences and the score, right? So this score actually it is telling the similarity between these sentences. Then we have the third data set. See, this is the third data set, AI job embedding fine tuning. So inside this data set, again, you will see, so we have a query, okay, this is the job description, which is a positive one, and then we have a job description, which is a negative one, right? So in this way, we'll have to prepare our data set. We will be having a query, we'll be having positive side and the negative side. Okay. So on top of this data, once we'll train our model, so my model will understand what is correct and what is not correct, right? Means I'll be passing a query and I'll be passing a sentence. So my model will easily understand, right? What is correct thing, what is a what is like the near one, okay, and what is like a not a near one, right? So I can explain you this thing with one example. I think with that your understanding will be very clear. So let's say we have a model, right? So I have one embedding model. So I have one embedding model. Now to this embedding model. I'm training this embedding model onto one data. Okay, so I'm saying over here, Sunny is AI master. Okay, so this is my sentence. Sunny is a AI master. So here I am writing Sunny teach AI, and the second sentence is Sunny teach Java. Okay, this one. Now I am marking this sentence as a negative sentence, and I'm marking this sentence as a positive sentence. Okay, and this is what, this is my actual query, right? This is my actual query. Now see, this is a positive sentence, means this sentence actually it is near to this particular query. Okay, and this particular sentence and negative means this is the far from, this is the far, this is far from this query. Now in future guys, whatever, see, in future, if this kind of query is coming to my model, if I'm getting a query, Sunny is a AI guy, right? So this model basically automatically will understand what will be the closest sentence, okay, what will be the closest document to this particular sentence, right? Because I already trained my model on top of this type of data, right? I already trained my model on top of this type of data, where this embedding model can understand what will be the closest. Let's say I have a like very huge list of the sentences, right? Inside this list I have, let's say, 100 sentence. Okay, it is all about the different it is all about the different tech jargon. So Sunny knows this, Sunny don't know this, okay, AI is this, that, whatever. So if I'm passing this sentence to my embedding model, so embedding model will automatically find out whichever is the nearest sentence to this sentence, because I already shown that kind of data, I already shown that kind of data to my model, right? So this is a simple phenomena, right? This is a simple concept behind the embedding model. Okay, now guys, here I kept the goal and all everything, and I kept like how this model have been trained. So what's the goal, guys? So the goal is close vector, right? So close vector, similar, close vector, different, distance vector. So if the sentence is different, so they will maintain a distance between that. If the vector are close, so they will be closer to each other, they will be the similar sentence. And I think I already given you the example. Now if we're talking about this training, guys, the embedding model training, right? So this is being performed using this three concept. So the first concept is called the cosine similarity, second is called the triplet loss. Either I can use the triplet loss or I can use this contrastive loss. Okay, this is also called the info NC. So this is the similarity formula, guys. This is the cosine similarity, there is a triplet loss, guys, and here is the info NC contrastive loss, right? So using this like loss function only, we are going to be train our model. If you don't know the training pipeline, so let me give you the highlight. So the training basically it always runs in a epoch. So here I can write. So if we're talking about the training, guys, the training actually it always run in a epochs. Okay, if you don't know the epochs, let me tell you the epochs. So in the epochs, what we do, we perform the forward propagation and we perform the backward propagation. Okay, so in the forward propagation, what happened? So in the forward propagation, we always calculate the value, right? We always calculate the value, means we perform the calculation in the forward propagation. If we're talking about the transformer architecture, so in the transformer architecture, we perform this calculation using the attention, okay, attention, and with the feed forward neural network. Okay, then guys, what we do, we calculate a loss over here. So we always calculate a loss value, right? And after that, in a backward propagation, so if we're talking about the backward propagation, what we do over here in the backward propagation, so in the backward propagation, we use the optimizer, right? We use the optimizer. Why we use the optimizer? To adjust the weights, guys, to adjust the weights, right? So in the backward propagation, we use the optimizer to adjust the weight. So here what we do, guys, see, in the first we perform the forward propagation, we pass our data, we calculate the values. Okay, we have some weights over here, the random weights, and we pass our data, we calculate the final value, then we calculate the loss. Okay, and then in the backward propagation we have a optimizer, and there we adjust the weight. So this is a complete training. Okay, this is called the one epoch. This is only called the one single epoch. Okay, this is only called the one single epoch. Now here, this loss function, now this loss function actually plays a very important role, because in the optimizer also we take the differentiation, we take the derivation. Okay, we take the differentiation, uh, differentiation of what, we take the derivation of the differentiation of this loss function only. I hope you are getting my point. If you don't know, guys, so this all the thing actually it comes under the deep learning fundamentals. So I can record a video on top of that. In future, definitely I'm thinking there I can teach you this entire mathematics and all. Right. So this loss function actually it plays a very important role. So we're talking about this embedding training. So in the embedding training, guys, either we use this triplet loss, or else we use this info nce loss. Okay, this one, this particular loss. Now here inside this loss, guys, you can see this similarity. Now how we are going to be calculate this similarity? So we are going to be calculate this similarity using this cosine similarity. Okay, so this is what, guys, this is the cosine similarity. Okay, this is what, this is the cosine similarity. Now using this cosine similarity only, we are going to be calculate a similarity. Now let me explain you the formula that what we are going to be do over here. So we have a similarity between the query, whatever query is being asked, and the negative document. We have a similarity between the query as well as the positive document. Okay, and this is one my hyperparameter, the m value. Now we are going to be check the max of it. Okay, and this would be the loss, right? So this value, the loss, actually we want to be minimized. How we will do that? So we'll use the optimizer. It will run the multiple epoch. Okay, and at the end, guys, we'll meet to the minimum loss, right? So we'll run our training until we are not going to be reached to the minimum loss. So this is one of the loss function which we can use, and the other one basically is this one, right? So we can utilize this loss also. Again, here also we are going to be use the similarity, but like the mathematical, the so calculating a loss in a mathematical way, that is little different over here. Okay, so this is the high level overview of this entire embedding model. So if you want to deep dive into the mathematics and all with all the examples, so I can discuss that in a near future session, guys. Okay, because to explain the entire mathematics, it would be the different kind of effort, right? uh, okay, and first of all, this fundamental should be clear for understanding this mathematics and all. Now after that, guys, what we'll do, we'll perform our own custom fine tuning. So in the third stage, what we'll do, we'll perform our own custom fine tuning. So let me revise this entire pipeline, and after that I will come to the architectural side. So here, guys, you can see, so first what we have a pre-trained model. Let's take example. Let's say we have this mpnet based model. Okay, now this model further have been trained on some pair or similar and dissimilar text. Okay, again, this is a generic data set which is collect from the different sources. Okay, the data set have been prepared in this particular manner. Either we can prepare in this manner or this manner, right? So let's suppose, guys, after this entire fine tuning, we got this model, this sentence transformer, all mpnet base v2. Now till here everything is clear, we got the fine tuned model. Now what we can do, we can perform our own custom fine tuning. So either we can download this fine tuned model, this contrastive fine tuned model, or either I can take this pre-trained model and we can perform our own custom fine tuning. So this own custom fine tuning would be the third stage. Okay, now, guys, which model we need to be considered, as I already told you. So whichever model is already trained on some data set, means they have already performed some contrastive learning and all, just take that model and perform your own custom tuning. If you're going to take a base model, right? So if you're going to be take a very base model, so in that case you will be required a very huge data set, right? So just take that kind of model which is already seen some similar and the dissimilar text. Then like you can fine tune that on your own custom data, and I will show you on the same model. Okay, I will take this all mpnet base b2, right? And after that we'll fine tune on our own custom data. Now if we're talking about the architecture, guys, see, this is the data set, the different data set. basically. So here I shown you this format, right? So according to the format I given you the link. So this is all the link, guys. You can go through with this link and you can check the different data set. Now, if we're talking about the core architecture, so guys, this embedding model actually we can divide into the multiple category. Okay, so let's discuss onto the architectural side. So as I told you guys, this embedding models are nothing. This embedding model, it is a transformer based model. Okay, now on the transformer side as well, we generally use the encoder. Okay, we use the encoder side of the transformer. So as I shown you, we have two side of the transformer. The first is called the encoder, the second is called the decoder, right? So what we do, we use the encoder side of the transformer generally. Nowadays we have a decoder based model also, and in some time I will give you that example also. So this is a encoder side of the transformer, and we generally use this encoder side of the transformer only for the embedding. Now let's see how this thing works. Okay, we are passing any text, then how this data is being converted into the embedding. So this is the step-by-step process, guys, which I mentioned over here, and I think you can clearly see this entire box. So let's say first we are getting a text. Okay, now this text could be anything. I'm writing a very simple text over here just to explain you. Let's say I'm writing AI. Okay, AI is a future. Now this particular text I wanted to convert into the embedding. So my final goal is what? So my final goal, see here I'm going to be draw the embedding, guys. I think it is clearly visible. So my final goal is to get a embedding out of this particular text. Okay, so first what will happen? So first, guys, this text will be converted into the token. So let's say we have AI over here. Okay, then we have is over here. This is the next token. Then a. Okay, then a, and then what we have a future. Okay, then what we have a future. Now what I'll do, guys, so this particular text I will be passing through this transformer encoder. Now inside the transformer encoder, you can see we have two main thing. The first thing is called the multi-head attention. Here right hand side you can see the first thing is called the multi-head attention, and the second thing is called the feed forward network. Okay, it is a neural network. Now what I'll do, guys, so this data will be passed either from the encoder on the decoder. So most of the model, actually that embedding model, it is an encoder based model, but nowadays couple of model are whatever model we are having, right? So those are the decoder also. I kept one table, and in some time I will show you that what is the encoder and the decoder based model. Okay, so guys, this particular tokens actually I will pass from where? I will pass from the encoder and decoder. Now what I'll do first, I will convert all these tokens into the embeddings. Okay, so that this token will be converted into the embedding. This is the word embedding, right? Word embedding. Now this is called the word embedding, guys. So we'll take any word embedding model and we'll convert that. Now after that, guys, what I'll do, I will add one more layer. So this layer, basically it would be the positional encoding. Okay, so this particular layer would be the positional encoding. So let me add over here positional encoding. Okay, positional encoding. Now after that, guys, what I'll do, see this all the sentences, this all the vector, actually it will go to the positional encoding. Now over here you can see we have input, we are going to be convert into the embedding, then we are going to be add the positional embedding. Now after that we'll pass this particular data. Okay, whatever data we have, so we'll pass this particular data, okay, to the attention layer, right? So this attention layer is nothing, this is for the contextual understanding, right? So after passing my data from the attention layer, we get the contextual embedding. So we'll pass it from the attention layer, we'll pass it from the neural network, feed forward neural network. Okay, so this is my encoder side. This is what? This is my encoder of the transformer. After that, what we do, guys, we perform the pooling. So pooling means what? To pooling means to take the relevant feature from the vector. Okay, so either we can do the max pooling, or we can do the minimum pooling, or we can do the average pooling. There are different ways of the pooling, right? So generally we perform the average pooling. Okay, so what we do, guys, we have a multiple vectors. Okay, we are passing from the attention and the neural network. So let's suppose we are getting multiple vectors over there, then we are going to perform the pooling. So either we can perform the max pooling, minimum pooling, and the average pooling. Okay, and after that, what we'll get, whatever vector we'll be getting, whatever single vector we are getting. Okay, if we want to extract more feature from there, so this is the optional layer, the dense layer. Okay, it is nothing, again it is a neural network only. So after passing my data from here, we'll get a final vector, this vector. Okay, this contextual vector. So this is the entire process to convert any sort of a sentences into the vector, right? So just go through with this entire points, just try to write it down like this. Okay, and step by step try to understand basically how we can convert any sort of a sentence into the embedding. So first we have a sentence, we are going to be converted into the tokens, we are going to be converted into the embedding, then we are adding the positional embedding, we are passing it to the attention neural network. Then whatever sentence, whatever vectors we are getting, we are performing the max pooling, minimum pooling, and average pooling. Now why we are doing it? To get the most important feature from there. So whatever single vector will be getting, again we can pass it from one projection layer, one from the dense layer. Okay, again it is a neural network layer only, and then we can then out of that only we will be getting our final flattened vector, and that flattened vector is called the embedding. Okay, and this is my contextual embedding, guys. I hope this entire thing is clear, and I hope you are able to understand this entire explanation. Now if we are talking about this embedding model, so this embedding model actually we can divide into the multiple category on a architectural level. So guys, here you can see, so encoder only model, cross encoder, multi dual encoder, and the decoder based embedding. So we're talking about the encoder model only. So we have this SBOT, E5, BGE. These all are the encoder based embedding. Now we're talking about the cross encoder. So this MS Marco cross and all the model basically will get under the co here, right? So those model actually it's a cross encoder. Some of the model is a multi-model dual encoder, right? And some model are the decoder based model. So these are the name of it. OpenAI embedding, Gemini embedding, right? So this model actually it's a decoder based model, right? Now over here, guys, you can see I clearly written a differences between the cross encoder and the dual encoder. What's the difference between it? Because I think you already seen the encoder. What is the encoder? So you know the normal encoder, but maybe this dual encoder and the cross encoder is different for you, right? And at many places, in whenever you are going to be create a rack pipeline, you are going to be create your embedding pipeline at those places, guys, you are going to be use this cross on encoder and the dual encoder kind of thing, right? So let's understand this dual encoder and the cross encoder. Here I written a clear cut differences. So how these two model, how these two like encoder are different, right? So these are different in terms of their data processing capability. So how they are going to be process the input, how they are going to be process their data, it is just having a difference in terms of the data input only, nothing else, guys. Nothing rocket science, no rocket science, nothing over here, right? So how they are processing our data, they just have that different capability. Now let's look into the dual encoder. So query and document encoded separately, okay, and then similarity computed between that. So on one side we are passing the query, on the other side we are passing a document, right? And those thing is being calculated separately. Inside the cross encoder, what we are doing, we are passing query and document together in one single pass, okay, and then we are going to be check the direct relevance score. Getting my point? So in cross encoder we are combining both query and the document, and we are passing it to the encoder. And inside a dual encoder we are passing the query first, means we are passing query and the documentation. Document means the query and the other data separately. So that is a difference, guys. Okay, nothing else. Now dual encoder is fast, scalable, and like we can pass millions of document, and cross encoder little slow because we are going to be combine our data over here. This cross encoder, you have heard, guys, this cross encoder actually we are going to be use it inside our this cross encoder actually we are going to be use inside the re-ranking also, right? So how we are doing that? Because we are combining the query and the other sentences of the document, okay, and then we are passing it through the model. So model is able to understand, right? Model is able to understand the relevance very clearly. So this thing, basically I even shown in my rack chapter. And on top of this cross encoder and DL encoder, basically I can take one separate session and I can decode the entire thing like this only, okay, if you want. So yeah, this is the entire thing, guys, and I think you understood how this embedding model works. Now I'm coming to the next part. So guys, now the question is, what is the embedding fine tuning? So let's understand this, and after that, we'll come to the practical. Guys, till now, I think you got to know what is embedding fine tuning, but it's still we need to check out the definition. So here is the exact definition of the embedding fine tuning. So embedding fine tune means training an embedding model further on your specific data set so that its vector representation become more accurate and relevant for your domain specific task. Okay. Embedding fine tune means training an embedding model so that its vector representation become more task specific rather than a generic, right? Now, whoever don't know about this thing means whoever don't know about the embedding and where this vector representation is being used, you will get to know in some time. Okay. Now here, guys, you can see, so normal embedding model, it is a pre-trained on a large generic data set, as we know, and it is good for the general search, right, or semantic search. But if we're talking about the fine-tuned model, so further train on your own specific data set, and model learns better semantic structure about your own domain. So we have a normal embedding model, which is just pre-trained model, or which is just like fine-tune on some general data set and all, like I shown you this MPNet model. Okay, so it is good for the general task, but if you are doing your own domain specific task, in that case, you required the fine-tuned model. Okay, you required basically your domain specific model. So in that case, you can do it. See here I kept some images also with that. Your understanding would be clear. Let's say we have a base model. So this is the MPNet base model. Okay, MPNet base model. Then guys, we have fine-tuned that model. So MPNet base, okay, B1 means all they are fine-tuned on some sort of a data set. Then guys, we have a base model, we have fine-tuned model. Now guys, this is the additional fine-tuning. So here, this could be your custom fine-tuning. This particular stage could be your custom fine-tuning. I hope you're getting my point, what I'm trying to say. So I'm saying over here that let's look into this model. So guys, this is the model, right? This particular model, MPNet is a base model, right? Now guys, they further tune this model, and the model name is all MPNet base 2. They have trained on their specific data for generating the embedding and all, right? Now, guys, on top of this model, again, you can perform the fine tuning so that it will look like this, the additional one, this one. Okay. So this one single image is clarifying all the thing in a single shot. And I hope this is clear. Now, coming to the step, like what all step is required to perform a fine tuning. See, guys. So step one, we'll have to gather the positive and the negative pairs. Then we'll have to pick a pre-trained model. Okay, pre-trained model on any model which is available, like generic fine-tuned model. Okay, then pick a loss function, fine tune the model, and after that evaluate the model. So this is the step which we need to follow to perform a fine tuning. Now, what kind of data? So we'll have to prepare this kind of data, guys. This one I already highlighted over here, this one. So we'll be having a query, we'll be having a positive match and the negative match, right? So model will understand what is positive and what is negative for that specific query, and according to that only it's going to pick a data from the vector database, or it's going to be pick the relevant document. Okay, now guys, here you can see, so why this fine tuning is required, why we should do that. So I written an example, I written a multiple basically points over here. Just by reading this, your understanding will be even more concrete. Okay, so here is the real reason for the practical use cases for the domain specific understanding. So let's say if you are a pharma company, if you are a pharma company and you have lots and lots of data, right? Lots and lots of data. Now on top of this data, right, you on top of this particular data you want to build a RAG. But inside the RAG pipeline, what you are feeling, you are feeling that your embedding model is not working very good. Okay, your embedding model is not aligned with your data. Then what you will do, guys? So you will take this lots and lots of data and you will train your embedding model, and then only you will utilize inside your RAG pipeline, right? Then only you will utilize in your RAG pipeline, and that thing can increase, right? That thing might increase your 60 to 70% of accuracy. Okay, now over here, see, domain specific understanding. Your model will get a domain specific understanding. You will be having a better search, a semantic retrieval, right? Specifically, I'm talking about the RAG system, right? Or task specific nearness, not only inside the RAG pipeline. Now if you are going to be perform any other task, let's say you have one query and going to be, and you are going to be check the intent, okay, regarding the other document, okay, of that specific query. In that case also you can utilize it for the duplicate detection, right? So you have a query and you want to be checked like what are document the duplicate to that document to that specific query, right? So you can do that also, right? So apart from the RAG, there could be multiple semantic search application, and here I have highlighted those one. So yeah, now guys, I think you are enough ready to understand the practical. So let's go through the practical. Let's understand the entire practical, and after that, guys, I'll show you the differences between the LLM fine tuning and the embedding fine tuning. Okay, so here I capped the differences, guys. I just need to discuss this one table. Now, guys, here is the entire training code. So let's execute it one by one. So first, we'll have to install the sentence transformer and the storage. After that, we'll have to import these modules. So I'm importing this load from disk. So I'm going to be load my own custom data. Then sentence transformer trainer, sentence transformer training argument. Then, guys, we required this multiple negative ranking loss. Okay, then guys, this a batch sampler, right? So this many thing is required to me. Now after that, guys, what I'll do, I'll load my model. So here I'm going to load my model. Now this model only I will fine tune on my own custom data. So yeah, the model is being loaded. Now after that, guys, what I'll do, so either I can take the data from the Hugging Face, any inbuilt data set, or I can prepare my own custom data and I can fine tune the model. So here I'm taking a second approach, means I'm taking my own fine tuned, I'm taking my own custom data which I already prepared. Okay, and on top of that data, I'm going to be fine tune my model. So let me tell you the scenario, the entire scenario. So the scenario is very simple. uh, I'm assuming that I'm working in one pharma company. Okay, I am working in one pharma company. Now, for this pharma company, I have to build a RAG pipeline, right? A RAG pipeline. So, how we create a RAG pipeline? So, we have a data, then we perform the chunk out of this data, then we perform the embedding, okay, and then we store this embedding inside the vector database in the vector db. Okay, then what will happen, guys? So my user will ask any query, okay, or I will be getting any sort of a query. I will be getting any sort of a query. So this query basically it's going to the vector database, right? So this query actually is going to the vector database, okay, and I'm fetching a relevant result, right? So I'm fetching a relevant result. Now, what will happen, guys? See here, this relevant result will go to the LLM for the, and LLM is going to be generate their final response. Got it? So this is a complete RAG pipeline. Now over here, guys, see what I'm assuming. See, I'm going to be perform the embedding, and this embedding model is not performing well. Okay, means on top of this data, on top of this particular data, this embedding model don't know anything about this data. Okay, so whatever embedding is being generated regarding this data and regarding this query, okay, so it's not performing a well semantic search. The semantics, it is not performing a well semantic search. Okay, then if I'm not able to perform the well semantic search, then we will not be able to get a relevant result. If we will not be able to get a relevant result, then we are not passing a good context to the LLM, right? So that thing should not be there. So what I'll do, guys, so I will train this embedding model on my own data set. Okay, I will fine tune this embedding model on my own data set, and then only I will fit it inside the RAG pipeline. So I already prepared data. So here is the data, guys. See, train pairs. I have this train pairs. If you want to see this data, I already uploaded this data. I already uploaded this data over the GitHub. You can check out, and you will get this link inside. You will get that link inside the description only. Okay, so guys, what I am doing. So here you can see we have this data. Okay, data. This is the information about the data, how the pairs look like. I can show you that. See, this is the information about the data, all the information, the meta information. This is a state.json. Okay, one more file we have regarding the data. It's again a meta file. This chunk.jsonl. So likewise the data will look like, okay, this like this the data will look like. Let me keep it over here. And after performing this chunking and all, after creating this pair and all, so I kept it inside this dot arrow file. Okay, so see, this is the data, guys. Now over here you can see we have a text. Okay, and regarding that, this text basically will be having a positive and the negative. Okay, so we'll be having positive and negative. And then, guys, using that data, what I have done, I have created this data 000 of 0001 dot arrow file. Okay, this is the compressed file which is being used by this Hugging Face only, right? And we can load our chunks and all, everything. I will show you how the data set look like, don't worry. Okay, if you're not able to see over here, I'll show you. Otherwise, you can download all this file from my repository itself, and you can check. Now, see what I'm doing. So I already kept the data in a zip. I did the unzip, and I'm loading it over here. See, I'm loading the tech train pair, right? Now load from disk, and here you can see we are going to be load the train data, this particular data train pairs. Now what is a arrow file, guys? So arrow file actually Apache arrow columnar format. So it's a Hugging Face data set internally. For Hugging Face data set, use it internally. Okay, so for the faster memory map, for the efficient column based mapping, for the faster training, right? Now over here, let me show you the data set. So if I'm going to be print the data set, see, this is the data set, train data set. Okay, and how many features we have? We have anchor, positive, and the negative, right? So anchor and the positive. Now if I can show you the column name, so see, this is the column name, anchor and the positive. Okay, so either anchor, positive, negative, or either anchor or positive, I can keep in this format, right? This will also be fine. So anchor means the real text and positive means the positive one. So automatically my data will understand which is a positive. If something will be negative, it will not show me similarity with that particular sentence. Okay, now what I'm doing, guys, I'm going to be initialize the loss function. So here is the loss function for the embedding training only. Now this is my sentence training, sentence transformer training argument. Here is my output directory. After the training, my model will be available over here. Number of epoch, right? This is the batch size, learning rate, okay, warm up rate, FP16 batch sampler, then logging step and the save strategy. So once I'll execute it, so my training argument has created. Now what I'll do, I will create an object of the sentence transformer trainer. Here I will pass the model, argument, dataset, and loss function. Now once I'll do that, guys, so see, my training will be started once I'll call this trainer.train. So see, the training is started now. Okay, so training is started. It might take some time. Now after that, guys, what I'll do, so I will save the model. Okay, so model will be saved over here, basically at this particular location, model pharma embedding fine tuning. Okay, so once it will be run, means my model has saved. It won't take much time because I already have a very small data set, so this training will not take very huge time. Now after saving a model, guys, what I can do, see, this is the additional code, means I can zip the file, model file, and I can utilize it later. So I'm not executing it right now. Then what I can do, I can do the inferencing. Okay, so here is my model. I will be loading my model. I will pass a sentence to it, and I will be and I'm going to be basically uh, then what I'm doing, guys, I'm going to be get a encoding out of it. Okay, so this is just an inferencing of it. Now see guys, the training is going on, and after that my model will be saved, and after saving the model guys, I will perform the inferencing. Now over here guys, this is my embedding model, so I can give a query around to that. So this is a general query I had written. Now if you wanted to see the data set, how the data set look like, let me show you that. I already have a data I downloaded in my local. See, this is the data guys. So this is the data pharma demo. On top of this particular data, I'm going to create my rag. Okay, on top of this particular data, and on top of this data only, I have trained my model. Okay, this PDF. Now this PDF and this data actually I have converted into this format. Okay, so where is the format? This one. Let me show you that pharma FT data. See, this is the format train pair. Okay, so I converted this data into the anchor and the chunk. Okay, and I compress inside this arrow file. So I had the PDF. Inside the PDF I had a text. Now that particular data I have compressed inside this arrow file. Okay, I hope you got it. Now how I did it guys, so for that I had a complete script. Let me show you that script. So I already created that script and I kept it inside the GitHub also. You can look into that. But yeah, I can show you that. So this is the script data creation. I'm just going to be open it, and this script I already given you inside the GitHub only. Right? Okay, so just go and check. You will get this particular script. Now see, so here guys, this is the entire data page. Okay, means first actually I created a PDF out of this data so that I can utilize inside the RAG, and using the same data only I prepared a embedding fine-tuned data. Okay, so after that guys, what I have done, so see positive and the negative text, this is the entire code. Just go through with it, you will understand how this data have been created. Okay, so to understand about the data and all, it's not very difficult. See, first we had a query, then we have some templates and all. Okay, and building a fine-tuning data set where we have an anchor, which is a query, and the positive chunk, right? So guys, you can go through with it, you can understand how this data have been created, and after that guys, what I have done, I have compressed it inside the arrow file so that later on I can utilize it. Now here I can give any sort of a query, and just to check whether uh, just to check guys whether this model is working or not. So I can take a query from the same PDF. Let me take that. So what is amoxicillin capsule 500 mg? Okay, so this is the query which I'm going to be asked. So here I'm going to be write what is capsule. Right, now what I'll do, I'll keep it in a double quote, and then I will run it. Now see guys, you will get an embedding out of this particular sentence. So once you will check with the embedding, you will be getting a embeddings over here. See, you will be getting an embedding. See, this time now the embedding is being generated, means I'm able to perform a uh, inference out of that particular model. Now what I'm doing guys, I'm going to be store this data. Okay, the this PDF data, okay, inside the vector database, and I will be using this embedding model to perform a similarity search based on the given query. Okay, and I will fetch the relevant result from that particular data. So for that, what I'm doing, I'm going to be initialize this files. Okay, so for initializing this files, I will have to I will have to run this thing, langchain and the langchain OpenAI. Okay, then after that guys, what I'll do, I will run this langchain community and the PyPDF, because I'm going to be initialize my rack pipeline over here. Then I'm running this PyPDF loader. Okay, so I'm running my PyPDF loader, and here I'm going to be load the data. This is my data. Okay, from the PDF. This is my PDF. Okay, pharma demo, right? So pharma demo, it is my PDF, it is my data guys. This one I can show you, this one. So on top of this data only, I'm going to create my RAG pipeline, right? So yeah, the package is going to be installed, PyPDF is going to be load, then it's going to be load the PDF. This is my all the document, means my all the pages of the PDF, and after that I can show you, see how many pages we have, 3 pages. Okay, now what I will do guys, I can perform the chunk of my data, but the data is very small, so chunking is not required. So what I'll do, I will initialize the files. I will import this Hugging Face embedding also. It is very important to convert my model. Okay, it is very important to convert my model into the Hugging Face compatible model. So I'm going to import both. Now what I'll do, I will give my model path, which I already saved over here. Here you can see, so my model is over here. Okay, after the fine tuning, I will be getting my model. After the fine tuning, I will be getting my model over here. Okay, this is the model, guys. So inside this particular folder, I have a model. Now I'm going to be load my model. Sorry, this is my model path. Now I'm going to be converted to the Hugging Face compatible format. Okay, now I get my embedding model. Now what I'll do, so let me delete this, is not required. Now I will install the FICE CPU. Okay, after that, guys, I will store all the data inside the FICE document. Okay, then see, this is my index. The FICE index is there. Now I will ask a question, what are the warning and the precaution. So see, I will be getting a result, and here you can see the result, guys. See, my result is working, means what I have done, on top of the PDF. Okay, I'm going to be create a rag. So I took that PDF, I kept it inside the vector database. Okay, now whatever embedding model I'm using for the similarity search, for the semantic search, that embedding model is already fine-tuned on top of this data, on top of this pharma data. And how I have done that, first I have converted this PDF into the compatible format, this file. Okay, here you can see this one, this inside the training pair you will get that. Okay, this arrow file, and then I fine tune my model. Now how I get this data, so using this particular script I got this data. Okay, now what I'll do, guys, so yeah, this is done. Now here I will set up my vector retriever. Now I will be setting up my OpenAI key. Here is my LLM. Okay, the LLM will be initiated, and then basically I will check whether my LLM is working fine or not. Now here is what, here is my renewable pass through str output parser. I'm going to be filter the warning. This is my prompt, guys. Okay, I'm initializing my prompt. Now this is my format document, and here is my complete rack chain. Now let me keep the key, the OpenAI key. Let me show you the final output, guys. So guys, I kept my OpenAI API key uh, inside the secrets, and I'm able to run my model. Now what I'll do, guys, I will import this runnable pass through, so that I can take a input on a runtime, and then str output parser for the final output. Now here is what, here's my prompt. So in the prompt, what I'm saying, you are a helpful assistant, use the following context to answer the question, right? Simple prompt. Then format document. Now this is what, this is my rack chain. Okay, so what I will do, guys, here actually I will see, here is my prompt, LLM and str output parser, and this context I will be getting from where, from the vector database. Okay, and I'm formatting that context. Now what I'll do, guys, I will invoke this chain. What I'm asking over here, what are the consideration for the Emoxley 500 mg. So if I will run it, guys, I will get my final answer. See, this is the final answer. And guys, the answer is correct. You can check out with this PDF. Okay, so that is a use of this embedding model. I hope you got it. If you not, if you didn't get it, then guys, again, please again check out with this video, go through it one more time. If you still have any sort of a doubt, please let me know in the comment section. Now guys, I will see you in the next video. So if you haven't subscribed the channel so far, please subscribe the channel, and if you're liking the video, then hit the like button. So until, thank you, bye bye guys, take care.